So, the only Hello and welcome to day number 2 of the 2023 Engine Performance Expo from Straub Technologies in Piney Flats, Tennessee. I'm Joe Costello, joined by Lake Speed Jr. and Ben Strader. Guys, we're going again, day 2, and today is the big day where we will reveal all the information we withheld from everybody in day 1.
Yeah, yesterday was a total tease, right?
It was dangled that carrot all day, didn't we?
Yeah.
We've got this engine. Oh my goodness, it has worked out. We made so much more power.
2 engines.
2 engines, and today we're going to reveal Are we going to reveal everything?
We are.
Okay.
Today we're putting all the cards on the table, right? So I can't give away all the secrets yet.
It's a long day. We got to dole it out slowly.
Right. But I will say this. So both engines, from where they began to where they ended, both picked up triple digits.
Triple digits. That's amazing.
Without a decimal point, right?
Yeah, without a decimal point, yes. Not 1.00 horsepower. It picked up triple digits. Both of them did. So you got to stay tuned and watch all day. It's going to be fantastic because, to the point where at the end of this whole experience this last year, because we did a lot of work together this past year, and toward the end of the day, Dennis Bourne from PME is going to be here, and he's going to sit right there, and we'll talk more. A 1, 2, 4 horsepower gain anymore is like, what? That's nothing.
Yeah, it's pretty tough to get excited about 5 horsepower when you know you can make hundreds, you know what I mean?
Right, and literally, Mark Cronkers is sitting back there, and we would cut our arm off the day for 1 horsepower on a plate engine. If he could pour in 2 or 3 horsepower, that was huge. And we literally did that the other day, and I was like, yawn. That's lame. It's ruined me. This whole project this year has ruined my threshold of expectation.
And so much of that's happened because of the technology that a lot of the stuff we've been talking about during the Engine Performance Expo. When we recap yesterday, look at all the stuff that we talked about yesterday, and we were dangling the carrot. We didn't even get into the super meat and potatoes stuff of today, but yesterday was incredible. How about Joe? What was your favorite part of yesterday? What session really stood out to you?
Well, I like the economic roundtable, honestly.
Okay.
As much as I'm into the horsepower, when you got Scooter Brothers up there and people who are captains of our industry giving you, Randy Neal, giving you their outlook for the future. Mm-hmm. To me, that's most important. What's the future going to be? Are people able to invest? Are people able to charge forward? And everything that they said aligned with that. Charge forward. We got good things coming. And even their concerns, because it wasn't 100% rosy, it's there are some concerns, but we feel good about where we are. To me, that means that everything else that we are doing is responsible. It's okay to go out there and pursue our passions, our fun, buy some parts. And, Lake knows I'm doing my own thing for my own little bracket car. That
yes,
I'm trying
we
to work
are.
on.
So last night at dinner, me and Gary Stennett finalized the deal. So obviously we worked on the Engine Performance Expo engine.
Sure, yeah.
And then we've, did the Extreme Home Makeover edition on my dad's cup motor, where we're doing the Extreme Home Makeover edition on Joe's engine.
So wait, was it Extreme Home or Extreme Hone? Was it
It will be an Extreme Hone Makeover.
Extreme Hone Makeover.
Right, for
Way to
certain.
go, Ben.
For certain.
Words.
That
was so good. Well, you guys are talking about me without me knowing about it. That's good stuff. I like it. But that's what I get excited about, right? The personalities today. We've got Greg and Aaron Stanfield are going to be here. Mm-hmm. We've got a lot of personalities. They're getting ready.
Steve Morris and his son are going to be here.
Just super excited about this whole start of the season, start of the year. Engine Performance Expo for me has become the kickoff to the year of racing, and everybody is finalizing their refresh from last year's stuff, making everything ready. They've got a great and positive outlook on what lies ahead. And so it's a perfect position here in January at the start of the year. I know there are going to be a lot of people that watch this throughout the year.
Yeah.
Right? We encourage you to share it, of course. Click the bell, subscribe. These videos are going to get broken down. But all of these people that are here for a reason. It's because we're passionate, we're excited, and we're ready to drive things forward.
So there's two great takeaways from that, Joe. First of all, you're right. The ability to confidently go forward, knowing that we still have an industry that we can invest in, trust in, and put effort and work in, right? It ain't going anywhere, right? That's awesome. And then you think about today, the ability to have this family sort of theme, right? So you got the Dortons, and you got Kyle and Steve, and you got Greg and Aaron, and it's you think about that and you go, only so many of you young guys those guys are lucky enough to grow up in this industry. Lake,
Yeah.
you grew up in this industry. But for the hundreds and thousands of people that are out there in the industry that don't have that strategic advantage, they have Engine Performance Expo. Like here, they're getting all this same kind of treatment of like, I'm going to share with you these hard fought battles and tricks that we learned, right? So I love the family aspect of it, right? But I also didn't have that advantage of growing up with a dad that had already fought a lot of those battles. And I'm excited to hear some of those stories today about how the generational aspect plays into the game, right? So I know you relate to this. A lot of the other ones that we're excited to hear about it because we don't have that advantage. And I think that's a great part of what Engine Performance Expo does is it sort of peels back the layers of the onion and says, just because you didn't grow up in this sport doesn't mean you can't make your way. I think that's awesome.
Well, I was so impressed yesterday by Jolie running that EM45.
That was super
That was cool. I was like, that's neat, right? Of course, all right, my son Benjamin's here. So
oh yeah, third generation
guy. He's here. He's working at RF Engines with Rick and Bob out there tearing down engines, and he's out there with Scott yesterday. They're honing blocks and learning how to run the HX45.
You're just proud, huh?
Oh, I'm so proud. I'm the proudest dad ever right now. I can actually start to kind of get a feeling what my dad must feel like when he's done things with me and all that. It's like it's cool. Like the family vibe going on is really great. So it's exciting. Of course, we got big things happening today. Big power, big advances, really neat stuff. Been running the hone, right? That's one of the big. That was kind of the coolest thing outside what happened in here yesterday. Just during the breaks when we were out there walking around, you could see the sparks in people's eyes looking at some of the machines going. And when they were started to work on the hone, we were honing the blocks, back there for the top fuel stuff, the sleeves.
Right.
And
that's right. Top fuel stuff.
Yeah, we got top fuel cylinders out there being honed. And I think there's a 60 grit diamond with a 600 CBN finishing. And these things got an RVK of 130, but the RK is 40. And the RPK is left. It was the super sexiest looking trace I've ever seen. It was awesome.
It's so cool. Not only do you have all the cool Rottler stuff here and you got the ability to measure it, you got Mark Malberg here. You got like the Jedi of surface finish metrology out here going, let me show you what we need to do. I mean, you can't get that anywhere else.
He taught my son Ben how to run it.
That's pretty awesome.
He probably knows how to run it better than I do now, right? He spent the day with Mark.
True. Yeah.
He's like, Mark's like, doing like that Jedi wizard stuff on there. It was incredible. So what we're able to do as a collective group here is incredible. When everybody was standing there yesterday when we came in, I was a very proud moment to see as an industry, everyone coming together, being willing to share. That's the ethos of the Engine Performance Expo. And what's really neat is, we can do this and we can do it live and you can watch it, but we're going to expand. There's going to be something that's hands-on. So talk about what we're going to be doing this year, Ben, in terms of hands-on training specific to honing.
Well, obviously, I have a soft spot in my heart for teaching and sharing and training. And so one of the things, again, that I love about the Expo is it gives people an opportunity to learn things that you just couldn't learn any other place. And, you've spent a lot of time over the last year or two learning about honing because honing and rings, man, they're married together. And so we started having some conversations about how could we go to the next level? How could we go a little bit farther than just making videos? And so Lake kind of presented the idea of what if we did like some actual live training? You could go somewhere and actually you could be the one running that hone and measuring the block. And so it works out that between EFI University's facility back there in Arizona and Chris's amazing facility here at Straub's, we have enough equipment that we're going to start offering through Total Seal and Rottler and the collaborative relationship actually a class where you could come in for just one day, start in the classroom, learn all about surface finish, the honing technologies and procedures, and then guess what? We're going to go right out into the shop, and you're going to put your hands on it, and you're going to be honing blocks and measuring the surface finish. And
amazing.
Yeah,
I'm pretty excited about that.
Well, and so you asked me a minute ago about like what I enjoyed the most. Really, what I enjoy the most is the exchange of all this information. There are people that they never seen one of these machines ever.
Right.
They're interested, but where would they? How would they get that opportunity to see it work, to see all of these things, to understand these elements? maybe they're interested. Maybe they've got a kid that's looking for a career. We need people who know how to do this. You know what I mean? I get all patriotic and I think about our country, right? Like, we need this.
Yeah.
The builders, the doers, the makers, the hands-on people. It can't be like a dying breed that just goes away. It can't be that. We have to have it. And that spark of energy, that excitement about it. Like, oh my gosh, this is an exciting thing. I'm not like in some dungeon machine shop somewhere and nobody knows my name. Like, engine builders and machinists can be rock stars in their own little world.
Exactly.
That was a new concept yesterday, the engine builder rock stars.
Yeah.
I love that. But you're right. We talk about all the economic side of like, okay, well, we know there's an industry worth pursuing. Now we've got to build the people that are capable of pursuing it. And so I've said for years that, this is great, but the difference between you watching somebody on a block, like Greg Anderson gave us that great tour,
Yes.
right? Great tutorial,
Amazing.
and did a great job. But I still feel like, okay, I mean, yeah, of course he's good at it, but like, could I do that? Would I really be able to? If I walked up and did it, would I be able to do that? And so you kind of get into like, well, you could watch a million videos of somebody riding a bike,
Yep.
but you really haven't experienced it until you try to ride the bike. Well, what we're trying to do is go the next step beyond the expo and say, we're going to let you come ride the bike. You're going to not watch somebody hone. You are going to hone a block. You're going to hook it up to the cable and set it in the machine and bolt it in there and program it. And then
You're going to torque the torque plate in place and do all those things.
That's amazing.
Yeah.
Yeah, what a great experience, right?
Yeah, this is like, engine builder world.
Are you going to be
right?
the first? You're going to show up, right?
I'm
You're
down.
gonna- yeah,
I am down. Well, you know me. I like to do all of that stuff,
I watched
right?
you change, transmissions for Hartford and clutches.
Valve
and like,
springs. He lets me touch the Pro Stock car. Big mistake. But
It's pretty scary.
no, it was very scary. No, doing it isn't scary. The next run, the car goes down the
Yeah,
track.
exactly.
That's when it gets scary.
Oh, yeah.
Like, what did I do wrong to this thing?
Yeah.
But it turns out, no, there's nothing like doing it. I make my living as a broadcaster. Announcer, reporter, podcaster. But what do I do for fun? Like, I want to turn a wrench. I want to grab something. I want to try to work something. I want to build something. And that's what this has been all about. And obviously, I'm a hobbyist. But for the people that are making a living doing it, they can make a good living doing it. And there's a lot of money out there to be made. Like Randy Neal talks about. It's like, hey, man, what's the number one motivator, right? People want to make some money.
Yeah.
And if you're doing what you love, if you enjoy it, if you feel fulfilled at the end of the day, like, hey, man, that was a good day.
Yeah.
We did good work today. That's life. That's it. What else do you want?
I feel like Randy's one of those guys that really has his finger on the pulse of what's happening in our industry. He understands the science, he understands the machinery, he understands the how to get it done, but he also understands that the business has to be healthy and profitable. Otherwise, we're not going to have a business to go forward. And so, he's a member of our fraternity. He's there every week, and he is heavily invested in making sure that the young guys, they have a path, right? So those of us that are in the industry, he's realized as much as all of us that it's not good enough to tell him, hey, you need to get in this industry. We got to show him how. We got to make the path, create opportunities, build training programs, give them expos like this. It's our job to make sure that happens.
Yeah. So the cool thing is, April 22nd is going to be
22nd,
it's a Saturday. It'll be the first full day hands-on class at EFIU.
Yep, operators are standing by.
Yeah. Lake Havasu City, Arizona is a fantastic place at the end of April, by the way.
April is the prime time to come
It is
visit us.
wonderful. So, and then the other one is going to be here the weekend of the Bristol drag race.
Oh, wow.
So
Dude, how
Bristol's
cool is
7
that?
miles down the road.
Yep.
So we'll be drag racing and honing right here in East Tennessee, and that's around like June 8th, 9th, 10th, somewhere around there.
We're gonna lock that date in once we get a little more info about when the race is and how that's going on. But
So EFI 101, right, is the website?
EFI101.com. We'll have in the next few days. We'll have some sign up links and registration spots so we know who wants to come and make sure we don't overdo it.
Right.
But within the next day or two, you'll be able to sign up and guarantee your spot to come and learn how to do it yourself, hands-on.
And make some plans to stick around to see a little 330 mile per hour nitro drag racing, of course.
Absolutely.
Like,
why not?
a little twofer. When you come out, you see the shop, you do some stuff yourself, you go out and you watch a race. Like, it sounds like a dream weekend to me.
It's going to be awesome.
Oh,
so
yeah.
there's a ton of stuff that we have planned for today. What do you
Yep.
say we just get to it?
Yeah, we should. First video of the day is going to be mind-blowing. This is in-cylinder combustion analysis. Stay tuned. You're going to love this one. All right, Engine Performance Expo viewers, you recognize this guy.
Back again.
We're here. Now, trigger warning, we're going to say something here in a second that may offend people's preconceptions of engines. But we all love engines.
Yep.
But we have learned something with this little technology that's in your hands that kind of changes how you look at an engine.
Yeah, that's true. A lot of times we look at the engine as, this one system, right? So
it's an engine.
It's an 8-cylinder engine. Most of us are working on pushrod V8s.
Right.
But the more we look at it, the more what we realize is it's not one 8-cylinder engine, it's 8 one-cylinder engines.
Yeah.
And as we start to try and manipulate the tuning and the delivery of air and fuel and spark to the engine, we find that those individual cylinders behave differently.
They're a lot like kids. And if you have a whole bunch of kids, they all have their own appetite and their own things that make them happy, things that make them mad.
They got a little personality.
Yes.
So all of them together are great, but they're individual. Right. And so our engine behaves the same way. So we decided to apply a little bit of technology and see if we could squeeze just a little bit more performance out of this 393 cubic inch LSX project engine. Right?
Mothering them along, right here. You gotta try to pacify them, make them happy, get the best out of them, coach them up a little bit. How can you know what their interest or
so one of the things that's a challenge is when we look at the engine on a dyno, we're really just seeing the sort of cumulative average of what all the cylinders are doing. And when we tune, we typically degrade the quality of the tune-up to sort of,
protect the worst behaving cylinder.
Yeah, protect the weakest one. So that means maybe that cylinder's got the right amount of timing and the rest are compromised a little bit, air fuel delivery, that kind of stuff. Well, what we wanted to do is separate the engine and look at each cylinder individually. And so the way that we did that is we actually took some combustion sensors. These are super high speed, high pressure. These can handle about 4,350 PSI of pressure.
Wow.
And it's tiny. It's only 5 millimeters in diameter. So whatever that is, 150 thousandths of an inch diameter, really small sensor.
Yeah.
Now what you got to do to use this appropriately is you actually got to drill into the cylinder head.
Yeah.
So what I did is I called our buddy Chris Straub and I said, hey, you know those heads that you got on this engine? Have you got any that maybe you screwed up?
More.
I just need one more. And of course he's like, what'd you break? I'm like, no, I didn't break it, but I wanna.
Yeah, we're gonna break it though.
So he sent us one that was like a blem casting or whatever.
Perfect, yep.
And what I did is I grabbed it and I took it in the mill and I started probing of where we could drill through the deck, the thick part of the cylinder head here, below the water jacket. And good thing we used a practice one because I actually penetrated the water jacket in a couple of these areas. But ultimately we found out where we could drill into the head here, and then we drilled and tapped and screwed in this little combustion sensor in all 8 of the cylinders. So now we can actually look at cylinder pressure graph data against crank angle and learn all kinds of things about the engine. So what we found immediately was the tune-up was really compromised on some cylinders over the others.
Right.
Now we could go in and use this cylinder pressure data and just track, for example, one point, which is what we call CA50.
Right.
So CA50,
that's crank angle.
That is crank angle.
So
it's
you
the
got
crank angle
crank
where,
angle and you've got pressure.
So it actually takes the data from pressure and temperature in the cylinder, and it calculates where 50% of the mass fraction in the chamber was consumed. Now that's a really good indicator of tune-up for us. It will generally precede the point of maximum peak pressure location.
Because it's only 50% of it being burned.
Correct. But what's nice about that is because it's integrated from all the data, it tends to average out some of the errors. If you were trying to chase an exact peak pressure location on every cycle, the engine doesn't repeat very well. It's such a cyclic sort of variation. You'd drive yourself crazy trying to always get peak cylinder pressure to happen exactly at one spot. So rather than do that, we look at that integrated value of
50%
CA50.
easier to find.
That's right. And so what we do is we target a location. For example, what I did is I started out and I said, I want all 8 cylinders to have the correct ignition event to give my CA50 value 7 degrees after top dead center. Now later I could go manipulate the overall timing to move it from 5 to 7 to 9 or whatever. But
because there may be some place where it's better to be that.
And we hope the dyno will tell us that.
But you can pick a place and say, here, we're going to get all cylinders to behave the same.
That's right.
50% burn at 7 degrees. You said after top dead center?
After top dead center,
Okay.
yep. So now what's wild is when we started doing that is we have our normal ignition timing table, and then we have trims. So there's 8 different ignition trims for each cylinder.
Right.
And then every couple hundred RPM we made spots to vary it. What's wild is how different the cylinders are from each other and how much they'll change over a range of RPM. You would think it would have some slope straight up, straight down. No. It'll be like add 9 degrees, and then the next box you might be taking away 2 degrees, and the next one you're adding 12. Like
literally 10 degrees spread of timing cylinder to cylinder.
And from like RPM range to RPM range. Like it's not a easily predictable, just put this slope in and it does what you think. And I think that's the hardest part to get your head around.
Yeah.
But it took several hours of continuous tuning and programming and uploading. But by the time we got done, it made a huge improvement on the way the engine ran.
I mean,
just that one data point of CA50.
39 foot-pounds?
At 3,600 RPM, we found 39 foot-pounds of torque.
Just on optimizing timing.
Yep. So now we always suspected that the engine needed more timing down low like that. The problem is when you get down low, it's real easy to have too much and make the engine detonate. So to be honest, you're just kind of scared to do that on the dyno.
Of course.
And so being able to look at the cylinder pressure and know for sure that it wasn't knock or pre-ignition.
You're not going to hurt it. It's say, I can put this much timing to it and it's totally safe.
That's right. And so that was the real advantage overall, and then being able to make every cylinder. And so the other thing that was interesting is you could see each cylinder's individual contribution to the overall power. Right, it'd be easy to measure one cylinder and go, oh, well, it makes, 50 foot-pounds, so 50 times 8 cylinder, well, that's 400 foot-pounds, right? But the reality is, some of them are making 85, and some are making 72, and some are making 68, and some are making 81. So having one combustion sensor in each cylinder allowed us to say, look, I don't have the ability to make every cylinder do the same thing because every cylinder doesn't have the same airflow. And we'll talk about that in a minute. But if I could just optimize the airflow that's there for every cylinder, make them all as good as they can be, first of all, it lowers the spread between cylinders, and it just makes all of them contributing the most. So I think from 3250 all the way to 7250, we averaged 11 foot-pounds of torque better. Which is a significant improvement on a naturally aspirated engine.
Oh yeah, it's a huge number on it.
And of course, that will pay dividends under boost as well, right?
And it's essentially free horsepower.
Absolutely.
If you have to change parts or anything, of course, the sensors themselves are very expensive, and this is software. But you buy it once, and then you can use it on everything.
Yep. So there's so much more you can do with combustion analysis than simply find the best timing, right? Like we can look at the amount of energy in the system being released over time. That's that CA50. We can look at the adiabatic compression and expansion curves as we log, as we show logarithmically the pressure and volume in the cylinder, which means we can go to our friend Billy Godbold and say, here's what it's telling me about my cam timing. It's saying, I can look right here at this point up there and say, it shows me that the intake valve is closing too late here because of the variation in cylinder pressure at each point at bottom dead center, at 10 after, at 20 after, and the same thing on the exhaust stroke. I can say, well, I can see in the middle of the exhaust stroke it has a lot of back pressure, or I can see that it has a low pressure area being caused by the pulse tuning in the pipe, but it's at the wrong time. And so as we start to look at it, we can compare what different header lengths and sizes and primaries do. And ultimately, for years, everybody's always said, oh, you need equal length headers. The reality is, you probably need 8 different length headers
Could be,
to make it just perfect. But ultimately, once we get it on the dyno, we sort of have what we have. But as an engine development tool, the combustion analysis is second to none, and we prove that on the Engine Performance Expo LS.
Well, what's cool is like you can literally take one header and run it on one side of the engine and run a different header on the other side of the engine and actually see right there. You don't have to look at the average of what the whole thing does. It's like, okay, what is this? What is that? And then you can still see how it behaves.
Yeah, we were messing around the other day doing some calculations in the software to calculate the torque and power in the cylinder, and we were blown away at how precise it was relative to what we could get from the engine dyno. It was unbelievable.
1 foot-pound?
Yeah, I would say between 1 and 3 foot-pounds worth of error, and, which is amazing considering the dyno is just averaging. You know what I mean? It's got power pulse inputs every 90 degrees. So I'm pretty stoked. I don't know how you feel about this, but to me, the effort that we put into it, we had to get a spare head. We had to, it was a lot of work to get in there and collect all that data, interpret it, use it to make a tune-up. But man, I don't know any other way I could find you 39 foot-pounds of torque on a naturally aspirated engine. Like,
no.
So you ain't gonna get there from here. So,
but what's cool is this is current NASCAR, current F1 technology. These guys have been doing this for a long time. I think back 2005 or 6, somewhere in there. I remember seeing stuff from GM that was doing this for NASCAR. So we're just taking that technology and making it available to you guys. What's really neat is we're going to be able to share with everyone what we're learning on this engine, because now it's done. this is just telling you about it is phase one. This is really cool, but the really cool stuff is going to come from what we share in years future
because
as we train things with the engine to see what it tells us.
Yeah, it's a development tool, right?
Right.
It allows us to make changes and isolate the results and understand where that came from, So, and the cost of this type of equipment has come down significantly. We're using that Plex PCA 2000 combustion analyzer. I mean, those things are about, I don't know, maybe $15,000 or something.
Right.
Traditionally, that was $80,000 to $100,000. The sensor technology hasn't gotten a lot less expensive yet. It's still fairly expensive.
Right.
One of these little 5mm Kistler sensors, they might be $4,500.
Right.
However, you don't have to buy one for every cylinder. You could simply move it around from cylinder to cylinder in the engine.
True.
And it takes longer and it's more tedious, but it's a way that it becomes, commercially affordable for the average shop that could do it.
20 grand, you could begin doing this for that much money. When reality is, for a tool that can measure that's amazing.
Pretty cool. Yeah. I mean, it's one of those sort of things that it opens up a level of information and data that's just never been available to us at this level before. If you're not some $100 million, Formula One or NASCAR team or whatever, you're probably not going to have access to this type of stuff. But now for, let's say, under $30,000 all in, a guy could outfit an engine and be gaining this kind of information. That is pretty exciting.
That is. Could you hook that up and run it in the car?
Oh, 100%. You could go right down the racetrack with this.
Yeah.
Like you can almost skip the whole dyno. In fact, that's exactly what we're doing on our project with the Sorceress Street Rod car, that twin turbo Pro Mod.
Right.
It's hard to dyno an engine like that.
Right.
It makes 5,000 horsepower. So we put sensors in the heads and we'll just take it right down the racetrack.
There you
That's
go.
pretty cool.
You see, that's why we come to hang out with this guy. It's always something cool. I literally walked in yesterday and I had some really cool information I thought was awesome, and I saw the results of this, and I instantly realized what I had seen yesterday was not cool.
rained right on your
cool.
parade.
Oh, it's like a downpour, But that's why we do this, and so hope you guys enjoyed watching this segment. So let's talk about it some more.
Back here at the Engine Performance Expo, got a roundtable discussion, but we've also got people commenting out there on YouTube, and we encourage you questions throughout the day. I'll hit the panel with them a little bit, and stay involved. We want people to be as involved as is possible, especially in these roundtable discussions. One person saying that their brain is already melting in the morning.
Good, job done.
And I appreciate it as well. I just love this stuff. And we encourage you to share and subscribe, and let's get this out there as much as is possible. But I do want to take a second before we introduce our panel to thank the people who genuinely make it possible. Of course, we're here at Straub Technologies, and so this great studio facility is available to us. Thank you very much, Chris, you and your folks. But Driven Oil, of course, on board. Rottler, of course. Mala involved. Folks at Goodson heavily involved. And we've got, next door, you're seeing like the eye in the sky view of what's going on out there in the machine shop. It's like a whole social scene out there, and racers are hanging out, networking, and exchanging ideas. It's great. There's a product display, of course. Comp Cams, Edelbrock, Get 'em Performance. We're going to learn a little bit more about those guys later on today. Total Seal, of course, we keep saying Rottler because they're so heavily involved. Making chips over there in the other room. CWT, that's Randy Neal's company. Super excited. Valvoline, Holley, EFI. Oh my goodness, without Holley, EFI. Think about all the stuff that they have done over the years. Morel Lifters. How great was John Callies yesterday? Awesome. We tricked him so badly.
We got him. That was great.
He won the Lifetime Achievement Award yesterday. He thought he was presenting the award, guys. He's like, I'm going to present the award to somebody, and he was the recipient. And, of course, his Morel Lifters and Straub Technologies. Guys, thank you so much for supporting the Engine Performance Expo, and to everybody out there watching and viewing now and in the future. You might not need these products now, but when you do, remember how involved they were and how they made this possible.
Exactly. So, with that segue, look at this panel. This is awesome.
George Bryce is back. He's rocking his plaid. Yeah. George's is like a fashion plate, of course.
He's an fashion icon.
Mark
got the moon
Conquest,
eyes
Billy
on.
Godbold, Ben, of course, who's a star celebrity. And then there's Lake. Somebody says, sit on your hands, Lake. I disagree. I would not understand you without the...
I can't speak.
I wouldn't understand what you're
I
saying.
have no Italian. We've done all the 23andMe and all the ancestry stuff. My wife's got like 20% Italian. I got none. But you would not know that by the way I talk with my hands.
Yes.
Right?
Well, good. Because you're changing the stereotype. It's not just us.
I need a helmet over there.
Yeah, George, you watch out.
You got the Ricky Bobby gene that you and I share.
Yeah. But anyway, I'll say this. after that last video, doing all the work with combustion analysis, Ben, you have absolutely ruined me now. The dyno is not fun without in-cylinder combustion analysis.
Yeah, unfortunately, that's one of those things that after you do it, you go, well, I don't want to go back to tuning engines the other way anymore. You know, it's not practical to do it for every single engine, but boy, you sort of wish it was, because it's a game changer for sure.
I remember the first time Mark showed me one of the results back when you were doing the RO7 engine, and I was like, oh, this is kind of neat. But then to actually hands-on and do it, it's like, oh, that's so good.
Yeah. What Ben just said, though, it's not practical to do every engine. Like we do very seldom do combustion analysis. We do it on a new engine, we do it on a fuel change or something like that, but our stuff is so common, so that
you're building
the
identical.
little changes we're building identical. We use the same manifold,
Right.
same. It to us, tuning a carburetor is very hard to do with combustion analysis because it's the things. As bad as people don't like carburetors, they're pretty simple and they work pretty dang.
Yeah.
They're
pretty
hard
darn
to
good.
beat.
Yes, and it really doesn't need. You can't learn
Right.
that much doing combustion stuff.
So you
on-
guys do it like if you're trying to move the ball, right? You're trying to develop new parts or
Yes,
something.
exactly. But we don't do it on our Xfinity motors. We probably haven't done it in 5 years. It's the same package. It's probably been longer than that because same manifold, same carburetor, same fuel, same everything. So
Pretty hard to imagine something
it's-
changed,
yes,
right?
our biggest thing we like to do with is individual cylinder camshafts.
Sure.
What the cylinder's not working, this one is working. What are we going to do with cam timing and
Yeah.
doing stuff like that?
Well, talking about fuel is a huge market. You know,
Yes.
think about like a couple years ago, the 400-inch Australian Pro Stock guys. You know, they went from all
Oh,
leaded
yes.
fuel got banned,
Yes.
and suddenly everyone was like, "Whoa! Now what do we do?" That was a huge deal for them. But like you said, now that they kind of have it figured out, it's like I don't have to do it all the
Right.
time. It's definitely more of a development tool than
Definitely a development.
It's not going to replace your dyno.
Right.
You remember back in the day when we first got our very first wideband, our very first NTK sensor for air fuel ratios, and how revolutionary that was in that moment.
Yeah.
And then when you got 8 of them, it was like, oh my gosh, we're going to win every race now, and I hope nobody else can have these. We're the only guys with these, and I was part of the when Superflow first came out. They had a pretty heavy wheel
Yeah.
with the teeth on it for us to keep up with the crank angle, and that was pretty scary because we had those come loose in the dyno room and stuff like that, and the sensors cost $1 million, it seemed like, and they got broke or burnt up quick. But nowadays, man, things move so fast, and it's very interesting to see when you got it going the way you did on this video, and you and I talk about it sometimes. It's been very intriguing to see the potential for the future now with different tools than we've never had before.
It's definitely a way to learn a lot about engines in a really short period of time. I mean, and like Billy, you and I have had lots of conversations. I don't know, to be perfectly honest, when I first started doing combustion analysis, which in fairness was a long time ago, but I don't know that I realized that it was so connected to camshaft. You're looking at the 4-stroke cycle in terms of pressure, and you're over here going, oh, well, you can see that's closing early and that's closing late. Like, there's just so much to be gained in knowledge of how the engine works and what's happening that goes beyond just like tuning the laptop sort of thing.
Right.
Yeah, I don't think that, some of those things when you start looking at components. So if you go in there and you're going, okay, well, carburetors make power, headers make power, intakes make power, spark makes power. There's all these kind of things. You go, oh, these things are making power. But really, the only thing that's moving your vehicle down the track is pressure. So fundamentally, you're trying to make pressure during that stroke that pushes the piston down, that drives the crankshaft, goes to the transmission, gets to the tires, moves the vehicle.
We start with pressure and then we lose as
Right,
all the
exactly. There's all losses in there. So some of the times when you're doing tuning, you're like not thinking about what am I really trying to do. So, when you're doing a header, you're trying to get the pressure wave to come back there to create signal. And what's that signal? It's pressure. To create low pressure in the chamber, to pull the intake charge in. You're actually pulling the intake charge in while the piston's going up. So think about what that means. You have to have enough pressure. You're taking that blowdown, that sharp wave out, reflecting it in the collector, moving it back to the chamber. It gets there right as the intake valve's open, the exhaust is still open, the intake valve's opening. To have the piston coming up while it's pushing exhaust gases out, and to create such low pressure in there that your intake manifold wave that's gone up to the bell and come back is higher pressure in the intake port than there is in the chamber, so that it brings air in. You can model this, you can think about it till you're blue in the face, but until you have a pressure probe in there and actually see it, it's sort of paradigm changing.
Yeah.
And then when you start really thinking about what you're trying to do, all the magic goes away.
Yep.
You know, in-cylinder pressure just disrobes everyone. It's you know it well from the NASCAR thing. You know,
I
when
was
you
gonna
go to-
say, do all that, and then I'll put them on a common plane and let it all talk to each other.
Right.
Oh, that was it,
No,
man.
it was like crazy how they all talk to each other and how this one's robbing that one, this one's doing this one, this one's like, you know, it's like crazy how all that goes on.
It's like you said, it totally disrobed it, because you're like, well, now I can see we did a bunch of playing around with headers, and you're like, but if I change the header, then all of a sudden the intake on this side is changing. Like, how's that possible? Well, they're communicating across that
Right,
common
and you saw
plane.
that with the two headers, right?
Absolutely.
You put all one length on
Yep.
there, it does one thing. Put a short one on this one, long one on this one, does something. Swap size, it does something different. Put both short ones on.
Yep.
Anything you do does different. You're always robbing. And then you get with the, like your motors, the 670, the 510 stuff, you're restricted in the amount of air. And you start looking at it, you go, man, that cylinder's really weak. This cylinder back here is down 5 horsepower. I'm going to get that 5 horsepower back, and all of a sudden I'm going to be up 5 on the whole field. You work, get 4 on this one back, and you're like,
you lost
well, great.
4 on the other one.
But you're sonic through the deal, and you know there's only so much
Yes.
air, and you're like going,
Yes.
I've lost 3.5. So you did all this work, and you did pick up 4 horsepower here.
Yep.
But at the end of
But
the
it had
day,
to come from
you're only up, a quarter horsepower.
How many times have you made camshafts that got this lobe separation and this degrees, 2 degrees smaller in the middle, 2 degrees bigger on the ends, or opposite way of people playing with this and trying to get it in it?
Well, I think we saw that. Like we saw that recently. You know, what goes on in your world is
Yes.
super hush hush.
Right.
But I guarantee that nobody's running the same. And there's not a cup car out there that has the same spark timing on every cylinder. There's not a cup car out there that has the same injector timing and pulse width on each cylinder. Each cylinder is individually tuned. You can only do that with pressure. Well, the camshaft's the same way. So the thing is that it's not this huge difference. You know, it's when, if you're 10% off of where you need to be, you don't need to be doing individual cylinder testing.
Right.
But if you're 1% away, you know, if you're 1/100th of a second behind the guy who's winning the NHRA Pro Stock race, you better be looking at individuals.
Yeah, if you're a tenth behind, that's
if you're
not-
a second behind,
Yeah.
you
Not
know,
what you work
go
on.
home.
Yeah.
You're not going to find it. If you're a 10th behind, maybe you think about it. But when you're, when you're 100th or 1,000th behind, then you need to really focus on that, because there's power there.
Yeah, and I think that's a good point, George. I don't mean to cut you off.
No,
I think
that's
that's a
good.
good point that we want to clarify, that, you know, sometimes you get into this mode of, we get talking about all this cool stuff we get to do, and the guy out there watching is going, well, I can't relate to that. I don't get to do that. You know, it's like, I'm not trying to paint this picture that if you don't have this capability, you can't be successful. But what we're talking about is, man, if you really want to get every last little bit out of it, this is the tool that you're going to have to use
That's
to
right.
get there.
And another part that's really important, Joe, about all of that is the doggone rings. Because everything we're talking about is pressure, you know, and we have no pressure if we don't contain it. And you know, we spend some time on that, but once you turn your attention over here, that sort of sometimes goes away, and you got to have somebody keeping on that show too, so we can contain all those pressures.
Consistency there, right there.
Absolutely.
I can't tell you how many times one cylinder won't seal up and it could change the tune completely.
The whole
right.
engine.
Yes. It
Even
won't.
vacuum in
Yes.
the crankcase changes the
Yes.
jetting requirement.
Yeah.
That blew me away. I'm like, that changed the jetting, and all we did was change the vacuum in the
Yep.
crankcase? I couldn't believe it.
You know, and then you fight this other thing too, where you spend all this time getting it just perfect on the dyno, and then we got to take it out to the racetrack, where then it's not the same anymore.
No,
right?
Same.
got G-force now.
Yeah. So,
Which is a lot harder in carbureted applications than fuel injection.
yeah.
Like what people do, you know, like all this individual cylinder tuning that we're talking about, you can probably do that on a good dyno and take it to the track and be fine. If you tried to do that, you know, on a steady dyno and took it to a drag race track, man, it'd be all, and carbureted, it'd be all over the place.
Yeah.
You would almost have to do the tuning at the track with all that equipment in a car, which isn't as easy as you might think.
No, but I'll tell you, that's something we're starting to
Yeah.
see more of.
Yes.
Even at the semi-professional sportsman level, NMCA, we see a lot of cars now that are going down the track with combustion sensors installed. You know, and now you know you can't rules-wise, you can't like go out there and race and have it be actively controlling the
Yeah, I
engine.
think NHRA got mad about that, right?
Yeah.
You know, you couldn't have the combustion sensors in the Pro Stock head because, hey, you might be tuning it going
That's
down the
right,
track.
yeah. But to go out on a test day and collect a bunch of data, like that's a really, really valuable tool to have.
Have it in
so.
the block. Yeah.
Here we go.
Here we go.
So this is
That's a great point. That's a great point.
Way too long.
You know, speaking about that common planar manifold and how it can affect things, Rick Fred made a great point when we were talking about Dad's engine and how it was so far down, right? So roughly 700 horsepower brand new to 480, and we said, okay, there's 2 cylinders that are definitely hurt. We know the ring seal was bad. There was micro welding of the ring, so we know they're hurt. But you do the math, like, well, 2 cylinders isn't 200, 300 horsepower. Where did it come from? Manifold,
It's
right?
because those 2 cylinders also affect the other 6.
Yeah, everything gets affected by it. It drags the whole thing down.
If the rings ain't, basically the rings are what's pulling your fuel, right? I mean, people think about compression, but it also works the other way around.
Sure.
When it's going down, it's helping pull the fuel. So if they ain't pulling, that means the intake ain't doing it what it's supposed to be doing.
Right.
Now it's messing up the rest of the world. How we spend so much time working on these manifolds and doing this. If one thing's off, it messes that whole deal up.
Exactly.
And George, those low friction rings you guys run, when you take away the crankcase vacuum, they don't seal, and that's
As
why
well.
And the fuel, I tell you, what George said a minute ago, pan vac is a huge difference on tuning, because if you don't have your pan vacs down, that means your rings ain't sealing good, and it's not pulling on those intake ports as good, and it just goes to pot after that.
But it's funny, if you had the ring that they ran in your dad's car, it probably wouldn't have changed as much because those weren't those low friction rings at the time. That was probably a much thicker ring, a much higher tension ring.
Yeah, the old ones
And
that
it
came
probably
out were
didn't have near as much
043s.
feedback.
Right,
either,
right.
you know.
And it probably, and that's the thing is like you'll see people, like you'll go, I'm not going to name names or say shows, but you'll get some TV show that people watch and they run different pan vac and don't see any different power.
I know why.
But yeah, of course you don't. You've got a ring that's thicker than
Half-inch
thicker than my
thick ring,
belt,
yeah.
and it's like, of course, it doesn't care because you didn't change the seal at all. Then it's just a little bit different in power.
People, our audience, okay, they don't look at it with the same vantage point you guys do. Just like you said a minute ago about having 8 different ignition curves for the 8 cylinders. A lot of folks watching this have no idea what that means. And it's also with in-cylinder cylinder measurement. Having one, if a guy can buy a cylinder pressure monitor equipment, he can buy one. And that's like having one wideband and a V8. You can get some information, but it's not. But I just wanted everybody that's watching to realize this is pretty unique. And it's also, when you have everything you need, this is what you need to do next.
Yeah, and what's frustrating about all this is how the engine is this like maddeningly, complex series of dependent events, right? So I'm over here hyper focused on this one thing and I get it just perfect, not realizing that it was affecting 10 other things in the engine. And now you got to go, okay, I'll get this one right. And you're just constantly like, I feel like it's the domino effect. You move one thing and they all go, you start all over again.
But now go up 500 more RPMs and they'll do it again.
Right,
Yes, sir.
right.
And a different
the
one
good thing
will-
behind why they have 10-speed transmissions and stuff. Now we can fine tune this torque band and
Really
fine tune this
narrow
power
range.
band and get going. That's one thing in like the NASCAR stuff where like on the Xfinity stuff they took away shifting. They made the gear read. So
Okay.
now we're 5,500 and 85. That's a whole different ball game than it is 7 to 8,500 because now you get to tune this in. Now you're a lot further spread and it's like changes a lot more.
Well, and I don't think you could overemphasize, George, you were talking about having 8 different spark maps, and I was thinking, there's 40. Like we have
Okay,
a different spark map. There's a different spark map for each cylinder, but also for each gear,
RPM,
because I don't think people have enough understanding of how much the rate of acceleration actually affects the tune-up as well, So you end up with 5 gears and then 8 cylinders, and you got it just gets crazy.
And some of the
complex.
rate of acceleration is 2 different ways, right?
Yes.
One of the rate of acceleration is just how quick you're going through the RPM. But when you're in 4th and 5th gear, you're actually loaded more.
Yes.
So people don't get this, that when you spark that plug and then that pressure happens, it tries to move the crankshaft out of the way, which stops combustion. You don't stay combusting as long. but then you load the engine harder, and then all of a sudden it can't push the piston out of the way as easy, and you actually get better combustion. That these engines make more power when they're loaded harder than they do when they're loaded light. And that sort of thing just sort of blows people's mind, that you've got these 8 engines all connected by one-cylinder engines connected by a crankshaft, sharing a plenum on one side. Half of them are sharing a collector over here on one side. Half of them are sharing a collector over here, and they're doing all kinds of crazy things. They're moving through the RPM at different speeds, and they're loaded. How much they're pushing against changes.
Yeah, I think about your stuff going down there to Mexico, and the guy runs over a cactus, and now one header's the collector's dented or whatever.
Crashed, wiped off, gone.
No longer.
Exactly right. Or the air cleaner. I tell you, the biggest thing out there is we plug up air cleaners.
Yeah, they get so much silt and dust.
They get to where they're pulling. We'll look at KPA, and if it's 99 down there because we're at the ocean, we'll get down to 78.
It's that plugged
It's up, and then it just completely
You're
changes.
back to plate racing again, huh?
But I'm gonna go on a little pet peeve here, because a lot of people don't have cylinder pressure data.
Fair enough, yeah.
Whatever you're doing, drag racing, oval track or nothing, when you go to the dyno, use the acceleration rate that you're going to be racing at.
Yep.
Because you can go tune up and I'm going to do 100 RPM a second. That tune-up is going to be completely different if you're at a quarter-mile short track or a half-mile oval track race.
Yep.
There's no such thing as 100 RPM acceleration rate. You go do your timing and all that stuff, quit doing that. Figure out what your acceleration rate is. It's pretty easy. If it's 250, if it's 500, dyno at that.
Yep.
Because if you don't have, at least then you're tuning up. You get the torque meter, you get this, you get to look at those RPMs, that timing, that stuff like that.
Right. Yep.
You'll be a lot better off than going there and going, oh yeah, look, I made this big number.
Right.
Quit worrying about that number. Look at what you're racing at and tune to, if that's what you only have. You know what I mean? It's very important to me that
I would say even if you have combustion stuff, you should
exactly.
be tuning that
Still
way.
do it. Because what we said, gear ratios are different.
Absolutely.
So you need to do it at, when you go through the gears, the 1, 2, 3, 4 gears quick. 5 and 6 are slow.
Well, that's the thing we saw. As the cycles, you're looking at each cycle, they're not all the same.
No,
even the same cylinder, it's not the same cycle to cycle to cycle. There's leftovers, there's crosstalk, all that. So, like you said, the speed at which it's happening is going to affect how much leftover and crosstalk there is. So, if you're not doing it the right speed, you ain't getting it right.
So one more quick morbid story.
Okay.
When I die, I'm being cremated, and Jason Lyons going to be pouring me down a motor.
Okay.
Right? And Randy Dorton asked me one time, he goes, why do you want to do that? I said, I want to see what it looks like. He goes, why? He said, 25 RPM later, it's going to look different. I said, I want to see what that RPM looks like.
I got my shot, though.
He goes, but then he goes, you're going to wreck that motor. I go, I want to wreck one more on my way out the door.
That's great.
Yes, they all look different. Every RPM looks different.
In every cycle.
Every cycle.
Absolutely.
And that's where we'll conclude this round table. Now my brain is melting as well. That's a nice share. Thank you, Mark.
Yeah, well, I look forward to being there for that.
Yeah. Can we make that an event in the expo? Like 20
yeah.
I hope
Do
it's
it right there.
I hope it's a long time away.
I don't care what motor it is. I just want to see what it is as I'm going out the door.
Oh, it has to be something good.
Oh,
I was going to say, I'll volunteer the dyno for
Okay.
you. So
Wow.
There you go.
That was
it's
interesting.
now an official event. I hope it's not soon, though.
Breaking a
Not
lot
me
of
neither.
news. A long time.
Yep.
But reason to subscribe, because you never know what's going to go down. All right, we're going to throw it to our next video at Keebler and Lake. You guys are going to do a product demonstration in this next one. We're going to keep on trucking here at the Engine Performance Expo. Remember, subscribe, click the bell, let your friends know. It's a beautiful Saturday. We are live here at the Engine Performance Expo, and we're going to keep on trucking.
Okay, Ed, we always talk about bore geometry and how it's so important to have the proper clamp load so that you simulate what the engine's actually going to see, what that cylinder is going to see in the engine. Now, you were showing me something earlier when you were honing these cylinders that was, I thought, a perfect visual example of what's the difference in that bore geometry in the free state versus the stressed straight, right? So why don't you show us what you were demonstrating to me, because it was like, wow.
Yeah,
to see it just happen is just like,
Yeah, it's
man, that's crazy.
It's crazy. So let's take a couple of readings here. We're gonna go in and we'll try to move this dial bore gauge relatively slowly so you can kind of see the needle peak, and we're right there at 0. Right there at 0 in the middle.
And this is a honed cylinder, so we know that we've been working the best we can to get this thing as straight and as round as possible.
And so we're 0 at the bottom. Now we're gonna go roughly 90 degrees. We're trying to keep it to where the camera can see it, honestly. So
Yep.
you can see that we're pretty close to 0 there. 0 there. And maybe a 10th tight there at the bottom. Now
And that's the cylinder in the fixture loaded.
in the clamp state, right, is what I would
Okay.
call it.
So now I'm gonna grab a wrench and you're just gonna take the pressure off.
All I'm going to do is take the pressure off, which is, you can see, is really a quarter of a turn. So you can see that we didn't load that terribly tight.
Yeah, it's still there. All right, wait for it.
Now we're going to go back in, and we should be pretty close at the top, and we're going to be
Whoa, there we go.
8/10 tight now in the middle. And then we get to the bottom,
Whoa.
and we're thousandths and 3/10 tight.
Whoa.
But then we turn it 90 degrees, and we're 0 at the top. We're big now in the middle by a half a thousandths, and we get at the bottom, and we're big by 8/10. So we go from 8/10 big one direction to 1/10 and 2/10 tight the other direction. So there's 2 thousandths out of roundness at the bottom of the cylinder on that spigot now.
Just due to clamp load.
Clamp load.
So there's your 101
Yes.
on board geometry and why torque plates and clamp load is so important.
Everything. You're right.
Well, you hear about, Chuck Lynch, talking one of our previous things, and had a great article he wrote in Engine Professional magazine about, hey, when you're putting your torque plates on, you need to use the same gasket you're going to run, because it's going to make that difference.
Same gasket, same thickness,
Same studs.
same lube.
Yeah.
Is it bolts or is it studs you're going to
Right.
run with? All of that stuff plays a factor.
Right.
And really, when you get into this stuff, this is what really
Yeah, yeah.
accentuates it here.
Right, yeah.
Now, this
so
is
your
worst
air-cooled
case
stuff.
scenario.
Yeah, air-cooled, like I said, because of the nature of the design of that cylinder,
Right.
it's the most challenging.
Yes, absolutely.
So,
Yep.
anyway, hope y'all enjoyed that little sneak peek, a little 101
Yeah.
on clamp load and bore geometry.
Hidden horsepower on location at the Engine Performance Expo. Celebrity engine builders and the rock stars of the engine industry, brought to you by Total Seal Piston Rings. I'm Joe Costello, Lake Speed Jr., joining me, and today we will be joined by father and son NHRA U.S. Nationals winner, father and son world champions Greg and Aaron Stanfield. Gentlemen, welcome.
Thanks for having us, Joe.
Yep, thanks for having us
Super
here.
excited, Lake. These two out there on the NHRA tour, they're very interesting characters in that they talk on the racetrack, right? Kind of mild-mannered, but they get it done. Greg, a 5-time Superstock World Champion, 1 Pro Stock U.S. Nationals. Aaron, 2-time Factory Stock Showdown Champion, has won the U.S. Nationals. And Greg almost walked away from it all, which is the best story.
Really?
Aaron dragged him back in. You were done. Tell that story.
Well, obviously the pro stock career took the toll on me, and Aaron was young and in school, and I was hoping he would get in the business world and see things, what he wanted, and he kept coming back to the shop, and it was in his blood, so he drugged me back in, and here I am.
We might be deeper than he was.
Yeah, you guys are much deeper. Talk a little bit about that, though, Aaron, in that your dad had this arc of his life and his career, and he did, have great success, but he was kind of, feeling done. And that's right as you're coming online, and it's like, hey, Dad, no, Dad, I'm just getting here. I'm just getting to the point where I can be involved and I can drive, and you can't quit now.
Yes, right around the time I was, in college, and I was like, man, I really want to do this. And that's around the time I was starting to get in the car and get to drive, and Yes, it's just he's always been my hero. So he's he's grown up and he's driven them. He's built them himself, and I guess growing up in that world, it's something I've always wanted to do. So we had the perfect opportunity to do it. We had to buy some equipment back and kind of get back in the engine building business, but it's been great.
Yeah, in the immortal words of Godfather 3, like just when I thought I was out, they pull me back in. They pulled you right back in.
I can say, as going racing with my dad has been the best thing. It is so cool. Working on things, making some more horsepower, getting tuned up to the racetrack, and go out there, winning some races with your dad. That's good stuff.
It's great. As I've gotten older, we favor each other. We work really well together. So
Yeah.
He's hard on me.
Is he
Well,
done?
it's the thing that you don't have to ask. You don't have to think, right? It's like me and Dad can go to the racetrack. We can work on something, and we don't even talk that much because you just intuitively know what he wants, where he needs to go. It's seamless, right? So I'm sure that makes
It really is. It truly really is. Yeah. He just lets me know when I'm off. I'll bring it back in, so.
Obviously, I'm young and I'm very passionate, very motivated, and it's cool to be able to push him maybe harder than he might want to go. But
you decide to climb the high mountain. Pro stock racing, that is not for the faint of heart.
yes,
Well, so what's interesting is that these two are some of the busiest people at any given weekend at an NHRA national event. Certain ones. Aaron's pro stock career just getting started. Of course, drives for Elite Motorsports, but he is a driver in that situation, running for a team. But at the same time, and at the same races, they have got their client cars, and he drives in Factory Stock Showdown, which means he's driving in two categories. He's tuning multiple client cars. Your dad might be running super stock at the same time. There have been times at the track where they have been literally cars on track every other session. Like, these cars to the lanes, Stanfields are up. Next group, Stanfields are up. Like that's got to be very challenging to manage. In our roundtable yesterday, just thinking about engine assembly, you can't be distracted. And there are a lot of distractions at the racetrack. How do you manage all of those different things? Clients, categories, different rules, different leaving on the starting line sometimes when you run top dragster. There's just a lot going on, and you seem to manage it so well.
for me, it's just maybe I'm young and I don't know any better, but I just kind of, when I get in the car, I just you got to focus and kind of block out anything that was happening right before you get in the car. And there is a lot of distractions and a lot of different obstacles, but like I said, that's something he taught me. When you get in the car, you got to slow everything down and focus on what you got to do.
In passing, we'll pass each other a lot at the races, and he'll stop and says, "Dad, is it going to be okay?" Keep working.
Yeah, keep on going, keep going.
Well, what's amazing about Greg is, he was a 4-time Superstock world champion, and was kind of on the sidelines, and that was like a good number. And then, the kid goes out there and wins a couple, so he comes back and wins another world championship. And so last year he defended the title, finished second, and was lamenting that a little bit. And you said it, the racers remember their failures. Not that second is a failure, but it's not what you wanted. And you just ticked off like 5 different moments in your life career where you were a whisker away.
Whisper away in a lot of classes. Stock eliminator, finished second. Competition eliminator, second. Pro stock truck, second. Pro stock, second. So I know what second's about. So I'm more about fixing losing than winning. So
Yeah, but you had the world championships in all those seconds, and you think about that resume, all those years, that's 10 years worth of first and second. Like, that's insane.
been blessed. Been really blessed.
And I wonder what makes you so good in the cockpit of the race car and what makes you good in the engine shop. Is there a relationship?
I think so. There's ability to, to focus at the job at hand. I mean, that's kind of the thing you got to do when you're driving a car. It's just the ability to concentrate and, slow things down and just
Fix your mistakes.
I'm a guy that likes to learn from his mistakes. So if I make a mistake, that's more in my brain than what I did right. So that's kind of how I tick.
No doubt. That's where it teaches you. Right?
Yes.
They stick with you.
And you learn from your mistakes. I mean,
Yes.
a lot of things, even in engine building, you learn from your mistakes, and sometimes mistakes make you better. So
Absolutely.
Aaron, does your dad ever get angry?
No.
Right? Like, he seems so within the tolerance, like the highs are not that high. Like, yeah, man, we won. That's really great. And
guess-
we lost, man. We got to fix that next time. It's kind of a bummer.
I guess that's kind of both of us people. I've won races, and they're like, man, you don't seem excited. I don't know. We're just very
Even keel.
That's
even
what I
keel,
told him. I
yeah.
said, Aaron, there's so many peaks and valleys in motorsports. And you got to learn to take the valleys with the peaks. So you just want to just be like this, just straight, just keep yourself even. That way the highs aren't too high and the lows aren't too low.
Bingo.
That's
That
just
is it.
And that happens in engine building. There's a lot of times when you build an engine, and I can speak for everybody that builds engines, you build this engine, think it's the best that you could put together, you put it on the dyno, and it's not what you want. So it's just a matter of picking it apart, seeing what's wrong. Just don't peak too high, peak too low.
Interesting. So Stanfield Racing Engines has been on the forefront of a category that's not new anymore, but is greatly appreciated, which was Factory Stock Showdown. FlexJet's coming on board as the sponsor this year, and Aaron has won a couple of championships. They've got a ton of clients, and this is supercharged factory part small blocks in 3,500-pound cars on a 9-inch wide tire with an automatic transmission. You guys saw that, and when that category was introduced, like a laser went all in on that with development. What was it about that category, about the concept that got you so excited and you decided to go all in?
For starters, we've had a lot of great people around us, and Stephen Bell really pushed us to wanting to get into that class. But what we saw is my generation, they know what a Coyote engine is, they know what an LS engine is. So for me, it's a lot more relatable than a lot of other things, and I think it's just that relatability. You know what I mean? It's essentially a street car engine that you're pushing to the absolute limits, turning it 10,000 RPM and making a lot of horsepower with.
So, Lake, that typically, not always, but engine builders will specialize in a manufacturer or whatever. So they've been building Chevrolets, and there was some discussion about the Coyote with the 4 valves per cylinder versus a 2-valve small block style Chevrolet LS, and there was a little bit of a rivalry about it. So what do these guys do? They go out and build a Ford, and they're going to get to the bottom of it, right? Like, well, at very least, we're going to figure out the ins and outs of both, and that way they have a genuine knowledge of what the differences are.
Well, that's the racer mentality that does that. I mean, back in the NASCAR days when the Ford came along, everyone was running the 23-degree Chevy, but of course they were laying them over and doing that kind of stuff. Well, the Ford came out and it's like, wait, this thing's out of the box can make 700 horsepower. Well, we better go build some of those and find out what's going on. And then it's just that competitive race. And, as we'll call it outsider from the NHRA side looking in, it seems like the factory showdown stuff is kind of like the pro stock of the old days.
Absolutely. Factory parts.
Yeah.
Basically is what you're working with.
And you got these big rivalries, right?
Yes.
It's you
the
guys,
Fords,
the Bartons,
Chevys, yes.
and all that, and y'all are just duking it out, and it's everyone just keeps.
It's good competition.
Oh
Very
yeah.
good competition.
And there's ego involved.
There's no ego involved in drag racing.
I see the ego involved. Well, and so this year, it was supposed to be last year, but sometimes things take a little bit longer. There is another new category that I think people are maybe even more excited about because there's a Liberty involved, the clutch involved. Why don't you tell us a little bit about what's coming with Factory X?
Factory X is going to be 1,000 pounds lighter than the current factory showdown cars. We're going to have a 5-speed with an 8-inch clutch in it. So it's on a 10-inch wide tire. It's probably going to run in the 6s over 200 as estimated DTs and speed. It's going to be fast.
That's going to be really fast.
And it's going to look like a street car.
It'll be a factory looking car.
So that if you wanna, so I love Pro Stock. I know you love Pro Stock. It's its own thing. My opinion is that 500 cubic inch Pro Stock is like the pinnacle of naturally aspirated racing.
It is.
Right. This boosted engine, similar or the same to what's in the Factory Stock Showdown, factory parts, but with slammed on the ground, absolute identical to factory bodies.
It's a breed between pro stock and factory stock.
Yeah.
Cool.
Yeah, good OEM war. Yeah. We're going to go after the Dodges and the Fords, so it's going to be good competition of all of us going at it again.
And Greg has got a car coming out like tribute car to the original Rod Shop. Like,
Nice.
yes,
Yes.
You have decided to go back in. So that's you getting reeled back into going fast again. Talk a little bit about the category, the development. I know everybody is excited. If you're not knowledgeable out there, this is something you're going to want to see. There's going to be some exhibition runs early in the season. Cars are just being built.
Okay.
There was some time spent with the rules package. Like, what are we going to allow? We're going to allow carbon fiber bodies. We don't know. Get us up to speed on some of the decisions that they made and just the pull of this category, like why you guys wanted to continue to be involved.
right now the car is going to be stock quarter panels roof. You're allowed to have carbon fiber doors, carbon fiber front end, but it's all going to be replica parts taken off of a stock car. So the overall body of the car is going to be stock dimensions as Aaron's factory stock car. So that's, and the carbon fiber weight is going to allow the weight to get off the car, obviously, because the cars are extremely heavy.
Tube chassis.
Tube chassis car.
Okay.
And I think long term down the road is the cars are going to be light enough to where if the electric side of it comes in, they'll be able to put those in those cars.
Yeah, and I've heard that that's a possibility.
That's a possibility. Yep.
Are the engine rules will be the same as factory showed up?
It's the exact same platform.
So
You'll be able
okay.
to take your factory stock engine and put in your factory X car.
That's exciting.
Yes.
This is really cool. So Gainesville will be exhibition, or is that actual?
Exhibition is going to be at Charlotte and Bristol
Charlotte
next
and
year,
Bristol.
and the first race I think is at Norwalk, 6-race series.
Okay.
So with the championship, I'm assuming they're going to have next year's what they're saying. So
All right.
Bristol, another reason to come to Bristol.
All right. So the Charlotte Spring.
Charlotte Spring.
Both
And then
Charlottes,
okay,
actually. They'll,
okay.
they'll be in both Charlottes.
Yep, I think we race.
That's good for me.
We race in the factory X will be in Norwalk, Topeka, Brainerd, Charlotte, St. Louis, and Vegas is going to be the races they're going to be at.
Super exciting. So, Aaron, you run Pro Stock, and that is so intense. I want to talk to you a little bit about your upcoming season, but as a driver engine builder, you're excited by Factory Showdown, you're excited by Factory X, you're excited by Pro Stock. There are people who are like, well, Factory X should become the new Pro Stock and get rid of the old Pro Stock and just have one thing.
No.
I don't want that. I love it all. I think we've got the room, the space. It's different. They're all different, unique aspects to it. Can you kind of explain the range? It's a spectrum of different cars, but they're all cool. Why are they cool? Why do you like them?
There's a reason why Pro Stock ended up, where it's at today. So I think it would be wrong to take away that development over a long period of time. But I don't think either will replace each other or compete against each other. If you know what I mean. I think they'll probably
like to
remain.
run
There needs to be a place for all out.
I'd like to run
Go
against you.
for it NA engines, right? That's the cool thing about a Pro Stock. I mean, it's
natural.
all out, naturally aspirated. Go for it.
Yes.
I mean, I think probably everybody would say
Yes.
you'd almost rather have less rules on the engine so you could do more. But we know
That's
it
Pro
costs
Stock.
a lot more.
That's Pro Stock. You can't take that away from Pro Stock. I mean,
That's the DNA of it, right?
Yes,
Is just
that
go
is-
fast.
This is more of a factory side
Yeah.
of racing. So you can't, it's
I think they're very different.
very, very different categories. And I think this will bring new blood into our sport. New racers, new engine builders, just more people into our sport of growing it.
And you've seen that already.
Yes. And that's what we need. We need more people, building engines, into the new class. So.
The Camaro, the Dodge Challenger, and the Mustang. If you think about how many you see, they're all sexy cars, whatever you like. Like they kind of brought the muscle car era back.
Yeah.
Like those three cars in particular. I know there are a lot of people that enjoy imports as well, and that's great. But in this particular scenario, but I don't know if you heard Greg say, I'd like to run against Aaron, right? Like their Factory X is where that can happen.
Take a little weight out. Maybe I can be as fast as him.
Yeah, or feed him a big
You never
meal or
know,
something.
man. We might do that one day.
What about it, Aaron? Running against your dad? Like that's something that I don't think it's happened, right?
It's happened in sportsman ranks, but never in a heads-up category. I think it would be pretty cool. Pretty cool to be able to share that with them.
I showed him our Pro Stock license on the way here.
Yeah.
You never know.
Still got
still
it.
got
You never know,
Still
Joe.
got it.
You never know.
What is that? Is that some sort of a tease? Did
never
we just
know.
break some news right now? I would love to see that, Greg.
never
You know
know.
that. Greg's the first guy I ever put a WFO sticker on his Pro Stocker back, was a big supporter of my podcast. Like early on, was there when they won the U.S. Nationals. Just amazing stuff. And to see him go through his career arc and long retirement and then come back.
Got my eyes fixed.
Short retirement.
Never know.
That's it.
Well, I remember in the early
already-
days of the Joe Gibbs oil, right, the driven stuff, and CV Products, we had to put duct tape over the labels, right? Because we weren't an official NHRA sponsor, but CV Products was our distributor. So we would take the 5-gallon pails of XP0, which was the Go Fast stuff back in the day. We put black duct tape over it and then go and deliver it, And he was like, heating that stuff up. You got like 200 degrees on the oil temperature. It's like, okay.
That's awesome.
It was fun stuff. That was my introduction to pro stock. It was in the early days of the oil stuff, and me and Mark would go to the racetrack. Remember, talking to Grumpy and everything. It was awesome. Yeah.
Yep.
Grump. Wow. So Jason was in yesterday, and we talked about pro stock, and he didn't like even the rules that they have now. The 10.5 rev limiter. Like, he wants nothing. He wants full development. He wants Formula One of a naturally aspirated engine and pro stock on a quarter mile. It's pretty much what he wants.
And when I raced pro stock, that's what it was.
Yeah.
That's what it was.
And
if you thought of an idea and you were creative enough and you could make that idea come a reality, then you were rewarded for your work.
Yep.
And that's what pro stock was. And I understand having to put rules on it to try to keep a harness on it.
On money.
To where things don't get out of control. To where if this team's got a $10 million budget and this team like myself doesn't have that kind of budget, where it'll be a runaway train. So sometimes you do have to pull that lease back.
Well, then people lose interest, right? Like the $10 million budget, they're winning 5 or 6 years in a row because they've got unobtainium.
Yep.
Then the people kind of walk away. And that is what happened. Meanwhile, this year, we had one of the most exciting years of Camping World Series Pro Stock ever. You had a great year. Talk a little bit about it.
We did. It was really tight racing all year long. Erica handed it to me a few times, more than a few, but
you got some licks in there.
Yeah, we've got some licks in there, but it was a really good year. We were, I finished third in all 3 categories I raced, so not exactly what we were shooting for, but still a good year. But pro stock, being able to, my first goal in getting in the car was I want to win a pro stock race, and it's quickly turned into we can compete for championships, and I'm thankful for the opportunity to be in that position.
So driving a pro stock car, often described, certainly in drag racing, as one of the more difficult challenges to do well, because there's so much going on, and the driver can certainly ruin the run, and also reaction time is so important. Just talk a little bit about driving the car and how challenging it is. There are people out there who, they see mid 6-second ETs, and there's no fire and flames coming at them. They're not going 330 miles per hour. But as far as like a skillful driver exercise, I don't think there's anything more challenging.
It's as far as I've gotten to drive a few different kinds of cars now, and it's definitely been the one that's kicked my butt the most. And yes, a driver can screw up a run in a heartbeat.
That damn rev limiter, right?
Yes, that rev limiter.
So if you did, that's why Jason wanted it gone, right? It's not about the engine development.
That's why I retired.
It makes it a lot easier for the driver.
I just turned the limiter off.
Well, if you tag the rev limiter, you're not done because maybe the other guy is tagging it too, but it's going to hurt the run.
Yes, for sure hurts the run. It's a science. I mean, there's so many things that people don't see. I'm sure you could talk to Erica and she could let you know how much of a robot you have to be perfect every single time. How many times you're putting the clutch on, how long you're putting the clutch on when you're doing your burnout, backing up, staging. How you're putting heat in the clutch affects the run, and obviously the shifting is its own science in its own, trying to get in the rhythm, and you have a very small window for it to run good. So you want to keep it off the limiter, but you don't want to shift it. You want to take advantage of every RPM you can. So it's definitely a challenge.
I assume everybody understands that when he says Erica, he means Erica Anders, the 5-time world champion, one of the greatest of all time. Couple minutes to go, couple seconds to go in that. I'm just interested in, like, anytime you start a project, and if you're talented, you're like, man, you did very well. I think you won your first race ever in a pro stock car. I think it was against Jed Coughlin, if memory serves me right. And but then as you've done it more and more, it becomes harder. How is that? Like, oh, I got this, and then all of a sudden it becomes harder. Like, you learn the challenges that you have to worry about.
Start thinking about it.
And that got you mid-season. This past season in 2022, you went through a mini slump.
Yes, it's easy. It's easy to get in a slump, and it's easy to start thinking about it. And you try to analyze your mistakes, but sometimes you can overanalyze it. So there's a really fine line there, and it's hard to find that line. So
You know what I preach to them? I say the great ones figure out how to get out of that hole.
yeah,
Just got to keep digging. Keep digging.
Yeah.
Well, I was back to the Formula One podcast, listen to Daniel Ricciardo. As you said, it's in my head.
Yes.
I overthought everything to the point where you just got to go drive. And it's easy to say that, but you just got to be able to pull that helmet on
Get in the car and drive.
and just not think and let it feel. You have to react, not think. If you're thinking, you're behind.
yes.
Greg and Aaron Stanfield with us here on Hidden Horsepower. Gentlemen, good luck in 2023. I'm super excited, but I really think, like this guy mentioned, getting back behind the wheel of a pro stock
that
car
smile. That is
three times.
cagey
Three
smile.
times
Joe,
on.
I've already talked to Royce Lee. Maybe just a little bit. Who knows? You never know. Just never
That would
know.
make me so happy, like personally. I know there would be a lot of people out there. There would be a great story. They got a fleet of cars over there. They got too many cars. They know what to do with them all. Why not a little Greg and Aaron Stanfield at an event?
The water's fine.
The water is fine. Oh my gosh, that would be tremendous. Gentlemen, thank you very much.
Thank you guys.
Thanks,
Yes,
guys.
thanks for
Appreciate it.
having
Excellent.
me.
Greg and Aaron Stanfield Racing Engines. Check them out at an NHRA track or national event near you. More Engine Performance Expo to come. This has been Hidden Horsepower Live.
All right, Engine Performance Expo viewers, we're here today in Jasper, Indiana at Jasper Engines and Transmissions. You know, Chuck, you used to work here, right?
Yeah, I did 20 years in these walls.
All right, and then Noah, you're here now.
Yes, sir.
So we're back here with this load cells, and there's a little fastener in here. And the reason we're here is because, guess what? There's a difference between the amount of torque you can put on that bolt and the actual clamping force. Because we really actually don't care about torque, do we? We really care about clamping force.
Yep. The engine really all it cares about is making sure that the joint is held tight enough, and torque is just our ways of getting to that point. However, what the bolt and the joint actually needs to see is the clamp load.
It's the means to the end.
Yes.
But the means don't always give you the same end.
That is correct.
So I know there's some variances that you can do with different lubes and different things that can impact it, because where is the actual most amount of friction and resistance?
It's in the threads.
In the threads.
Yep. And there's a significant amount underneath the head of the bolt as well.
So as it hits the surface that it's clamping to, that friction under the head, that's why the lube you put on it can make a big difference, right? We can put 3 different lubes on there and for the same torque get 3 different clamp loads, right?
Yeah, we can fluctuate the final clamp load about 15% depending on what kind of lubricant you use. If you use it dry,
You see, that's why we're here, because I love that stuff.
if you install it dry, or if you use like a more of a moly-based grease, you can fluctuate clamp load a significant amount.
We're gonna try that, aren't we?
We are.
Okay.
And actually, just jumping back a little bit, the torque, by definition, is the measurement of resistance or rotation, right? So we know that there's tons of variables, and especially for us engine builders, what's the condition of the threads in the block? Do we qualify that? The threads on the fastener, are we trying to reuse a fastener? Is it a new fastener? The underhead condition, is there a washer? Where's lubrication on the washer? We set ourselves up with a lot of variables, so we can't have that variation in clamp force, and quite honestly, that's why so many engines now have a torque plus angle. Even fasteners that aren't torque to yield, and that causes a great deal of confusion, because if it's a torque plus angle, it must be torque to yield, right? No,
You
not
think?
necessarily.
Okay. So explain real quick the difference between what we talk about, a torque to yield bolt type situation versus just a regular, hey, I'm torquing it to X foot-pounds because that's what says in the box.
Right, so the fasteners that are, and Noah, jump in,
Yeah.
but fasteners that are designed with a torque to yield concept, again, sometimes we use the term that it works like a spring. In essence, it does, but we take them in, all of these fasteners do see some plastic deformation. There is going to be some plastic deformation.
Is whether
And some
you
of the
yield or not.
Right, whether you yield or not. And so that's probably one of the demos we'll do here. We'll actually take a fastener to yield so that we can see what's happening there.
Yeah, I have to relate everything back to the stress versus strain curve, which is a curve that material science uses to determine the strength of a material. And typical your torque to angle bolts, which is more of your, it might be a straight torque, and it might be a torque plus an angle, will only get you certain, kind of in the linear curve of stress strain curve. And then if you go beyond the yield point, that's what we typically consider a torque to yields. But in your service manuals and whatnot, a lot of times they'll just say that it's a torque to yield bolt and replace it, but that's not always the case.
How does that relate to someone that says, okay, I know that I'm going to torque based on what it says, but I'm also looking for a certain amount of stretch because the manufacturer says I need this much stretch. How does that relate?
Well, most of the time the manufacturers will tell you to use a brand new bolt in those applications, which we recommend also, but there are times where we've identified that a bolt can certainly be reused. The bolts can be tested and verified that the bolt still maintains strength after the preload point.
Got it.
And preload is the point at which the bolt gets installed to. So if we say the installation process is 60 foot-pounds plus a 90-degree turn, I'm just making this up.
Sure.
But whatever clamp load that is after that 90-degree torque is what we call the preload point. So any additional load to that, whether it be in the engine or whatever, is going to be beyond the yield point or beyond the preload point.
Got it. So, like, for example, you had some fasteners, you put them in, you stretched them with the torque, you measured it. Okay, I had X amount of stretch. Take them back out, put them back in. You have to make sure that they haven't actually elongated, because you could get if you're using that zero basis again, you could have actually already stretched it, and now you're beginning to yield it, and you won't have the clamping force that you think you have.
Correct. So we might perform a test like that, whether or not we can mount a head on an engine for mocking up purposes, and then take the head off, and then can we use those bolts again to test more or not? So
and that's why it's kind of helpful to have this thing, right? That way you can kind of know.
Yeah. With that,
right, and that's kind of like the rig, for doing connecting rods, where it's got drill points and spot facing that you can say, okay, it's going to be acceptable if that bolt is stretched this much, and once it gets beyond that point, so people want to know, can I use it 5 times? Well, maybe not.
Right.
Maybe yes, maybe, because the dynamics of the engine may have impact on that, in addition to the stress and strain that you've from the application.
Bingo, right? Because there's a window. It can begin to stretch, but it hasn't yielded yet.
Yep.
So there could be maybe a couple thousandths or more stretch.
Or what
and still be
percentage
there.
of yield.
Yeah, before it actually goes.
Yep.
This is why this is so much fun. They're really tall, aren't they? I'm a little bitty tiny guy. I feel itty bitty here, but it's okay. Big brains, big information. So we want to go ahead and do some demos?
Let's do it.
All right. Show what we got here. What's in here now?
So right now we have a Ford 7.3 Godzilla head bolt. What we're doing is we're going to basically stress this bolt all the way past its tensile strength, which means we're going to bring the bolt right up before it starts to rupture. So we're going to stretch this bolt beyond the yield point, beyond the preload point, and actually beyond the tensile strength
we're going to break
point.
Try to.
We're going to make it really stretch, yeah.
It's going to be unhappy.
It's going to be unhappy.
So explain the rig setup here. Right? Why don't you move around that way you can show everybody what this is, because I'm the dummy, and you can show them what we got.
Right now we've got a, we'll start from the top. We have the bolt that's going into a heat-treated spacer. Then we have our load cell, and then we also have a dial indicator reading the bottom of the tip of the bolt.
So that'll give you how much stretch there is.
Yep. So the load cell will give us clamp load,
right?
Which we can then calculate into what stress is.
Got it.
And then the dial indicator is then feeding us the bolt stretch,
Yep.
which we can calculate into strain.
Strain, yep.
And then this is a digital readout of what the clamp load is giving us. And this is, you add a 0 to this
okay.
this digital number. So we're actually looking at 10 pounds instead of 1 pound.
Try to fix that just right there like that.
Yep. So now we're reading 40 pounds. And then basically what we're going to do is apply stress to the bolt, go all the way up. What we're going to do is go all the way up into the curve until we start to see the clamp load decrease steadily.
Okay. Cool.
So at that point, the bolt will be necking,
Yep.
which means that the bolt is continually stretching, but clamp load is decreasing. Yep. So
let's touch base a little bit on the spacers. So if you're going to try to replicate what's happening in a particular engine application, I want to look at the thread engagement in the block and so forth. This is actually take up the space that, if you want to use the actual bolt that was going to be in the engine, you need to take up the space of the cylinder head.
Right.
So you can do things like put a gasket in between, and then it would be like a soft joint as compared to an absolute hard joint. So this is a hard joint mechanism, or semi-hard, because once you start adding layers,
like a main cap
there's some deflection.
type deal right there. Yeah, something that doesn't have a gasket in it.
But we know once I add those layers, there's some more deflection to accommodate. It's not a dead hard joint.
yeah, and I should specify that in the material science world, what they would do is put it into like an Instrom tensile tester, in which case that they would just pull the bolt apart. We're doing a similar test. However, we're adding a few extra variables. We're including the friction on the threads and the friction that you were talking about underneath the head. So we can fluctuate different types of lubricants on this and try to make the best we can reproduce our test results and compare how things are going to work. It's important that the spacers are heat treated because we're trying to treat this as a hard joint and we're trying to eliminate as many variables as possible.
You don't want it moving around.
Correct. We don't want the spacer to sandwich, and with
mild steel would not work too well.
Mild steel, you would see it starting to deform. One thing that I should have specified before is the tip on the bolt is typically a really ugly indention, or however it's manufactured. There's usually it's not a flat surface to measure off of. So what we do whenever we do bolt testing is we chuck these up in a lathe and then face it flat. And then for some of our testing, we'll also face the head of the bolt flat as well. Sometimes if you don't have a fixture like this, you can eliminate the dial indicator and then use a micrometer to measure overall length. So this is the way we used to do it, and then we built this fixture so we can have the dial indicator feed data into a computer.
Nice. This is cool. This is fun stuff.
All right, so
there we go. Torque wrench.
Yep. I think
Proper
we're
torque
ready to
wrench.
go. So we're going to increase torque and watch this go up.
All right.
So I'm going to try to get out of everyone's way.
We can see the thing here. We're good. So we're 242, 687, 872, past 1,000, 1,200. Close up on 1,300. We get past 1,300, 14.
So remember to add a 0.
Yeah, 15. That's just 15, almost 15,000 pounds then.
Which is pretty typical for the modern automotive boats.
15,000. Yep. Oh,
It's
it's going the other way to it now.
Yeah.
Yep. It didn't make it to 15,000.
So I can feel how the torque is starting to.
It's
the bolt's
vacillating
starting
now.
to stretch.
Yeah.
And we can go quite a ways. Oftentimes with head bolts, a desirable feature.
Now it's 15,000. So it dropped there for a second, but now it's coming back up again.
Yep.
And you'll see work hardening and then death.
Yeah, a lot of that is because I'm not being consistent at the speed of me pulling on this. But you can start to see that the clamp load is decreasing as I'm adding more.
Yes,
There
right
it
there.
is.
Yeah, there it is.
So we'll stop about that point. And our final torque that we hit was about 110 foot-pounds.
110 foot-pounds of torque,
Yep.
and it's yielded that bolt now.
Yep. So the bolt is beyond the tensile strength, and it's starting to neck. We haven't got to the rupture point.
Okay.
The reason we don't go to the rupture point is because when the bolt breaks, the load cell becomes unhappy.
Okay.
And oftentimes load cells break.
We don't want to do that.
We don't want to do that.
We don't want to buy a load cell. No.
So yeah, we want to take the bolt as far as possible, and begin to see that necking, and then we can shut it off.
All right, so we're not going to break a bolt.
We're not
going to break a bolt.
We're not. We technically destroyed a bolt,
Yeah.
but it didn't break.
There we go. It's ruined, but
it's
not broken.
ruined.
There's
Yeah.
a difference.
It's going in the scrap bin, so we can
Yeah,
loosen
don't put
this
that
up.
in an engine, yeah.
No. So what's desirable about head bolts is typically you want a long plateau as it's going up the stress strain curve. You want it to stretch a long period of time. That way the bolt can fluctuate in the length in your engine without clamp load fluctuating a lot.
Got it.
So you want to keep consistent clamp load, even though that the bolt may be stretching with thermal expansion or
You
what
saw
have
that. Once you got into a range, it really didn't matter
Yep,
that much,
yep.
right?
It
was
really
just kind of hovering in
plateaued
there.
over.
Yeah.
Yep, that's exactly right.
And kind of a good way to check some of that is, okay, if I want to see where I'm at in that range, just a simple way of saying,
Yeah.
if someone wants to pick up a load cell and they wanted to find out some of that information. So say if it's, 45 foot-pounds plus 90 plus 90. Okay, so at this point, well, where am I in that flat curve? And that's where that kind of the tattletale on that that dial
Yeah.
torque wrench can kind of give you some insight into if that's your window of how long it stays in that area, because you see it go up to like 100 foot-pounds and it stayed there for 180 degrees. Okay, so if I have two 90s, okay, let's see what it does if I go 270 degrees instead of 180 degrees.
Okay.
And that kind of gives you that where you are in that factor, what's the safety factor, because again, you can, with lubrication and so forth, you can really mess that up. We take the friction out of the equation, and
Because that was dry.
right.
Yes, that test was dry. Typically, we will always match whatever lubrication that we would use in the actual install.
Right.
So we can compare and contrast. But for this demonstration, we just installed it dry, and I would expect to get maybe several hundred pounds greater than 15,000 pounds using a different lubricant.
So you have this, a new one of those same ones? Same bolts?
Yes, yeah. We can perform that test right now.
Let's do that. Yeah, come on.
If you don't mind threading that out, I'll get some lubricant.
And in an environment like this, you're going to be comparing. Okay, what's the OE say? Okay, they say do it with just oil. Well, if we have a particular manufacturing process, or we use a different fastener, and maybe I want to achieve that clamp force, but maybe my strategy's different because
Right.
there's some variation in the fastener material, or oftentimes we get the question, what's a torque to yield bolt look like? And well, years ago it was, okay, it's always necked here, they stretch in the neck area. Well,
Right.
look how long the threads are. My stretch zone's actually within the threads.
Got it.
So it's quite confusing to say what is a torque to yield bolt.
So
I think
the stretch is here, not necessarily there.
right,
Okay. And people would think that it's there because it's necked.
right. So I'm
That
using
makes sense, yeah.
1.5D. That's still kind of the rule. But if I look at the threads, I have 1 inch of threads engaged, and I have 4 inches of thread. So that zone can be controlled, because typically those aren't cut threads anymore; they're rolled.
Rolled. Right, exactly. Yeah.
And so they're very precision in the crest to root dimension. The radius is in the bottom of the root, so it gives you a better area to stretch than say, okay, the elongation of this piece of rod,
Yep.
as opposed to something that gives it that spring kind of opportunity.
Got it. Okay. All right, so we got one lubed up now.
Yep.
So you got lube under the head.
Yep.
And on the threads.
Yep.
All right. And that's some kind of moly grease, I can tell.
Yep.
Because it's dark gray.
This is about
Which, by the way, grease, the color of grease other than gray is dye. Red grease isn't better than blue or green or purple grease. They just put dye in it and make it that color, by the way. There's your tribology fun fact for the day. All right, so here we go.
This is about on the complete opposite end of the spectrum of a dry running bolt. So this is typically, this is not what you would see, or this is about as friction eliminating as possible.
Yes, yeah. Because it's a grease, because you have very low sliding speed right here. So you're not going to build an oil film. So the grease basically gives you that higher viscosity, which can help separate those parts. So a grease will give you better lubrication in this contact than you would oil.
Yeah.
With it being
Oh
grease,
yeah, and you're way past 15,000 already.
Well, yeah, and we're only getting up to about 1560 or 15,600. So it's only a few hundred pounds higher. However, it might make a bigger impact during your preload when you're actually installing the bolt.
Yeah, that makes total sense.
And without doing a test like this, you don't actually know how close you are to...
It just looked like it was coming up more smoothly too. It was less erratic coming up, which makes sense to the reduction of friction. It's less stick-slip, because what can happen is it can simulate that there's more stretch there until it has a chance to relax.
and I think you've shared this in some previous presentations about when it's grease, though, you're going to have to wait, because that's actually going to disperse its way out.
Yes,
and the clamping
it will.
forces are going to be indicated
Yeah.
that, hey, I lost clamping force. The grease is no longer there, and impact stretch.
It can move, yeah.
Space is taken up. And
So that's cool. So we were able to run it dry and run it lubed and see the difference. And that was a significant difference.
Yeah, it was several hundred pounds of clamp load difference. One thing that I guess why we use this testing methodology is to qualify aftermarket bolts here at Jasper. So what we do is we try to identify. Obviously, there's a lot of bolts out in the world, so we're trying to identify whether or not a bolt can be reused in the automotive industry in our particular cases. So if it's a head bolt where it's a critical fastener, we have to go through and scrutinize a bolt to this magnitude to identify whether or not it's going to hold up over time, and if it's even strong enough to be used. So this test helps us identify frictional differences, whether it be in the threads or under the head. It also helps us qualify the tensile strength and seeing how high will that peak go between an aftermarket bolt and this bolt. Then we'll go through and evaluate other physical properties, dimensional characteristics, making sure that the threads are rolled and not cut, and coatings. Coatings will also play a role in how much friction is being applied. So this is really what helps us. It's absolutely fundamental for us to be able to qualify aftermarket bolts.
I think one other thing we would like to do, Noah, is, okay, based on, we're talking about torque typically. Let's take a fastener, lubed and dry, but let's go to a straight torque value. Okay, what are we going to see in clamp force if we only torque this thing to, say, 65 foot-pounds? So usually we're going to have a snug value, and that's probably where we're going to get messed up in the first place, because 90 degrees is 90 degrees, 180 degrees is 180 degrees. We can mess this up early on. So let's go back to dry, torque it to, say, 65, 70 foot-pounds, because we know that we're not going to hurt the bolt at that point. Then let's lube it and see what the clamp force differ is between those 2 points.
I like it.
Y'all do what you need to do, because yes, we want to find out right there, right?
So one thing we'll want to do is the moly the molybdenum almost like embeds itself
Yes.
into
It's
the
in the
threads.
yes.
So we're gonna have to clean that out. And luckily, I think there's a tap right there. We can
Run the tap down there.
run the
and-
tap down it and some cleaner.
All right, so we got it cleaned up, all the molly's off. So we got our new one now that's non-lubricated, and you're going to torque it to a set value.
Yep.
And then we'll see what the clamp force is.
Yes, sir.
And then we'll repeat it with actually lube on it.
Correct.
All right.
Correct. We're gonna torque it to 65 foot-pounds.
All right.
Both times, unlubricated and lubricated. Alrighty. So right at just under 8,000 foot-pounds, or 8,000 pounds. Mm-hmm. So we're going to take this off.
All right.
And the nice thing about this test, like Chuck said earlier, is that we can perform this test without worrying about the bolt deforming, permanently deforming or yielding, because we're not taking it to beyond its yield point.
Right.
So technically, theoretically, all of the deformation that's occurring here is elastic, and it will return back to the original length it was. So another 65 foot-pounds.
Let's see what we got. Whoa.
And we're up almost 300 pounds. 300 pounds over the other one.
Yeah, that's impressive. That's a big difference.
When you're installing a bolt that's right there at the critical curve, 300 pounds might make a big difference whether or not a bolt can be reused or not reused, but your overall joint assembly is actually going to work or not.
Right. That could, the difference between success and failure
Yep.
could be right there.
Correct.
I love it when lubrication is the go, no go on something. It just kind of feels right to me. Well, I can't thank you guys enough for letting us come in and demonstrate this. Hope you enjoyed it. Thanks for watching.
Welcome back to the Engine Performance Expo. So much information being shared, guys. We had to give Lake a break, though. Poor Lake has been going for a couple of days.
You got to wind him up, and he goes for quite a while, but eventually he's got to have a little recharge and swap out the batteries.
Exactly. But we've got a cool product spotlight. We got Kevin Feeney from P1 as in Point One, talking about studs and fasteners. What I think is cool is the name, though. Tell us a little bit about that, Kevin, because it's kind of an ethos for the product.
It is. I mean, we're all about quality and at every step of the manufacturing process. And Point One was really established because the premise, especially in racing, when 99.9% is not good enough, and you're looking for that 0.1%, we're always striving for that, in quality and strengths of our parts.
And so, who better to help grill Kevin than Ben and Billy? Of course, you spent a lot of time in this area, and without the appropriate, clamping force and fasteners, like none of this works.
And not only have we both spent a lot of time working on this, but we've both spent a lot of time at the facility at Point One, and it lives up to the name. I mean, you'd have to admit their capabilities there are over the top, Billy.
Oh, absolutely. It's one of the best metallurgical labs I've ever seen. We were driving up, and I'm looking at the building, and I see this big nitrogen tower. And I'm like, ooh, they've got some heat treat stuff in there. 'Cause nothing else needs that much liquid nitrogen. I'm just like kid in a candy store. And it's amazing because you go in there with Kevin. Kevin was my boss for decades, or at least, a decade. And, getting in there and getting to play in their metallurgical lab, getting to go by all their machinery, seeing what's going on with their heat treat, it's absolutely amazing. And the people there from the owner down, I mean, talking about going through there and caring about each machine, knowing everything about machines and just crawling all over the shop floor. It's amazing. And the shop floor is just like a studio. It's beautiful. It's a great place.
And not only is their metallurgy .1, you know, I mean, it's top level, but so is their metrology.
Oh,
I mean,
absolutely.
Like, unbelievable. You know, you guys have been talking about surface finish, and you've been talking about, you know, all that stuff, and like the ability to measure and know what you have to work with material wise on the metallurgy side, and then, you know, guarantee that you're making what you're hoping to make. I have not come across a lot of places like that.
Yeah, it's really a unique environment. You know, everybody is just getting familiar with the Point One brand, and we've actually celebrated 50 years of manufacturing with the parent company last year. So we're not new to manufacturing, American-made manufacturing. Just you know, a new name in the fastener world, but unique situation, and respect that you know, we put all the disciplines in place, did all the research, understanding the market needs. And again, you know, quality is first and foremost. I mean, we start quality as soon as material comes in the door. I mean, we're actually, we buy only certified material, raw materials when it comes in the door, but we don't trust that, you know, we're getting what they, you know, we've ordered, right? We take their certification, it goes in the, you know, the metallurgy lab, and we, you know, we spot check and make sure everything is matching up to what we ordered.
Yeah, y'all take a part of the bar and actually cut it out, and they'll do a chemical analysis first, and then they'll look at the metallurgical properties. So not only do they know is the right ingredients in the cake, but is the cake as strong as it's supposed to be?
Yeah.
And they do the same thing with the blocks when they get in aluminum, when they do some top fuel blocks and things like that. All of that's looking down to the very, you know, the Point One.
I think the other thing that makes your place so interesting, Kevin, is how incredibly vertically integrated you are. Like from when the metal comes in, you know, material comes in the door, all the way up through a finished fastener. You know, you're doing the labeling, you're doing the boxing. I mean, literally every step of the process happens right there. You're not shipping stuff off and waiting for it to come back. I mean, that's a huge investment of effort to control every aspect of making a fastener.
It certainly is, and I mean, the end of the day, you know, we put it pretty simply. You know, we like to sleep at night, right? So, you know, we understand. I mean, you know, we've been on the consumer side of it, you know, on the manufacturing side of it, using fasteners, and you know, understand, you know, the requirements, and you know, again, every, you know, quality has got to be checked at every step. I mean, getting the material in the door, going through the blanking, whether we're cold forging it or hot forging it. Through the heat treat process, you know, and heat treat is critical. Like, obviously in fasteners, amongst other things, your manufacturing is, you know, if you got to depend on somebody to outsource that to, so certainly today's times we're concerned about lead times, but really just controlling it, you know. You know, if you send it out and if they want to mix up the recipe a little bit, if you will, you know, to fit their needs, and it may not fit our needs or, you know, ultimately our customers' needs. So, you know, it's just important at every step of the way, all the way through packaging, like you indicate. I mean, you know, we've, you know, been that guy that's been there at, you know, 12 o'clock on a Friday night getting ready for, you know, a race the next day, and, you know, you don't want to be short of component.
Well, or you just think about some stuff that you can't even control. You take all this care and time to make a fastener, and then we don't want to just toss them in a box and wrap them in paper and then ship them off, because you don't know what UPS, FedEx, you know, they're getting drop kicked across the field. You guys, you know, you're protecting the threads, you're, you know, hand placing them in the boxes, and then, you know, foam over them, like every step of the way, like literally to go there and witness the door opens, a truck drives in with raw materials, all the way to like it shows up on your doorstep and you go, man, even the packaging is 0.1%. It's a super impressive operation.
Yeah. So, Billy, did you have?
Yeah, I do mean I hate to, I can't not touch it, and I need
you know, you want to touch it.
But I mean, this little piece that people don't understand, like this rod bolt. You know, Kevin spent so many years trying to get out of valve springs, but this little rod bolt, when it's stretched, it's under such high stress through this area. This is like a spring. And so you have to treat the metallurgy, the surface finish, everything from the rolled threads to how this is ground and polished is all about getting the ultimate strength you can there, so they can put more clamping force. So you can use a lighter fastener to create the same loads to hold your engine together.
Yeah, because ultimately it's the clamp load that we have to depend on to make the engine stay together.
Right.
You know?
Right. This isn't just a bolt being bolt. This is a spring holding everything together.
Definitely not the kind of thing to skimp out on when you're building a high-performance racing engine that you want to go win races with.
Yeah, these guys are the king of, you know, when good enough's not good enough, you need to come check out what they're up to.
So let's get to the most important part, Kevin. Like for people out there who are watching now and in the future, if they're like, oh my goodness, I didn't know about these guys, and I want to check out what they've got and find out more information. People who are uninitiated, where can they find out more about you?
Yeah, the best place to find more about us is at p1mfg.com. We've got a nice virtual tour of the facility, go through all of our capabilities and show the metallurgy lab and the metrology lab and, understand who we are and what we do.
You guys can hit that website, find out more information, and let me tell you, you got to get up close and personal. It is like jewelry. Billy, I'm with you. Like, oh my gosh, they're amazing.
You're going to see, wow.
Exactly. Kevin, thank you very much.
I appreciate it.
Great job, gentlemen. Thank you very much. Excellent work. We got more to come from the Engine Performance Expo. Of course, we want you to subscribe. Seeing those subscription numbers go up on the YouTube channel, that is amazing. We want you to share it as well. And the next roundtable, your questions, if you've got one, throw it up in there. We're going all day long. We're going to reveal the big horsepower numbers, all kinds of great stuff coming. So stick with us here at the Engine Performance Expo. Let's hit that next video.
All right, Engine Performance Expo viewers, we're still here at Jasper Engines and Transmissions in Jasper, Indiana. This lab here is pretty cool, guys.
There's some great toys here.
There's a lot of really great toys here.
Yeah.
But one of them behind us, behind Chuck here, is a profilometer, which we've seen these a lot.
Sure.
But there's something different about this one versus the one we're dragging around, putting in cylinder bores all the time. So Mark, explain the difference between what this one is versus the one we normally are been using.
Sure, this is a skidless device. So the only thing that touches the surface is the diamond.
Right.
There's no little skid holding it in range.
Right.
So it's suspended by its own drive unit, which is essentially perfectly straight. So we're going to touch the surface with a diamond and pull it along a straight line without any help.
All right, and what's the significance of that?
The significance is we can see waviness now.
Right.
If we think about our skidded gauge, the skid holds the stylus in range, and if the surface has a hump, the skid goes up and we don't know it.
Right.
But this one, it's just the diamond.
Okay. So Chuck, why is that so important for what you have sitting behind you here?
So the surface of a cylinder head, we want to be as flat as possible to apply a uniform amount of clamping force to the gasket, right? With modern gaskets, MLS gaskets particularly, and they're used from heavy-duty diesel to high performance, right? So they're used everywhere now. In the past, it was a limited breadth of products that they went on, but today they're everywhere. Well, if I have a wavy surface, it's kind of like the suspension bridge thing. Suspension bridge sags, but I have a pretty rigid gasket that doesn't really sag and it doesn't fill those voids.
Sure.
So now we have either combustion leakage or coolant leakage or oil leakage.
None of which are good things, by the way.
Right. Look at the complexity of heads to now. All the brains and controls are in the cylinder heads. So now we have high pressure lubrication up there, the coolant, of course, potentially a fuel rail that's running through. So we can have mixing of materials, but the biggest thing is, is combustion escaping and getting into your coolant, your fuel, your oil. So that's all bad. So the flatter the surface, the more engagement we have and the better for sealing the engine. MLS gaskets are also hard to read. Old conventional gaskets, when you see things like that, it usually removed the facing material from the body or the core of the gasket, and you could see exactly what happened. Now we get a gasket back and we scratch our head, we take a straight edge and check it for flatness, and it's okay,
Sure.
It wasn't 3000s warped or whatever, because you'll look in a service manual and say maximum warpage 3000s. Well, uniformly across the surface, that might be acceptable, but usually it's much higher frequency, so we have that deviation in a very short area. So it actually, if you take MLS gaskets and kind of pull the layers apart, is where you're going to see the indication of compression, leakage, and things of that nature. So waviness is much more important than ever before in what we're doing.
So you raise a really good point. You talk about warpage and that big scale flatness. Gaskets like that. I mean, that's what they're made for, is to bend to big scales. If I tried to cram a stack of paper between my fingers like this, it'll fit. But the same depth like this, they won't fit. So is that flatness of 3 thou over the whole surface or localized? And
back to the frequency you're just saying. That's what matters.
Right. So in some places what we do is we have flatness, but we also have zonal flatness. you're allowed 3 thou over the whole surface, but only a thou within 2 inches.
Right.
Okay. So that's the difference here is that surface finish does matter, like roughness matters.
Yes.
In terms of having everything clamped together and fixturated right. But really that next level you have to look at, which is obviously maybe even more critical, is the waviness. And that waviness can be imparted by the tool you're using, correct?
Right, and actually we've been having conversation with the team here about what induces some of that waviness. Now, you always start with the easiest thing first, right?
Okay.
So if I'm seeing waviness, the first thing I'm going to do is make sure that all the feet are secure on the floor. That's the easiest thing to do. Okay,
The machine's not rocking.
Is the machine level and secure to the floor? And then I go to my fixturing that I'm going to put my part on, cylinder head, cylinder block, and make sure that that's all rigid, that I have good integrity, that I can tie the part down, and that's not inducing waviness. And then you can start to look at things like ball screws, motors. One of the things that was brought up was actually a drive issue. So intermittently, the motor was stopping. So there's in the CNC world, vertical machining centers or lathes or whatever, they have ball bar testing. And ball bars you fix into the spindle and they're fixtured on the machine somewhere. And you tell your machine to do something and it does what it thinks it's doing. And this thing qualifies what it's really doing.
Right.
And what happens when motors are going different directions, okay, so I'm going to run X positive and change my mind and go X minus, Y positive, Y minus, Z positive, Z minus. And you have what we call reversion spikes when it gets to those points, and you can adjust a lash out with that. So basically that's what they were actually seeing is, okay, it gets to a point, the motor is intermittently start, stop. And so as it starts and stops, once you come up to that particular frequency, it probably settles out. But in between there, I might be setting up the opportunity for vibration.
Sure.
And
that
it's
vibration turns into waviness.
Right. So
that only makes
there's
sense.
a lot of places you can look. One of the things from my past was like there's holes that are milled in the tool holders.
Right.
Well, we use some lubricant and we spray on the head surface and that makes things sticky and we create chips and now they're up inside the fly cutter head. Now it's out of balance. So we talk about balance often.
Oh, yes.
That's a really easy
Wow,
place
that's a
to
great
just
point to think
take
about.
some carb cleaner and wash that out and all of a sudden, a problem that was there 30 seconds ago just went away.
Your fly cutter's out, literally it could be out of balance, just a buildup of gunk, and now it's inducing waviness because it's sitting there floating essentially.
Exactly. So, that just emphasizes how important maintenance is.
Yeah.
Because we need to maintain it as we go, not let it get to chaos, because that chaos can end up in the surface. And
okay, so what is this example back here? Explain what we have back here, because I know this is a cylinder head, obviously, and I can see lots of machining marks on there, but I also see Mark's graph over there. And is that good? Is this bad? What am I looking at here?
Let's let Mark elaborate on it.
Sure. Well, in this world now, we're a skidless measurement. This is really important. This is the cross section of that metal.
Got it.
So this is exactly everything. If you were to take a microscopic walk, not just looking at the fuzz, but looking at the lumps, or not just the grass, but the hills.
Yep.
And so here's a graph from this surface. Now we took this measurement in a particular location where we could see some lines on the surface.
Yep.
And those lines are very visible to our eye.
They look ugly.
They look ugly. There are 3 lines that look like there's a problem.
That's like, this shouldn't be there. This has got to be a problem. And it's next to a water hole too, by the way, so it's even equally scarier.
Equally scary, right.
Yeah.
So those lines might cause us an alert. Like if the whole surface was covered with that, we'd be scared. But if we check out the profile graph itself, it was just a little frostiness in the bottoms of the valleys that light up to our eyes as this horrible thing. Our eyes only see slopes. They don't see height.
Okay.
The eye sees a change in reflection. In those areas, the surface doesn't reflect as well. But you see when we zoom in over here, the bottoms of the valleys are a little rougher in a spot here and then here and over here. But the texture is the same really in terms of roughness.
Okay.
The gasket is going to see the same roughness throughout. So that was one interesting piece right here. The other thing that I tend to look for in a data set like this is what is dominant. What's the shape that really is going to get me? In this graph, the red line is the waviness, and everything above and below waviness is roughness.
Got it.
So imagine if we flatten that out, that's the roughness.
Got it.
But if I look at this, I say, what should I be controlling? Should I be controlling the cutting action or the wobble of the mill? Well, the cutting action seems to dominate this data. I would say there's not a lot of waviness compared to the roughness in this example.
Okay.
Let's switch it around so you can see what I mean. I'm going to load a data set right here on the same scale. Now check out that.
Oh, that looks really bad.
Right. So now
That looks like a sawtooth.
Yes. Now the waviness is totally dominating the roughness. If we look at the red lumps compared to the fuzz that lives on top of them, this is a real waviness deal. Now this particular data set was a mill head that wasn't square to the axis. It was wobbling once per revolution, and you can see that sine wave wobble going on. So squareness was a waviness cause here.
Okay.
Each revolution wobbled back and forth. So in this case, managing waviness would be really, really important. Imagine an MLS gasket trying to, find a home on that.
You can't find that, right? Yeah.
Right.
Right.
And
can you go back to the previous?
absolutely.
So this indication here is where the gasket manufacturers do have a plan for this. They have what we call cold seal technology that they'll apply to the gaskets, and they can deal with that type of stuff. There's nothing they can do to deal with that previous example.
The big
a
one.
failure.
Right.
That's a failure.
Yes, exactly. So it's a matter of balancing enough roughness to give us some traction, kind of grip in there a little bit, a little bite, but keeping waviness under control to manage conformability. We can conform to certain frequencies, shapes, and in this case, we should be able to conform well because those wavy lumps are within the zone of roughness. And if that roughness is acceptable, that waviness should be acceptable.
This is too cool. This is why I hang out with these guys in places like this, because you learn something every time. Go back to the one that's really scary looking. Because I just want to see it one more time.
You want to get scared?
I just want to see it. That is really, really horrendous, by the way. But that's why we have these tools, right?
Exactly. Right. And how does it present itself in an engine? Again, if you're looking at the gasket itself, you might see the layers if you pull the gasket apart. Or let's take a look at a Fuji impression.
Yeah,
this is fun.
Bright red, high load. Pink, low load.
White.
White. Yeah.
Time to take it apart.
No load.
So there's some really, really great tools out there.
You can see a ton of variation here, which is really amazing. Look at that. It's really red near the studs.
The bolts.
The bolts.
And as we talked about earlier, and that's pretty standard. The
clamping force.
11 millimeter bolt holes that we were looking at as far as clamp force, they're pretty much, you can say they're going to be 12 to 15,000 pounds of clamp force. That's just, I've looked at bolts for years and years, and that's what you see. So, the material, the strength of the gasket's got to be able to stand up to that as well.
Yeah.
But,
So you introduced an interesting point on those holes. I want to go back over here a minute if we can.
Okay, sure.
So remember the defects we just pointed out, and you rightly observed they're coming out of a hole. Think about that cutter dynamic.
Oh, intermittent cut.
Intermittent cut, exactly. So we come out of a hole. Now sometimes maybe on the block side we'll have a tab over here or something like that. Totally intermittent. And we can actually see it set up waves depending on when it hit.
It starts to
might
bounce.
go low one revolution, the next revolution it's high, the next revolution it's low, based on the width of the cut changing. And we can introduce waviness
to the intermittent cut.
Because the intermittent cut and the variation in thickness coming out of it. So
it's like your spintron for that. It's like, am I in valve bounce? Yeah, I'm in cutter bounce.
Right.
And even unsupported low, let's say there's a tab out here on the block. It's not supported, so it's not going to cut. It bends down and springs back when you're done. And that also can contribute to waviness based on springiness.
Right.
So there's a good technical term for you.
Springiness.
Springiness.
New word.
It's like winteriness, only it's warmer.
Like slickeriness.
You got it.
Yeah.
You know, and we've talked about this in the cylinder bore surface finish stuff. If you're not measuring, you're guessing, because more so today than ever, I have, you know, plasma wire transferred for the cylinder, or I have Alusil, Nicosil, compacted graphite, typical just, you know, gray iron. And it's a real challenge to say what's going to work and how it's going to respond. Like the CGI stuff is like machining steel. It reacts much like steel. So tool geometry, speeds, feeds, you know, you need a library of everything that I've got going through my shop and keep track of it. There's not a one solution fits all.
Sure.
But that's the great thing about what we're doing here with Engine Performance Expo is we're giving people this network of resources so that you don't have to be intimidated by all the variables. It's, as long as you know that they exist,
Right.
and then you've got resources to be able to pull to action to be able to make sure that you solve the problem. That's what it's all about, is that we're smarter collectively than we are individually.
Absolutely. Right. You know, the networking part of it. You know the names, you know how to get a hold of the people, and we can get solutions because someone has dealt with it already. You know, it's an old industry.
Right.
And even the modern stuff, you know, we've been talking about honing cylinders with CBN and diamond. And you take a look at like the two-stroke Detroits in the 80s, they were honing the cylinders, induction hardened cylinders with CBN. So it is making its way out into more segments of the market. But again, just, you know, rely on the opportunities to talk with the people that are in the group and a part of all these teams, and we can get to a solution.
Sure.
So the moral of the story is change is happening. It doesn't have to be scary because you have friends that can help you. All right, Engine Performance Expo viewers, this is the whiteboard session I've been waiting for 2 days. This is my man, a good friend of mine, Dr. I said doctor, he has the PhD, Mark Malberg, who is the surface finish guru. And you've helped us
pretty
so
high
much.
bar, man. Pretty high bar.
I'm just saying.
Yeah.
But, you know, we talk about surface finish all the time.
Yeah.
Honing all these things. And, you know, you made a point the other day that these cylinder surfaces are the most engineered surfaces on the planet. So you deal with all kinds of surfaces, not just cylinders. So talk a little bit about surfaces, why they're important, and what makes these unique.
Sure. I mean, surfaces are important everywhere. You know, you heard the smooth as a baby's butt kind of thing, right? Well, products are designed to feel smooth as a baby's butt in some industries. You know, something you're going to touch and deal with, or, you know, something that's going to look sexy, or something maybe that needs to seal against an explosion. Well, that's the world of surfaces. And it's not just roughness, it's roundness and waviness and, you know, all the shapes that go with it. But to your point, cylinder bores have had more papers written and more research done on them than any of those other cool surfaces. So it's like ridiculously engineered, and we still don't quite have it all figured out.
Oh, it was, as a tribologist, you know, for all the years of doing oil testing and research, surface finish was the missing link. It was the variable that we didn't know.
Right.
And
it's voodoo.
But once we had a ability to measure a surface, now all of a sudden we can begin to engineer and change that surface and understand what's going on, because the contact mechanics are not nanoscale, but they're really small scale. It's not that macro scale of, does it look flat? Well, it could be flat, but as the previous videos watched, there could be waviness in there that changes that contact geometry. So it's really important to have the ability to measure.
Right.
And that's really what we're talking about in this segment, is this surface system, which is a complete package where, you know, we've talked a lot about in many videos, a profilometer. Now this is a Zeiss profilometer. So explain what that does real quick for people who may not know what a profilometer is and what it does.
Sure, it's pretty basic, but incredibly accurate. There's a diamond that's going to wiggle up and down on the surface. In this case, it's skidded, so there's a big kind of chunk of metal that keeps it in range. So we rest that skid on the surface, and then the diamond wiggles.
So as it goes, makes its trace and goes across, it's following all those little peaks and
Right.
valleys
Exactly.
that are on that surface. Because it looks flat to the naked eye,
Yeah,
but
no.
it really isn't.
So I want to bring up one point you raised there.
Mm-hmm.
We see a graph that looks on the screen sometimes that looks like this crazy stuff.
Mm-hmm.
We got to remember this is magnified a whole bunch. These are millionths of an inch, and these are inches.
Right.
So we get fooled when we look at this picture and we think we've got these steep valleys and how could you ever get a diamond down in that little thing? No, that's real wide. We blow this up so we can see it.
Right.
And it's all about seeing it. In this world of surfaces, it's not a number, it's a shape.
Bingo. So you need, and the reason why these valleys are so important
Yeah.
is because that's what holds the oil.
Right.
Because oil is both the gasket and the lubricant for a ring seal.
Exactly.
So to get
Yeah.
the ring to seal, to get cylinder seal both on the intake stroke and during combustion to make efficiency, you have to have a gasket. You have to have proper lubrication for longevity. Those valleys are what's going to do that job. So we have to work really hard to make sure in the honing process that we are creating with maybe the first operation,
Yeah.
a rough enough surface that has this valley, but then you're coming back and you're plateauing over it
Yes.
to generate the load bearing area.
Right. We're combining two processes. It's actually, it's not a surface, it's two surfaces. It's a smooth one on top of a rough one. It's creating that surface that's already been broken in.
Right.
In manufacturing, we say, well, that's not cleaned up. Exactly. We didn't want to clean it up.
Right.
We want to leave those valleys behind. And we want to do it in the right way, though. It's not just leave some behind, it's tuning that. And that tuning of how deep do we go? Let me take your plateau
Sure.
and we'll move it into the surface here.
Yeah.
Well, that might work in one application. Somebody else may need it down here.
Right.
And it's hard to see that with numbers.
Exactly. So one of the things we've seen with the profilometer for a long time is it makes this little trace and then the
Yeah.
numbers pop up.
Right.
And we're all focused on the numbers. But then once you begin to see with the software that you
Right.
developed, the TraceBall software, which is part of this surface system that's available from Total Seal, is these detection zones. So
Yeah, all right.
you've got this trace right here.
Yes.
But when you look at it on the software, we can see a red area,
Yeah.
a white area in the middle, and then a blue area. So explain why there's different colors and how those relate to the numbers.
Yeah, so helping people connect, back to their gut feel. I'm working in the wood shop, turning on my lathe, and I can see the shapes and I can control them. You're not controlling them with numbers. You're controlling them by feel and your own knowledge and
see.
experience.
Yeah.
So in the world of surfaces, in the roughness world, in these RK parameters we tend to use,
Yep.
we're dealing with a surface that actually has kind of three zones we care about.
Yep.
And in the TraceBoss software, we have the RK parameter, that core roughness, the RPK on the peaks and the VK on the
RPK,
valleys.
yep.
So we've colored those zones so you can see what's being reported as peaks. They're reported in red on the screen.
Right.
So we can say how much of that surface is peaky versus the running core surface. And then, hey, we happen to have a blue marker.
Worked out.
This is just like it was meant to be. There's a blue zone that kind of tells us this is the valley region of that surface. And it's that connection from numbers back to craftsmanship.
Yep.
Using both sides of your brain, the math side and the creative side.
And what really got my attention when we first started playing with the software and looking at it and seeing it is that diamond, that trace,
Yeah.
is what's real.
Absolutely.
It's the real surface.
Yeah.
The numbers are a numerical representation of the trace.
So true.
So we're already playing the telephone game.
Yes.
If you're just relying on the numbers alone.
Yeah, well, so have you ever been to a concert and it was the greatest experience and you tell your friends it was 104 decibels? It didn't convey the experience.
Yeah.
This picture is the experience.
Right.
Those numbers are like the decibels at the concert.
And that's
So-
that's the cool thing with the TraceBall software is that as opposed to trying to run the profilometer and look at the gauge and see all this stuff, now we can run the profilometer from the laptop using the software. So we could put this in the bore and scan the bore and you can look at it. And what's neat is because now you can save those files.
Right.
You're not dealing with one moment in time.
Yeah. See what you did last week. Or-
Right. So if you change well, for a perfect example, if you change what your roughing abrasive is, right? So we'll pull up here real quick. 3 different homes, all finished with 600 grit CBN.
Yeah.
But one of them's going to begin with the 325 diamond.
Okay.
Then we're going to go to a 170 diamond.
All right.
Then we're going to go to a 70 diamond.
So we're working on that base texture.
Right.
And you're going to kiss them all with a 600 in the end.
Yes.
All right, let's see.
That's the idea. So
cool.
let's start off right here. And I believe, one on the screen already is the 325 400 diamond. You can see that, that little flat area on top.
Yeah.
But those valleys really aren't going that low. Now let's try bringing in the 170s. And you can already see those peaks
those
extending
downward
down.
valleys in there. Yeah.
Those valleys, they're going to hold the oil because, hey, if I'm going from gasoline to say methanol as a fuel, I'm going to run more fuel through the engine with methanol than I did than gasoline.
Yes.
So I need more valley to do that. Then, of course, we've been honing some nitro top fuel cylinders back there this week, and
wow, you see that blue zone grow? So
went
we're
crazy.
just adding all kinds of volume down here. Now, we didn't even talk about numbers.
No.
It was an entire picture conversation, and we're back there on the hone saying, should we add a stroke or two completely on the profile graph?
Right.
In this world, those numbers move around so much, and you might have valleys that half count as peaks and peaks that half count as valleys, but that picture is truth.
Well, the other thing the other day, Mark Cronquist, who's been part of the show and is original Engine Performance Expo founder, right, in terms of sharing information, he made the comment that when they were, at one point at Joe Gibbs Racing, we had an oil consumption problem that was based on the fact that we were hitting the numbers, but we actually weren't getting the right surface. Only when they went to a lab and took a cylinder and actually could see the cylinder under a microscope, they're like, oh, this looks terrible.
Exactly. You hit the numbers, and it turns out it wasn't the symphony, it was a fire truck.
Right.
The decibels were the same.
Exactly. You want to see the song.
You want to hear the song, see the shape.
Right, so the next part is you want to see, well, guess what?
Yeah.
This can give you that two-dimensional trace.
How tall is it? How rough is it?
Right.
But let's get better.
This is the coolest thing ever. A USB microscope that you can now couple with the software. Now I can pull this up, and it's going to do me 2 things. One, I can see the surface.
Right.
Magnified.
Porosity, honing marks, reversals.
Everything.
Absolutely.
Is it clean? Or is
clean?
It
oh, yeah.
folded and torn? You can see that with this.
Absolutely.
Plus, it actually tells you what the crosshatch angle
Live,
is.
as you move around.
Yeah, I can move this around, and that crosshatch angle changes as it picks up the different crosshatch angle.
We're going for a walk inside the bore.
And then you've got this little thing in the background, the little spider plot, if you will, the blob.
Yeah, right.
That basically shows you how uniform it is, right?
Right. It's kind of the strength. How strong are those lines? Sometimes if you've got boring marks, you'll see a horizontal spike stick out because there's strength in the wrong direction.
Right.
So we want to see a nice X.
Yeah, you want a nice, clean, defined profile. And I know some people have already been playing with this. They've already started to notice that uniformity is actually one of the real keys to how well that engine performs.
Oh, that's
They can
next
have
level.
all the same numbers, but that uniformity is what's actually beginning to drive it. So crosshatch angle, surface finish, they're both really critical. So to talk more about crosshatch angle, we're going to go to a video with me and Ed Keebler demonstrating this tool in action. Hey folks, Lake Speed Jr. and I'm back with
Ed Keebler.
So here we're at Rottler Manufacturing, here where you make all the cool tools.
Yes, sir.
And Ed, I was noticing something on these machines that when we go into plateau mode, which is, obviously when we're trying to get the right surface finish.
Yep, when we're trying to get that maximum or extreme plateau.
Exactly, we're going for the extreme plateau.
Yep.
You'd be able to have your roughing operation and then your plateau operation. And I've noticed on these machines that when we go to that plateau operation, that the stones feed out and get their pressure before the head ever starts to spin.
Now,
tell everybody how that impacts crosshatch angle? Because we know crosshatch angle is really important in terms of how the oil moves up and down. Right? You guys know it. Oil is one of the elements in our ring seal soup, and crosshatch angle is that transport for the oil. So Ed, explain what we're seeing and why that's different than just the regular roughing mode where it just starts spinning and does its thing.
Right. No, that's a great catch, Lake. So what it is as we all know, we're looking for a consistent crosshatch angle from the top to the bottom. Right. Okay. We don't want two different crosshatch angles. We want the same crosshatch angle.
Now, isn't that one of the advantages of having a vertical hone?
Absolutely.
Okay, so
yes.
Just having a vertical hone by itself means that you're going to be more consistent in crosshatch top to bottom as well as board geometry, but we're talking about crosshatch angle here, so back to what you were saying.
Yep, absolutely. So what happens is when we're putting in our deep V's or with our rough abrasive, okay, we're taking out 2, 3, 4 thousandths typically, or even more.
Right.
But when we're plateauing, as you and I have discussed many, many times, we're taking out microns.
You're really not, it's not stock removal.
No.
You shouldn't be able to measure it really with the dial bore gauge.
That's correct. We're taking out 40 millionths of an inch, which is not measurable with a half thousandths reading indicator.
If you've not watched before, right, 100 micro inches, which is what we're talking about in terms of top to bottom of our surface finish, 100 micro inches is equivalent to 1/10 of a thousandth.
That's correct. Yes.
So we're talking about 1/10 total maybe on your dial bore gauge.
That's right. Yes. Yep. So what happens is if we were to do this in the normal mode, what the machine will do is it will expand the abrasive. It spins and it's expanding abrasives. It goes down and does a crash protection stroke, and then it comes back up to the top, spins till it reaches size, and then it begins the honing process.
Okay.
If we do that in a plateau mode, we're taking out so little. What we end up with is we end up with a flat crosshatch at the top.
Ooh.
No crosshatch at all, because we're going over the top of it.
It's just they're spinning
it's
like
just
this.
Setting there spinning. So anytime we're removing less than 2/10 or less, we want to be in the plateau mode. And in the plateau mode, as you explained, the stones expand several times to seek the proper pressure in the cylinder wall, and then the rotation begins.
Yep.
So that is really the key, and it's especially important when we're talking about these extreme plateaus. In the past, we've always talked about 220, 280, 400, that sort of stuff, and we're trying to inform people that really the way to get these extreme plateaus is a very rough abrasive followed by a very fine abrasive with minimal stock removal. And
well, I'm going to say this. What we've called plateau honing, for most people would understand as plateau honing, really was just making it smooth.
That's right.
We really weren't plateau honing.
No, we were not.
We thought we were.
That's right.
But we were just making things smooth.
That's
what we're doing now with this really rough, abrasive to go to size, and then plateauing with a much finer abrasive is actually plateauing.
That's correct.
We're calling it extreme plateauing now to give it a different term. But in reality, when you look back, like my dad's old engine, when you look back at a plateau home back then, it's just smooth.
It's just smooth.
It's just smooth.
That's right.
There's no valley. There's really no RK. There's no RPK. It's just smooth.
Yes, and you can really see that with the profilometers when you see when you get the sketch across there where it's actually tracing the surface finish. It's a very dramatic difference when you do a trace with the roughing op and then you do a trace after you've gone in with that that fine abrasive. You can. It's a very definitive plateau.
Well, I know a lot of guys are using what's called the RZ, which is the peak to valley distance. And they're actually using that as their guidepost when they go finish their roughing abrasive to make sure they have enough RZ before they begin plateauing so they know that they don't take away too much. Right?
That's
If
right.
you don't have enough RZ to begin with, you can't get there.
Right. That's right. RZ is the distance from the highest peak to the lowest valley.
Right. So how does this impact crosshatch angle consistency? And why don't we talk to everybody and show them the way you guys have a really cool tool that can add on to the machine to check
Yes, absolutely.
Because I know on this machine, I've seen these machines enough now that in terms of how you determine what your crosshatch angle is on these machines isn't by changing belts and stuff like that to figure out the stroke speeds and stuff. You just dial in the number on the screen, right?
You just put you put whatever crosshatch angle you want, anywhere from 0 to 90, and the machine will figure that out for you.
I like it when machines do math for me.
No.
Yeah, I'm not like Ben Strader that can do the math in his head.
In his head.
Yeah, of course he makes us dumb people feel better by having this calculator, like he's actually using it.
And the wheels are turning. And
right, exactly. All right, so we can just punch in the number on the screen.
Yes.
The machine does all the thinking. It does all the work.
Yep.
But how do you check it? Because I know traditionally we even have these little cards that Keith Jones made.
That's right. Yeah.
You can hold that little card in there, and you can kind of look and see what the crosshatch angle is by figuring it out, and then you got to do the math in your head of what that included angle is.
Right.
But tell us how you guys are doing it with this new tool.
Sure. Well, the first thing we have to do is give a shout out to Mr. Malberg.
Yeah.
Okay. Because Mr. Malberg is the one that developed the software that was enable us to do this sort of thing. And, and it's pretty cool stuff.
Oh, it is really cool. Wait till you see this.
Yes.
All right, show me what we got here.
So
what is this little deal here?
So this is a camera. And what it enables us to do with Mark's software is we can actually set that in the cylinder, and you can actually take a picture of it if you want, but it's got a magnifier on it and a light, and you can adjust that to get a good clear picture.
Right.
And then there is a like a diagram that will actually show you and read out the exact crosshatch angle. And that's what this has enabled us to prove to everyone how accurate these vertical stroke machines are. I mean, we won't vary more than a degree from top to bottom typically.
So this is your seeing eye, actually.
This is our seeing eye.
Yeah, you can go in there and it sees it, and again, the software figures it out. It looks at that crosshatch angle, indicates it, and then shows you right there on the screen what that crosshatch angle is.
Yes. Yep. Yeah.
Isn't that cool?
Yeah, it's pretty cool stuff.
Yeah, well, again, it's another tool for verifying what you have. No different than the profilometer is for measuring the surface finish.
Right.
This is your optical tool for measuring your crosshatch angle.
Right, exactly. Yep. As you and I have talked, we keep getting better and better at this, and it's because we have the tools to measure and to quantify.
Man, I keep thinking about Scooter Brothers, right? Scooter, you're right about all these things, right? You can't change what you can't measure.
That's right.
Here it is. That's just why he made Billy buy CMMs before they ever bought CNCs.
There you go.
If you can't measure it, you can't improve it.
Can't improve it.
So why even have this great machine if you can't measure it? And we got this awesome machine.
Right.
We also have the awesome tools to be able to measure it. So in the end, you get better, more consistent surface finish, better consistent crosshatch angles, which means your engines are going to be better and more consistent. And that's what this is all about. So hope you guys enjoyed this segment. Thanks for watching.
Thank you.
High above the machine shop here at Straub Technologies, the Engine Performance Expo rolls on. Time for our next roundtable, something that is near and dear to the heart of Mr. Lake Speed, who has been, like, that was a geek out session right there a minute ago, Lake. But I mean that in a very positive way. The passion, the technology, you and Mark with like a great new toy and then showing how it all worked. But surface finish is what we're going to talk about. We got Mark back, of course, Chuck Lynch, Ed Keebler, Billy Godbold. We're working you today, Billy.
Whatever, same pay, right?
That's absolutely correct. We paid the same thing.
Board.
Yes, we're not even. No, but the snacks are good.
The snacks
We
are
got
great.
coffee,
Excellent.
lots of coffee, snacks. Charles Navarro here. He was working, of course. Get in there, Charles. And I'm going to have a great discussion. And you're excited about this one. Tell us.
We were saying with Mark during the surface system demo that surface finish has been the missing variable. Charles and I have done as much work as anybody together and all this stuff, and obviously with Billy too, is that was the missing link in so much what we were doing. We were doing oil development, and if you don't have handle on your surfaces, you are blind. You can easily lie to yourself and accept the good results. Kind of like Jason Lyon was saying yesterday on the dyno, it's a tool. You got to use it correctly, and it's easy to lie to yourself and accept the stuff you want to see and dismiss the stuff you don't want to see. And surfaces are a huge variable in what that surface texture is. And I was fortunate enough to meet Mark through Billy when we were trying to develop oils for Charles, which is why they're all in the same panel, by the way. And then, you know, I leave Driven and I come to Total Steel. I'm like, oh, I need Ed and Chuck now because we got to do cylinders, right? And clamp load. I mean, I will never forget when we were there at Jasper looking at that Fuji impression film and the clamp load video we did earlier. It all relates. You have to have all that contact geometry. It all has to come together, which is why we have everybody together for the roundtable.
Tremendous.
You can't understate, you know, the surface finishes. They're everywhere. But like the tip of a valve, you know, how many people grind tips of valves, gives no consideration, and then they wonder why a rocker's worn.
Yeah, roller tip versus slider tip. When you have a slider tip rocker, that surface finish on the tip of the valve is critically important. And people, you know, you start looking at metals and you think about the strength of metals, you think about failures. Failures are never macroscopic.
Never.
Every failure starts at a microscopic level. You know, in every failure, people take anything in my office, they say, what happened? And you have a broken part. It's quick. It's like, well, the applied forces someplace microscopic were greater than the tensile strength, someplace microscopic. And they go, oh,
yep.
What's that mean? I said, it means it broke.
Yeah.
You know,
it just broke in a really small place,
right, and then
it propagated to a big
It
place.
propagates, and then they go, well, what do we do with that? And it's like, okay, well, one of two things. You've either got to figure out, why was that material weak at that microscopic point, or why were the loads high at that microscopic part? And of anyone that I know, I think the work I did with you, Comp Cams, doing exactly what you talked about, looking at the entire, you know, look at the picture. You said that the numbers were an expression.
Yes.
But the picture was the truth.
Yes.
You know, and we could look at those pictures, do that scan, look at what the lobe surface looked like, and that correlated so well with where we saw failures. As we made the bearing areas higher, as we controlled that contour, we would spread the load out over a larger area. And of everything I've ever been involved with, and, you know, whether it was parkerization, taper, everything else that we've done with flat tappets on roller cams, new metals, new heat treats, all that stuff, new lifters. Nothing made as big a difference on the number of warranties we'd see over a year than what we did by controlling the surface profile, spreading that load. So really, as far as headaches, you have taken away, you've added more years to my life than anyone in this building.
That makes up for the other headaches I've caused elsewhere.
Oh, that's fine.
I appreciate that.
Yeah.
Well, because I take them away, right? the chaos I create takes them away. You got to add it back.
Well, it's a balancing act. No, I think what was really cool, Billy, is you'd talked in the past about pushing material,
Yeah.
and then discovering geometry through another conversation you'd have.
Yeah, and that was from one of your former employees. You know, one of the things. You know, we were talking. You and I had good friends at Cummins, and you know, I'd come up with this tool steel recipe. We'd work with Carpenter. We came up with a brand new recipe, and I was proud as a peacock. I am walking around just strutting, thinking, you know, I have taken this up from 260 KSI to 280 KSI. And then I go up to the guy that's doing R&D at Cummins, and I'm like, hey, what materials do y'all use? And he told me one, and I kind of went, huh? And then I told him about mine and how much. And he goes, well, Billy, how much did you bring up the UTS? I'm like, I went from 260 to 280. So he went like, oh, well, that's less than 10%, isn't it? And I went, well, yeah. He goes, what if I told you that I increased my strength by 100%? And I'm thinking, well, you know, the best steel in the world is low 300s. The worst steel's down in 150s. You can't double it. You know what I mean? So if you're 200 KSI, there is no 400 KSI. So I'm like, dude, look, I know this. You cannot double the strength. He goes, what if I reduce the load by? And I'm like, oh my goodness, I was on the wrong side of the equation. Instead of looking at making materials, do you want to make material as best you can? Absolutely.
Sure.
But that's the way you get the 5s and 10%. When you want to go in and make the huge changes, you've got to spread out the load. If you're going to spread out the load, you have to do it by surface engineering. And we talk about surface roughness, surface waviness. We talk about compressive stresses through shot peening, nitriding. It's all about surface engineering. And when I got into surface engineering, understanding what the surface did, it was really kind of a life-changing perspective.
Absolutely. Should we mention who actually had that conversation?
You can. I'm just going to,
Thank you, Roger. We appreciate your help. We appreciate you sponsoring part of the Engine Performance Expo this year, too, by the way. He's now moved on from Cummins.
Yeah.
He works for Valvoline. He's the head of global R&D for Valvoline. Hi, Roger. Thank you.
Yeah. And you made me feel kind of silly.
Thanks for that too, Roger.
All right, so moving forward, we know surfaces are hugely important. I always look to you, Ed, and say, okay, well, how do we get there, right? Because that's the tricky part. It's like, okay, we want to end up in Toledo. Just came to my mind.
Wow.
But how do you get there? Right? How do you get from here to Toledo?
Right.
That path. So
Right.
I think that's where really leaning on you these last couple of years, I've learned so much of how do you apply the technology of the hone, the abrasives, and that process. I mean, my son Ben last night was telling me how excited he was to see you guys in action back there at the hone, figuring out how to hone those top fuel cylinders to get the surface we were looking for. And that it was like, it wasn't like, we want that number, you want this number, well then you just do this, you do that, and X comes out. It's like, no, it was an iterative, it was art.
Right, it is. Yeah, it's absolutely an art, but we have to have the prescription written or the description written by guys like you and Mark and Billy and everybody else, because we're the people that we do enough research, we try to get to the right surface finish that what I consider the experts want. I've always said I'm not smart enough to tell you what you need, I'm just smart enough to give you what you want.
Right.
And I have to say that I love this format, because yesterday for a couple hours and then this morning for 2 hours, I sat next to that gentleman right there and got completely re-educated.
Ben mentioned that. He's like, with you guys yesterday working with that sleeve, with the surface system, it was like everyone's light bulbs are going off, and it's like, holy crap, this is a whole new thing.
That was really great. Now, let me interject here. It was cool to be able to sit around and all look at the same picture without having to pass a gauge around and guess at a number.
Yes.
We were working more like craftsmen than accountants.
Yes.
It was really cool to see the engineering minds kind of freed up to talk about shapes.
Yeah. And I have to add to what you were saying, Billy, is Mark, the probably the neatest thing about Mark is he says, quit looking at the numbers and look at the picture, because a picture's worth 1,000 words, because we get so caught up in the numbers, and when we just look at numbers, we don't understand really what those numbers are telling us.
And there's another thing, like from working at comp cams, working with the quality people you have in there. At some point, like Mark and I, if you start telling me surface parameters, you give me an RA, I've got a picture in my mind.
Yes.
Then you give it then you give right. It could be either one, but I know about what it is.
Yes.
Then you tell me some of the other parameters. Each time you tell me a parameter, I'm redrawing a picture in my mind.
Yes.
You throw waviness, I'm drawing a picture in my mind. But that's after 10 years of doing this.
That's right.
And with different gifts than everybody else has.
Sure.
So
Yep.
I'm a mathematician. So you give me numbers, I'm going to do math, physics, you learn that sort of stuff. But when it came to the quality guys, once we had pictures of what this means, then all of a sudden the people that were manufacturing, at the machines, dressing the wheels, the people who were at the profilometer checking the part, man, they saw it and they got it. And it made when you hire good people, if you tell them a number, it's hard for them to be excited about it. But you give them a picture of it.
Right.
And it can be something like honing. Like I was at a shop and they changed the block a little bit, so it's a different sleeve. They had a great honing recipe, but it didn't work the same on each material. So instead of trying to get the same number, they started trying to get the same picture on different material, and it was great.
Right.
And it worked. take it to the dyno, and it did exactly what it was supposed to do.
Wow. Awesome.
That speaking of the picture, that's like one of Mark and I talked about this when his book came out. It was available many years before. I'd bought that other book that was from the UK or whatever.
Oh, yeah,
and,
yeah, we moved it, yeah.
And because we had a profilometer, and I went in the shop, and he said, "Okay, for statistical process control, we need you to record these numbers." Okay, what's that number? Well, you just record that number because that's important, and we record it. Okay, I put this number on the chart. Oh, I want to understand what that is. So I get this book on surface finish, and then peaks and valleys and amplitude, and I'm like, oh, now I've got this mental picture that this all makes sense, and now it feels much more important than 7RA or 22RZ.
Well, and that connection is what Ed and I were talking about yesterday. We were looking at honed surface and deciding, can we add strokes or not?
Yes.
We didn't make that decision with numbers. We made that with your intuition of how much material is going to be removed. Do we have room for 5 more strokes and still keep the valleys that we need? And getting people into the other side of their brain, the left brain, right brain numbers and art, it's both. We can do both. And that's really powerful. And it was some great conversations that move the ball so quickly.
Yes.
We don't have to do 100 tests to see if statistically that column of numbers on the spreadsheet moved. We can see it right there. We can turn the knob and see the change.
Right.
So it's very cool to be in this space of art and math and engineering and science and design.
Yeah, it really is. I mean, I'm up there in years, and I'm more excited today than I was 10 years ago.
That's awesome.
Because we're learning, and we're learning at such a fast pace.
Yes.
And it's like you said, and it all has to do, at least to me, the key has been, it's been this surface, this surface finish or the surface parameters or
it's all the surface engineering.
Yeah,
everything about it. Because, like I said, even the carbon structure inside the sleeve. So it's all about that material and how it all interacts at the surface.
But 10 years ago, was it possible to know this? Or do we only know this now because technology has made it possible to understand it?
I don't want to hurt feelings. It's been around a long time.
Yes.
You had the original Sun and Plateau honing document.
Yep.
Was it 83?
Yeah, 83.
Yeah, but it's that kind of thing of not invented here, or we don't need it yet, it's not broken, don't fix it. And we've had other levers we could pull. And we've pulled all those other levers. Like Billy, pulling the material lever.
Yeah.
I'm going to keep working material until
ran out.
You ran out.
Yeah, right. Yeah.
And so I think we're into that space. I've always talked about the evolution of my field, metrology. We went from length with micrometers to position with coordinate measuring machines. Well, what's left? The geometry and the roughness and the waviness within that, from size to position to shape. And I think a lot of industries are experiencing shape is the next frontier, macro and micro shape.
Yeah, when Mark was at our shop, and I've read all the textbooks, like we work with aluminum engine blocks, like Aliasil, Locasil, but I've seen pictures of what that surface is supposed to look like in a textbook. But he brought his equipment, and we put a Nicosil cylinder in, and looked at. You could see the plateau finish. You could see that it was there were no red spots. It was all green and just a hint of yellow on a properly honed Nicosil surface. And then that had the same RA with the Metrology as the Locasil surface, but then you put the microscope on it, and it's like 100% different. How do you get the same RA number on two surfaces that are 100% different?
Right.
And I had never been able to actually see those silicon particles that are exposed. That makes the whole system work because those cylinders aren't honed.
Sure.
So it functions completely different. So that goes to every material has to have the proper surface finish.
Yeah.
And it's not one size fits all recipe.
No.
Huge thanks for that, by the way. I've got the coolest demo surface in the world now, thanks to you.
Yeah.
But
Fortunately for a D-chunk block, right? So this piece of the block came falling off, and Charles gave it to him, and it's like...
I'm so glad that block blew up. Well, it was you, Lake, that pulled that surface under the microscope the first time.
Yeah.
And I heard you go, wow. And I had to come running.
It's to me, I have it saved on the thing as one of the reference surfaces because it's 3D. When you can see the little silicon particles in that matrix, then you can see the profile scan and you can see each of them. You're like, and then you went back and put them in the white light.
Yeah.
So go to digitalmetrology.com. What's the page where you have all the compared surfaces?
Yeah, it's the Surface Notes blog. And
Okay,
so we
Surface
just
Notes blog.
Yeah.
And you literally have a single hone, a plateau hone, an extreme plateau, a Nicosil, a Suma bore, the Locasil. It's all there in 3D.
In the same scale.
In the same scale.
So you can compare them, and they're in the library. You can download the files if you want to play with them. So
It's life-changing.
Yeah.
Just telling you.
I probably emailed that to more friends, than anything that's come out this year.
It's amazing. But it's that next level. It's the progression, right? The whole point of having conferences like this, why SAE has conferences, why STLE has conferences, why ASTM, everybody has conferences. Why? So we can get together, share, so we can get better. That's the whole idea. If we're not getting better, but who said that yesterday? If you're not working on getting better now, you're going to be worse.
You're going to be worse.
Right? So you have to keep getting better. And that's what's really great about this environment. I think that's part of it, Ed, is that culture change where information's, like I said, been around for a long time.
It's been around a long time.
But now we're all of a sudden we're disseminating it and we're adopting it and we're changing it. That's huge.
And I really do want to give you huge kudos because one of the things that you have done is make it easy to learn and comprehend. You get to some of these, like you were talking about, and these people are talking here, and I'm down here. And this gentleman right here brings it on at the level that even I understand. And I'm not the smartest hack in the group.
Well, Ed, so tell you what, when I go to some of the tribology conferences, I like the presentations that have pictures.
Yes.
Because I can learn more when there's pictures up there.
That's right.
Like, what word did you just say? I have no idea about, that picture makes sense.
Well, the digital metrology website, your website, has a little series called the Notebook Series.
Oh, yes.
And if you guys are interested in metrology, if you're interested in surface engineering, that's a great place to start. Go to the Notebook Series, find that on his digitalmetrology.com or something like that.
That's it.
I can't spell it, but I think it's there. Go in there, look at the Notebook Series and go through there, and it talks about each of these things. That accessibility, because you guys are talking about 1983, and I know it's a lot before that. In World War II, there was a tremendous push to learn about needle bearings and learn about the barrel shape of needle bearings, learn about crosshatch, learn about all this stuff. It's been around, for the better part of 100 years. It's a difference between the technology being around and the technology being accessible.
Yes.
And what we're not seeing now is, we had the earlier talk on cylinder pressure.
Right.
Accessible, the technology, that's been around since World War I, with the drum and a piece of thing. But it hasn't been accessible to recently.
Right.
Same thing, the metrology side, it's been around for a while, but accessible and learning to use it.
There you go.
Yeah, that's like the Auburn Botel Speedster engine, that's straight, overhead cam, roller followers, supercharged.
Yeah.
1920s.
Right.
But just the accessibility. So that was crazy expensive then, but all those things mattered. So.
Right. And you're 100% right. You look at it in racing, you talked about not knowing when you're ahead or behind. What happens is, if you're a little bit ahead, when somebody catches up with you, the first thing you do is deny it. And then as soon as you go past denying it, they're so far ahead of you, you've really got to scrape. So you've got to keep pushing forward on everything. And this has become an accessible place where people can really make a difference.
I think that's the great point, is that these technologies aren't necessarily all that new or novel. They're not unproven. They're not risky technologies. They're actually now just accessible. They're the
opposite of risk.
Right. In fact, they're the exact opposite of risk. They're actually more proven, more engineered, more studied than the stuff that you can buy or have been purchasing. These are things you can really lean into, rely on, and get better with.
Great job. And the way, I wish we had some pictures right here for me to look at, because I would understand better. But I think everybody needs to go to Mark's website, first of all, check out those photographs. And this is an interesting transition to our next video, which is the future of engine parts. Which, thinking about, if this is relatively old technology that now is available and being utilized, it just gets me a little bit excited. Like, what what does lie down the road, like what is possible in the future that maybe we have yet to do, and that's our next video. Excellent job by the panel. Thank you very much.
Yep.
And we're going to throw it to that next video, the future of engine parts, as the Engine Performance Expo moves on.
Hi, I'm Tim Odom of Engine Pro, and today we're here with Dan Begley from MALA. There is an exciting new bearing technology that Dan has brought to the marketplace, and we want to discuss that today and introduce it to you. Dan, what have you got?
So today we're doing a soft launch on our new F-Series line. We always had different series. This is a different suffix. It's an F-Series line. Tim, this is really cool because we took some new technology that we found and in the overlays, and we brought that to some old markets, older engine applications, the small block Chevy, big block Chevy, and the LS. So some very common things that we've made some improvements on.
So it's my understanding the F-Series bearing could replace the H-Series bearing. So how is the construction different than the H-bearing that we're also familiar with?
Great question. The H bearing is the staple bearing that I went off and made the print of. The F bearing is a tri-metal bearing. It's a cast substrate, so it's 20-30% stronger, same as the H bearing was. Difference is on the bearing itself is the overlay on top. This is a plating which uses different materials in the plating process. So the seizure resistance is about, I'm still working on some more testing, but about 90% higher of seizure resistance on the same bearing with the same geometry as the H bearing is.
So it's a premium version of an H bearing, really, with a premium overlay, and it's going to give that extra level of performance beyond what we've experienced in already a great H bearing.
That is correct, yes. So I always like to think when you're putting it together, I mean, if you can put a better part in there, it increases the reliability, better for the customer, better for the engine shop. They can put a better part in there because you can't control what happens when that engine goes out and what people do, or what situation is. But this puts more margin in the part, significantly higher seizure resistance on it.
Okay, and you also have a new ramp design on the main bearing.
Yeah, now this is a typical ramp and pad design. When you have a standard flat surface, a crankshaft comes in and hits the flat surface, you cannot get oil in there because two flat surfaces, you can't get oil in there. So in this case, this is a LS bearing, this is an H bearing, and it has ramp and pad. So on the back side, as rotation goes in, it creates a ramp to the pad to help lubricate the pad because the overlay, or in this case the substrate, which is the thrust, will start melting out when frictional temperatures gets up. So by adding oil with a ramp to the pad, you've increased the load carrying capacity 93%.
93%.
And so what I tell everybody is a lot of people don't even know this is on the standard LS.
Right.
And they'll fit the crank up and they'll need more crank in place. So the first thing to do is they sand the thrust, right? So you've eliminated this feature that's on there. So you've taken some reliability out, but this standard feature was never on the small block Chevy or the big block Chevy. So we've taken this and we've added it to the small block and the big block on the F series, and so you can create more oil to feed the whole more load carrying force to the crankshaft.
And when are the applications when you're going to get more of that load on that crankshaft? We talked about some of them earlier today.
Yeah, so typically a lot of drag cars do run stall converters. As they are waiting to go out there, those converter stalls, the converters balloon, they expand. Or if it's a straight shift, the clutch, just the force of the clutch and putting the clutch lever in is pushing directly onto the thrust surface. So by having that oil feature in there, it increases how much force can be put on there before you start a seizure into the thrust surface.
Engine life, bearing life, they go together. Yeah, so when are these bearings going to be available?
So right now we're working on manufacturing. We soft launched these at PRI, and we're working with manufacturing right now. We have stuff in queue coming. The goal is hopefully by the end of first quarter, possibly into the beginning of the second quarter, when we'll start phasing them in. And it's not going to replace the H, but it's going to be an F. So it's going to be new to everybody, but the geometry and everything is the same. We're just adding new technology into new engine platforms.
So this is going to be an exciting new premium level bearing beyond the H bearing. I think is going to be really interesting to a lot of you engine builders who are building the high end where you really want the best in bearing technology. So when you're ready to buy your next set of bearings, check with your Engine Pro warehouse and ask if they've got the new Clevite F-Series bearing.
Hidden Horsepower presented by Total Seal Piston Rings. Rockstar Engine Builders, Exposed, Joe Costello, Lake Spees, and we are joined by Steve Morris. Steve, I got to tell you, the folks out there on the Engine Performance Expo YouTube chat have been clamoring for you to be on the show. Excited to get involved and learn a little bit more about your engine shop and your trade. And the one thing that you said is that you are involved with anything boosted.
Yes, anything boosted, 1,000 horsepower and above, because we don't do anything nitrous.
No nitrous.
Period.
That's not what you said a minute ago. I appreciate
I was being kinder because every once in a while there's still some nitrous people out there that get
NOS,
personally offended.
I'm sure we'll say NOS, nitrous oxide sucks.
Yes.
Right. But isn't that what it's all about, right? Like those kind of rivalries. Like we've got the Ford versus Chevy deal. We've got all these different things. And boost versus nitrous, and the turbo guys are in a different direction, I guess. But that's part of it. That's part of the fun.
Yeah. Oh yeah, absolutely. I don't mean anything serious by it. I mean, if I'd say something,
oh no,
don't back up from it, Steve.
Nitrous sucks. I'll say that, and we're even coming up with a Nope shirt, which is based off of NOS, like Nope instead of NOS, So, but it's just all in good fun. I mean, if somebody wants to waste money and burn up pistons, that's their prerogative.
That's what Dominator said yesterday, right? It's like I
you can do anything you want.
Yeah, he said flat out, like it was an affordability, and it was sustainability.
Right.
About sustainability.
Yeah, well, he switched to boost.
Switched to boost. Yeah, there you go. Now
to boost because of just all the associated work that comes with a nitrous application.
Yeah, and my little saying too is, I mean, if nitrous was better, they wouldn't keep on giving it weight breaks to compete. So that's just
we're digging ourselves in a deeper hole here. Just see if we don't go on right. Well, it made me think about though. It's actually a fair point that I think back to the very first Engine Performance Expo. We had the video with Pat Musey.
Yeah, I was just thinking about Pat. Pat, if you're out there, hey man, we're good.
And he was talking
you're
about.
You're cool, Pat. It's okay.
It's all good. Yeah. And he was talking about how the cylinders talk to each other and to this morning's roundtable about the combustion analysis and how, cylinders talk to each other. And that's one of the things that makes, we'll call it nitrous more volatile in a sense, is that you're putting something in that manifold, that common plenum manifold. It doesn't just go where you ask it to go. It goes wherever the hell it wants to go, right? And a whole bunch of them may go over here. And now all of a sudden, your tune-up is way off because it decided it wanted to go left versus right. And spark plug's going to do what it's going to do, and next thing you know, there's a hole in the piston.
Yeah.
Right.
Yeah,
and
exactly.
that's no good.
Right.
So
Steve, let's talk about.
I like boost too. Boost is fun.
Boost is better.
It's all fun. Okay, but let's talk about how you got here. I'm meeting you for the first time. Where did you get your passion for engine building? Where did you start realizing that you wanted to go down this road? General curiosity for how things work is typically what people say, but what's the story behind it?
So if we go all the way to like the beginning, I was just telling this story that none of my family was involved in racing.
Okay.
In fact, none of my family is involved in racing except me. And they were music oriented, or my dad was an engineer in electronics and
automotive industry. I know you're from Michigan.
No,
okay,
not in the industry at all. I just had a passion. I liked engines. It was interesting to me. And I have this uncle, my Uncle Marty, that this guy was, when I was growing up, he's 9 years older than me. And when I was growing up, I'd see he had this Craftsman lawnmower with a Kawasaki 175 engine, and he'd hand narrowed up a 9-inch rear end and had 50s on it and was driving it down the highway. And he made articulated go-kart. I mean, center articulating go-kart, and he's like 16, 17 years old with weird motors and stuff. And so he actually got me interested in that kind of stuff way back in the beginning. And then I just liked the engine side of things, and I like horsepower, and I don't know anything other than that. It's just something that just is. I don't even think about it because it's just natural. It's just what I always have. I've never done anything else.
So that was before you had a driver's license or after?
Before. So I've never done anything else. I've always just been interested in one thing, which is just engines.
So what was the first car?
Well, my first car was a 1978 Cutlass, and we pulled the and it was a 4-door one. So we pulled the engine out of it and using the maple tree in the back of my yard and pulled it out, hook up the chain fall on the branch, and we pulled the engine out of it because it had an old 350. Yeah, no, it's 265 olds in that, and put a 400 Pontiac in it from a buddy of mine. Yeah, Pontiac. And yep. And I remember we had it all dressed up and everything, just with chrome air cleaner or air cleaner.
Oh yeah, of course. Oh yeah.
Just the stupid stuff. I mean, that's all I could afford. And we did the same thing. I had the old Krager 50s on that thing.
Super shops back in the day, man. Yeah.
Yeah. It was just fun. I drove it around I drove that thing around for probably 2 years and never had anything other than empty exhaust manifolds. It just was manifolds and no pipes.
Straight down.
Yeah.
I'm sure the neighbors loved it.
Yeah, they didn't care.
But what about, okay, so going from that to it's a job, it then becomes a business. Like, did you go to a local shop and try to get in there, or how did you go from being an interested young person to going to work?
Yep, so it's in high school. I just told this story too because this is funny because in my high school auto shop, that's where I first started doing stuff, obviously, and I got kicked out of high school auto shop in my senior year. Yes, I was exited.
You and Mark Cronquist, by the way.
Yeah.
Oh,
good company.
What do you do to make that happen?
Well, so we did an engine rebuild and shop, and it was just stupid 350 Chevy. It was nothing special, and then other kids put the motor in the truck, and it was for my auto shop teacher. It was his personal deal. And they went to go start it up, and the thing wouldn't start up. And I go, the distributor's in 180 off. It's just misfiring. And they go, no, the timing chain's 180 off. I said, no, that's not possible. The timing chain cannot be 180 degrees off.
Let's put the small one on the top.
and then it's one rotation and it's back down to the bottom. I said, that's impossible. That's not possible. You just have the distributor in the wrong spot. And we got in this big heated argument and I got kicked out.
And you were right.
and I'm right. Yes. So after that, go from high school. There was a really nice little program at Ferris State University, which is in Michigan, and they had an automotive machine program, and we did everything there, just learning the basics, learn how to basically turn on a machine, how things are basically working. Everything from a old cam grinder to crank grinding.
Oh, wow.
Yeah, everything. So it was a good experience, and then I went to work in a little machine shop behind a parts store.
Okay.
And that's my first experience is starting out at it was smaller than this room.
Right.
The complete machine shop. And so I worked there for a couple years, and right away my passion actually, even though my passion now is anything boosted, but actually my previous passage was anything pro stock. So
Okay.
I was always involved in NHRA pro stock, and I had these little set goals of what I thought I was going to do in life, and one of my goals was I said that before we had, I was going to have a kid at 21, which we did. That's my oldest son, Tyler. And I said, I want to be doing NHRA Pro stock engines by the time I'm 23 or 24 years old. I said, I want to be doing this. And so I'm working at this little machine shop.
Yeah.
The guy retires. I'm 21. The guy retires and says, hey, I think that you would be a great person to buy the shop. What do you think about trying to buy the shop? Well, I mean, it's really small and cheap, relatively speaking.
Yeah.
And so I borrowed some money from my mom and grandma and bought that little shop. And probably the problem is that he went away. So nobody was there helping me do the business. He just kind of went away. Well, I'm 21 years old, and no offense to 21 years old, because my younger son over here is 21 years old, but you're semi-retarded. You just don't know it. You haven't connected all the dots.
Kids. I'm sorry, but it's
sorry. You haven't connected all the dots yet. You will. And when you're like 30 years old, go, oh my gosh, I was not very smart then. So long story short, I lost that business and I had to sell it. But all of a sudden, this opportunity came up to work for Richard Maskin.
Okay.
In the Dart cylinder head program. So I went there and interviewed for a cylinder head porting position. So I'm sitting there grinding, porting heads and doing the whole deal. And it would have been Kevin Feeney.
Yeah.
So, and Kevin's here. So I'm 99% sure Kevin Feeney came up to me and said, we don't think you're going to fit in with the cylinder head porting, but we have an engine position opening up, and we think you'd be really good for it. And I go, really? Okay. And it was in the pro stock room, and I'm thinking, ching, 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 everything's freaking happening. It's awesome. This is going to be great. Well, this is like in June or July or so when I interviewed there and didn't hear anything back. So I started my little campaign of I contacted these guys. I called Dart up. And would have been talking to Kevin, actually. He should remember all this, actually, maybe. But I would call them guys up every week. Have you made a decision? Have you made a decision? Have you made a decision? For 6 months. Because sometime in December, probably the end of December, around Christmas time, they said, you know what? We need to bring somebody on. See you here January 1st. And I started January 1st, 1995, and I was 24. When I started.
There it
Persistence
is.
pays.
Persistent.
Yeah, absolutely.
Yep.
And you definitely, they couldn't say no. This guy wants it too bad. Can't say no, right?
Yep. Wanted it real bad. I have a plethora of stories with Richard Maskin.
Oh, I guarantee you do.
and that era right there, like they were hot at that time too.
Oh, that was. I came in right at World Championship with the McDonald's, with Jim Yates. Everything was just firing on all cylinders, and everything was great. And I will tell you, the one of the primary things that I learned immediately was, I think it probably quite literally was either the first or second day that I was there. So it would have been like January 1st or January 2nd. They were dyno engines, so I'd never even seen anything like this. So I mean, I went from never even seen a dyno to NHRA Pro Stock dyno, and
awesome.
It's awesome. And I'm just flabbergasted, and I'm just nobody. And we're sitting there, and at that time it was just Paul Hoskins and Richard Maskin, and Richard's running the dyno, and this motor just singing perfect, and it just and it spilled its guts on the floor, knocked a rod right out of it. And the thing that I always remember and that I'd like to make people help them understand is they're sitting there, and this is a pro stock engine. Its name was Shelley. We named engines at the time, and its name was Shelley.
They still do.
Yes, name was Shelley. So Shelley just coughed her guts up on the floor there, and I'm like, oh my gosh, what is going on? I don't even know how to. I'm not saying anything, do anything. And I very vividly remember Richard and Paul go, what do you think happened? And Paul goes, I don't know. Well, let's go figure it out. And I immediately understood that I came in thinking that these guys know everything. And I really started understanding, these guys are figuring stuff out. And that's all I've ever done. I just figure stuff out.
Gotta stay curious, right?
Yep.
That's amazing.
Break it, fix it, figure it out. But the smartest people you think out there in the world, they're figuring things out because they don't know. They're just. What happens when you do this?
Find out.
Yep.
That's great.
That was bad.
That's great.
Let's not do that again.
Yeah,
Something else.
24-year-old Steve in there with like icons of the deal, pro stock. He's into it.
Yep.
Let's go mop it up. Figure it out. Figure it out. All right. So fast forward till now. You talk about boosted stuff. Preferred method of creating boost is Because we have Pro Chargers, you have root styles too. Like what and where are these engines going? Are you drag racing? Are these powerful street engines? Like where's your typical customer use your product?
My niche and my whole market really is drag and drive stuff.
Okay.
Yep. So big horsepower, but we need to drive it. And so when we're driving this stuff, we're driving an engine that does make 4,000 to 4,500 horsepower, and this thing is idling for 8-10 hours in a day. I mean, just sitting there driving, pulling a trailer, 2,000, 2,500 RPM just for 8 hours. I mean, just driving and stop traffic, 100-degree heat. I mean, you have to do all of that with these things. So that's my niche is that whole field. And as far as the power adder of choice, I'm started out doing Pro Charger stuff. In fact, I did first started out with I wanted to do make 1,000 horsepower on pump gas, and somehow I did remember Inside Drag Racing with Brent Kepner?
Yeah.
I did somehow we got connected and did a show, and this would have been in like 1998. Sorry, I left Dart to open up my own business. I had that desire to do it all again on my own. So I left Dart, started up my own business, and did this whole show about a 1,000 horsepower pump gas Pro Charger deal. And so that's where I started out, was in the Pro Charger field. We do probably more right now of turbocharged stuff than we do of Pro Charged or centrifugals. I do a little bit of root stuff, a little bit of screw stuff. No nitro stuff, obviously, very minimal. NA stuff, if somebody wants me to, I'll do it, but really focusing on just big horsepower, drag and drive, turbocharged, Pro Charged, centrifugals, stuff like that.
Excellent. Shout out to Brett Kepner, by the way, Hall of Famer, great guy, and probably, arguably, the most knowledgeable drag racing person on the planet right now. Guy loves it like nobody else, and it's great. So let's get into drag and drive a little bit more. As time has gone by, that is a thing that has
huge
taken over because of all the great elements of travel and community. And we're going to do a road rally, and we're going to drag race, and we're going to make 4,000 horsepower and all those things. But that can't be easy to accomplish those things.
Yeah, no, it's not easy at all. So I showed up at the first drag and drive event with my station wagon that I'm racing right now, and so that was drag week. That was at KIR, so it's Kansas International, and blew it up right there in the spot. In fact, they were really upset at me because I drove it all the way down the track, and it dropped oil down. It was horrendously bad.
Don't do that. All your kids out there.
Please don't do that. Make sure you pull off the track and not screw everybody's.
Control, slow to a stop.
Yeah, yeah. Don't do that.
You'll make friends better that way.
Yep. And so, anyways, I was there, started that, or I didn't start it, but I mean, was there in the very beginning of that, and so I always had that interest in it because that was like the key deal. It's like, this is a really good thing. This whole drag and drive thing is really interesting because I like that. I mean, it's a
crazy challenge, right? So
it is.
Brian Loans.
Yes.
Brian Loans.
The Dorkomotive podcast.
Yes.
You should subscribe to that. Over Christmas, they had the 1992, hot rod fastest streetcar showdown.
Yep.
Where that was kind of the origin of a lot of this drag and drive stuff, and that told the whole backstory. It was fantastic, and I didn't really know any of that stuff because I was a NASCAR guy back then. So it was really incredible because I think made the comment like the second year they came back, they made everybody do a 25-mile drive and like half the field blow up.
Yeah, exactly.
Because it's really challenging to do what you do. I mean, I remember a few years ago when Drag Week came through Charlotte while I lived in Concord.
Yep.
And I remember Kevin Studecker, who works for us at Total Seal, him and Ben Strader did it. And I remember they left Charlotte, then they drove over here to Bristol.
Yeah.
And so, you're literally driving a few hundred miles, do all this crazy mountain stuff.
Was that the hurricane year?
Yes. It was awful, right?
During the hurricane, yeah. So there's this great big cover on Hot Rod Magazine of Tom Bailey, who's a buddy of mine and good customer, the original Drag Week guy with me.
I thought that was your engine.
Yeah. driving through the rain, and it was just downpouring. So I mean, that car, you know, is making like 3,500 horsepower, and it's, you know, I mean, we're on at Mickey Thompson ET Street, I think was what we were driving it on, and I mean, it is so atrociously bad. In fact, we get people look at that picture. It's on the cover of a Hot Rod magazine, and it was Hot Rod that took the picture, and people think that it's a scam. It's like, you can't drive a car like that. Yeah, you can.
And how fast did it go?
This going like 650s.
Yeah, a 650 car driving in a hurricane.
Yeah, in a hurricane, and it was so bad. There's no windshield wipers on it. Yes, it can. In Michigan, you can license a car like that. People ask this all the time. There is no emission testing in Michigan. They don't do anything. You can just about license anything. So it's licensed in Michigan. And it didn't have any windshield wipers on it. So you just put Rain X on it, you know, do that. And there's obviously no defrosters in a Pro Mod style car.
Right.
So you got the windows down. So it is freaking downpouring so bad you can see it on camera. So you know it's raining really hard. And rain is coming inside. I mean, it was brutal. It was brutal. It was brutal. We won that year, but it was brutal.
Yeah, that's awesome. Running out of time.
650s.
Yeah, well,
that's still crazy to think. 650s
Tom ran in the fives
on
now.
the street.
Yeah, we've gone fives now.
Now they've gone in the fives. They came out and did some exhibitions at the NHRA a couple of years ago. Had a great time. What's the greatest challenge of that, though? Like, I'm thinking about just the heat sink immersion of all those high performance parts on these. You mentioned like you might get stuck in traffic. Like there could be traffic on a drag and drive, and what is the greatest enemy of your engines during that process?
Overheating, and they just sit there and idle. I mean, we've been in. Let's see, not that year. I think it was the following year. We were in Washington D.C. We're on traffic on whatever one. I mean, it's
Beltway.
Yeah.
Variable, right?
Yep. I mean, you're stuck. You're just sitting there. And in the Tom's white car isn't as bad. My station wagon's not real bad at all. But Tom's orange car, the one that the Hurricane car, you have to sit like this because it's got the exhaust pipe comes out on a side pipe from the turbo, and it touches the bottom frame bar and the A-pillar post that kind of comes down there. And so the roll cage is so hot, it is, I mean, the water sizzles off of it. It's that freaking hot when you're just sitting there. So me and Tom would get out of the car when we drove to the gas station, had to refuel because it runs on pump gas. So drive to the gas station, and we have videos and pictures of us. We would literally just walk in the beer cooler and stay there for 15 minutes, just try to cool down.
You're cooking in there.
And then go back in and get in the car, you know. So I mean, those things are tough. If it was a 9-second car or 10-second car, those things are pretty easy and probably would be fun to drive on drag week. It is not fun. I guarantee you, I've done this for like 11 years now. It is not fun doing drag week at that level or sick week at that level. It is a lot of work. It's hard.
Yeah. Steve, we're running out of time here. Yep. Your first appearance on Hidden Horsepower. Speaking of podcasts, please subscribe to Hidden Horsepower presented by Total Seal wherever you get your podcast. We got more just like this. But the first time we meet somebody, we always ask them about advice to the next generation, some young person who's out there watching, maybe their dad's watching and they're thinking, man, this sounds really interesting. I want to get there someday. I would love to be the story of you at 21 years old. That is amazing. But what advice would you share with the up-and-comers that can help them get ahead?
If you have the guys like me, the owners or boss or whatever, are looking for somebody with passion and somebody that's willing to start at the bottom, pay your dues, and work your way up.
There you go.
Period.
Simple as that. Steve, thank you very much.
Thank you.
Steve Morris, engines.com, the website on the shirt, Drag and Drive, Boosted, and Hey Nitrous Guys. It's just all in fun.
It's all in fun.
It's all in fun. It's all in fun.
Don't hate.
And this has been Hidden Horsepower. More Engine Performance Expo coming up. Stick around as we hit our next video.
Hi, I'm John Callies, and we're going to talk about the basics of crankshafts and what makes the difference between a standard crank and a racing crank. The nomenclature, we'll start up here. This is the snout, and this is a naturally aspirated, so you have this keyway for your cam drive and for your dampener, and on a blown car you have two keys, one opposite. This is your first main. This is a 8 counterweighted big block, 4 3/4 stroke. And it's got everything done to it. In other words, the whole crank is polished, so we're starting with the top end piece. So number 1 main, 2 main, 3, 4, and 5. Now this also acts as a thrust on a Chevrolet and your flange in the back. Number 1 rod bearing, 2, 3, and 4. Now the counterweights, 1, 2, 3, 4, 5, 6, 7, 8. A production engine, like we're seeing here, does not have center counterweights. My feeling, this is my personal feeling, is I like each to look like a single cylinder. So I want a counterweight opposite every rod journal. Now, you'll notice that we have different shapes on the leading edge of the counterweight. Now, you can have a bull nose, you can have an angle. Each manufacturer has their own specialty. When this one was done, the idea was to try and push the oil away from the rods towards the mains. And to be honest with you, to try and prove which one's better, it would be a very difficult, you'd have to be at one of the cup level development dynos, and I don't know, it would be even worth the effort, okay? But anyway, that was what this manufacturer did. Oop, I forgot one thing, which was important. Is you have heavy metal in the counterweights because this is a 4 3/4 stroke. But one thing I wanted to show you is if I put this level on top of the mains, you see that there's distance between the bottom of the rod. Our overlap is terrible. And it's going to bend right in this overlap, and that just starts cycling. Next thing is you're going to get cracks around here and cracks around here. Now, obviously, material, radiuses, finishes bring the level up. But in all honesty, this is the weak point. So when you put heavy metal in, I've seen people put heavy metal through the end, which is absolutely wrong. And it's more work to do this, but you have to drill, ream, you want a 2/1000 press, and that heavy metal will not come out. And again, there's different types of heavy metal. So the good manufacturers buy precision OD, so they don't have to mess with the heavy metal. So they buy it in the width and the diameter that's already ground. Now, on this particular crank, you see there's a hole here, here, and there's a hole. It's drilled from the back, and that's strictly a weight reduction item. Now, where you start in a dry sump pan, where you make different stages in there, when you have this, you can deflate what you're trying to do. But that's another story. But anyway, this putting the heavy metal in is very important to do it correctly. And I've seen on the internet people drilling in the end and putting it in the end of the counterweight. And you do not ever want to take a chance of that thing flying out at 7,000 to 8,000 RPM. And the other thing is, you see the lightning holes here? Now the lightning holes, the only reason they're there was to reduce crank weight. And over the years, what it became is, how big a hole can I put in there? Look at my crank. Look at the weight I took out. Unfortunately, there's a point where you get so big, one, you get close to the oil hole, two, you cause more deflection. This hole does not help the structure of the crank. However, people demand it. So I'm just saying, there's a balance there. Now this is a blown up version, And I wanted to talk, first of all, on a racing crank. And what I'm talking a high level of companies, okay? So you have Winberg, Callies, Bryant. Those are what I'm saying, have the equipment, can do the proper job. What is important is the flatness of the rod, the flatness of the main, and what type of radiuses you put in. So a typical production crank will either have an undercut that's heat treated or a 80 thousandths to 90 thousandths max radius. Every racing crank, the minimum is going to be a 125. Then that causes the bearing manufacturer to either make a narrow bearing or you do it yourself. Okay, but now there's plenty of bearing manufacturers that make different items. Now the other thing is, these holes, that's another picture, this flatness, I want to keep from 0 to 2/10 all the way across. Same on the main bearings. And you'll look at stroke difference. On a racing crank, it'll be +1 to -3. That's kind of the spec. On a repaired crank, it's going to be +0 to -2. And if you think about it, guys, if you send a crank in for repair and you grind it and now it's a +1 and you had all your other pistons and rods fit, and now this one, the piston's sticking out, you don't want that. So that's why there's two different specs depending what you're doing. Now, how do you get that roundness? Well, the only way you do it, this is called an Arnold gauge, and it's a 3-point gauge, and this goes over the main journal or rod journal. But here's the trick. If I start out at 4.5 thousandths, I'm going to end up down here 2 or better. Well, now, if you're doing production crank rework, you do not have the time to go to these specifications. Racing cranks, that's where they're more expensive, because this is only time and operator. And of course, when we call it rounding up, in other words, I have it in the grinder, and I'm grinding, and I'm watching this thing come down to 3, down to 2, down to 1, down to a half, and I'm listening, and I can hear it round up as I get to my point. So if a guy's listening to the radio, I don't want him grinding my cranks, you know. Now this is a snap gauge, and the same thing. This is intense, but this is where you're using after polish, because you don't want this crank spinning and put something on it to mark the thing up. But these are masters, okay? And so you have to have a ton of masters, or you use air gauges, but the same thing. An air gauge may have 3 or 5 points it's doing, or in this case it's 1, and you're going to snap it on carefully. And again, you want to make sure when you're done polishing that you have not put dips or whips or whirls, or you want it round. So like this is a master gauge that goes 0.0000, guaranteed. And all these things are expensive. That's why you don't see them in a normal shop that's doing just regrinding cranks. The flange is an important area. Now one, this is a racing diesel rear crank, and it has 8 bolts in it. Also, this flange is critical, because the flange, you don't want any more run out than what is at the main. So you'd like 0, you'd like this at 0, it may go a 1/10 out, okay? But this is what you want. Your flywheel, your flex plate, whatever you're bolting on there, should be a precision fit to that center. Now the bolts, now this is a 6 bolt, so is this. And of course we have this timing ring on it, which gives your crank timing and ends up being where your camshaft is. But anyway, 8 bolts have more clamping load than 6 bolts. And when you go from an LS engine to a LS7, they went to 8 bolts. Reason is they needed more clamping load to keep that part on. Side note, when I did 100 years ago the Pontiac Super Duty 4-cylinder, I had 10 bolts. And the reason for that, at 8,000 RPM, we had over 14,000 vertical shake, 10,000 pounds longitudinal shake. Well, you needed stuff to hold on. It was horrible. Now this is the 100-year-old way of polishing. And I know you guys are going to tell me that you can do a perfect job. You use a bolt that's worn out, you put WD-40 on, you have all these tricks. The problem is, if you don't have a hard backing, your shape is horrible. The other thing is, if you put as much as one little line around, you will lose 15% in durability, creating a fracture point. Now this is a Rossler machine. This is how you get a that crank picture is using this. Now this is media, and then it has a recipe of other things that go in with it. But that crank you saw, that is a 12-hour process to get that crank. And so you have rim, which we use on the lifters, but it doesn't work as well on a crankshaft. So Rossler's kind of being one of the companies that stepped up. But just like the rim, they tell you just do this and this, and you find out, no, there's a whole learning curve and your special recipe to make it work the way you want it. Now, when we get done, we want to have the radiuses at 2 micro or better. But the difference is here, there is no circumference pattern on the radius. It's polished through being scrubbed. Now on the journal itself, if we might put it under a microscope, you would see polishing lines. But you don't want that on the radius. So that's why you have 2 different types of machines. Now this is Q-Pack microfinishing machine, and this is a 15 micron paper. Now they did these cutouts to supposedly polish the radius. It doesn't do a real good job, but the point is I don't want the marks around it. So this is really the first process, is doing the rods and mains, both with this Q-Pack machine, this 15 micron tape, and we want to get 2 or better. But you see here, the trick is, this is 100% cylindrical, the size of the main or rod. So therefore, you don't get bumps, whoops, anything. So again, we're looking flatness within 0 to 2/10. This is a Sheffield precision measuring lab, and what this does is determine index, which is where are the crank pins to each other, and also what the stroke is. Now, this is a computer program that you touch off and it gives you the results you want. Now, just to give you an idea, we want the index to be 0 to -2. Now, it's very difficult when you get a crankshaft to look at the index. It's easy for you. I got a lot of stroke checkers to determine what the stroke is. So you kind of take the word, and really the companies I mentioned, they do a great job in hitting the tolerances. So this instrument, Sheffield, this is probably a $15,000 kit, you know, but that's what it takes to know what you're building. Now, crankshaft materials. So we got now I'm talking performance now. So we got 4340, 4330, and fuel is ENB 30. Now, everybody says my imported crank's 4340. I'll guarantee you guys it isn't. It's not like 4340 that I would buy from Timken or some other manufacturer in the United States. Now 4330, the 3 here is 1/10 less carbon. Now the new LS LT cranks are 4340. Chevrolet finally got off the nodular iron crap and went to a good material. And that's why people love these things, put hovers on them, you know, I mean, they get away with a production crank. The thing is, the 4330 has vanadium in it, and the vanadium allows you to get the hardenability easier where you want it. So your billet stuff is always 4330, okay? Now 4340, you nitride it. Now on a fuel crank, that's this ENB30, and again, 3 manufacturers that make a fuel crank, Bryant, Callie's, and Winberg. Yeah, I'm sorry. Yeah. Now, the thing is, you through harden that crank. Now, when you through harden a crank, you cannot straighten it. You know, you might think, I'll just put it in a press or I'll beat on the radius. It isn't going to change it. So now, just to build this crank, now that's $5,300 for a fuel crank that maybe makes it 8 passes, maybe you get lucky and get 15. So going fuel racing is expensive. But now we're heat treating it to a 55 RC. But before we do it, every surface on the crank is 140 thousandths oversized. So now when you get it back, you got to grind all the mains, rods. Now, this flange is 55 RC. Now I got to drill it, I got to tap it, I got to drill the front nose of the crank, tap it, and they use, it's a special carbide high pressure drill, but when you break one, 155 bucks out the window. So, and then your taps are crazy too. So one, very hard to build these things. And so everything is longer. Now, what I like is on the EMB30 is Timken, by the Timken billets. Stuff's right on, same every time. But when you see this, don't be surprised. If you guys had to build it, you go, I'm not going to do that, you know. And that's why there's just a few people doing it. So I know you guys, if you take a file and drill it for me, see how much fun you have. Engine oil flow. A small block Chevy, whether it's an LS or an old 350 or a big block, 5 gallons a minute is what it takes to run the engine. Now, pressure and flow. If I had my way, we would not have oil pressure gauges, we would have oil flow gauges. So you knew you were getting enough oil to do the job. Now in today's cup engine, they're running 9 gallons a minute. And you go, well, wait a minute, everything's so close toleranced and watched, why? Well, you forget there are a minimum of 16 nozzles putting oil up to the underside of the pistons. Every spring is being sprayed, and it just takes this much oil to do the cooling that you're needing. Now, laminar flow is where you get the oil, it gets spread, so at the highest compression pressure you have some film thickness. Now this is a portion here, and so you can see the radiuses and the finish. And these holes, when I first started, we had fixturing and we'd move the crank to 7 different fixtures to get the oil holes in it. But we were using regular drills and you would get circles inside the oil hole. Now it's all done CNC, and you use a carbide tip and it's just a beautiful hole, so it makes the oil flow through this area. Now today you have a specialist in the shop, maybe 2 or 3, that put the radiuses on the oil holes, and that's because you can ruin a crank right here or make it. So you have specialists that do it. Now, this is the main bearing and the rod, and you have this angle. Now there is a formula for this angle to help develop how much pressure behind the oil column as the RPM goes up. But more important than that, right here is top dead center. 12 to 14 degrees after top dead center is your highest compression pressure. So when I had Pontiac's money and working for GM, I built cranks that had the hole go from here 30 degrees, 50 degrees, 60 degrees, and then I did one at 80. And every time I moved it farther back, the laminar flow would spread across the entire bearing by this point. So that's where this 80 degree ended. And so when you move this up, you do not have the laminar flow across that rod bearing at the highest point you need it. So that's just one thing that we worked on, and that developed that. And what's surprising is when you look at a production crank today, it's real close to that. So kind of fun. Crank differences between these two cranks. Of course, a small block, the original stroke was 3,480. The LSLT is 3.622, and of course that changes with the LS7, bigger bore, smaller stroke. Rod diameter 2,100, main diameter 2,448 to 2,559. And the reason they did that is you wanted the overlap between the two. The snout diameter used to be 246, and this was back in the day. People started putting fluid dampeners on that weighed 5 million pounds, and they'd break the nose off. So our position was, if you're going to use a fluid dampener, we're not guaranteeing anything. But now fluid dampener has come out with an aluminum unit that is really cool, and the benefit is the hertz rate that it can cover is around 350 versus a dampener that, let's say, is a rubber dampener, it might have a 50 hertz. So pretty cool thing to look at is the new fluid dampener. Now, of course, the material of the original one was nodular iron. They went to 4340, which is a big plus. The counterweights, because of the engine block, are smaller. Now they put the counterweights out so the balancing becomes easy to do. And a thing I really like is the thrust went from the rear to the center. Now, if I just had this crank, you Ford guys would say it sure looks like a Ford. Yeah, Ford had a better idea, okay? And so now we fixed the snout size. We put the thrust in the center. Why do I like that? Because this crank is flexing. Now I'm controlling the length in the center, not at one end, okay? So that really is a help. So they did a wonderful job on this crank. And you see, the thing is, where you see this is an aftermarket, and you see they wanted big holes. And I'm telling you, when you put holes in, you have to be careful where the oil holes transition. But the worst thing is, when you're cutting in and making this narrow, this still becomes the weak point of the crankshaft. Now, on this particular crank, with your thumb, you can figure the transition between the radius and the flat. And we don't want that. We don't want any edge. It should be a perfect, smooth finish. Shaft Tech is a good friend, and he does repairs. And he has all the equipment shown in his repair shop and can go nitrite, do everything. And I'm just saying, if you have a race crank and you need it repaired, these guys can do it, and they do a first-class job. So anyway, I thank everybody. Thank you very much.
There's nothing better than John Callie's with the pointer.
Oh, exactly.
You know, like he is. There's, you know, Warren Johnson, of course, is the professor, but John Calley's the professor. There's multiple professors, and what an informative segment. Welcome back to the Engine Performance Expo. Joe Costello, Lake Speed, Rick from CP Carrilla. Like, it's been going great, Rick. Obviously, we got some products we're going to talk about, but your thoughts on the expo so far? Got in on the mix yesterday. I've had a great time. What about you?
I think it's really cool. I've done a few of these deals where it's just the camera and you, and I don't do well. I kind of lock up. Anybody that knows me will say I got a gift for gab and I like to tell stories and whatnot, but the camera and me
don't get along.
This is cool because you guys can share the pain with me, but you're kind of seasoned professionals, so
we make it easy.
I really like the roundtable.
They're great,
format.
aren't they?
It's just like the guys sitting around over a beer talking about technical stuff, racing in general, all this, and it's just, you know, with a camera on us, but I think probably everybody, it's just a more comfortable setup for them. So I think it's really cool.
It lets everybody else kind of be that fly on the wall to hear those conversations you wouldn't get to hear otherwise.
Exactly, yeah.
Well, and when it's direct to camera, you're trying to keep it going. Sometimes there are points that have to be made and things need to slow down a little bit, and people will. And for those who want to see that roundtable, you can go back into the archive and watch all of this. That's a great benefit. I know I'm going to go back and watch a lot of it. You blew my mind yesterday with, I mean, I know CP Carrillo is big.
Right.
And being at the NHRA, there are so many cars and teams that you guys sponsor and help out.
Right.
But some of the numbers you dropped on us yesterday about just the scope and the scale of the business surprised me. Just huge stuff. I know we got some parts and pieces, rods and pistons, but you guys have got a tremendous industry over there.
Yeah, it's really grown. I went back out 1st of June this year. Cindy's like, you got to come back. Just the 6 years since you've moved to North Carolina, I mean, we've grown incredibly. There's way more, you know, machines, the old OEM things growing like crazy.
It's crazy.
So I spent my first 18 years or so working there, and I was blown away by how much it's grown just recently.
Well, me and Hartford went and took a tour in early July, and Matt was blown away. And I had seen it about a year before, and I was even blown away how much it happened in a year. I mean, it is jaw-dropping technology at CP Carrillo. I mean, it's amazing.
Well, when customers ask, you know, about longer delivery dates these days, you try to explain to them over the phone in numbers like I was talking about yesterday.
Repeat those numbers, by the way, because they were playing in my head. That was mind-blowing.
A high of 15,000 in 2016. So that's the constant number of pistons during the busiest time, 8 to 9 months. It never goes below that number. So 15,000 in 2016, 44,715 this past February.
15 to 45, essentially. That's crazy.
And so the work has tripled, but the only way to keep the delivery times the same is you have to triple your production. And nobody can triple. You can't grow your production 300%, you know, in 1 or 2 years. So, but I wish I could almost like the old Star Trek shows.
Yeah.
Beam me up, Scotty.
Oh, yes, sir.
If you could beam each customer into the machine shop to see that.
Yes.
And the few guys they come to California, you know, for the World Finals or the Winter Nationals, and they come and have a tour, then they get it.
Yeah.
You know, it's we used to have a guy who used to joke, we don't have coin-operated piston machines. We just can't go out there and put a quarter in one of them and have pistons drop out of the bottom. It takes a little while to make some of this stuff, and especially when you're trying to do a really good job of it.
Well, you know, to that point,
right?
A piston like this that has vertical gas ports in it, obviously high compression. I love the thin ring grooves. That's really nice.
Yep.
And explain what this little bit of blueness right there is.
Well, we highlighted that with the marks a lot. We lay the pocket back because this is the fast side. The air and fuel coming off the intake valve during overlap. If it hits the valve pocket radius, it can separate air and fuel. So you got to put more fuel in to try to make the same amount of power. Anytime we can get a more efficient, I call air fuel management setup, which is this, and this improves cross flow, by the way. You can make more power with less fuel in. Typically, when you clean up the air fuel mixture, you don't have to light it off as soon, so you can pull the timing back, which is always worth torque and power. So this is a shelf part. Comes just like that. Pistons, pins, rings, spacer rails in this case. And this is what we call a bullet piston.
Oh, that's a bullet.
Yeah, so this is our Sportsman bullet line. When the market dropped in 2008, we were trying to figure out a way to not fill our pockets better, but help ease some of the pain for the consumer.
Right.
So by buying a piston with we call it a forged side relief. In other words, the side relief's not machined, it's as forged.
Yep.
And without having to do a bunch of internal milling for lightning, we save money because we're buying more of a net piston that we don't have to do as much finish work to.
Less machine time,
less machine
cost.
time, CNC time, that's money.
Shelf piston.
So
Joe, this is crazy, right?
This is the same, and these pistons are made on the same equipment as a current Pro Stock motor, Formula One.
Yeah.
There's no, we don't cut any corners in machine work.
You're not like, oh, that's built over here, makes the shelf stuff.
No, it's all
the good
the same,
stuff's over here.
It's all the same equipment.
That's the thing. Well, the other thing too, before we run out of time, is obviously you guys, we had the rods from my dad's engine, which are old Carrillo rods from 1998 that Richard even said he probably had machined the small ends on, and they're still running great.
Right.
I never think about you guys in aluminum rods. And you were saying some things to me earlier today about this design here on the cap that was really interesting because aluminum rods and CP Carrillo just don't go hand in hand, but obviously they probably should.
Well, one of the original Calvert brothers who helped start CP, and the C in CP stands for Calvert.
Yep.
We had purchased Carrillo in 2008, and so especially in drag racing, we were always finding ourselves trying to convince aluminum rod fans to run steel rods.
Right.
And so in a sales meeting, Dave says, well, we make aluminum pistons, we make steel rods, why can't we make aluminum pistons and let them have a choice?
Yep.
So we went to work. It just so happened at the same time, all other rod companies other than Venolia at the time had a plate rod. And so plate rods, much like billet pistons and cranks, it's the extruded raw material and you machine the part out of it.
Yep.
That's okay, and that material has some grain structure because it's been extruded into the primary shape. But when you forge a part, whether it's a crank, a rod, a piston, you're taking dies and smashing the aluminum into that shape, and you move the material and increase grain structure.
Right.
And
Which
grain
increases
flow.
strength.
Yep, which increases strength. So contrary to popular belief, forged parts are stronger than billet parts.
Billet parts are easier to make.
Billet parts are easy to make for rapid development. They're more expensive for us because of CNC time and programming.
Right.
But the forged piston, once you've invested in the dies and got the forgings made at the forging foundry, it's cheaper for the customer on the end run because it's less CNC time because the part is already preformed.
That's awesome.
Amazing stuff. So let's try to jack up that number from 44,000 as much as we can. Tell people, how and where they can find out more. Obviously, guys got great customer service, and people want quality parts and pieces in their engines. We're hearing it over and over again. If you're going to go through all of this, if you're going to go on a drag and drive, if you're going to be baking in heat, things got to last. And so people want good quality stuff. Rick, where can they go to find out more information about CP Carrillo?
Well, they can call us at the shop. I don't know, give the number here. Or not.
Sure, yeah.
949-567-9000.
Give that again. I was talking over you.
It's 949-567-9000 is the California number. You can ask to speak to any of the sales guys, including Rick Pannington. That's the best way to do it.
You know what I love, Joe, about this?
Yep.
So here's a high horsepower piston, a shelf piston with a 1 millimeter, 2 millimeter ring package in it.
They know.
I love it. They know.
They know.
It's not
They
just
know.
us
Right.
saying it,
Yeah, no,
right?
they know.
We know.
Yes, exactly.
You don't need a 16th ring if you're making big horsepower.
No.
And we will prove that later today. Stay tuned. Does cylinder bore finish affect friction and wear? We're here at Southwest Research Institute to find the answer. Okay, to get the answers to those questions, we brought in the ace, Dr. Tribology himself, Dr. Peter Lee, who's the head of
Tribology here at Southwest. Yep.
All right, so this is the largest independent research institute in the world, right?
Pretty much in the world, yeah.
Explain to everybody what we're going to be doing to learn the answer of whether or not cylinder bore finish affects the friction and the wear of an engine. So how are we going to do that?
To get the answers to the questions, you need to get rid of all the extraneous information that you have coming out of an engine and all those extra things that are happening. Well, we're going to take the actual parts themselves, so the rings and the liners, and we're going to machine those so they actually fit together in our test machines.
Okay.
And then we're going to rub them together, and we're going to measure the friction response, and at the end we're going to measure the wear on some of our super fantastic 3D wear machines that we've got.
It's going to be super fun. By the way, I've already seen a sneak peek, and it is actually mind-blowing.
And then we can control the temperatures, the environment, everything that's happening in there, so that all we're actually going to be looking at is the friction
between
the wear,
the piston ring and the
liner.
cylinder wall.
Yep, that's right. And just get just those answers and nothing else.
So what we're doing is taking real parts of real engines and actually simulating the effect of the engine here in the lab. See, that's gonna be so cool. And now the best part is, not just are we measuring the friction and the wear, you have these really cool optical profilometers.
Yes.
Like, people that watch our videos know that we are talking about our little Metrology handheld 2D profilometer. That's a Lego set compared to an S16, by the way.
That's a joke in comparison to what we're going to be looking at. What we're going to get is this 3D images of what's actually happening and what it looks like at the end of the test, and we're going to be able to compare the one surface and the unworn surface.
Yeah, it's going to be. We've already kind of seen some sneak peeks at it. It's pretty stinking cool.
It is.
Yeah. And so this is going to take a long time to get the results back. We're not going to have the results at the end of this video, by the way. Don't leave the video. Subscribe, actually, so you can see the results on a later video that comes out, because it's going to be days upon testing.
Well, the list you've got back there, it's going to be
kinda long.
Yeah, getting longer and longer.
Yeah,
it's going to be quite a while.
Yeah, the more ideas we have, the longer the list gets. But it's going to be really fun stuff to be able to see the friction, the wear, not just on the numbers, but also the visual representation of what's actually happening on the liner and in the ring itself.
Those visual representations tell you so much more than just numbers. Just being able to see the difference, be able to see the cross hatching that's in there and everything else, you're going to be blown away. It's amazing.
There's a lot of different ideas on how someone should hone a block.
Yeah, absolutely, yeah.
And there's all kinds of different ring materials and coatings available.
Yeah, and it's all about the combination.
Yeah, 'cause we have 3 different surface finishes. Yes. We have 3 different ring materials, and we're gonna have at least 3 different oil combinations. So
that's a big matrix.
That's a really big matrix, which is gonna give us lots of information. So stay tuned, because we're gonna come back with another video once this is all done and give you guys the results.
Welcome back to the Engine Performance Expo. Big thank you to all of our sponsors and all of our viewers out there. We've had a great couple of days. It has been so much fun, but I got to tell you, Lake, I'm super excited about this because, you know, we talk about it all the time, that this sport, this trade, engine building, cars, car culture, drag racing, motorsports, it's a family thing.
Right.
The family that races together stays together. I don't think there's any other sport, maybe there is, and you can definitely, get me on email if there is, where so many families, like grandfather, son, grandson, fathers and daughters, fathers and sons, are all out there competing, and sometimes against and with each other. Like, that just doesn't exist anywhere else. Maybe bowling. But maybe bowling, but that's it. And here we've got the Stanfields, we've got the Dortons, we've got the Morrises. Kyle, welcome, of course, along with Steve and Keith and Jeff and Greg and Aaron. It's just great. Perfect examples of like passing that knowledge down, the knowledge, the passion, and you guys are out there doing it together. Like, that's what people dream of, to be able to keep the kids interested, out of trouble, moving forward and doing something that's going to like benefit their life, and you get to do that every day. Steve?
Yeah, it's a it's a blessing, and I'm thankful for it. I mean, outside of making sure that we don't kill each other, or because we see each other all the time. He just recently moved out of the house, so that's been good. It's given us a little bit of separation. But no, I mean, it's been something I think about, and I see other people, especially in our industry, and that some of the what I would call them, like, the founding fathers of like Sonny, or even John Kazi's out there, I mean, that don't have a son to take over, you know. So I'm just very thankful for that. I think it's.
Well, you just shared a story about a machine shop owner. You're 21 years old, and he's like trying to, sell you his shop because there's no one else, and you've got all this knowledge and passion, and you want to share it, right? You want to share it, and you fortunately you have someone to share it with, Keith.
Oh yes, yeah. I'm very, very blessed, as Steve said. That when I started the business, Jeff was just. Of course, he wasn't born when I started the business, but, we're trying to make it grow and trying to pay the bills. So his first years, he was almost like a single parent because Dad was always working.
Yep.
And it was only when he got up in age that, hey, I'm missing something, So we started go-kart racing, and it evolved, and then our relationship became closer. And of course, then when he, at that time also, he was sweeping the floor, helping, learning, where boats go and all of that. And
the things back where you found them.
and now,
Aaron, Jeff, and Kyle, y'all can relate to all this.
Something there. Now that it's reached the point where he's teaching me, So, and I'm sure you're finding the same thing, both of you that. Now, the big thing is these the electronics that gosh, I'm too old to learn, So, but even the mechanical stuff. When he went to technical school, I didn't have any training, so he was able to teach me. Well, this is the way you machine this part. So, I wouldn't take nothing for the relationship. Of course, if you come to our shop, it's. Jeff, myself, my wife, and my daughter, and quite often the 2 granddaughters. So, again, we're very blessed. Ain't all roses, but we certainly, it's just such a blessing to, be your family. I don't know how people do it that their children or their grandchildren live on other parts of the country and they only get to see them at Christmas or whatever. So. And I'm sure you guys feel the same way.
Greg, what about you? Your son has followed in your footsteps. You're obviously, you guys are together. You're happy. You've got a grandchild now, but
ours is a little different because I know not only build the engines, we race. So we're racing together as well as building engines together. So we get to work hard in the shop and we get to go race and enjoy it. So it's definitely he's helped me a lot. And keeping me in this sport and keeping me going. Without him, I probably wouldn't be here.
You'd be on the beach.
Probably.
We hear about the cocktail with the umbrella. Yeah,
I still try to sneak off every now and then. It's like, where's Dad? He's gone.
He's on the beach. Jeff, what about it? Working with your dad. There's, if you watch modern culture, movies, books, there's so many storylines about the, the hard-headed relationship between fathers and sons and a disagreement. There's a saying about, like when I was 20, my dad didn't know anything, and when I was 30, he knew everything. What's your opinion of working with your dad and the relationship?
Well, it is a blessing, and when you think you're right and you think he's wrong, and you better think twice because normally he's not wrong. But we do work well together, and it's just I don't really consider it work. It's something I enjoy doing, and I'm very blessed.
Did you ever consider not getting involved in the engine trade or following down the road your dad has blazed? There are other people. We had a young man in here yesterday. He's going to work on skyscrapers, right? It's like, hey, I'm going to do something a little bit different. But was there a time that maybe you thought, I don't want to do this?
No, I've always had the interest in the engines, and there was a point in time I've had opportunities to go to the Cup guys. Glad it didn't. Because none of those are still here. It's I've always had the interest in engines and trying to make things better, and it's worked out very well.
Kyle, you're the youngest among the kids in the group. What's your opinion of the business, following down the road that your dad has blazed to the trail, getting involved in the family business? Obviously, you want to sustain it, you want it to thrive, and maybe you are bringing some new ideas, new generational ideas. I think about exposure on social media. I know you guys have a YouTube channel. I know that you guys have embraced a lot of that. What's your take?
You don't think Steve started that?
He did.
Actually, I
He started it. I'm just trying to keep it going. But
there you go.
Yeah, so
he brings in the more youthful side. I see things that I think are, oh, that looks really neat. That's really cool. And he thinks, those wheels are that is so 1980s. We're like, oh, wow, I think
it's
cool.
very dated. And then it's just like, I try to bring the cutting edge opinion. I try to keep my finger on the pulse of like what people are thinking in drag racing a lot, and try to bring that to him, to his generation, and then he brings a lot of good generational knowledge back to me. And I think we work really well together that way.
And since you're talking about that, like, where do we, the older folks, find out the pulse of the drag racing community now? If you want to share it with us, we'll listen.
Yeah, I mean, anything from just watching the television to scrolling through social media. I mean, I know like that's like one of the biggest complaints that it seems like the older generation has on the younger guys. It's like, oh, you guys spend too much time on your phones, but that's kind of where I'm. Yeah, I know. That's kind of where like we're learning some of this stuff from. Different social media pages, watching different YouTube channels. There's a lot of educational material available out there.
Wait a second. There's actual information out there?
Yeah, on the internet, they do have accurate information.
You're not just looking at other people's lunches. They're tweeting photos of their meals.
Right. Well, there's that too.
Okay.
You're sure it's all accurate?
Not all of it is accurate, but there's getting to see a point now where like there's beginning to be a lot more accurate information put out there.
Excellent. Do you find that, and for the younger guys in the crew here, people of your age, Aaron's 27, you're 21, Jeff, you're a little older. But,
I'm an old guy.
What about your peers? Interest in the automotive culture, engines, speed. Like when you talk to people that maybe you went to school with, right? And not everybody is into this, but are they interested? Like, what's the outside view of people your age of what you do?
Right, from outside of the industry, it's a tough one to say, but I went to this University of Northwestern Ohio, and almost everybody they went to school with, they all have a passion for the sport, but the trades are just paying them so much more money. They, like 9 times out of 10, they end up going right from UNOH to a trade school, or they'll go right into the trades and become welders or whatever. But yeah.
Aaron, what about you?
I think social media is a big platform. I mean, I have friends that's followed y'all's YouTube page, so I think that's that's pretty cool. Y'all have had an impact on people outside of drag racing or motorsports, so I think y'all are doing great. Keep that up. But like as far as social media goes, I mean, we wouldn't be seeing this information, this great stuff here without it. So I think it's an important tool. So I would say the young guys we can definitely help with those things.
Well, I think there's been a misconception. I'm gonna call it a misconception that the younger generation is not interested in motorsports.
Yes.
That they don't have cars, they have phones, they don't want to have the license and all that. But I think that's not true.
Yeah.
I mean, my son Benjamin's back there, right? So Ed Keebler and those guys from Rottler are teaching him how to run a hone, and that's great. And he's interested. He's passionate now. His interest is maybe a little more airplanes and motorcycles, but it's still about horsepower. It's still about engines. So engines are still appealing to people regardless of their age.
Yes.
All right, we're running out of time. I feel like this just started. This is so interesting to me. So we can do like a quick rapid fire. Okay, we'll start down on the end. And we'll start with Lake, right? I know your dad's not here.
No, hi Dad, if you're watching.
Yeah, but as you're coming up and he's passionate and you're passionate and you guys ever like butt heads on a subject that and how do you guys typically resolve it? And I'm going to ask everybody, like, you ever get to the point where like you just disagree, like father and son, you're on different sides of a thing, and how do you work it out?
I mean, I ended up going my own way earlier in life. That as a teenager, it was like, whoever said when you're 20, you think your dad's an idiot and all that kind of stuff. I don't think he was an idiot, but it's like, okay, well, racing is his thing. That's not my thing. I grew up in the shop. You guys ever worked for room and board? And I remember getting that lecture one time. It's like, everybody else got the paycheck. I'm like, where's mine? Room and board, son. Right? But that was a great lesson. That was an absolute great lesson. That just because I was pushing a broom in the shop didn't mean I had earned the right to get a paycheck yet. I hadn't proven myself yet. So I appreciated that tough love early on. But I had to go find my own way for a little bit and then realize that once I was on my own, that the interest in racing, the interest in engines drew me back. There was a natural attraction and magnetism in there, and I came back to it. And then when I made that choice to be in the industry, it was my own choice, and then I was full on in it. That's how we end up here with this, is that I chose it on my own. But I did wander away for a bit, but the greatest thing was going racing with my dad. When we started go-kart racing again, because I grew up with he was go-karting this was before NASCAR, when I was born, and we traveled all around the country in an old Dodge van. And the first time we sat in a vintage go-kart, and I heard the crackle of that two-stroke and could smell the methanol and castor bean oil, it was like being transported back in time. And that blue go-kart with that 135 on it is my favorite thing. I can sit in that thing and hear it and smell it. It's just pure happiness. It brings you back to those days as a kid, and I do. It was so long answer to that question, but I had to go find my own way. But that wasn't his fault. That was my fault.
What about you, Aaron? And I'm going to go right down the line, because this is something like the transfer of knowledge and energy and life from one generation to the next. It's a big part of it. You and your pop.
Obviously, I grew up around it, but he never pushed me towards it. I went to college and just kind of made my own decision that I wanted to do it, and he was ready to get out of it at the time, and so I drug him right back in. And
I tried to make him clean parts every day.
I tried. He tried to cure me with the parts cleaning, but it didn't work. But I kept pushing and just been very, very blessed. Yes, we do might butt heads from time to time, but I guess that's one thing he's taught me is to be passionate, and if you believe in something, support what you believe in. And we do go at it sometimes, with our opinions, but we're working towards the same common goal, and we both understand that, and we both favor each other, work really well together.
Awesome.
Good word.
Jeff?
Well, we don't so much butt heads anymore because we've worked together so long now. But early on, if I'd say we'd butt heads about anything, it'd be about some of our diverse work thing, because at that time we had so much NASCAR work, and that was all I was like, I want to do this. See performance there. And we would take in, or he would take in, anything. Anything.
I would be dead when I took in some of these jobs.
But the way the world has turned out, many years later, that's what's made us a better company, and that's kind of our niche, so to speak.
They'll do anything.
Diverse.
We're blessed to have the ability to feed off each other. Instead of butting heads so much, I think we all screw up, we make mistakes, but we can learn from them. But and I hadn't thought about it until now, but we have over the years been able to feed off each other's what limited knowledge we have, and occasionally be successful at it. So.
That's a team right there. Kyle, you and your pop.
Yeah, going back to what they said, despite the stereotype you might find of father and son butting heads, I don't think me and him really butt heads hardly at all. I mean, except for just the little stuff that doesn't really matter. But as far as big blowouts, we've never had any. For the most part, he's thinking what I'm thinking, and we kind of share that intellect the same way. But just that transfer of knowledge is just really good between us, I think.
Well, tremendous. Dads.
It's a competitive advantage in your business, actually.
Absolutely.
The fact that you can feed off each other.
We're always on the same page for the most part.
Well, let's be fair. You go back in the history of humanity. Isn't that the real reason that you have kids? For labor? Right? The agrarian culture, right? We got to work this farm, man. We need kids. And so engine shop, you don't need quite as many. Dads, good job. Good job with the kids, dads. And kids, keep it going, make them proud. Thank you very much, guys. Just a great thing. Hopefully my dad's out there watching as well. Dad, miss you. Next thing we're going to talk engine balancing, and that means Mr. Randy Neal is up on board CWT. Let's find out what he's got.
Well, I'd like to welcome everybody here to EPE, and we have a lot of good information. I'm joined by one of the most talented people in the industry, and that's Dan Begley from Mali. Dan, introduce yourself here.
I'm Dan Begley from Mali, technical sales engineer. My job is I help design engine parts. Prior to coming to Mali, I was in NASCAR for 27 seasons, so I got to build a lot of engines, got to see a lot of stuff. I was a reliability engineer at Roush Yates for 9 years, so I got to see a lot of end result stuff. So come to Mali is helping with new products, and interesting because is what we're bringing our conversation up is because see a lot of stuff happen, and as we get involved, we see the dynamics of engines changing and what's happening and the effects that we're seeing on bearings. So,
Sure. Well, listen, my name's Randy Neal, and I'm the owner of CWT Industries. I'm really Dan's sidekick. The beauty of this is that Mali has been very generous by giving us an awful lot of technical information. And what we're really going to cover today is, I always use the term, this is not your father's Oldsmobile. Things have changed. And we want to just sort of walk you through a few things. And Dan's got some great assist video here and details that are really, we think, will enlighten you. So let me just start out real quick right here with what our topics are going to be. And so really, there we go. We're going to cover these subjects here: evolution of engines, bearing function, torsional harmonics, and balancing dynamics. There's a working relationship with all of this. And so the key point is we got some highlights. We're not going to go too deep for you, but we think it's going to open up your opportunity to think this is not your father's Oldsmobile. So let's jump into it. Back in, we use here 1955, we have a comparison of engines to 2022. The original Chevrolet was 265 cubic inch, 195 horsepower, 5,000 RPM. Now we leapfrog here to Pro Stock, and we're now looking at basically double the cubic inch, but we're 1,500 horsepower. Some people say 1,600, we're normally aspirated, but they're running at 10,000 RPM. So what's unique about that is that we also have this bad boy here, same cubic inches, but we've got 11,000 plus horsepower. Here's one of the things that's interesting, and that is doing this sometimes gets that. Now that is not the goal of where we're at today. What we really want to do is get you back to understand this primary here. For instance, the rod journals on this are actually bigger than this, and yet we're making more power. So we've learned either through processes or materials that we can do some things to make power. So let me just give you a little idea though. To want to just follow the simplicity of this engine. It's the same thing we started with at 265. We got crankshafts rotating, pistons going up, down, camshaft, lifters, rockers. All of this is harmonious, and they all have working relationships. And you got to understand they have their own personalities. But this crankshaft right here, that bad boy will do things that you don't like. Now they're connected by way of drive systems. I don't care if you're belt, gear, whatever the system is. These, whatever happens here at the crank is going to go to the cam. I don't care who you are, what you are, you can't get away from it. Now we can make the arguments of which one is a better type. That's another story. But we want to get you to understand how the harmonic relationship is. So I borrowed this from Haas presentation, and they like me, I like them. So they're allowing us to do this. But what we have here is two tuning forks, and they're independent. You can see hollow boxes, and there's a string holding that little ping pong ball. Now he's going to strike this one, and you notice, again, no gap other than air that has a direct response. You have to understand this is the same thing that happens in the engine. Knee bone connected to shin bone connected to ankle bone. Well, cam, lifter, rocker, all the way to valve tip. Now what he's doing here is he's changing this, and he's going to change the frequency. That's all he's doing. Now the strike is virtually the same, but now nada. There is no response. Why? Because the frequency changed. We have to get you to understand that as the engine is running, these frequency intercepts, and that's the way I'm going to describe this, can take certain components and put them into a hysterical position. In other words, they go nuts, all right? Everything is following, guess what? Link right to the next. So it's a mission statement here is to study that. So application of engine bearing, the operating environment, I'm going to turn this over to Dan because there it is.
Yeah, so first of all, just so everybody understands, we'll go over the basics of how a bearing works, because that's an interesting question a lot of people don't understand. So a bearing has eccentricity. Basically, the distance from here to the side, there is an eccentricity. It's basically a ramp. So what we're doing is we're filling oil. A bearing is self-generating fluid film. So as the oil comes in, you will see that the force is coming down, typically, until, as you're going to see in the presentation, we're going to talk about forces going around crazy, not just always down at cylinder pressure, but it's taking an area of oil and it's squeezing it down to create a hydrodynamic film to keep the shaft away from the bearing. And saying that, it's kind of like a wedge. If you take a wedge underneath a door, and the more you push the wedge in, the more it tries to pick the door up. The same thing happens as we take oil and we take oil film, it pushing the shaft up to keep the shaft off of the bearing itself. So typically, a connecting rod load oil pressure is 720 degrees of rotation, and you will see there's a high force. That's obviously where the engine's firing at. But the engine is the force is actually oval, and in doing so, it creates where you're trying to squeeze the oil in, and the rod itself is changing the bore shape of it depending on the rod you're doing. All right. The other interesting thing is if we look at the oil pressure, you'll see in the 720 degrees, there's different. This particular area right here, every time the piston rod, the rotating assembly is trying to come out the exhaust port on the exhaust stroke, you can actually create a negative pressure at a given point, which we can get into cavitation. Things happen because it's actually trying to pull that piston rod assembly out of the exhaust port, pulling away from the journal itself.
Dan, real quickly, in doing that though, as we change the clearances, as we get bigger, and that is a propensity, what happens?
This gets bigger. So you create more air in there, which can create more cavitation. We've directly found the correlation in past experiences about tighter clearances is less cavitation because you're decreasing the amount of space that it's pulling away from.
Perfect.
So this is an FEA of a single cylinder crank. So when we talk about crankshafts, we're going to talk about a cylinder. This is a single cylinder, and a crankshaft is several single cylinders mounted together to make a V8, inline 4, whatever it may be. So this is an FEA, just a picture of it with a main bearing 1 and a main bearing 2 and a rod journal. So if we move forward, this particular FEA, it will show the magnitude being red being the highest danger point to blue being neutral. This particular FEA was done and with deflection at 6,500. You can see by the way the crank is shaped, you're getting deflection from the rod journal to the main. In this case, the front is 41 microns and the back being 27 microns of tilt. That crank is tilting itself, which is affecting your main bearing clearance.
So load basically is really what is a factor here, and depending upon the structural integrity or the strength of the unit, dictates how much deflection we get.
Absolutely.
Okay.
Yep. So this particular one, we're talking about peak oil film pressure. As you remember, we talked about the hydrodynamic creating a film pressure. Okay, yeah. This is an FEA that's showing a film pressure, and at 6,500, you can see red, again red being the danger zone, a higher film pressure, which means less film thickness. The point of the bearing is actually showing a spot right here, which directly aligns with the red. Now, this is 6,500, all right? So we're changing the film pressure going in there. Sure. The interesting thing about this test, as the engine picked up in RPMs to 7,500, we've actually had.
Wow.
So you can get, as we're talking about harmonics and frequency going, it actually can change. So you may hit a particular RPM that things are really unhappy at.
Well, see, that's one of the things we are going to dive into. People have to understand as we develop into it, the crank doesn't take a single path. In other words, it will transition and can hit critical frequencies that can totally disrupt. We're going to go into that a little bit later. Follow up in here.
So this kind of stem off what we said. Now this is film thickness. Again, a lot of danger, a lot of red at 6,500. And our film thickness is better at 7,500 because the cranks actually changed as the RPMs went up. This is showing less red.
We want to make sure that we understand that no two crank assemblies are the same, no two engines are the same. If you're a 265, which I showed earlier, and then we have Pro Stock, man, the only thing I'm going to say is common is that it's an engine. Everything is different.
Everything else is different,
Right.
exactly. So now we're taking single cell crank, we're making a V8, right? You have all the 5 main bearings, you have the 8 rod journals, FEA of a V8. Here is we're going to show you a simulation again, red being highest. So now we have the simulation that we can show. And this is focusing strictly on this area right here. So as you can see, the crank flex is over exaggerated, but you can see the stress, the magnitudes change as the firing loads happen on this crankshaft. And you can tell it by the different colors that it's showing. So we're going to take that section. This was a snapshot of the particular crank that we had. Again, we're looking from this area over. You can see, all right, you're getting a firing pressure on this. Right. Right, and it's actually coming down here and you're getting some deflection, again, as we showed on the cylinder, and which is changing how much main bearing clearance you actually have versus what you thought you had.
Well, a lot of the clearance, the guys, the natural go-to is open clearance. And they'll see edging effects on the bearing, so that the propensity is to go there. And what we're trying to bring to the conversation here is materials and processes are what's going to have to be introduced to understand that needs to be stronger. As we make more power, the process, in this case the crank, they surrender. Well, if you take a cast shaft or you take a high-end alloyed shaft, it's two different animals. So you can't mix those. You have to understand there are limits. The thing that's interesting right here in identifying, go ahead, pick that up.
Yeah, so as mentioned, so there's a force here. Interesting thing is counterweights. So we're going to get into counterweights again on this, but notice how much red is in the counterweight. So that's another force that's coming in to creating. All right, again, red being danger. There's a lot of red down here that we don't even think about. A lot of people don't even think about what's happening in that counterweight on there. Again, you see the deflection coming in and the effect that's going to have on the main bearing wear.
So again, what you're showing us here is not one single thing takes place, it's cumulative. There's a lot of things going on here. This is the one that has been the eye-opener for us, is to understand the counterweight's mission statement, primary, is to be the unit that counters the amount of mass rotation event that we have on a piston rod assembly. But we have been very, very cavalier on how we have treated that counterweight, and so this has opened up a lot of discussion, and the FAA is saying, hey, pay attention.
So as we're talking about the crankshaft bending, so we're going to talk about journal orbiting. So again, this is a 720 degrees. There's different colors of it. You can see the crank is moving around. So all these fill spaces are allowing that to get oil into the journal to feed it in as we talk about how a bearing works. All right, so now you get deflection as we're showing on those. Sure. What happens?
There you go.
It gets bigger. All right, the journal is looking like it's bigger. So the problem is, instead of it having spaces that it can fill that oil in to generate, you're not giving it any spaces, so you create a very, very small area of film. And in this case, as we mentioned earlier, the force is going down, showing me right there that the force is going up, all right? Right. Force is over here, force is over here. So there's different forces that are showing because of the deflection of the crankshaft.
The key point of this demonstration is that there's a normal assumption that this crankshaft just sits there and rotates. It doesn't rotate, it orbits. In this case, I'm going to define that as gyration. Now, all of us know line contact is not the goal. We have to have a bearing film. We have to have a means of allowing this thing to survive. But here's the deal. As the unit flexes more, it challenges everything here. As I increase the clearance, all of a sudden these patterns change, everything. In fact, what happens is the crank that is balanced becomes unbalanced. You gotta understand it's in an orbital state. So for those of you who have opened up clearances, I get it. What I'm trying to come back and simply say, hold on. You don't realize, you think you cured this, but you really caused that. And that's where we're going to go into another discussion.
So we'll get into bearing components. So a typical tri-metal bearing is there's 3 layers. There's a steel backing, there's a substrate, and a plating overlay. So this is a microscopic view of what a bearing looks like. The steel backing, the substrate, and then an overlay over top. So a typical H bearing, or cleveite H bearing, is a copper, tin, lead overlay. So the top is a plating of copper, tin, and lead with a cast substrate and the bronze substrate here. Nickel, there's a nickel layer, and that's just, it's a couple microns thick just to prevent migration into the substrate. All right, we also have a Q1, which is a V bearing, and that is a lead indium. The lead indium is a more pliable. It is for our higher stress loads when cranks are orbiting.
Sure.
It allows movement.
Right.
It's a softer bearing, so it won't give you the service life as a copper, tin, lead bearing, but if you have a lot of crank flex going on, that's kind of a necessity sometimes.
Well, and that's just it. We're application bound here because if you have, if I want to talk about flex, I can talk about top fuel. If I want to, even some of the supercharged engine, we're getting to a point where we have so much deflection going on. They've given an avenue of some remedy. However, it's not the perfect one. In other words, other bearings have different applications. So these overlays right here are very important in how they interface.
Absolutely.
Okay. Go ahead.
So we also have coated bearings. So a coated bearing, again, is the same, has a steel backing, bronze substrate, an overlay. A coated bearing typically has a moly-based graphite overlay over top the advantage is, so a bearing is only as good as the lowest melting point of its components.
Okay.
So a coated bearing will put a moly layer, graphite base with a resin to hold it together, and it creates a thermal barrier over the overlay. So it protects the overlay, and if you have a dry start, you have frictional temperature,
right?
Or you lose it. As we mentioned earlier, we have the no oil film. It creates a moly base, which is a dry film lubricant to help protect the overlay because bearings aren't self-healing. So once you melt a component out of it, it's gone. It is gone, and it wants to start grabbing.
You know, the one thing that people, and there's start-stop applications that have started up. When I first heard about this thing, I went into a panic. I said, this won't work. The remedy was the overlays. Right?
It is, absolutely.
And so it gives that Band-Aid effect, right? And it's proven itself to work, bottom line, but it's per application.
So a little different bimetal bearing is a steel backing. Usually it's an aluminum substrate that goes over it, aluminum overlay. It's all in one. It's kind of a sintered process where it's squeezing on 2 pieces of aluminum together and bonding it to a steel backing. So there's a purpose for a bimetal, but it's not as robust as a performance engine. We wouldn't want to go with that application. So typically the H and the V bearings is a cast substrate. So the cast substrate is a copper, tin, lead mixture. It's melted together. They heat the steel strip up 2,000 degrees. You hit the copper, tin, lead. So a substrate is in 2,000 degrees. You're taking 3 elements: copper, tin, and lead.
Right.
All right. So when you mix 3 elements and you melt those together, melting point of copper is the highest at 1960 degrees Fahrenheit. So you melt 2,000 degrees. Now you take the elements, copper, tin, becomes an alloy of bronze. All right, so bronze mixes together and creates green structure. The lead doesn't mix in with bronze, so it develops a margin between it to support the structure that the crystals build as they're building the alloy to give it support. The bronze or the lead is there for embeddability of foreign debris.
Right.
And it helps structurally support with allowing movement of the crystals and soften and dampen what's going on. A sintering process is the same copper, tin, lead, but you just shake it up and you heat it and squeeze it. You don't melt it. So you still have the same elements, but you don't develop an alloy.
Right.
So a sintering bearing has a lot more lead in it, so it's going to be squishier.
Okay.
It has movement, and sometimes that is not a good thing, most cases. And you can get fractures in it.
Okay.
Because you're not molting it and crystallizing it, so you can get fractures, so you can get a part where it just will fracture and you can lose part of a bearing.
Wow.
So typically a cast substrate, as you can see on the picture, you can actually see the green structure. You can see the small amounts of lead that are in it. And again, that helps for embeddability. The sintering substrate, it's easier, it's cheaper, but it's not near as strong. So it's the same ingredients, but as you can see, there's no green structure in it. Because you're not creating an alloy, so you create no green structure.
You know, this particular unit fascinates me because I look at this a little bit different. Load disbursement or equalization of load, and then I see a sort of a fragmentation event here. The embeddability, key factor. We know that we don't make the perfect engine.
Exactly.
We do have these particulates, sometimes unknown. And so this thing, in other words, it can survive where this one is not as survivable.
Right. And exactly. So copper will adhere to steel. So when you melt it, it will adhere. In this case, we're not melting it, so the adhesion on a sintered bearing is less because you don't melt it. So lead will never adhere to steel. So you can have a point where it just delaminates.
Oh, okay.
So typically speaking, load carrying rate, again, is higher, about 20 to 30% on a cast bearing.
Okay.
So a cast copper is around 12,000 PSI that it will hold of load bearing versus sintered is 10,000.
Wow.
So, and it's because, again, it's because you're taking the elements and you're making an alloy. So you're creating grain to support.
That is amazing. This is a key factor.
Absolutely.
You know, and you know, a lot of our people that are listening here, you know, you go to a part number or you read something. What we're trying to do is have an awareness issue. Do a deeper dive into what you're purchasing. You know, find out what's going on. There are better products, and sometimes, you know, quite frankly, we're a little naive in our understanding. Listen, we're at an era now, we're making more power than we ever have.
Right.
This matters.
So surface fatigue, so as I mentioned, you have the lead, all right? Yeah. So you have to, you can get big chunks of lead within the substrate. So what happens is the lead will actually crack. So you take an engine apart and all of a sudden there's part of a bearing missing. Big chunks out and maybe always down steel.
Like that?
So you can see it, the cracks will actually propagate, and at some point they can connect and pow.
So, wow.
You lose a chunk of bearing. Now that could be just part of the substrate. It can go always down to the steel. But the fact is, it's the lead and the adhesion on where the fracture lines connect, so you lose a part of it. The beauty of on a cast bearing is it takes that porosity out of the substrate because it's creating a grain structure.
You know, this illustration right here is pretty neat, but I know you and I have talked before, and so you came up with another way of visualizing this for us.
Yeah, so I had my kids task me. I tasked my kids, I want some Jello. I didn't tell them why. So a simulation of this is if you take a bowl, and we'll use the glass bowl as the bearing shell, the steel backing.
Right.
And I said I want orange Jello. Well, I did the orange Jello because that's representing the substrate of the bronze, the copper, tin, lead. And I couldn't plate Jello, so I took a can of Rust-Oleum paint and I made an overlay on it. All right, so that's typically a bearing, right? You have your 3 parts in there. And everything's good. Now we get the crank flex happening. And what happens? It wants to move the substrate. So when you move the substrate, next thing you know, you get the fatigue in your overlay. And the fatigue is because the Jello shook. In this case, in the crankshaft, the substrate is shaking, and the overlay on top is showing fatigue marks.
So now, the difference here, and again, the centered versus our best bearing, this right here has a better chance of working, correct? In other words, the base is better.
Yes, the better the base, it's kind of like building a house, right?
Okay.
If you're going to build a house and you're going to put a roof on, you're going to build 2x2 walls, or you're going to use 2x6s, right? So the stronger you build the support to the overlay, the more chances that your roof is going to stay solid.
Cool. How did you get there?
So this was a fun project I got to do one time, Randy. This is a crankshaft, and what the experiment was, the test was, is what is pressure from the main journal to the rod. So this is an instrumented crankshaft, And if you look real close, you'll see that there's instrumentations that we took pressure sensors and we did at the main journal, and we did pressure sensors at the rod journal.
Okay.
And it comes out right here where we actually took this and we live ran this with pressure sensors in there.
Cool.
So it was a fun project we did. So we took an engine and we started up, ran it. We ran it 3 different tests: 65 pounds, 60 pounds, and 55 pounds. The blue representing the 65, red 60, and white 55 pounds. So as we ran, now that's galley pressure. All right, so that's what everybody looks at, galley pressure. That's how much oil pressure I have, right? Well, not so much in the rods. All right, so as we ran this to 8,500, we noticed on the 55 pounds, we lost 36 pounds to the rod journal at 8,500. At 9,000 RPMs, we lost 44 pounds of oil pressure at the rod. So basically, at 9,000 RPMs, if you ran 55 pounds of oil pressure, you had 11 pounds of oil pressure at the rod bearing.
But the galley pressure stayed constant.
And the galley pressure, you can see the flat line. I mean, this was a nice oil pump. It got on the PRV, it was running well. It's very flat oil pressure, galley pressure. So a lot of people are saying, well, I'm gonna make more horsepower. I'm gonna decrease the oil pressure because it's a parasitic loss, right?
Right.
Well, before you go and just start cutting oil pressure, keep this in mind. At 55 PSI, you had 11 PSI at 9,000 RPMs to feed that rod. Remember we talked about the self-renewing oil?
Yeah.
It's very minimal at 11 PSI of how much oil it's going to put in there.
Well, where did it go? I mean, what happened here? How did we get there?
Yeah, everything has leakage. We bleed off because we need a certain amount of oil to cool the bearing. Remember, we just talked about the oil cools the bearing. The bearing's only as good as the lowest melting point. So you need, just like a radiator, you have to cool the bearing, because if you can't cool it, you get frictional temperature. You get frictional temperature and you start melting the overlay out of it.
So this is the primary hose, and this is my sprinkler system.
Exactly.
Okay.
This is what most people don't ever get to see.
Oh, okay. All right, perfect. All right, so what we want to do is we want to change a little bit of our subject here, and we're going to go into crankshaft torsional loading, cause and effect. Again, understanding how these things work is pretty simple, actually. But it's also, there's a little bit of naivety here. So you have a combination of what's called first order balance, second order balance, and then that is handled through a damper. Now, what that simply means is that as we're going and making power, there are torsional events that are taking place. Now, these are controlled by these mechanisms here. Now, this is just an example. This is not perfect. But this is somewhat OEM. This is aftermarket. Now, fluid versus elastometer type, all of them are good companies, great companies. But they all have their own unique properties, and that's where a deeper dive has to take place by the industry to understand application. So let's dive in just a little bit more to that. Staying within the elastometer type, you can see here, this, guy got hold of this thing, he'd look at it, says, okay, we can use it again. But then when you do a deeper dive, you'll see some fracturing here. Well, keep it going longer, and now you're done. That's the bottom line. This is ineffective, and they're going to have separation. The bottom line, though, one of the Achilles heels of elastometer type units is from the day they are made, the day they go into service, they have to degrade. In other words, they can't get better. That's one of the Achilles heel. However, before I'm sitting here making a negative, understand changing the elastometer will make a difference in the overall performance. So for instance, just a real quick, Dan, you have a lot of NASCAR behind you, all right? And I know you did a lot in the damper areas. Tell me about that.
Yeah, so the damper areas, what we did was we had different durometer O-rings we put on there, and every race we came back, you would see, one of the inspections I did when I was on the NASCAR side is inspection of O-rings, and they would just deteriorate. Just the frictional heat, O-rings would flatten out, they would get hard, they would get brittle. So we actually changed durometer O-rings to fit what the engine liked to keep it from getting crazy, as we're going to talk about.
Now, this is per track or just on
we did it per track.
Okay.
So there was different setups that we had at the track to compensate for the RPMs that engine was running at.
Wow, that's interesting. Okay. Well, let's go over here, and I think we freeze frame. Okay, got it. Simulate.
Okay, Dan, we're going to go into something a little bit different here, and this is a rather interesting segment in that crankshaft distortion caused by combustion and torsional forces. It's not rocket science. As you make power, the crank winds up and goes back and forth. So we want to give you a couple of sort of viewpoints of how this is really working. And let's see, I went backwards, sorry, let's go forward, there we go. Now, what we did, and I illustrate this on purpose, this is a diesel application. I know a lot of us don't do something this big, but it illustrates very nicely what's going on during the cycling. Now, the free end, that's where the damper is, and these red marks that you're seeing is basically a torsional windup. So the FEA gives us a good idea of just what's going on, and you'll see the different combustion cycles, and you'll see how the crank responds. In fact, there's sort of a critical right there, and I'll freeze frame that in a minute. But you got to understand, I don't know what the technical term is that I can use here, but other than it gets to a point the crank is just pissed off. That's the best way I'm going to describe that. Now, and somehow it has to live through that. So we're going to let this sort of finish out here. And let's move on. So what I've done is I've done a freeze frame, and you can see from all the locations at the radius area, this is the stress point. And so this crank at one given point is just totally aggravated by torsional load. Well, the fact of the matter is that this is shortening it up to a little 4-cylinder. Same deal, and you see it rocking back and forth, and that's what people need to understand. It's not a wind up only, it's a cycle. So over time, it will fatigue. Now, that fatigue event goes to this discussion here, and that is what we've learned. Here's our load right here. On the counterweight, you notice the highlighted area. Why in the world is the counterweight hostile right now? What is going on there? Well, this is what we've learned about the cranks. And again, the mission statement is the counterweight's primary is to offset the event of the piston rod assembly. Well, what happens is that we use that area as correction area to modify when we're lightening the crank. In other words, compensating for the unbalance. The problem with that is that the units are standby. God damn it. Can we fix that?
Yeah, just go back and I'll...
Okay, I'm going to pull it back to that, start on that fix. Let me kill this right away. That doesn't happen again. I thought I killed it.
I don't.
Yep. Even the phone's mad at me. All right, here we go. Let me get back.
That's where I need the bigger stick at.
Yeah, I know, it's a whack. All right. So let me think what was it. Okay. Here we go. In this particular picture, what we're trying to show here, this is the load, and what we're understanding is, of course, the piston rod assembly is sitting up there, and the counterweights, their mission statement is to comp that for balance purposes. So what we end up doing is we end up typically drilling holes. Now, we have found that the counterweight area of the crank is becoming unstable. In other words, we're going to talk earlier, or a little bit later here, we're going to go in and we're going to talk about torsional timing. But this is the eye-opener right here. A lot of guys, let's just be fair about it. What we do is we go the easiest way to remove material. Problem is sometimes we go over center. In fact, I'm going to say actually every time we're going over center. Because there's no way I can drill a hole in that counterweight and make it stronger.
That is correct.
Right?
Remove metal is not the way.
That's exactly it. So here we go. Let's go in and see. Here's what we would consider the result of that cycling. This is an AC magnifying image, and you're seeing this is the radius area of a journal. And I'll give you another picture here. And so there's just two different views, and these cracks are surface cracks, mind you. But if we do a DC inspection, we'll actually see some of that to be subterranean. Bottom line is testifying I'm surrendering and I'm getting weaker, which ultimately is, by the way, failure. So all of that is just a stress issue. Now, this is just, in this particular case, this poor crank's having a bad day. All right, now it's a Duramax issue. Now, it's not uncommon, but a lot of the reasons behind that is it's externally balanced from the factory. Now, bringing it internal helps, changing the firing order helps, changing the cam profile helps, but the bottom line is, as soon as you exceed more load than integrity, you get two for the price of one. Not a good idea. Now, this is another example. Now, this is actually out of a GTR system, and it's sort of interesting because this is a drifter system. I don't know that I totally understand drifting, although it's really fun to watch. But these guys, what we have found is they're making 2,000 horsepower. They're out there and they're hitting up against a rev limiter. And what happens is you change the firing sequence of combustion. When that combustion changes, literally this thing gets out of sequence and you'll end up with separation. Again, 2 for the price of 1. Well, here's a close-up of that. Now, we can see some heat marks into this, but more importantly, this is a very violent separation. It's interesting on these particular cranks, I rarely see number 1 go out, but I have seen it done. Most of the time it's always in the rear, and that's because this is the load on the backside of the motor, and when you're hitting that rev limiter, it's ratcheting. And then all of a sudden, it's over. Okay, Dan, let's just go back into a cause and effect type deal where we have fretting. We see this in a lot of engines. I just got to tell you, there's a predominance of this for externally mounted engines, especially if they try to elevate themselves to higher RPMs, right? And we're going to talk about that a little bit more later, but you'll notice this fretting is always eminent. This actually has hit every main in this block. This happens to be a Ford block, but I'm going to pick on this area right here real quick, and I'm going to blow that up. And so what we have is, it's not uncommon to put the cap on during the phase of inspection. You notice it's a little loose. Well, what happens, the go-to area has been dimpling like this, or it'll take spikes, whatever we're going to do, in an attempt to fold that over. I got to tell you, I know it's done, I've seen it done, and it's absolutely a waste of time. And here's why. As soon as you get a false sense of seating, as soon as you start that engine up, that's dead soft material. The only thing that's holding this now is the clamp pressure, right? So it's important that that gets fixed. And this is caused, by the way, mostly from multiple order vibrations, first order, fourth order, and so forth. We're going to talk about that a little bit more in a minute.
So, Randy, this bearing came out of an LS engine. As you can see, it's an upper bearing because it has the oil groove, the oil holes in there. Number 2 and number 4. Right. So there's this much crank flex going on there. So if you look, the crank flex, again, it's upper. So we talk about the load going down, not always when the crank's moving around. So you can see the angle this is going into. There's an angle that the crank's actually working itself up. This is number 2 or 4. I can't remember which way it is, but it came out of the same engine. But you can see there's basically no wear on this main bearing. Right. And there's a ton of wear on this side. Right. So that's how much, we talk about the microns of tilt on the crankshaft itself. This is showing exactly where we're going. This one in particular, if you see, you can see close up, you can see some fatiguing going on. So we're getting that much movement on there. And there's some striping going on right over on this side. So your frictional temperature of the bearing got higher than the overlay at the melting point, to the point of it's starting to melt out the components of the overlay. First step of seizure is starting right here, that you're seeing the black marks coming out of the overlay, that it's melting those components.
So in essence, once I've arrived here, it isn't going to get prettier later.
Bearings don't self-heal.
That's right, and we're done. You know, I've shown this before, and then I always get the questions like, well, look, how do you know your main boards are aligned? Well, in this particular application, we said, it's an alignment, it's geometry problem. Right. So what we did, took it all apart, gauged it, put a go, no-go bar through it, checked the run out and everything. Guess what? Not the block. Nope. So we had a situation where we realized the windup, and this diagonal is showing not just, you would think of just this and this, no, it's like this. It's almost a coaxial motion. So it's very unique. So again, we have another main bearings here with these upper because of the groove, to the point of we're getting so much flex on this crankshaft that if you look at this bearing, you can see that it's all the way through the substrate, or into the substrate. It melted through the overlay. You can see the deformation coming right through here. All this here coming in, it's coming out the sides, where we have so much crank flex that we're getting into the substrate. Now, this particular one is pretty universal across, but there's that much flex that we're getting into the upper again. Sure. You know, let me go back and elaborate on the last one and this one. The one thing that, you go to the shows, PRI and so forth, or tech seminars, people are always coming up and say, hey, here's my bearing, what do you think, right? And so they ask all these different questions, and hopefully you have the answer. We try. Okay, well, I'm not as smart as you. So on our deal, they'll come to us and say, hey, can balancing fix this? And the answer is no, it won't. Because the difference is that the balance, if it is properly done, is doing its job. Right. The crank, on the other hand, is not structurally supportive enough to handle load. That's the differential here primarily. If we've done everything else right, I mean, you don't have to be Dick Tracy here. You can figure this thing out. Something is surrendering. Guess what? The crank. Now, how do you fix it? Guys are constantly coming to me and say, well, what do I do here? I'm going to open the clearances so I don't have the contact. I said, well, you got a lot of problems. We've explained that already. I said, but here's what I'm going to suggest. Stop making so much power.
That's not a good answer.
Yeah, stop it. You know, the deal stops right there.
Yeah.
Right? That's not who we are. No. So what I got to get to do, and this is what Dan and our mission is, to get you to be aware of the fact this is not your father's Oldsmobile. What we're making power with now, within the envelope of the componentry, hey, it's time to step up your game. You know, there's no magic here, guys. No magic at all.
So this goes back to, we already showed this slide once, but just kind of reiterate this. Again, arbiting, you get spots fill. As we showed in the previous pictures, they were uppers. Right. So this is exactly what the FEA was showing, that you can get a load because of crank flex on an upper, getting a thin oil film right there, and you're getting excessive wear. It's exactly what we're seeing on those.
See, and these 3 points right here, just clearly stating to you, this thing is not rotating as you would think and envision. This thing is distorted, and you're getting line contact. You're asking the bearing to save you. Exactly. And the coatings do a good job right up till they don't.
And once you lose the oil,
you're done.
You're done.
Okay, good enough.
So another example, this is one particular main journal, an upper and a lower, but this is the next step of failure mode. You can see again crank flex where you're getting some wear in here, but notice this is always down to the substrate on both. All right, and notice the black in there. All right, we're to the point now where we're starting the frictional temperature, we're coating the oil on the bearing. All right, so we're a step closer to seizure of what's going on when you start seeing this black embed into the substrate.
And once again, no recovery.
No recovery, not self-healing.
You know, you can go to church, you can pray at church, you can go Monday, Wednesday, Friday. It still ain't gonna save it.
It's not gonna fix that.
Yeah, there you go.
So insufficient oil, you know, this has a lot of wear on there. Again, you can see the similarities other than it's more straight across, but it's from edge to edge, pretty well the entire bearing itself. Just not enough oil. And what oil is there is getting burnt to the substrate because of the black looking in there. Another case example, we're near failure on this engine.
Okay.
All right, kind of going back to the same thing now. Back we had this once before, of filling in the void of oil to create a pressure. Again, we talked about pressure being down. We've proved that you can see it in numerous locations based off of crank flex, and when that is no longer available well to fill the wedge, there's no oil to be had.
Well, and once again, I want to reiterate, the go-to when we see some of these things, the natural tendency of industry is make it bigger, right? Open the clearance. Well, let me tell you, that's sort of interesting because we start seeing some different things.
So if you make too big, now we can't build pressure because we have too much bleed off.
Right.
All right, so to the point you have too much bleed off, you can see there's a lot of wear all the ways across the bearing.
Right.
So it's just case in point of you're just not getting enough oil to develop an oil film and you're making contact with it. Now this is very subtle, but if a little more horsepower, a little more crank flex, etc.,
go downhill.
It's premature wear,
Oh,
and it's a downhill.
Yeah, absolutely.
All right, excessive bearing clearance. You can go too much, and to the point of where you have a centralized location that you're getting load on a very small portion. Normally, you would want to see more wear across, and if you get very centralized, it's just again, we're not having excessive clearance. We have too much bleed off on the bearing itself.
You know, I don't think people quite understand the load. We think of the compression load pushing down.
Correct.
But then we're going to go to overlap. And as we open these clearances, now we got a rattler, right? So what's the piston rod trying to do? It's trying to leave the game.
It leaves. Every exhaust stroke, it's trying to get out here. Rev chips. Now you can double that.
Oh, out of sequence cycling. So what happens is just a rattle back and forth.
Yes.
And as you add clearance, then it has velocity and stop.
Yes.
Right? And ultimately will burn out the bearing.
Absolutely.
Right.
All right, cavitation. We mentioned earlier, as it's cycling around, trying to throw the piston out, you can create a negative pressure in the actual bearing itself in that area. So cavitation is the cause of air that's imploding, and it's microjet cutting into the overlay. So as that is pulling away, it's creating an air bubble. The air bubble explodes, causes an erosion effect on the overlay. So now you've disrupted the smoothness of the bearing, made a rough spot. If you get enough, you get bleed off that comes out the side. It's an opportunity to have another disaster happen.
Well, and again, as we open clearance, in other words, when I talk to the oil guys, oil manufacturers, they say, look, we put anti-foaming agents in here. We've really tamed a lot of this down, all right? But as we open the clearance, we've just canceled what they were trying to cure.
Yeah, we made that void a bigger area.
Yeah.
Because now we're throwing it out. We did some, when we were on my NASCAR time, clearance was relative to how much cavitation you have. The more clearance you have, the worse cavitation you had.
So once again, just, you mentioned it before, but this is like a sonic cleaner.
Absolutely.
I got this little air bubble, or a series of micro bubbles, and I got compression load, and I got cycle frequencies hitting.
Right.
I mean, let's be fair, 10,000 RPM, that's 166 times per second. So this thing is compressing, and it is your sonic cleaner, kaboom.
Exactly, same effect. So oil film breakdown, any oil's good oil. Wrong.
Yeah.
Okay, oil film breakdown. If you don't have the right additives in it, you again create where you don't have enough lubrication because of the additives, and it just changes, and you get higher load contacts because the film is breaking down because of lack of oil additives. Cheap oil is not good oil.
Well, not only that, the viscosities that we're looking, and I'm being told that we're going to be forced into zero viscosity applications. The old 50 weight and so forth that we used to do.
Thing of the past.
Wrong answer. All right, good. All right, so we're going to sort of go into, now we talked about the bearing, and we sort of indicated some of the things that happen in clearance, pressures, and so forth. But dynamic balancing, and we're going to talk about first order just for a second. So I got a couple of illustrations here to try and get you to understand. But the first order is the one thing that the balancing machines that you have, that's all they can do. They find first order only. But if you don't correct first order, it is absolutely relentless. I use an old adage that's like a little baby with a little hammer locked in a room unattended. Leave it alone, that baby will destroy the room.
Absolutely.
Right? Okay. So, but here's our real goal. Now, here's our crankshaft up here, and here's just a silhouette. So what we're trying to show is there is a principal center line of axis, right? Then I'm showing this diagonal line, and that's because there's a weight mass here and a weight mass here, so it's not perfectly balanced. However, it is equal and proportional so that the center line, as you intersect, and you look at this 2D drawing over here, it's canceling, just like a seesaw. All right, now that's important because this is balancing, equilibrium, all right? It really is a simple deal, but we have a tendency to go through and not follow the rules of engagement because when we look at the screens, this is euphoria. This, I've arrived at heaven. TDC, BDC, 180 degrees, I canceled just like the previous illustration. But by doing there, this thing has only 0.02, and you say, wow, that's really nothing, and it's right, because look here, at 1,000 RPM, I have 0 forces.
Nice.
0, all right? Smooth. As I go up to 10,000, I only got 0.37 pounds of force. Cool.
That's nice.
No worries, the bearing and the oil can handle that with impunity. All right, now, and we look at it in another way, what we call a third plane approach. We got the left side, the right side, and you'll see here, I'm really tight on my balance and really tight in the center, but there is a slight difference. What's important is there's not enough value of force to cause trauma to the crank. We call it excitation. In other words, hit it with a hammer, it rings.
Right.
Well, when you're perfectly balanced, you got a little hammer.
Little hammer.
All right. So here's one of the things that's sort of wrong. We got equal weight, but it's out of position. Now what happens is the CG moment has moved off center, and you can see it here on this slide. So what's happening is, I'm going to go into a illustration here. And basically, this is out of a crank kit, by the way. We had 26 grams on the right, 33 on the left, and in the middle I got 17. You say, well, okay, but I got 3 different pulses.
It's not going to be happy, is it? Right?
It's not countering anything. All right, so I'm actually adding to some of the trauma that I'll see in the fourth order. Now, this is our goal. We can do it. But I want to bring in torsional events. I want to give a simple way for people to understand. At 6,000 RPM, if you want to know what the hertz frequency is, you simply divide it by 60. Now that tells you 100 hertz. Well, guess what? 360 degrees out of a V8 now, we're going to have 4 combustion cycles. Now we have 400 cycles per second. All right? Now we got 400, 100, and then remember, out of this 100, I may have some oddness there. Right. I didn't cancel. But in this particular case, I'm doing 24,000 torsional pulses per minute. That's 6,000. I'm going to leap all the way to the bottom here, 10,500 pro stock. All right? Same deal, but now they're 42,000 times. Think about it, per minute. That crank is pissed.
That's a lot of happenings going on.
Oh, it's just out there. All right, so now let's move on to it and say, why the counterweights? Why is there a counterweight on it? Previously, our friend John Callies, my apologies, Mr. Callies, sat there and gave us a wonderful description of how cranks are designed and so forth. But here's the key. The counterweight balancing rotating mass assembly is the function of primary, right? In other words, it wants to offset.
Sure.
What it does do also is it adds structural strength to the crank, makes it stronger.
Absolutely.
Assists torsional control. Maintains shape and rigidity. I'm really trying to get, and this is important, shape and rigidity is the common thread I need to have geometry, bearing clearance, oil film. When that goes south,
everything changes.
There you go. Now, this is primarily what we see in the field.
Yes.
People get in there and they just go crazy.
It's easy, isn't it, Randy?
Oh, well, it's a go-to to get it mass out of there. Excessive drilling with inconsistent spacing weakens counterweight, causing excitation and fluttering. Whoa, what's fluttering? All right, here's the deal. I've already taught you about torsional count.
Yes.
But now I got that counterweight in its own environment doing this. Now I got the crank doing this, and I got this guy over here doing this. Man, this is chaos.
A lot of stuff happening here.
Yeah, higher RPM gets worse. Now, this is unprofessional contact. This is where I'm at. I had a customer send this to me right before we did this presentation. He said, what do I do with that? I said, oh, well, that's easy. Take it out, bury it, and salute it. It's done. All right?
There's a lot of things going on here.
Yeah, this is insanity. All right, but unfortunately, there's living proof
that,
there's something going wrong here. This is what's important. We suggest minimal drill depth. We suggest minimal number of holes. Keep in mind, if you drill that crank, you can't make it stronger. Anybody wants to argue about it? My number is 770-446-1999. All right, be glad to talk. But here's the answer. No hole drilling. This is not unusual in cup, right?
This is what we did all the time.
Absolutely. So we come up with a solution. Now, this is just a silhouette of a typical campground crank. And they've done this because the piston rod basically has to have enough clearance to get by the counterweight. All right, so in this case, this example is very simple. It's 106 grams. This thing's like a Christmas tree, and it comes in and it plots the different angle, and every crank is different. All right? But by following this, it's very simple, 106, and this particular unit, I'd have to take 133 thousandths on the lathe, and that will get it really close.
Look, a nice clean cut on there.
Oh, it's perfect.
No flutters.
Is it perfect? No, it has an Achilles heel. If there's a hole already, software can't see it.
Can't count.
But you're going to be a lot closer, or
sure.
what I call a safe zone. All right? All right. As cylinder pressure and torque load increases, crankshaft turns are twisting as much as 2.5 degrees end to end. Normally aspirated. Key word. Then I got this little statement here, boosted horsepower. I got news for you. I don't have a clue.
Nope.
2.5 degrees, that's nothing. You know, we got guys making 4,000 horsepower out of what used to be 165 horsepower. I mean, this is insane.
We're going to unknown land right there.
All right. But again, this crank is actually a pretty good crank. It's well designed, all right, but it's subject to the loads that I've talked about. It will not, cannot endure this unrelenting cycling. So we need to start talking about how to control this. And most of this aggravation is a combination of first order, fourth order. Right on this end, the free end, we call it the post. That's where the damper is. I got to tell you, there's technology out there now. And I know John had actually introduced that earlier. But the bottom line is, that is the new wave. We have to understand, if we don't control it, this will surrender. It will fatigue and separate. Now, I'm just going to touch it. Now, our friends at Fluid Damper did give me some data here. It was interesting. If I follow this curve, this is original design pressure, right? Properly designed damper right there. You notice it didn't cancel. It damped, okay? It cannot sequester. But then I got this racing guy, and he does nitrous, boost, whatever.
He's adding something to it.
He's up here. This standard damper is out of here. Waste of time.
Yes.
Now, different applications have different deals, and we talked about it a little bit earlier on the different types of manufacturing. But understand, you need to get to design engineers. You need to have this conversation. And I got to tell you, it's worth the time. And when you call them, they don't want to talk to you, they hang up, just dial somebody else. Eventually, you'll get an answer. All right, this is the primary reason of design. This is an OEM's end line, and you'll notice 8 counterweight diesel. Here's an aftermarket 12 counter. This guy will live, this guy will die over time. Just simply cannot relentlessly be cycled. This has pure countering all the way through. Here's my pet peeve, 4-cylinder guys. I love them. We call them rice rockets, and I'll get some hate mail for that statement. But here's the deal. When we're talking to these guys, they immediately go in on a lathe and they just whittle away till there's nothing there. And they lost the whole idea why the crank was designed, the mission statement of the counterweight. They have a second order problem that is critical. You just went there and pissed it off more. You do this, and I guarantee you, you're going to sit there and have things happen. Things are going to fall off the car, literally. Yep. Now, one of the other things, we have load areas, and this is just an example here. And I got to tell you, as we start making more and more power, you see a lightning hole up there? You need to pull that back. You need to start thinking, this surrenders the strength. Now, the guy said, I don't want that weight there. Okay, I got the answer for that. I don't want to break the crank.
Because with that hole, you get more deflection.
Oh, absolutely. Again, show me the hole that's drilled that makes it better. We got to have a discussion.
Correct.
All right, now this is a little fun for me, and this is right in your area. When I come in now, John, of course, this is one of his designs from way back. A really cool idea. He's diverting oil away from the journals. I get that. But that's not where I'm focusing. I'm focusing right here. Now tell me what you see.
Yeah, so as we change to oil holes, we have some FEA on that as far as back to the oil pressure of how much air you actually can introduce into the rod journal. So now you can increase cavitation just by the hole. Polishing that hole, if you polish that, with that, the longer it is, the more area that you can pull away. We can have change film pressure by that not being round. A perfect bearing is designed around a perfectly round shaft.
Keyword round. Okay. These things go in the field. Let's say the manufacturer's done his job. He sends it to the shop. He puts a little witness mark on it for whatever reason, and out comes this polisher. John had also talked about that. If you can see a spark, you're a dead man standing.
That is not polishing. Now we're grinding.
That's grinding. That's right. Uncontrolled grinding. The other one is these guys sometimes get over center. You know, these shops with a handheld die grinder, they can screw that up to the point that redirection of oil means the oil's not going where it's supposed to go.
Exactly.
Okay. So it's a key issue. Now, I do want to talk about this because this has been done in Europe for decades. It's an interesting deal where we're using tungsten, all right, Mallory, if you will, as the actual counterweight. Now, this is good conversation because we're moving forward. I'm going to give you another example here. And here's one, just dual coupled. And so it's pretty, it looks good and everything else. But the point is, they have lowered the diameter, the radius, and so the polar moment has been radically improved. XL decel consideration does one more thing. This material here is not nearly the same frequency as this here. It's a damper.
So we're dampening the crank.
There you go. Now this is stuff in the future. This is stuff, now I say future, Europe's ahead of us. We're over here saying, I don't want it. And the guy worries about it coming off. I'm going to make two statements. That rod is going on there where all the load and all the true distortion is, and those they're hanging on. Well, guess what? This is a follower. This is not that.
Right.
So the naivety of understanding what's going on, what the two applications are, listen, this is future right here. Rank tolerances, we need to just broach on that. I love it when we see all this stuff enter the market with different tolerances. You know, I see them on the box balanced. And I've always tell people, especially people who buy our machines, say, look, take the crank from the customer, say, I'll spin it up. If it's in tolerance, free. There you go.
There you go.
Ready? I've never had a customer ever tell me you gave a free
You get
job.
paid every time.
There you go. But here's why. I got to get you to understand, this is a kit. This is out of the box. It said it was ready to go. 208 grams of unbalance at 1,000 RPM at 39 pounds of force. Believe it or not, you just barely would feel that. 16 times per second it's hitting the crank. Let's move over here to 4,000. Remember, weight stays the same, but the force increases exponentially. At 4,000, it's 626 pounds, and it's hitting the crank 66 times per second. At 8,000, it's the same weight now. You got to remember that. It always stays the same, but the force changes. So at 8,000, it's 2,500 pounds, 116 times. And if you really go over center, you're at 10,000. That's 166, or almost 4,000 pounds. I call that a fender swapper.
Yeah,
right?
It's going to break loose there.
What do you think the bearing is feeling about now?
I think we already saw some of those examples.
There
Not
you
really
go.
good.
There you go. So you got to understand that's first order, and that's why it's critical, because if you do this, it won't get better. The only way to remedy this is to take it back apart and rebalance. But here's our pet peeves. External balance is because they're sitting on the free end, right? They are on the crank, but the proximity to the bearing is closer. On the free end, depending upon the length, this unit is out here, and I'm giving you an example. This is only 28 ounce inch. That unit is 794 pounds of force, or excuse me, weight, but it generates 1,790 pounds of force out here. Now, it works in concert with the rest of the crank to balance it. But as you go up in RPM, it takes its own identity. It has its own life cycle. Now, just to give you another example, if this is 1,790, I move at 10 thousandths. That's going to move up to 2,400 pounds. If it goes 15, more. Oh, wait a minute, snapola.
Exactly.
Right? 28 versus 50. It's sort of interesting, these charts are here, and people who watch this, they can look at these things. But you got to understand, the difference is also the number of times per second this engine is being hit. It's going to fatigue out. Last thing, see those two holes?
Yes.
Bad idea.
Nope.
You never drill on an inertia ring, and especially if it's a elastometer, because what happens is it creates its own identity again, and it will pull away from the bonding of the elastometer. We've all seen these things rotate over time, and every time I go and I'll see that, it means it happened earlier, right? All right, oops, there we go. Now, at the end of the day, our whole mission has been, wake up, America. We are not building our father's Oldsmobile. We have new products, new technology. You got to sign on to this. Technology is your friend. Dan, how would you finish up?
There's a lot of new technologies. Things are changing. The engines are lighter. Components are lighter. As we get into rebuilding new things, there's a lot of things that are changing. Technology, like you said, what we're bringing to the market today is different than what we had years ago. Bringing awareness of when you're seeing parts never lie. Just knowing the story they tell, and reading the parts is key.
Well, the old saying, knock, knock, who is it? Technology.
Absolutely.
That's where we're at now. Thank you so much.
Thank you.
Welcome back to the studio here at the Engine Performance Expo. Randy, Neil, and Dan, boy, they just took us on a journey. How interesting was that?
Oh, they're fantastic. I mean, the relationship between all of these parts. We keep talking about it over and over again. Things are systems. They don't exist in isolation. They're not independent. Everything is connected. And Randy and Dan just gave us a tutorial on that.
You change one thing, you change everything.
Mm-hmm.
But we're about to dive into it with Trevor from Get 'em Performance. And Get 'em, I'm like, go get 'em, right? And you're like, no, man, there's actually a meaning behind it. Talk a little bit about your background, Trevor, because we're going to talk carburetor parts. We're going to talk a little big money bracket racing, which I am super interested in. I know everybody wants to just go fast and get to the stripe first, but you can make a lot more money bracket racing these days. But how did you guys get started? Talk a little bit about your background.
Yeah, I grew up in motorsports. I'm a third generation. We started out truck and tractor pulling. We'd run blown Hemis. We got into that side of the business, which I still love the truck and tractor. I love the grassroots side of racing.
Mm-hmm.
Then you get into, I was in DuPont for 20 years, did a lot of the NASCAR programs and everything. And then I moved over I was with Holly for a few years. And then after I left Holly, I got into actually comp cams.
That's where we met.
And him and I spent some time in Dubai. We spent some time racing together. And of course, you have kids, you get older, you're married to kids, and all that comes along. And you get some of these private equity companies that are buying and selling. It's like, you know what? I'm going to jump out on my own. And a whole idea of of Get 'em Performance was Grady, my oldest, Eli, and Trevor Motorsports. And they junior dragster race, and we played a lot of the NHRA stuff, we played a lot of the other bracket racing, but something that's come on the past few years is really a lot of actual the big money bracket races. I mean, we can race for $1 million about once a month now. So that changes, but going to Get 'em.
You heard that right, folks. $1 million. $1 million bracket races. They're a common deal. Everybody should know this by now, but it does blow people's mind. That's a lot of money.
It's a lot of money.
That's a lot of money.
Oh, yeah. Well, you've got great engine builders out there that kind of focus. They do some NHRA stuff, but they focus on the Sunset Performance engines, the Chris Wilson Performance engines. You start looking at those guys, and they really do focus on the bracket racing and being extremely consistent. So that's a whole nother program that when we played Pro Stock, that was as much horsepower as we could make. When we played a lot of the racing, it's as much horsepower as we could make. Now a lot of it in the big money bracket racing, it's how fast can we go and how consistent can we get there and how repeatable is it? So then we get into carburetor world, and I love the carburetor. I love Pro Stock probably as much as anybody. The Steve Schmitz, those guys are all a lot of my heroes in that side. So when you get into making something consistent, all right, you get into molds, you get into castings, so it's like now we have machinery, big CNC machinery, as we talk about Rottler and those guys. How consistent can we make it? So now a thousandth really matters. A quarter of a thousandth really matters. A thousandth on a bracket race really matters. And our kids that are coming up today, my kids are heavily involved, so you got to know that they're heavily talk about. They'll talk about 3 dead 2, 5 dead 1, and you're going, that's a 6-pack in any racing form.
A 6-pack and you're loading up.
That's right.
So let's talk.
The thing is, we see consistency. All I could think about, Joe, when we mentioned that, is Eddie and Matt yesterday in the video about carburetors versus EFI, and how with EFI, you're telling the engine how much fuel it's going to get. Whereas with a carburetor, the engine's asking for fuel and the carburetor's giving it what it asked for. And how Matt was saying in that video, hey, my clutch is more consistent with a carburetor than it is EFI. So Trevor talked, and this is the brain of the carburetor that helps it make it consistent.
The metering block is the brains. And there's a lot of calibration, a lot of configuration into that metering block. Now, backing up, truck and tractor pulling. I love Enderley. I love the big and uglies. I love that world, and I'm very good at that side. EFI, if anybody knows my NHRA background, I was the NHRA. I did all Holley EFI on most of my cars. And we started the COPO program. We worked very hard on that piece there. But carburetors, one thing that you get into a carburetor, the motor is asking for something. We have to develop a fuel curve, a launch, an RPM curve, and it's creating a vacuum. That goes back to you guys as far as total seal, as far as the head flow, and how much it's asking for. You got to build that fuel curve to what that engine's asking for. So that's really all that goes back to even some of the Pro Stock. That motor's asking for something. How do I make that cylinder happy? How do I create as much power, as much torque in that cylinder individually that I can make? And that goes back to that meter block. Going to emulsion, everybody goes, oh, just change the jet. No. There's a lot more into that calibration. If you start talking emulsion, a lot of times you'll have 5 or 6 emulsions into it. Now you'll open one up, you'll lower one, does it suck air, does it suck fuel? And that's all when the car will launch. Basically, the fuel level goes down, needle and seat pick it back up. So when it goes down, I need to suck a certain amount of air to go lean. Fills back up, it starts pulling more fuel, not just through the main jet. So there's a lot that goes really into the carburetor science. Just raising and lowering the floats a lot of times will change jet size 4 or 5 thou each time you raise or lower that float.
So what products do you have available for, obviously I would imagine the mainstream carburetors that are used in this style of racing? What products do you have available for those guys? And where do we find out more?
Well, basically I make a 650 from 4-barrel to a bladed carburetor, and that's some discussions there also.
Yep.
But a bladed carburetor, just a real quick about that.
Yes.
A bladed carburetor, we all make 4-barrel carburetors. Everybody knows 4-barrel carburetors because in all honesty, a 4-barrel carburetor is easy to make. It's drilling a hole, it's boring a hole. Now a bladed carburetor gets a little bit more complicated, just to the point of we have CNC machines today. I brought a basic booster here. Now we can 3D print things We'll 3D print main bodies. We'll 3D print everything. We will shape the body around the booster to get the booster to pull fuel through the metering block. So the machines have changed so much from the 60s and the 70s and the 80s. And then you get into the 90s of the machines starting to come in. And then you start shaping a body, or you start shaping a booster around some of the airflow that you're needing. So if you tell me you want a 1600 CFM carburetor, okay, we can machine that to 1600. If you want it to 2100 CFM carburetors. So we make carburetors roughly around 650 CFM up to around 3000 CFM. So that we can actually make that carburetor specific for that application.
Just gasoline and methanol. Bracket racing guys, they're all in methanol, or a lot of them.
A lot of the guys are methanol. We do from race gas to pump gas to E85 to methanol, Q16. I mean, all those fuels have come into play over the past few years. And Q16, the oxygenated fuels have really have really changed this technology also, because if you take your carburetor out of the box and say it's a normal off-the-shelf carburetor, if you go to a normal gas situation and put Q16, usually it's around 15 to 20 thousandths more is going to go through the main well and through the boosters.
Absolutely, we did that on Tuesday, by the way.
That's exactly. And most people go, oh, well, I just put Q16 in, it went crazy lean. Oh, yeah, it's going to.
Yes.
Yeah, I promise you, it's going to. It just don't have the main well or the emulsion pack in it to be able to flow the Q16 through it.
A lot to unpack here, but that's why people can go to the website. Give your vitals, Trevor, because I know there are a lot of people out there that are watching now and in the future that are going to say to themselves, they're looking for an advantage. Like when you go out there, you're battling against 400 guys, you're trying to win a check for $300,000.
No, we're going for $1 million now. We're going for the millions now. We're not going for $300,000 anymore.
Well, you know, they cut it up in the end, right? You get down to 16 cars, they start splitting it up.
That's right, that's right, that's right.
Bring it home. But where can we find out more information about Get 'em Performance?
Yeah, go to our website, getemperformance.com, 904-509-0329. I mean, and this really is a family business. Grady's 16, Eli's 14, me and my wife and everything, we're heavily involved in the business. We have a handful of employees in there, and all we do is CNC from basic small carburetors all the way up, and really we focus on billet carburetors, billet parts.
Excellent. Well, great job. Good luck with that, and we'll hopefully see you at a big money bracket race in the future.
Sounds great.
Awesome. Thanks for coming, man.
Thanks,
all right,
guys.
more to come here at the Engine Performance Expo. We're going to kick it out to our next video as we are continuing the process of learning, and sometime soon, we'll be revealing,
getting close,
the horsepower numbers.
All right, folks, a big question we get all the time anymore is about these plasma spray bore stuff, you know, like the Ford Coyote. I mean, heck, Ed, there's Nissan, Mercedes,
Audi,
Porsche,
BMW.
Yeah, a bunch of them are using a plasma spray bore. So, Ed, explain a little bit what the difference between a plasma spray, what is a plasma spray bore, and how is that different from our regular old cast iron sleeve like we have in here?
Yeah, no, that's a great question. You know, so it's applied. You know, you'll put a cylinder or a block in an actual machine, and you've got a wand that goes down through there as everything rotates, and it applies the metal in a. It's really like a spray weld.
Exactly. Yeah. Exactly.
So it applies the metal to the bore. Typically, what you'll do is you'll bore. Depending on where you want to be, you might bore the cylinder out 20 thousandths and then you spray it up to 40 thousandths.
Okay.
And then you hone out to whatever size you want.
Right. So here, describe this little sleeve right here, right? Yep. So for a traditional iron sleeve.
Cast iron sleeve.
Right. And that can go in either an iron block or an aluminum block. Now, the plasma spray bore is typically being done in aluminum block engines.
Typically.
Now, you can do it in an iron block engine.
Absolutely.
One of the really neat things about that spray process is that it creates porosity.
Absolutely, yes.
And that's kind of the key to the honing difference, right? Which is why we're standing next to the Rottler, this is H85, right? Or H80 hone.
Yep.
So H80 hone, because you're gonna hone that plasma spray bore cylinder completely differently than you would one of these.
A standard cast iron bore, absolutely. You know, when we're using cast iron bores, we're trying to apply or create the RVK.
Right, the valley.
The valleys, the deep grooves where the oil lays helps the sealing process. With a spray board cylinder, we don't have to do that. In fact, it's a completely different process and, and a step-by-step deal. We're actually using up to a 1200 grit diamond to get a very smooth finish because we already have the RVK in there from the porosity of the spray board.
Exactly. So those pores, they're created by that process, they hold the oil. So you don't need those valleys that we're trying to create with our traditional abrasive. So you mentioned 1200 grit diamond. So I know like when we did the Engine Performance Expo LS block, we used a 170-200 diamond and then plateaued over that with 600 CVN. And you just said you're going to finish with a 1200.
With a 1200, yes. Yep. And one of the reasons is the whether it be the spray board or even really a Nicosil coating, it's such a hard material or a surface that we want a really smooth finish for the rings. We don't want to wear our rings out.
That's a good point. The plasma spray board is very hard, similar to Nicosil, so that if it's really rough, it's a cutting tool and it's going to kill your piston rings, and we don't want you killing your piston rings. It's not a good day.
No.
I know, for example, like my car, the Wombat, it has Nicosil, or actually Suma bore cylinders in it, right? So Charles Navarro and Jake and those guys at LN and Raby Enterprises, they are investigating. That's what these cylinders are for. These are air-cooled Corsa cylinders. So the first generation of that testing was actually done in my car, where we took a water-cooled Porsche engine, which would normally be Nicosil, but we, as opposed to using Nicosil, we're exploring using Suma bore. And yeah, that engine's got 10,000 plus miles on it, doing street use and things like that. It was amazing when we did the first teardown at 5,000 miles. I mean, nothing. I mean, it's nothing. It's just nothing. It does. You in this mirror finish looking like that. It's crazy. And it just doesn't wear.
I have just a quick story. I have a gentleman up, and he's an engineer for Dana. They're into pulling trucks. And so he decided he wanted a big bore motor. So he went and bought 2 square pieces of 4340 steel, 1,700 pounds a piece. He carved out 2 engine blocks predicated on like a big block Chevrolet. 4 750 bore. And he Sumi bore coated it. And they unfortunately, and he'll tell you this story, is on the dyno they forgot to put a couple of restrictors in and lost oil pressure and blew the thing up. But the cool thing about that was they got in there, honed that Sumi bore out, stick welded the gouge out, sent it out, had it re-Sumi bored in that one cylinder. I honed it again. They've been running that motor now for 4 years, 5 years. And all they do is at the end of the season, they'll stick maybe that 1200 grit in there and go up and down a few times, and you're golden.
Okay, so that's a really great point. So let's say someone watching is, they've got a Coyote or an Audi or whatever that has this factory applied spray bores, because this is Suma bore, which is from Oerlikon Metco, but there's other companies that have similar process. And so they all kind of end up as the same thing. So what are some do's and don'ts for someone that's thinking about rebuilding, rehoning their engine that has a plasma spray board?
The first thing is you don't want to be touching this with a 300 grit or a 400 grit or any type of abrasive that's going to remove a lot of material, because it's a sprayed on coating.
It's very thin.
It's very thin, and depending on where they started and what the bore diameter ends up being, I mean, you could have 5 thousandths of coating per side on that. And so
you're not going to go 10 over.
No, you're not going 5 over typically.
Right, exactly. That's a great point. You're typically not going to go 5 over, 10 over. You're not boring it out. You're talking about taking the same cylinder size, cleaning it up essentially, and like you said, a 1200 grit abrasive at say 10 strokes isn't going to remove hardly any material.
You won't measure it at 10 strokes. You won't measure the material you're taking out. And I think even some of the guys in the Cup series, I think you're talking about oversizes of 1,000ths.
There you go.
Or 2,000ths. Sumi bore is a unique process, but it's a unique material. And,
exactly.
it's pretty intriguing. It's some pretty neat stuff.
Well, one really cool thing about it is because of that 1200 grit finish, it is so flat on top. It creates these perfect plateaus that have these little deep valleys to hold the oil. The bearing ratio, right? Talk about that Abbott Firestone curve, the MR1, MR2.
It's incredible.
Oh, it's unreal. I mean, we'll show you guys some examples of what a Sumibor cylinder looks like versus your traditional cast iron cylinder, and you're going to see that cast iron cylinder looks like the Rocky Mountains, whereas this stuff looks like an Arizona Mesa plateau. It's amazing the difference.
Yes, and honestly, if you'll compare the Abbott Firestone curve to a cast iron bore versus a Sumibor, you'll see a huge difference in that.
Right.
In the slant of the curve. There's really not much slant in that Firestone
it's
curve.
Pretty much flat.
When you've got this Sumibor, it's really pretty eye-opening.
Well, like I said, it gives you
there's no wear.
Well, exactly, because it doesn't have a lot of grit or a lot of tooth to cause any wear. Right. It's got plenty of area to support the load. Plus, it's got enough valley to hold the oil. It's very porous surface acts like a sponge, so it can seal. So I guess the takeaways from this are that as a new sprayed piece, there's a different process, right? You're going to use like a 325 and get close to size, and then go to 600, and then go finish with the 1200. These are all diamonds. You have to use them in hard like that. Because it's so hard, you can't cut it with a traditional abrasive. Or you'll struggle with a traditional abrasive.
You're going to rub on it a long time with a standard abrasive.
Right.
And yes, you're absolutely right. It's a different process. So typically what we're going to do here is we're going to take 10,000s total out.
Okay.
So we're going to use a 325 400 grit diamond to what we'll call rough the cylinders within probably 4.
Okay.
Then we're going to take 2 to 3 thousandths out with a 600 grit diamond.
Okay.
And then we're going to step up to our 1200 grit diamond to get down to what we call base finish.
Okay.
And the finish that you're looking for the rings and all on a Sumibor coated or a spray bore coated cylinder.
All right, cool. And we got this cool little fixture here that Embry and the guys here at CNC Blockworks made for us to be able to hold those cylinders in there, because we're not, as a modular cylinder, it doesn't have a block to hold it in right now. So this is a pretty neat little piece.
And that brings up another great point is you're looking at an aluminum cylinder here, and I don't know if you can see how thin we'll call the spigot area of this is, and this creates a tremendous problem to hone, because it wants to breathe.
Right. And this is common on every air-cooled engine, right?
Yes.
Not Porsche, not Volkswagen. We're talking Harleys, everything that's air-cooled.
That's right.
They all have this same problem.
They all have this same problem. And the other thing you're going to find is you have to be able to clamp this piece to hone it. Otherwise, it'll spin in the fixture. Well, if you don't create an even clamp load, what happens is you will distort these bores.
Right.
And some of them are these, they're made by L&M they're a high quality piece here.
Right.
Okay. And you don't get near the distortion. But I've seen some of the standard old air-cooled Porsche cylinders that I can grab with my hand and just squeeze and distort them 2,000ths.
Ooh, that's bad.
So it's really
neither straight nor round at that point.
Yeah, neither straight nor round is for sure. And so when you clamp them in there, I've literally, once you unclamp them or untorque them, I should say. There are spots in there you can't even read with a dial bore gauge. I've seen them 5-6 thousandths out of round.
Yeah. So that's some blow by there.
Super important when you're doing this sort of stuff to have the clamp fixture that mimics how they bolt into
the
an
engine. Right, there you go.
Torque plates or whatever you want to call them. Super critical on stuff like this. In fact, I don't think you can get by without it.
Oh, exactly. Yeah, it's having the proper fixturing. Like I said, it's just like a torque plate for a larger engine to replicate that clamp load, so that you get the proper distortion. Then you're honing to fit that way that it's actually round and straight in the engine as assembled, so you get the proper ring seal and proper engine performance.
Yeah, I mean, you go to great lengths to make your rings round.
Oh, yes.
And we go to great lengths to hone these cylinders round. But when you release them, they're anything but round.
Exactly.
So yeah.
So it's kind of neat to see how shiny this is, and how like you said, there's really no crosshatch to this versus we have a crosshatch in a traditional cylinder to get that oil movement up and down, hold that oil. But here you really don't have that. It looks very different.
Yeah, there is a slight, you can see a slight crosshatch in there, but it's a very shallow one.
Right.
Because again, we have the porosity that holds the oil, so we don't need it.
That's perfect. So anyway, hope this little video gives everybody a little bit of insight and some do's and don'ts. If you're starting with a sprayed cylinder that's brand new, then hey, there's a process to it. If you already have a block that's already been sprayed and already been honed, and you're just wanting to refinish it, there's a different technique. Keep that in mind because you don't want to overbore it and destroy it, because this is a pretty good material. You want to take advantage of it. So hope this video has been helpful. Thanks for watching.
Performance Expo rolling along. What an amazing day it has been. We are learning so much about it, and only because we have a great, amazing place to have this shoot, talking about Shroud Technologies. And guess who joins us now? Chris in the house, and of course James Goad with him. And we're going to talk about some of your stuff, which I think is super exciting. Not only do you have this amazing machine shop going on, you're hosting us and providing coffee at a great level, and a really cool dog to play with. But the reason you have this is because you've been so successful making high performance parts.
Well, and that's, yes, I've been blessed. I've had wonderful mentors over the years and stuff, and I've listened, and we've come to this point, and we were talking about as far as the industry and giving the industry something that they needed, which we build a bunch of big inch small block pump gas motors these days. But the problem is when you start building big inch small block Chevrolets, it takes a lot of cylinder head on these things. And when you start going to a 23 degree small block Chevrolet cylinder head, you get into the situation where you've got to have shaft rockers and stuff. So just a set of heads could cost you, and the rocker arms, you're looking at about $5,000. So we started on this project about 3 years ago, and of course everybody knows what happened 3 years ago. We got COVID and that stuff going along. So we've been working on a little bit all this time and stuff. So what we're introducing is a small block Chevrolet combination. This is an 18 degree head. We went for the purist of you all out there, one of the small blocks, and the lovers of the small blocks. The old double hump Signia is on the end. So
that was just a cool factor.
Well, it is
all about the cool
James,
factor,
it is a cool.
Chris.
Yeah, it is a little bit of a cool factor. Yes, and
hey, you got me to stop by your booth.
Well, and that's it. James stopped by at the PRI show, saw the heads, and I told him what price point we were going after, and he says, "You're kidding me." He said, "My fans love small blocks, and that's a killer price, and that's something everybody can afford."
That's the thing. The value of this, it is going to be unbeatable. So that's why we've decided to build a motor up here, and we're going to take it over the dyno, and we're going to prove. Now Billy keeps saying, conservative.
Yeah,
conservative.
He wants to hold you and I down for some reason. You think it's because
he's still excited when I said we was fixing to put 20 pounds of boost on. He's still not talking to me over that, so just so you know. So that was the thing about this. Not only is it a really nice cylinder head, but the fact that the value of this thing, that for somebody to be able to take their 427, 434 small block, and I'm not even going to say the price. I'll let you say it. But
so the guy with that pump gas small block that wants 700 horsepower, this package, what you're looking at is you get the intake manifold, which is a two-piece design. This comes with both a 4150 flange and it comes with a 4500. So that will be in the box. It's already integrated in are the bungs, so you can add nitrous if you want to. This is a single plane intake manifold. So, and you get the heads come complete. You get the fasteners, you get the rocker arms. The new fastener company with Mr. Feeney, P1 will be making the fasteners for our cylinder heads. So with camshaft lifters, fasteners, rocker arms, pistons. We've even come up with a custom piston design. It'll be based on the weight of the 23 degree pistons. So a guy would be able to disassemble his 23 degree small block over a weekend, install this package with everything you need, have 700 horsepower by Sunday night at dinner time for $6,500. Now,
and we're going to put this to the test and actually do the dyno testing. With every part, everybody thinks that I get special stuff, Ryan gets special stuff. There's not one part that's going in this motor that isn't right here in this shop. And we've been doing the videos as we've been doing the machine work on it. So the package, when we video it, there's going to be no fugazi things going on that, oh, Reaper's got a different camshaft, he's got this. We're building this exact motor for me putting my Chevy 2 to go play on the street with.
And for you engine builders out there, this package will be available for you. It will come in an unassembled package, so you can buy the castings, you can buy the parts, any type of level, and this will give you a product line that makes power, fits a great market, because there's a bunch of big inch small block stuff out there running around type deal.
Not everybody has swallowed the LS pill.
Well, that's true. I mean,
and I'm not, LS motors are fantastic. You do a little bit to them, they make huge horsepower. But I beat my 406 in my car for 7 years.
Well,
and I drove that car on the street, raced it. I mean, it was to the point that every time I freshen it up, I have to check the line bore. That motor won't line bore no more, just from having it cleaned up. That's how many years I ran that motor for 15 years, and I've never heard it.
Well, and let's face it, the small block Chevrolet platform is the basis of really, for most of us, why we're all here. I mean, this engine family created the high performance market. And we're giving those small block Chevrolet people out there today a package that affordable, makes power. Now, casting wise, I'll just go ahead and state it now. Castings are cast in China. These are permanent mold. But these things have been gone over by some of the greatest minds in the industry here at the Expo, and they absolutely said that is one of the nicest cast intake manifolds, cast cylinder heads that they've seen. The fasteners are coming from the United States. The valves are coming from South America. The springs are coming from the United States. The retainers are coming from the United States. This is a worldwide package from manufacturers all over the world. So, you know, it's everyday life. We have to realize.
And to get that value. The thing is, I don't think people really, it bothers everybody as bad on small parts coming from overseas. It's the fact when somebody puts a U.S. flag on it and they don't do what you just did.
Right.
Very few people will do what you did. This is where this comes from. Honesty gets you everywhere.
The guys up at Harlan Sharp making our rockers, U.S. made rockers. So yes, I mean the package, so intake manifold, rocker arms, complete cylinder heads, gaskets, fasteners, pistons, camshaft, Morel lifters. These will be featured in a hydraulic roller package or a solid roller package. All this for $6,500. And this head out of the box flows 320 as cast. It'll be available in a CNC version for an upcharge. James asked me this the other day, and I told him it looks like about $700.
That's ridiculous.
That's
a worthwhile upgrade right there, right?
Here's the thing, I wouldn't even blend the bowls on somebody's heads for $700.
So let me think here. $6,500 for cast, $7,200 for CNC.
And they flow 380, and they're still only 257 cc's.
Yeah, here you go.
So it's going to be there for either the engine builders or the public, and available. We're looking at March as a release date, the end of March, and this product line.
I bet we got dyno testing before March.
I think we are going to do some dyno testing before March, yes. We would, I think we've got a few sets that might be here, including intake manifolds and stuff.
So when this is released, you guys will have actual real numbers from the dyno with this package. We're not changing anything about this. Not changing the camshaft, nothing. Everything is going to be exactly what you buy. Because just like Chris's honesty, I don't like lying to nobody about that.
Can't.
Everybody thinks we all get special stuff. And some of us do get kind of special stuff. But I want to do this motor with nothing special, exactly what they see on that video, when they see that video, the numbers they see is going to be the same numbers they can achieve at home with this package.
So this will be sold under the VEPR line, which stands for Velocity Enhanced Port Range. And this 18-degree project, we nicknamed it back a long time ago Mayhem, because we feel that it's going to create mayhem in the industry. So Mayhem will be available here in March for the purists of the small block Chevrolet at $6,500, or I guess you all are telling me $7,200
for the CNC version.
For the CNC version and stuff, that's what we're looking at.
It would be not smart to not do it.
Well, think about
not when you take all your stuff off your motor itself and get half the money back.
Right. That is an awesome point, by the way. Like, right?
You
put it
literally
over
take
here.
everything out, sell it for 50 cents on the dollar what you paid for it, and have half of this paid for. not being an 18 degree. There's a world of difference between an 18 and a 23 degree small block head.
And James brings up a good point. You resell that stuff, that 23 degree stuff, the manifold and everything else, because you don't need it. Header wise, your headers will fit on these cylinder heads, so that's not to worry.
Oh, that's a very unique thing right there too, because you didn't lock nobody in for this being a semi-spread port exhaust. All spread port exhaust, of course, they do the small headers.
Right.
Which nobody makes a factory header factory header. An aftermarket header for a Chevy 2 Camaro, you got to spend a lot of money on that. But they put both patterns in. So your existing headers will bolt right up on this.
That's nice, yeah. Yeah, and you can flip that around if you want, Chris. If you know, that's something that's worth seeing, the exhaust side, so everyone can see. All right, so operators are standing by. You want to get in on this? I know you do. Like me, like I'm a Pontiac guy, and this made me feel sad. It's really what it did. It made me feel like sad. Like, oh man, cost it's expensive to be a little different. But what you guys have done, Chris, obviously, first of all, thank you for inviting us in, and you take on a lot of extra responsibility for this whole thing. That we show up and we have a good time, and then we like party at your house and then leave, and you got to clean it all up.
He makes it easy, doesn't he?
He really does. He really does. And James, how you've gotten behind this thing, and just like hearing you guys talk about it, lay it out, like things like that didn't and don't exist. It makes it so easy. Like, hey, we want to do something. We want to go fast. We want the father-son project. We want to do it. How do we do it? Like, this just lays it out, makes it easy.
And the combination, it's like I tell everybody, I could give my car away tomorrow, and I won't sell my tune-ups. The tune-ups are more important. The package, because all the time and effort it takes to put one of these packages together that make power, because anybody can throw parts together, but that don't mean it'll fall out of a tree when you go to run it.
Right, and all with one call and one order.
This is actually going to be a dyno tested package when it's done.
So Chris, I'm sold. But where and how? Like, tell them to, where to go to, how to order. Are you like forming a list, obviously, of who wants this thing? How's that going to happen? Lay it out there.
So through the AAM group and their associate warehouses across North America, this product line will be available. Look for the coming soon as far as the Vepr product line and stuff, and we'll be making product announcements. Contact your local machine shop and tell them that you're interested in the Vepr line, and be looking forward in late March at those price points.
Awesome. And there you have it. Just another bit of breaking news, I would say, here at the Engine Performance Expo. Great job, guys. James, thank you very much. Appreciate your work, of course, on YouTube and otherwise. Love watching you on the show as well. Chris, thank you very much for what you have done. And everybody, we're getting down to it now, Lake. We're getting down to it. You and Ben Strader are
closing in.
We're going to set some oil levels. We're going to figure out some things. Check out the next video.
So proper lubrication can be defined as the 4 R's. Right oil, right place, right time, and right amount.
That's interesting, isn't it?
Yeah.
Wonder what the right amount would be. So obviously if we have too little,
that's a bad thing.
Pretty bad. But does it hurt me to have too much?
Pretty sure it does.
Well, one way we could find out is we could put oil in the thing and run it on the dyno, and then we could put more oil in it and run it again. Like, I think we ought to probably try that.
Let's do that.
So what do we got for a baseline? What oil do we have in the engine? What are we planning on doing? How much do we have? Is it the right oil in the right place, the right time, the right amount?
Well, it's the right oil because it's the 15W40 driven GP1s. We've run this engine before. We've already done oil analysis and a complete engine teardown, so we know.
We know it's the right oil.
It works,
definitely
right?
Works. Yep.
And so we've got 5 quarts in there right now.
Okay.
So we're going to start off, the oil pan can hold 11.
Yeah, so I was going to say, to me, being a wet sump, being that it's a LS, and these engines have a little bit of trouble with drain back. So especially as we get up to higher RPM, 5 quarts seems a little on the low side to me. But,
probably so.
But as long as we have more than 0 PSI oil pressure, we'll probably be all right.
We have enough to get the pan full if we need to.
That's right, yeah. So as long as it's not full of parts, we're okay.
Oil is good, parts no, right?
Parts bad,
I'm with you on that. So let's go to the dyno and find out.
Okay, let's go try it. Well, that was interesting, wasn't it? So exactly what you'd expect. That's really
I held
not,
my breath there for a second when the oil pressure was doing this.
I was watching it, but it sort of stabilized there. You know, we're in there and it dropped down to, about, let's see, probably 35, 40 pounds, but a lot less than the 75 or 80 that it was at before, right? So, saw it sort of take a nosedive, and it's like, all right, I got my finger on the throttle just in case, but it leveled out, so it was okay. But here's the thing, because of that, it made significantly more power. I mean, like not like, hey, we put a different cam in it.
Right, yeah. But it was better than it's been on the earlier runs today.
All day long. Here, let's look by how much here. So let me clear a couple of runs out. So literally, just here at 7,000 RPM, it's 12 horsepower better, 12 and a half horsepower better.
12, all right.
So you think about what 12 horsepower is. If I was driving around in a 12 horsepower go-kart, that's a pretty good time.
Oh, yeah.
You know,
we drained about 7 quarts of oil out from the previous run. Now, not the exact same oil, but it was 7 quarts of oil. So what we're going to do now is we'll add 2 quarts of oil and run it again and see if we lose our 12.
So we should see an increase in oil pressure,
I would hope
as well as probably a decrease in power. So we're going to give up some engine performance to get some engine safety.
Yeah.
All right, let's give it a shot.
See.
All right, so this is GP1 1547 quarts. Okay. What do you think about that one?
My heart didn't stop on that one that time.
No, it was pretty obvious what was going on. Like the oil pressure was rock solid. In fact, it was even climbing a little bit. But the whole time I was looking at the oil, my other eye was staring at the power going, well, that really cost us a bunch, right?
Yeah.
So we try to do the same tune-up and keep your temperatures, real close to the same and all that. But man, there's no way to deny that. You put a bunch more oil in it, it's certainly better for the life of the engine.
Oh yeah, what's that, 61 pounds of oil pressure versus almost 40, 30 something?
Yeah, so they both start out right about 60 or 61 PSI.
Yep.
Now, the old run with only 5 quarts in it, at 5,100, they started to deviate. And with 5 quarts, it dropped all the way down to a low here of about 36.5 PSI.
Right.
By that same RPM, the 7 quarts was actually climbing, and we were up to 68 PSI.
Almost double the amount of oil pressure.
Pretty darn close.
Yeah.
Now, here's the real kicker. So again, doesn't really do much down low. The oil pressure really starts to drop when it gets up high. That kind of thing's going on. Check out the difference in power, though.
Yeah.
Again, didn't make a lot of difference down low because down low, the windage isn't nearly as much of a problem.
Right.
But man, after about 64, 6,500, by the time we got up here to the top, that thing over here was making 630 this pull versus 646 on the last pull.
16.
So 16 horsepower just to protect your engine. Like, it's probably not even worth it. If it's the final round, take some oil out of it.
Exactly. But wait, there was still a little bit of a dip right at the very end.
There was. You can actually see it here if I bring the oil pressure back over. Right about, 7,000-ish, it starts to lose, which is what you'd expect, right? It starts running out of oil out of that wet sub pan. So I think we ought to put more in and just
Two more.
So let's go to 9. Turn it up.
Why? Yeah.
It's going to be like Spinal Tap where it goes to 11, right?
If we got room for 11, we could.
All right, let's see what 9 does.
Cool. All right, so fixing our oil pressure problem, there's a price to pay?
Yeah, so I got good news for you. We put enough oil in that we do not drop oil pressure at all anymore.
That's so 9 quarts of oil,
no problem.
Oil pressure's rock solid.
Now the bad news. So when we put a little bit more oil in there, it hurt us a little bit. It really did.
Yeah.
When we put a lot more on there, holy cow, does it hurt the thing. So check this
Exponentially
out.
bad.
So we start out, all three of them, at very close to the same oil pressure. Before it at 5,100 with 5 quarts, it really dropped a ton. So we put 7 quarts in it.
Yep.
And that held all the way to 7,000 before it started dropping again.
Right.
So you put 2 more in it.
Yep.
And now it stays rock solid the whole entire way, all the way to, we went 76, 7,700, no problem, right?
Perfectly stable.
It costs a lot of power to do that. So
There
let's
is
check it
a
out.
Very, very high price to pay.
Well, so here's the thing. Normally, that's what you would do, right? You would keep adding oil until it wasn't losing oil pressure. That just seems like the logical thing to do. But let's see what we had to pay to get that. So when I look at the power over there, it's jaw-dropping. First of all, when we went from 5 to 7, it didn't really start to cost us until about 6,400 RPM.
Right.
With all the extra oil then, we started paying all the way down here at 4,800. But by the time we get to 7,500 RPM, there is 60 horsepower lost. 60 horsepower. We're talking about, you know, in foot-pounds, that's 455 foot-pounds with only 5 quarts, down to 412 when you put 9 quarts in it. So
without the parachute.
Wow, holy cow, 60 horsepower from 4 quarts of oil extra. Now the good news is, probably not going to hurt the engine.
No, your oil pressure's fine. You know, rock solid oil pressure, there's a price to pay for that.
You're just going to run it there a lot longer because it's going to take you that much longer to get all the way down the track. But
now, your results may vary in your engine, but for this engine, with what we just did, that's real.
So what's happening is that all that extra volume of oil is sitting down there in the oil pan, the crankshaft swimming through that and slapping it around. Now, don't forget, this engine has those big, giant Bill Miller aluminum rods, too.
Right. Yeah.
Way more surface area than maybe a small steel rod might have.
Right.
There may be a higher penalty we're paying for this engine specifically.
Yeah.
But no matter what, you're going to pay a penalty.
Price. Yeah, exactly.
So this makes me want to put a dry sump on this engine and really see what we could gain.
I
Seems
think
like
that's
there
a
ought to
good
be
idea.
60 plus horsepower from what we've just seen.
Math just says that right there, right?
I mean, there's
right
probably,
oil, right place, right time, right amount.
Boy, that right amount is tough, isn't it?
Yeah, buddy, it gets you every time.
Well, I think what we need to go is go back and you know, recheck all of our work. Let's take the oil back out and do this test again and make sure. But if something changes, we'll tell you guys. But I have a feeling we know what's going to happen.
Exactly.
All right, so Ben, the look on your face when you finished that last dyno run was priceless, but it just showed the real-time reaction of, you know, we talk about oil all the time, and it's one of the things you pour in the engine, you kind of put it in and you forget about it, and who really goes and checks their oil level that closely? Let's be honest, right?
Well, no, to be honest with you, that's what we were talking about, and I was like, I mean, it's probably going to lose a little bit of power, but I was somewhat shocked. I mean, I truly was surprised that it was going to cost that much. In fact, I made the joke. I said, well, I think I'd rather just have less oil pressure.
Pretty sure you'd like to have less oil pressure compared to the price you paid. I mean, those last 2 quarts, the tax on that was massive.
Yeah.
You know?
I mean, it's one thing to have not enough in the pan where it's not picking it up and it's getting stuck in the top of the engine, so your trip pressure is dropping. But it's another thing for that crankshaft to have to swim through that just ocean of oil that I can't imagine what it must look like inside the oil pan.
Oh, it had to be ugly. Now, as we said during the video, full disclaimer, this engine's a little bit different and unique because of the aluminum rods and all that.
So they're a little bigger. Yep.
Your results may vary. It may not be as bad. But I will say, I've had experience in the past where, you know, an engine builder called me up and said, hey, you know, we tried to do it. We did an oil test, right? I'm going to put my driven shirt on back for a minute. I actually asked Scooter for his, but
he did, yeah.
I didn't want to leave him naked out there, so I just pretend that I'm wearing my driven shirt again right now for a little bit. People would call me up and say, you know, we changed oil, and man, we just lost a ton of power.
Yep.
I mean, one time it was like 30, 40 horsepower, and they realized that it was a wet sump engine, and they never drained the oil out. They just had 5 quarts in, they added 5 more, and that's why they were down 30, 40 horsepower because of the same situation.
Or the other thing that can happen is you drain the oil out, but you don't wait long enough. And it's amazing how much residual oil can be up in the cylinder heads and in the valley. And so you go, well, it quit coming out of the pan. I'll just plug it back up. And, you know, next thing you know, you've got maybe 6 or 6.5 instead of the 5 that you thought you had. I mean, that's stuff that happens pretty regularly.
Oh, absolutely. The other day, after we did the dyno test on my dad's engine at Dennis's, we were down the street is the go-kart track. So we went down there, we went out go-karting a little bit, and we have a 4-cycle engine, it's a 250cc, 10,000 RPM, double overhead cam, 4-cycle. It's awesome, by the way. And I need to do an oil change on it, take an oil sample, and same thing. You drain it out, you put in 16 quarts, 16 ounces. 16 ounces didn't come out. To refill it back was only 12.
Wow.
So it held that much within the system. And that's a tiny little engine. So like you said, it's really easy if you think that
right?
if I put this much in, well, I got to put that much in again. Well, back to your experience, Charles, with the Porsches.
Yeah, we struggle with, because people tend to, if they see, oh, my oil level on the online dash gauge went down 1 bar. Oh, I need to put oil. Well, they need to let the car sit overnight, let all the oil go down to the sump, then get an actual reading. And they don't realize that oil also expands when it gets hot. So they go tip-top full when it gets, and then they go to hot, or they go to the track, even worse. And the oil level's overfilled, and you run into the same situation you have there. But it's even worse on some of the Porsche models, because the crankcase is under vacuum with an air oil separator.
Bingo.
And it overloads the air oil separator, then dumps the oil back into the intake, then hydraulics the engine.
Or at worst, no mosquitoes, right? Like,
yeah.
Oh, it'd be really bad. Yes,
Yeah,
it can
yeah.
be a bug truck with if the air oil separator breaks. That's one of the great things about those engines, actually, is the fact that you're using that crankcase, or say the manifold vacuum, to create crankcase vacuum. So the engine actually runs in vacuum. You can check it. You can see what's going on. It's really great. You can check ring seal health, all that kind of stuff, by putting a manometer on it and checking it. So those are some nice things about it. So we know that oil level, obviously, is very, very important. And I think one of the other things that we found last year on the Expo engine is viscosity also matters a lot.
So I was thinking about exactly that a few minutes ago. We were running the dyno, and I don't remember which oil we were taking out or which we were putting in, but I remember both of us were like, oh, this is going to be great. Or, this oil's got some friction modifiers, and we were like, this is going to be, and we do the run, and we just sat there and looked at each other like, hey, so what's wrong with the dyno? Why
did we miss?
why did it make less power?
Broke, stupid thing.
Yeah, dang dyno. We had that conversation yesterday going, everybody blames the dyno, but it was like, why did this thing just make less power? And we started to realize, like, darn it, we weren't thinking about engine temperature. We weren't thinking about, the difference in viscosity. And so all of a sudden, we have this thick molasses oil running around in there. And do you remember what the differences were?
Yeah, so we went from BR30, because this is my go-to oil to break in everything, because it's, going back to, Mark sitting here earlier and stuff, the Gibbs guys developed this oil. This is what we developed at Gibbs. And we developed it in conjunction with this oil seal ring. So it has the right additives and has what doesn't need to be in there, right? You don't need friction modifiers and other things in there. So it's the right additive package for getting rings to break in, not just flat tappet lifters. So it's got the zinc, it's got this kind of stuff. So when we were breaking in the engine, we're like, hey, we got one engine, we got one shot of this. Got to make it right. Parts are hard to come by. Make sure it breaks in right. So we had the BR30 in there. We had run it in, of course, with no friction modifiers in there. When you go to the race oil, it should make more power.
Should be better.
Right, so we're like, oh, here. So we went for that, we put in 1540 race oil, and we're like, oh, yeah, we're going to probably see some net gain, because that was our conversation. We're going up in viscosity slightly, but we're adding friction modifiers. So is there going to be a net gain where we lost a ton? It was like 15 or something. It was crazy, like shocking number. But then it kind of clicked into us. Viscosity index is what we were not thinking about.
So we went from a straight 30 to a variable 15 to 40, right? I think is what it was.
Yeah, 15, 40, yep.
And so the question was, okay, well, which side of that are you basically on? Well, then we realized, remember the fuel problem we had because the engine was cold?
Yep.
It was doing the same thing where when the engine's cold, then there's no reason for your oil to thin out or anything. And so we have all this 40 weight oil in there. Basically.
Right. So what we're really talking about is, all oils get thinner as they get hotter, right? So if we're starting off, say here, we'll call this 100 degrees Fahrenheit. And then over here, you're at 212 degrees Fahrenheit. Let's say this is the 15W40 right here, right? And then we'll have our 5W30 break-in oil right here. So up here, there's going to be a bigger difference than there is over here, temperature-wise. So over here, that oil's, we'll call it 15 centistokes. So centistokes is the actual flow measurement. Take the oil, you put it in a container, you heat it up, and you flow it from point A to point B.
Okay.
So you're trying to see what that actual flow rate is. Well, so this was 15. The 5W30 is actually 10. So it's, you know, considerably less percentage-wise, but what got us was over here,
Where the engine's cold.
where the engine's cold, where we were running it at, because we were doing more of a drag race type application thing.
So sometimes on the dyno you do that, right? You go, I'm going to start the engine when it's cold. I'm going to let the cylinder heads come up, but the block temperature was still probably, I don't know, 110 degrees or something.
Well, we actually ended up putting for this year, right? We ended up putting the temperature sender in there
You're right.
to measure
Yep.
the temperature to
Yep,
see.
the
So
oil temp.
at the way we were running it last year, what was the oil temperature?
So there's a pretty good lesson to be learned there too. We were making a lot of assumptions about if the engine temperature is this, the oil temperature is probably that, but we weren't actually measuring it.
No, we weren't
And so
measuring it. We were guessing.
Because of this test that we failed at,
Mhm.
we went back and said we got to add an oil temperature sensor to this thing. So
Yep, we need to know.
Yep.
Because over here, this one was literally around 30 centistokes, and that one was 70 centistokes.
more than twice as much.
Yeah, and no friction modifiers are going to overcome that.
right. No amount of money can fix that. There's no magic potion or nanoparticles that can make that better. And we just paid a huge price for that. But it goes back to, it's like one of those moments where you know better and you just kick yourself for being stupid. It's like, oh, all oils get thinner as they get hotter. Inversely, they get thicker as they get colder. If I'm not measuring oil temperature, you have no clue, because your water temperature and your oil temperature are two different things. Now, they can end up running closely together.
If you run it long enough, you can get them the same. Yeah.
Yeah. Or what? Well, I'll say this: based on all of this experience, from the Expo engine, all the stuff we've done out there at Shaver's Place in the past, everything, that when you start the engine up, the water temperature is going to rise faster than the oil temperature. But then at some point, oil temperature catches up and then begins to exceed it.
Yep.
So
at the end, your oil temperature ends up being hotter than your water temperature because it can't get rid of that heat that fast.
they have different specific heats, right? So water is able to absorb and dismiss heat better than oil can. So it takes longer for the oil to heat up, but it can't reject that heat as easily. That's right. So it stays hotter. So the difference in specific heat between the water and the oil is what causes that paradigm, or that shifting nature in that relationship, which is why it's so important to measure it so you can know it. Then you can choose appropriately.
We can test with consistency. You know?
If you know what temperature you're going to be running at when it matters,
Precisely.
then you set your viscosity knowing what you're going to run.
Not for what I'm going to start the engine at, what I'm going to finish the engine at, really. So there's another component here, Lake, that, Charles, your engines, they tend to have pretty small counterweights, right? So compared to like this big giant thing we're working on, so you could make the argument that, well, maybe I wouldn't see as much loss in that engine, but guarantee there's going to be something lost. What we didn't point out, though, in the video was that the loss that you get was basically this exponential increase.
Yes.
So what we saw at, say, 6,500 was bad, or 7,000 was bad. By the time we took that thing, I think, what did we go, 91 or 9,300?
Yeah.
It was like over 100 horsepower.
It was
loss.
over 100, yeah.
So that 57 or whatever it was there at 7,000 was almost 100 or more at only 9,000. So that loss curve, was kind of going up like crazy as the RPM went across. And
Exactly.
so no matter how much you start out losing, whether, like you said, we had these big giant aluminum connecting rods, or I have pretty smallish steel rods and small counterweights, the fact is you're going to lose something, and you lose more as the RPM goes up. So it hurts you even worse if you've got a high RPM engine.
Well, I think back to the dry sump or the deep sump pumps or sumps that you have for the track stuff. It makes a lot of sense to, one, get more volume of oil, because that will help that rise in temperature. Because the larger the volume of oil you have, reservoir-wise, the longer it's going to take to get hotter. So it will tend to run cooler.
Longer. It's a
longer.
big heat sink. It just takes longer to get hot, but that also allows you to run the oil level lower without sacrificing total system volume.
Yeah, so you're playing the balance between how much windage I have and how much volume of oil is moving through the engine. That's
part
of the game.
You know what? What comes to my mind? There's these 4
Let's see if I can remember them.
Yeah.
All right, quiz. All right, you guys.
Let's see. You probably need the right oil.
Yep.
You're gonna have to help me.
The right time.
All right, so we got the right oil,
Okay.
and we got it at the right
Place. Gotta have it in the right place.
the right time, as he said. And then you need to have it in the right amount.
So what did you used to say? The very best oil in the world doesn't help your engine parts if it's sitting in the bottom of the pan rather than up in the cylinders or rocker arms or whatever. So, right place, right time, getting there when I need it, right? Starting that engine's pretty tough on things. So, and then got to have the right amount.
And then that's the argument of the day. What is the right
amount?
the right
amount?
The amount, the right oil, the right amount. Yeah. And there's not enough time for us to discuss that today.
No.
Well, I think the takeaway though is it becomes very application specific. So your engines, you got customers that go, well, it's just a road car, but then every once in a while I want to take it to the racetrack, and so you're like, okay, well, geez, you should use a different oil at the racetrack than you use on the street. He goes, I know, but I don't race that often. And then you have other guys that are like pure racers or pure street guys. How do you deal with some of that?
Well, you just have to educate them, and whether they listen to you or not, that's a different story. But people don't realize a street oil is not formulated for the track, and a track oil has less detergents in it, higher anti-wear additives, more friction modifiers, and then probably the most important, at least for our stuff, is the anti-foaming agents.
Yeah.
Because aerated oil doesn't lubricate.
No, not at all.
Yeah.
Really bad.
Yeah.
Well, in fact, I actually wrote an article for Hot Rod Magazine. So if you want to go online, you want to get the real deep dive, because again, we could talk about this for 20
sound like Randy now.
more. Yeah.
Deep dive.
Deep dive. Yep. I picked up on the lingo, right? All the key buzzwords. Deep dive. So Hot Rod Magazine, you can search for diesel oil ZDDP or diesel oil zinc. And because a lot of guys will go to the parts store and buy diesel oil because they know it's a little bit higher viscosity.
It's good for protection.
And it's got more zinc in it, so they're going to use it. Well, the problem is they have the lowest level of anti-foam additives. They're not designed for higher RPM applications. So that was one reason when I was still at Driven, we developed the DI line of oils, not just for direct injection, but also it brings in the same chemistry that's in the race oil. It's all the same components that are in the XP oils, including the anti-foam package, so that it is designed to be more of that hybrid. It's not purely a street car oil, but it's not purely a race oil. It kind of combines the best of both worlds. So I know from Speed Diagnostics side, when we see the used oil analysis from the guys who track their cars, the GT3 RS guys who are killing their cars, we see literally single-digit wear metals, which is the gold standard, by the way. If on your oil analysis report you're seeing single-digit wear metals, you're doing really good.
Doing it right.
Yeah. And you really don't know what your oil's doing unless you test your oil.
That's 100%.
And that's the other thing. It's like, well, I use XYZ brand and I've never had a failure. Well, that's great. Well, what amount of wear do you have inside your engine?
Yeah, right.
Just the fact that it hasn't failed isn't a testament to the quality of the
and
oil.
ironically, they're just talking about some catastrophic failure. You're like, well, that's great, but what if you've been giving up power because you didn't have good ring seal? What if there was more friction? What if your oil level was wrong? Like, just saying it didn't blow up on me, that's not a great performance metric.
That just means you didn't fail.
Yeah, exactly.
It's like saying, I didn't fail, therefore I got an A in school. No.
Correct. Yes, yes.
No, you could be the C student or D student and just didn't know it.
That's right.
I think that's where, where it really reminds me of, Charles, is if you're not doing testing, if you're not measuring your oil, it's no different than when we failed to measure the oil temperature. Right? You're leaving a lot on the table. Right?
You're
Did the
making
engine
assumptions.
run? The engine ran fine.
Yeah.
It didn't blow up. We didn't have a failure.
Yep.
It just didn't run what it was capable of running.
You could go one step back and say, what would have happened if we hadn't been measuring it on a dyno? We would have been like, this has got to be better. So I'm putting this oil in, going to the track every weekend, assuming I'm doing the best thing for my program, and I would never know because I hadn't measured it. We made the fundamentally flawed assumption that because this oil has more friction modifier, surely it's going to make more power. And we ended up losing power because we weren't measuring those variables. And I think about that a lot, going, what if we'd never measured it? What if we just assumed it was better and we'd been racing all this time? Well, that's what you just described, right? You have all these guys who are going, well, I'm using XYZ brand, and it hasn't ever blown up on me. I'm like, well, that's good.
Yeah.
But it's not going to win you a lot of races.
Well, it's really easy. I think back to last year in the engine, I chose the wrong fuel and I chose the wrong oil.
Well, you're fired.
I'm leaving.
You're fired, yeah. But did we learn from that? Right?
We did. We totally learned from it because you mentioned something earlier. It's the application.
Yeah.
Right? Application always dictates chemistry. And that's where we missed. When I chose the fuel, when I chose the oil, I was thinking about 160 degree water temperature,
Different
280 degree oil temperature. I wasn't thinking about 100 degree water temperature, 100 degree oil temperature. I was thinking NASCAR racing. I wasn't thinking pro stock. And that's where I made the failure, was not understanding my application before I made my chemistry choice.
That's not that much different, though, than us saying, well, we're going to get hyper-focused on this one performance variable. And for us, that was oil pressure. So to get more oil pressure, I'm going to put more oil in the engine until I finally go, yay, I got all the oil pressure that I wanted, but now I don't have any horsepower. So, like, you're going to have to figure out, based on the application, well, what matters the most? Would 30 PSI of oil pressure have done the job, or does it have to have 50, or we were trying to get whatever 60 or 70 or something? You know, did we really need that?
Yeah, what's the question? Like, that's another discussion. I think GM did a study back eons ago, and it was something like 6.5 PSI per 1,000 RPM was the number. I was always told it was 10 PSI.
Yeah, right. 10 per 1,000.
10 per 1,000. And I started digging SAE. Like you said, another discussion earlier was like, well, knowledge is out there. Is it accessible? That knowledge is there. So you just have to sit down and look for it and read it.
That rule of thumb wouldn't work very good on Spinal Tap, by the way. And I'd have 110 or 112 pounds of oil pressure. So there's some variable to that rule of thumb, but that's why it's a rule of thumb, too. Yeah. But you're right. Once you start looking at, like, well, what's the right number? Well, it depends on the application. A drag race engine can get away with things that you would never get away with on your road racing thing.
One of the great things you said about the accessibility of that knowledge, again, I'm going to tell on myself, right? I really screwed up because I actually wrote the chart that's in the driven catalog that is oil viscosity based on temperature and bearing clearance. Oops. Yeah. But listen, we're all human.
That's being a dad, right? Do what I say, not what I do. Right?
Right, yeah. You know, so that's the great thing. I think it's page 36 in the driven catalog, if I remember right. It lists, hey, if you got an aluminum block, or an iron block, an aluminum rod, or a steel rod, this is your bearing clearance, this is your oil temperature, this is the viscosity you're supposed to run. That's why it's so important to be able to measure all of these things, because when you measure, you have data. When you have data, you can actually make correct decisions, not
what'll happen is if you get the data and you're measuring it, it's going to tell you. We always go back to the same thing. It's going to tell you what the answer is to the 4 R's. What is the right oil? What is the right time? What's the right amount of oil? We know the right place on all the good parts. But my point is, like, when you're trying to make that decision, nothing's going to give you more answers than measuring it and getting the data.
Yeah. At some point, you have to trust the data. And pretty soon you're going to hear us say that again. So we'll keep on moving. There's another video headed your way right now. Okay, Engine Performance Expo viewers, you know this guy.
I know Don McCaskill.
That's right. We're back at Shavers. This time, this old test mule of ours has told us a whole bunch, hasn't it, Don?
We have pretty much worn ourselves out trying to learn from this motor and trying to hurt it, and we just can't do it. It just keeps going and going and going. It's like the ever-ready machine. It just won't stop.
Exactly.
And every time we do something, we're learning something new. Every single time.
Right. One of the recent things we learned this past year was the line-to-line skirt coating. I've heard about this stuff for a long time, but we actually got to use it for the first time
on this particular engine.
Right.
And one of the reasons that we had to do this is because we went up and saw our good buddy Brad Legman up at QMP, and he gave us a perfect cylinder bore finish for our test.
Right.
And because of that, we had a fairly new piston that was in there it's been in there for not that long.
Yeah.
Because he had to make the bore a little bigger, we had to do something to put a coating on the piston to compensate for the piston to wall clearance. Now, in the past, when we have tried to do this, it hasn't been very successful. But these guys at Line to Line,
This was pretty good stuff. Like Don was saying, when you open that bore size up, because we needed to get the surface finish right, we had missed a little bit on that, and we said we got the good surface finish, but now our bore size is kind of in between.
Right,
You didn't want to go order new pistons because the pistons are pretty new still. Yeah. What was cool is they were able to, coat those skirts and add thickness to it to be able to compensate for that additional piston to wall clearance that would have been there. So now we have the right piston to wall clearance, and what's unique about it is it's abradable. So it's designed to wear off, but slightly. So it doesn't flake off in chunks.
Right.
It just kind of wears in and self-fits.
Right.
And it was pretty cool to be able to see, what we saw blow-by-wise by having that correct piston to wall clearance, having the piston
correct finish on the wall.
Yep, all that together. It's the ring seal super I was talking about, right?
Made the ring seal wonderful. Yes.
Yeah, that
and,
was
and
all.
we proved that with the blow-by meter.
Exactly. Yeah, hooking this thing up, even though it's a dry sump, a wet sump engine, not a dry sump, wet sump engine. But by hooking up the blow-by meter to it, we can actually see it. And that ball was so low and so stable.
Well, we thought
it
wasn't really hooked up right at first because we haven't seen measurements that low in a while. Now, through this ring evolution, we have gotten better and better. The total seal ring is something we've been using for 40 some years, or however long they've been in business, and we've always had really good luck with that. So, we know that as far as blow-by goes, it's been very beneficial to especially our race motors, but as you guys have progressed in the last couple of years, you've made it even better and better. And so when we were looking at this last test with the blow-by meter, we're like, is it hooked up?
Right. Yeah. When it's bad, it's like 10 to pegging it, and this thing's hovering down there at 2. Yeah. And we're like, wow, that's pretty impressive.
Yeah, so it was nice.
The line-to-line thing was really great. It's a great tool to have in your arsenal, being able to adjust piston to wall clearance without having to buy new pistons.
Yes.
You can reuse pistons. You can adjust your surface finish. You can do all those things to make that good ring seal soup.
And it lasts for a while.
Right. Really durable.
Really happy with those guys at Line to Line. They did a great job.
Yeah, so there's a little tech tip for you guys who are watching the Engine Performance Expo. Thanks for watching.
Welcome back to the Engine Performance Expo.
Wow, you actually can stumble.
Too.
I didn't know it was possible.
It does happen, but I hate it when it does.
That'd be like George losing a race.
Yes, exactly. We were just George.
We were the throttle at the starting line.
You know what? I want to let everybody behind the scenes. George and I were just having a conversation about exactly this.
I am so sorry.
You jinxed him.
Because he told me I hate it when I stumble, and you stumbled right then.
I had never even thought of stumbling.
Oh,
he got in your head, John.
I didn't do it. I didn't do it. He said it.
It's like a red light.
Let's move beyond it, guys. We're just going to move past it. Now, this is an interesting roundtable because we talk about all of these, jobs and product spotlights and everything that we're all into. This passion, Chuck, obviously with the AERA, but none of it works without the most important aspect, which is the people that are doing it, and the next generation of young people. We got a couple of them in the shop here. You can be passionate about it, but where do you go with your career? Where do you go to advance? You need to make a living. You need to earn money. You need to eventually, if you have a family, like all of these things. Sometimes, chasing your passion, you might think it's irresponsible because am I going to be able to pay for life, take care of my parents? Who knows what it is? But there are many different journeys to go on, paths to choose. Scooter, you were just telling me yesterday, you love building the team. You love building the team. And so we're going to spend some time on that here on the roundtable. For folks out there, if you've got a young person or is looking to get involved in the economy, whether it be racing or otherwise, you're going to want to pay attention to this one. So let's start with Scooter a little bit. When you're building those teams, what do you look for? And when you put people that are, young in the industry on the journey, like, explain that a little bit more.
When I look for people to join my team, I look for the head, the hands, and the heart. The head is certainly what they know. They have to know a certain amount. The hands is what they can do. The heart's where you have to concentrate. If a young person out there thinks they want to be in our industry or whatever, it could be a cook or it doesn't make any difference what they decide they want to do. But they have to have the passion for it. They have to have the heart for it. And if you have the heart, then you give up everything else in your life to go for that heart and spend that period of time learning and doing and being good at it and devoting yourself to that passion that you have. And if the young person can indicate to a team that they want to be on, that they have that passion and that heart, the team will take them in and the team will teach them and let them learn. But they have to have the heart and the passion and the drive, and that only comes from within them.
Tough to teach that, though.
Can't teach it. They have to just have it.
The want to.
They have to have the want to.
Yesterday we talked about what made us different, being racers and winners, and the determination and where did it come from. And that's really a tough question because I never remember anything other than that. And our team, just like Scooter said, over the 40-something years of Star Racing, we had probably 100 different people have come through there to work and learn how to work with us and how to do the work we do. And when they would leave me and go to a competitor or go start their own place, I used to really get my feelings hurt. It would give me an attitude about, I got to quit sharing everything. I got to quit telling everything. But what I realized that Jackie and I at Star Racing, we became a stepping stone for our industry, because a really great racer would come spend time with us and then move on to a team that gave them a different opportunity. A mechanic or a crew chief or a welder or a machinist would come through and learn how to win and how to build really big horsepower and do things that you couldn't do other places, and then they would move on. So I felt like we were like just a pro stock university. That's how I felt for a long time when that many people came through there. And now at my retirement age, I do Tech Talk Tuesday every Tuesday at 6 o'clock Eastern, and my goal is to continue that same path that I was doing when I was in my store trying to make a living, trying to pay my bills, and I'm still trying to share those things to people that have the passion and they're interested and they want to tune in and they want to try and grab it. And that is the only reason I'm here right now, is so that we can get this group together that's into trying to educate our youth and our future, and create an opportunity for others to work in this industry.
That's why I wanted you to be here.
Thank you.
Is because Tech Talk Tuesday is wonderful. I mean, I watch them all the time and learn things, and that's part of the idea of this roundtable, is that there are so many places and opportunities now to gain knowledge. I mean, Chuck, at AERA, you guys offer all kinds of, the webinars you guys have, the magazine. I mean, speak to a minute about the different resources for education that are available through AERA. We keep on saying young people, and that's great, but there are also people that maybe they're a little bit older that decided they want to do a career change, and they like going fast. They like horsepower.
Great point.
You're never too learned to begin to learn something different, or never too old to learn something different to make a change.
Right.
You know, so I think.
Yeah, absolutely. The engine machinist certification program that we currently offer, we're actually bolstering that up some more. We have about 75 schools that are involved in the administration of it. We have from high school levels to people that want more credentials for their shop. Some of the production engine rebuilders, that's their growing methodology. Okay, you asked for more money, but we ask that you show that you're making yourself more valuable too.
Right.
So if you can seek more credentials, then it makes you more valuable.
Yeah.
But to go back to what Scooter was saying about the heart, Cass was talking about in the past couple of days, he mentioned the scripture. He's like, are you on the work or in the work? If your heart's in it, you're going to, proceed much further. And trying to portray ourselves or exude something of our industry that is exhilarating, even if it's the heavy duty stuff. This is high performance, but there's performances in different areas, like the big giant heavy duty diesel stuff. Mitchell was talking about, he ran across the video and there's this, he goes, it had like 1 million views of this big diesel engine chugging and smoking and puking, but it ultimately starts up, and they're like, that sends you down a rabbit hole. Why did it smoke? Why was that white smoke there? Well, and you think about the diesel, and okay, the compression of the air is what makes the air temperature 400 degrees, but the thing's freezing cold, so it's sucking that energy out of it. So I got to compress more, and it gets it back up. And finally, the diesel fuel that's petroleum jelly at the moment turns into something that'll flow. And finally, there's enough heat in the cylinder, boom, and it lights up. you know, and like, wow, I think I might want to be there someday in that world. That's pretty neat stuff, you know. So I think it takes all of this, you know, in the bits of education. So, you know, Tech Talk Tuesday, I love it. The EFI group, I mean, you know, we fire messages afterwards, you know, it's just a flurry.
And during, right?
Well, that's another great resource, right? From what you have at AERA, what you do with Tech Talk Tuesday, to what you're doing with EFI University, from the hands-on classes to the Dr. Lambda group as well.
Yeah, sure. I mean, I always looked at it as though, I really like what you said about being sort of a breeding ground, right?
Mm-hmm.
Like you had this ability of people to come and learn stuff, whether they knew they were doing it or not. They probably started with you thinking, this is the greatest thing in the world, I get to work on this, but somewhere along the way, some other opportunity came along. When I first started this, and I'm kind of proud to say that EFI University is going to be 20 years old this year.
God,
that's 20, yeah, thank you. 20 years of just teaching people exactly about engines and fuel injection. When I first started, there was a whole bunch of racers that didn't like to share information, that kind of warned me and said, you know, you're gonna teach yourself right out of business. And I said, no, I'm never gonna have that. As long as we have another group of 16-year-old kids that get their license and find out how fun it is to do a burnout, they're gonna want to do more, right? So, Scooter, when you talk about the heads, the hand, and the heart, it's hard to teach. I don't have any curriculum you can sign up for how to make me passionate, right? Like you show up with that part. We can help you on the head part. Hopefully mom and dad have helped you with the hands part. You're willing to get in and do the work. But I was never afraid that if I shared too much, they were going to run away with it and put me out of business or anything like that. I always felt like there's enough market that I'm always going to have somebody that's curious, and I'm the first customer of EFI University. I built the school that I wanted to go to. My job, I'd say this all the time, is that unless there's an actual class happening at the moment, my job at EFI University is to make sure that I'm learning. So we have an entire research and development facility. We do contract testing for other people. You know, some of that so we can have revenue, but largely I gotta teach the things that I most want to learn about.
Stay in front.
So that we can stay up in front and give somebody a reason to come to our class, you know. And so whether that's an adult looking to change careers, whether that's a kid just out of high school, our programs are kind of unique in that we're not the traditional, 18-month or, semester-based kind of training. We're very, what I like to call a la carte. So you can pick a subject you're really interested in and come and go, boom, for 3 days, 5 days, whatever, drink out of the fire hose and really stay focused, and then go home and put it right into work, right? But after all these years, what has it been, about a year and a half now? It's not 2 years yet, about a year and a half, I guess, or something like that, I don't know. I had this idea, somewhat from COVID, that the only complaint that I ever get about my school is people go, well, I wish I didn't have to go home. It stinks that I came here and I realized how much there is to do and learn. I can't absorb it all in just these few short days, but man, I wish there was a better way and I didn't have to go home. And so we started our fraternity, and George is there and Chuck, you're in there, and man, I was really proud of it. We were sitting at a table and I started looking around the table, and I'm like, of the 9 or 10 people around this table, 8 of them are Delta Lambda fraternity members. And so really all that fraternity is a way for us to stay connected to each other and a way for people to still get education but not have to leave wherever they live in New York, Kentucky, Florida, whatever, and go all the way to Arizona. And nobody ever really complains to me about how much our classes cost. Maybe only in the beginning when they swipe the card, but by the time they're done, they usually go, yeah, exactly, till the wife finds out. But by the time they're done with the course, they go, gosh, I would have paid twice as much if I would have known how good it was going to be. Yeah. But normally I just can't get away. And so when you have adults that, Joe, you said they have car payments and rent or mortgages. Man,
volleyball games on Saturday.
Volleyball games on Saturdays, exactly. Yeah. It's hard for them to get away. Jason's a perfect example.
Yeah.
Jason Lyon and I were talking last week, and he was saying, man, I want to come to your class. And I said, I'll quit it. And he goes, no, really? I'm sure that no matter what, if I sat there, there's something I'm going to get out of it. And he goes, what's way more difficult for me than coming up with the dollars to pay for it is, man, where do I find a week to just get away and stop working? And so that challenge, the way that we kind of tried to approach that was with our fraternity, where George does Tech Talk Tuesdays, and then he hangs that up and he comes over on Wednesday nights, and we do an online basically discussion group, and we have videos that we do every week. And so it's been an amazing resource, to be honest. It has far exceeded my expectations for what we would get out of the group. I said in the beginning that I wanted to learn as much from the members of the group as they learned from me, and that's overwhelmingly
it's
been
great
successful.
how much we do get to learn, even if we're kind of part of it, of the structure of it. Just getting so much feedback from the rest of the members
we get to learn a lot. And I was also pretty proud to see how many people you have here that are involved in that. And also I noticed that talking about this pathway, as the friends that I have at this table right here, made me smile a minute ago. I was sitting here thinking about how much of an impact everybody's had on my career along the way. And man, that's such an advantage to have. And I want to tell you thank you.
Let's talk about, we got a couple minutes left, but just like some, what I would call concrete steps to achieve, right? Like we keep saying young people, but you're right. Like a veteran who's been in for 10 years and they come out and now they're a go-getter, and they come out into the world. You see a help wanted sign everywhere. Why aren't those jobs being filled? Well, because people only want to invest their life, which is so meaningful now, in something that they really want to do, care about, and I think everybody here has got that. So this is clearly, if you're into cars, if you're into engines, if you want to do a burnout, all of those things, if you appreciate that, this is a worthy area, an area that needs it. But what are some like concrete steps that someone that is interested can do that can help them advance in any one of these fields? Example, like write down what you're capable of, create a resume. If you follow where I'm going on that, for people who are watching this, maybe clip it and forward it to someone like, hey man, follow these steps and go to your local machine shop and say, hey, I'm willing to push a broom for 6 months to learn some stuff. You got any insight, Chuck?
Yeah, I mean, you can shoot me an email at chuck@aera.org.
Yeah, Chuck's just like, I'll hire you, send me an email. Right?
We have the Engine Rebuilders Educational Foundation, and so we're trying to work with shops, schools, and what to help stimulate that educational path. So if you think that you want to enter this space, there's definitely support. Since I've been here, we've had some ideas about even trying to bolster that further. We're looking at even a deeper push into the schools. So, I mean, there's those avenues. Again, if you have the interest, of course, we're trying to get into the high school level now.
Yeah.
And like there's things like Project Lead the Way that's in my area that we've interjected into, and it's so there's those things. I think that's what scares people off a lot is there something to help get me going? And I think we definitely have that with certification, with the foundation to help support the cost of. So, I mean, we can get you headed down the right path almost at no cost to you.
I would say probably the most important thing, I think all the way back to however many years ago, and there was a guy named Dave Arce, who you guys all know. He was the guy that actually gave me my first shot, and it wasn't because of my resume. And so when you think about like, oh, what's it take to get in? It wasn't because I knew all this stuff. What's way more important than your resume is your readiness. You've got to go over there and knock on that door and say, hey, I'll do the work, right? And then what happens is if you start out with the readiness and you get that foot in the door, you'll get the resume. But you know what's way more important as the resume is the relationships. So those 3 R's, right? The readiness, the resume, and then finally the relationships. You talk about all the people in this building that came here this week are all because of relationships. We've agreed to come together. We may have raced each other at some point and been bitter rivals or whatever, but everybody here is here because out of a lack of selfishness, right? Every single person that I've seen in the building this week is saying, I'm willing to give because somebody else that I have a relationship with asked me, are you willing to help build this industry, grow this industry, attract people to it? So, it's way less about the resume than it is just the readiness to roll up your sleeves and get to work.
George?
That's good. I agree. My first try, I know we got to wrap up, but I was going to say going to that machine shop is what I did. And I aggravated them. They didn't run me off. I kept making me work harder. I learned really fast, and I was very fortunate to get my foot in the door that way. So I was the readiness guy.
And I was going to say the same thing is to this person that wants to get involved is be visible. If you want to work on a race team, go hang with race teams. Go be at a machine shop. Go be visible around whatever you want to do, and it'll work its way out. You'll find your way in there.
And the first couple of weeks, they're going to be trying to figure you out.
Heck
yeah. Don't take it personal.
It's the interview.
They're going to try to figure you out. They're not just going to hand over, $50,000 worth of equipment and let you touch it.
Right.
You got to prove yourself.
Unless it's Hartford and he lets you, like work on his race car.
I had to prove myself a little bit just to get to that point.
That guy asked me one day, that same guy, he said, "Can you drive a stick?" And I said, "Yes," and he handed me a broom.
Gentlemen, thank you very much. Excellent round table. And email Chuck, right? For those of you that are out there. And before we go to the next video, Lake, because we're getting down to the wire with our build engine,
Yes.
both of them, I want to shout out to the sponsors.
Sure.
The people who make it possible. Like, this wouldn't happen without all these people behind the scenes. Thinking about Holly, EFI, and Morel Lifters. We got a great display out there. Straub, of course, who does not own the building, by the way. Chris is a tenant here. The AM group owned the building. I was giving him credit. And he is doing a great job. He is a great host. Valvoline, of course, CWT, Randy Neal, amazing job. Total Seal, Piston Rings. Hartford's got a lot of name checks out there. Rottler, they've got their whole team here.
Yes, they do.
They're running the whole show here. I got to check out like all the hits they get, all the sales leads they get. We zoomed in on South Florida, some of the machine shops in South Florida. It was really interesting. Thanks to the folks at Rottler. Get 'em Performance, we just learned a little bit about those guys. Amazing stuff. Edelbrock, Comp Cams, Silver Seal, Goodson, of course. What would a machine shop be without those guys? Of course.
Right.
Mala and Driven Oil.
Right there.
Yes, we got two people, a developer and obviously a captain of industry. Thank you for your support of the Engine Performance Expo. Lake, throw to the next video because you're heavily involved and we're getting down to the meat.
This is Valve Train, so
Can't wait. This is
we've
gonna
been
be
we've been trying to make a little more power of the engine, trying to get that RPM turned up. So tune in, watch this thing, and see how high it can go. Okay, so the last time we saw this thing on the dyno, we knew that it would only go to about 8,100 RPM, and we thought we were hitting the rev limiter, but it actually wasn't the rev limiter.
It was valve float.
Yeah.
Now, we suspected that on the dyno. We took it apart, we took the cylinder heads and everything, and we put it over on the Spintron.
Right.
And sure enough, that's what we saw. We were floating the
arches
valves
at 8,100.
So now what we thought was, I'll bet you the rocker system isn't stiff enough. And so we went to Comp Cams and we got one of their new BSR shaft mount rocker systems. Now, let's talk about pros and cons. What I like about the system is that it fits right on the cylinder head, no modifications. It all fits like stock, LS type locations. I love that it joins all the rockers together. It adds a bunch of rigidity and stiffness in the system. Now, if you're not that concerned about pushrod length, let's say you got a hydraulic lifter, slam dunk.
Yeah.
We, of course, had a solid lifter.
Right.
And so that meant we also needed a pushrod change because with a stock rocker arm, there's no way to adjust the valve lash.
Right.
So we went back to Comp and we got a set of their
XDA
3-piece push rods, which are phenomenal. Really, really cool to be able to tune the lash really painfully at first.
That is the downside.
That is the downside. You have to take the whole rocker system off if one of your lashes are wrong. But now once we got it set, it was set it and forget it. We never had to deal with it again. That was awesome.
Yeah.
Now, what we suspected was the old system wasn't stiff enough. So we set about, as we did in the other videos, the total system stiffness testing.
Right, you can check the difference in total valve lift between the checking springs and the real springs to see how much deflection there is.
That's right. So I kind of expected that it was going to be a landslide, but in reality what we found is there wasn't actually that much difference in the actual total stiffness of the system.
Right.
Now, when we talk about the
vertically, statically, essentially.
That's right, statically, and just the vertical lift, the amount of loss wasn't that much different statically. However, the things that do make a difference are not just the total amount of stiffness, but the ratio of stiffness to mass.
Right.
So first of all, we're getting the same amount of stiffness basically out of this system with a way smaller rocker arm, lighter, less mass.
Less mass,
we were able to use that stiffer 3-piece push rod from Comp.
Right, but before when we actually went stiffer on the Spintron, it made it worse.
Yeah, well, because we had to go bigger to be stiffer, right? So with the 3-piece XDA push rod, we have the larger base, but we're back to a normal sized push rod that will clear the cylinder heads and all that. So it was a great solution. What really I think is going to be the most improvement here, though, Lake, is the idea of moment of inertia, or MOI.
Got it.
So to kind of explain that, it's weight and distance, right? So weight times arm equals moment. So I got this 3D
Archimedes and his lever you're talking about here.
There you go.
Yeah.
So here's a 3D mock-up print of a really big, long rocker arm.
Yep.
And so the pivot length of the rocker arm from here to here basically it's got to be the same because it's the same distance.
Same lever ratio.
That's right. So,
but that one's lighter, less mass.
Way less mass. So if I put a bunch of weight out here and you get this thing swinging, it's going to have a lot of momentum because of the moment of inertia.
Right.
And so I really feel like even though the total stiffness is the same, the higher stiffness to mass ratio of this system and the really lower moment of inertia, I think is going to do good things for us.
Well, there's just, you look at it, you can see there's less mass out here on the end.
Oh yeah, absolutely.
By far. So, all right, so this is what we've done to try to solve the valve float at 8,100 RPM. So
we literally could not take the engine above 8,100 before because it was on the limiter, which wasn't the rev limiter. It was just holding the valves open. So hopefully we run this thing again, it'll go above 8,100.
Let's go fire it up and let's see what we find. Let's
I'm
see
all
what
over
the
it. Let's do
RPM
it.
limit is now.
Yeah, let's go. Okay, let's see what we got here. We'll replay here and see what we got. Obviously, we took it way past peak power, but that's okay. What we were really trying to do is see how stable we can make it. We can see the peak power was up here, 75, 7,800, just like it was before. But you can see here on that run, we actually went to, about 9,250 or so, and it was smooth as silk, like no problem. So the work that we got going on there in the valve train looks like I would say paid off. 9,250 from 8,100. That's what, about 1,100 RPM or so of gain from going to that new rocker system. I'll take that. So now what we got to do is go back and next year figure out how we make this move up and get some more airflow. But now that we can do the RPMs, no problem. We'll figure that part out.
Hidden horsepower on location at the Engine Performance Expo. We are delving into the world of the rock star engine builders and certainly learning some of the best tools and tips of the trade. Lake Speed, myself, and we are joined by Dennis Borum from PME Engines. Dennis just got me up to speed a little bit. I'm super excited because you kind of walk in multiple worlds. Of course, the round track world of NASCAR, delving into the world of drag racing. Welcome to the show.
Thank you. Thanks for having us.
Well, this is one of my favorite segments. I've been waiting for 2 days for this one because we're going to spill the beans finally on some numbers, right? So I believe they have a video queued up. I don't know, have they shown the video yet? Can we nod the crew? Let me know. Have we shown the video yet of the dyno run? No. All right. Go ahead and get the video queued up while I'm preparing the setup here. So back in the summer, me and Mitchell showed up with one of my dad's old Ford C3 engines. And Dennis was nice enough because back in the day, PME, they built engines for my dad at the end of his career. So we went back to where we started from, right? We put this old Ford C3 engine on the dyno, and it was underwhelming to say the best, right?
Yes, it was a disappointment.
Right.
It was a disappointment.
Yes.
Now, had you dynoed the engine originally, like when it was first?
No. Okay. It was one that Lake had acquired. I think
Dad had bought some engines that used Bush engines at an auction. Bob Cronin, a good friend of his, had freshened them up so he could go vintage road racing. And so Dad had an idea they should make about 700 or 7 horsepower. And then we put them on the dyno and we made like 477.
Less than 500, yeah.
Yeah, less than 500. Like, so we were like more than 200 horsepower off of where we. Oh, it was. Now the challenge is then it's going to be easy to make a lot more power. But we tore the engine apart. Man, we couldn't really see much of anything wrong with it.
Yeah, the only things were it was lower compression.
Yeah.
There was a few things there. It had been built as, at the time, Bush or Xfinity engine. So small ports, intake small. But the dyno didn't really tell us there was something going wrong, and the teardown didn't tell us there was anything big that was wrong, other than those things. right there.
Yeah.
So that was still a bit of a mystery at that point.
Yeah, what's this giant delta between what the dyno sheet said in 2002 versus what we're seeing in 2022?
Right.
We're like, oh, okay, where are we going to find a couple hundred horsepower to get back where we were or should have been? And so we went to work, right? And you guys did a great job. We got Greg Anderson. We honed the block. We worked with the guys at CP and Carrillo. They checked the old rods out, and then we made new pistons. We did new rings. We did the gas-ported piston with gas-ported rings. We did 0.7 millimeter, 2 millimeter ring package. So we went from a 043, 1.5, 3 millimeter package to a 0.7, 0.72. Went from just lateral gas ports in the piston to lateral gas ports in the ring and the piston. Then we got Billy and the guys to do the camshaft, where the guys at Comp really stepped up and got us a new valve train. John Callie's with Morel got us the nice Black Mamba lifter, so it has a keyed.
Yeah, and then we machined the block, put the keyed bushings in, and just basically the foundation of it, we kept the crank and rods that were in it, obviously. We talked
same
about.
block, same crank, same rods.
So the heads, at that point, it's like, okay, we rework the heads. Intake valves bigger.
Yep.
It was very conservative before.
Went to a 1.8 rocker.
Right.
Which people have run higher ratios than that in NASCAR, so it wasn't. We didn't kill it. We didn't go crazy. Like you said, we used really conservative stuff, like new old stock parts and a lot of things that weren't just incredibly expensive or unobtainium. Just use normal, tried and true stuff that was pretty easy to get. Like a kind of a project rebuild where you kept a lot of good stuff.
Sure.
You kept the old oil pump, same old pan.
Yep.
We definitely left power on the table there. Right? There's things we knew that you could have made a lot better if you did better heads. You did awesome. Well, yeah, you could do anything you wanted to.
Kind of like a house remodel. How far are you going to go, right?
Right. So extreme home makeover, right? Type deal.
Yep.
So we did all that. They killed themselves this past weekend to get it together. You want to tell them a little bit of the story about the valve springs and everything?
Oh yeah. Well, that was, to me, that's a normal day in the engine builder's world that nobody sees.
Right.
Matter of fact, Joe Nemechek was at the shop the other night, and I was doing some work on it. He goes, people don't know how much time it takes to do this stuff. I said, nope, it's a passion, and the assembly part's simple. It's the preparation. Well, one thing that we didn't really look at close enough was the fact that when we got the cylinder heads together, we knew the valve to piston, or our coil bind was close. So we got the engine together, we checked coil bind. Coil bind was really close. So we had to do some work with spring seats. We needed a longer valve.
Yeah.
That wasn't going to happen.
Right.
So we spent a good bit of time there to get that project going. So, but it did. It all worked out as far as assembly goes.
So we got it all together. We finally got it on the dyno on Tuesday.
Yep.
And Dad came.
Yep.
Come hang out and watch.
Really cool.
That was neat to see. He enjoyed watching it. So I guess what we need to do now is we need to stop talking about this engine, right? We need to actually show the dyno pull. So here, watch the dyno run.
Here we go.
that was easy.
The bar was low,
That
right? I
bar-
mean, that was the helpful thing. We even talked about that when we dynoed it back in June. We tore apart. So, well, this is either going to be the highest mountain we've ever got to climb, or we set the bar really low and we're looking like heroes.
Yeah, we would have been disappointed though if it was 700.
It would have been.
Yeah, or even 720.
Yeah, I wanted way more than that.
So what was the final number?
Well, I guess there was one. So one of the great things about how you really dyno, right, is that you don't just take the best run. In fact, what you need to do is make multiple runs, and then average. You throw out the best, throw out the worst, and then average, right? When you throw out the best, it throws out the highest number, right? So Frankie did a great job. I mean, he was like super fast. I mean, you tell you Frankie works his butt off.
Yes, he does.
And he was doing a great job. And we were changing fuel, we changed oil. At the very end, we threw everything out, right? We put in the Mark's 0W16 JGR oil. We put in VPQ16. We tuned it up, jetted it up, did everything we could. And so it was like 760
plus
something when just off the braking oil. But then putting in the race oil and the race gas and really getting after it. There was a 781 run.
Yeah, just over 80.
Yeah.
So it was a good, and I think my goal was if it was plus 750, 755 is what I kind of thought. Well, this is achievable, and it did better than that.
Yeah,
so
it was.
All the people involved, Billy and CP and the whole thing.
Right. The whole everything came together. It was great. And I hardly slept the night before when you sent me. I think he ran it a little bit before, and he sent me like a half a dyno picture. I'm like, oh, you're teasing me terribly.
That's right. I think what I sent you it was just over 700, maybe 705.
Yeah.
And Frankie looked at it and he goes, well, I'll get another one. I said, no, he's not going to see that.
But we did everything we could to make it right, from getting the hone, we used the right braking oil with the rings and everything we could to get the best possible ring seal, because that was the one thing we could know was kind of bad before, was the rings were micro welded. We had a whole lot of blow by the first go round, and I think the blow by went from around like 10 or 11 CFM down to, I think it was running like 2.5 or something on that last few runs.
And there's one other thing that you weren't aware of till right now.
Okay.
Oh, here we go.
And
nitrous, he lied to me.
when I put the pan on, I meant to call you, and I forgot till just now we were talking about it. So, do you remember when that engine come apart?
Yes.
And taking the pan off, what a pain that was.
Yes.
Okay. So, putting it back on, that pan was originally built for piston sprayers.
Okay.
They weren't on it. None of us noticed it. It was an after. It got washed, it got put on the cart, looked at. The day before that, on Friday, I was getting ready to put assemble the pan and looked at it, make sure it fit. It's like, there's fixed piston sprayers in this pan. Early on in probably the mid to late 90s, some of the bigger teams were the development on spraying the bottom of the pistons and cooling it. We'd learned that OE'd been doing it for years ago, but some people were later to the game doing it, because if you go back to the 80s, probably nobody.
Yeah.
And then as time went on, well, it had it there, but it wasn't hooked up. And I looked at the block and I was like, maybe it was hooked up. There's a port here. It wasn't. So Taylor welded a fitting on the side of it, and we plumbed the pan. And I forgot to tell you. So the pan is plumbed. It has piston sprayers in it now.
It does?
Yes. So
we were spraying the pistons.
So the folks at CP will be happy to hear that.
Oh, yes. Oh, yeah.
So.
Well, I probably wouldn't have had them anodize the ring groove and try to squeeze a little bit more out of it had I known that. So it's good, right? We were safety. That was knowledge I didn't need to have.
That's right. That's right. There you go.
Because I would have been more risky.
Yep.
On the deal.
But having your dad there was the icing on the cake.
That was great.
Because, I remember building motors for him then.
Yeah.
And it was really neat here. And he was emotional. The fact that he heard the motor running, and just I'm sure all of the thoughts of the past and everything else
came flooding back, right? Mm-hmm. Well, the thing was, like, we had offered up, because Mitchell and Logan know the guys who own Rockingham Motor Speedway, and they've just recently repaved it. Mm-hmm. And they said, you guys are welcome to come use the track.
Okay.
Dad's very first time in a cup car, actually any race car with a roof on it, was at Rockingham in 1979. And we were like, oh, this is going to be awesome. We'll let Dad go back to Rockingham and get in the car and relive it and do all that. And he's like, after seeing the engine run, how much power it made, he's like, I don't want to go to Rockingham. That's too small.
Oh, that's too small.
I don't want to go somewhere where I can go fast. I want to go ride in a parking lot. It's like, let's go to VIR or somewhere there's a long straightaway. I want to go fast. You know, I'm like, okay, Dad, you can go where you want to go.
Yep. So hopefully we get to go to probably VIR.
Sounds like that. That's where he wants to go. So that's where we're going to go.
That's awesome. Well, this has been a great project just to follow along on the social media, obviously. But the connection, there's been like a little bit of subplot here on this Engine Performance Expo, you know, family and fathers and sons and everything. For you to take this cool project, use it as an informative bit about the advancement of technology,
Mm-hmm.
importance of ring seal really is what it's all about. You can't just sit your engine around. I'm looking at the products that are on the table that help.
They're all part of it.
They're all part of it, but the payoff, like that payoff, Dennis, to watch, Lake, I don't want to say Lake Senior, but Lake, like get emotional over the firing of the engine to resurrect something from the past and have it be better than it ever was.
Yeah.
Like that's got to be just an amazing feeling.
It does. The whole past, that engine, the history of it, for me, was really neat because back in that day we did so many Fords.
Yeah.
And that was really.
You built a lot each week.
A lot of Fords, yeah.
Because back then there was qualifying engines and practice engines and
and everything else. That's right. And I only tuned for your father one time that I went to the track to fill in for another guy.
Okay.
And before the race, it was at Darlington. And the only thing he came up to me before the race and said the only comments he made, he said, just make sure the parts stay in the motor today. And
I got the rest.
So,
at Darlington, those were true words right there.
Yeah, that's right.
Yeah, you give him a piece of good drive at Darlington, he's gonna make it happen.
Very good there.
Yeah, it was really good. Well, the other thing about this whole project I think is kind of neat is that he asked the question unprompted. He's like, so at the end of my career, 98, what do these things make? Because he wanted to know where does this thing stack up compared to what it was back then.
Yeah.
Yeah, and what is that general number? I mean, you don't have the exact.
Well, there might have been people close to that, but I'm going to say it was in the 50s. You know, there was most of the guys were in the 40s. There might have been somebody's squeaking 70, but it is pretty neat because we had good stuff then. I mean, we didn't change the block.
No.
We didn't change the crank.
No, same rods.
We didn't change the heads.
Nope.
Matter of fact, the guy that tuned those heads up, Jim, at the shop, he's worked in the port room there since 1985. So he ported all those heads then, Ford. So it wasn't like he didn't know what to do then, and it does now.
Right.
But we were able to the little things. I really give credit to the piston. And we put a bigger valve in it, but the piston was a huge part of it.
Yeah.
And the camshaft, those two things. The other things the big gains were there, but.
Took an elite level racing engine of one era, refreshed it with the best of the best of our era, and made 50 horsepower more.
Well.
Yeah.
Yeah, probably.
Yeah.
Yes.
I mean,
that would be exactly it.
Nick Ramey, we got the rocker arms from.
That's right.
He used to work for
that's pretty amazing. So, simply put, that's pretty amazing.
Yeah. Yes. So Nick built an engine for Rusty Wallace recently
with new old stock, not the best of what's available now.
And that's what what Nick did is he built that engine for Rusty, and he said that's period correct.
Yeah.
What they would have built at Roush Yates in 1997, 98. So around the same time period as that, he said that engine made 733, and they dynoed it a month ago.
Yeah.
So we're about 50 better than that. And that part of it, like I said, is the piston, going to lighter ring package, all that stuff. And we've seen it at the testing we've done at Shavers. You go from a 16th ring to a 0.7 millimeter ring, it's going to be 20 horsepower. And so it's there. So you put together the better the cam, better rings, all that just adds up. That's how you get the 50. And realistically, we talked about the dyno sheets the other day. That engine on its fourth pull in 2002 made 656, call it 660. Once it was rich, and we tuned it up, and you got about the 900 CFM airflow, about 300 pounds per hour of fuel flow. It made 690. is what it made. And that's the real number, right? And then we went through all the other stuff that's not real. Because we talked about the dyno stuff the other day. So to go from 690 to 780, we picked it up 90 from where it was new. I mean, that's huge. And then it was just a very satisfying project overall.
Right. It was.
What do the guys in the shop think about that? Because, I mean, you guys work on all kinds of things. And was this like oh, God, this thing's here? Or is this kind of like, oh, this is going to be kind of interesting to see what this is?
No, I think a lot of the guys that were involved in it, it was good. Paul, or assembler there, Paul's been with the company since, I think, 45 years.
Yeah.
And so he did a lot of those engines then also. So for him, it was a trip down memory lane too.
That's cool. I know you had that same experience.
Oh yeah. So it was, and then on last Saturday when we finished the top end, and I mentioned to Joe beforehand, the drag race team that we're doing work with Rick Ware and Clay Milliken, the car chief came over and helped assemble the top end, which is Jesse Snyder. So he was all excited, to be able to. And I thought, wow, I get to work with a top fuel guy. We're going to put the top end of this motor together.
That's awesome.
See, it's all cross-pollinating. And so let's take a second to talk a little bit about that. In that your background mostly in NASCAR, and you kind of come up, but now you're getting drafted in or selected to be part of the drag racing community and nitro burning top fuel cars. That's kind of interesting. Rick Ware has come into the sport and is bringing money, but also technology and relationships. What are you doing with the Clay team and Clay Milliken's team, and what can we look for?
Yeah, so they we had talked about this last year, Rick did, and then we went to the last 5 races of the year with the team, really just watching, wondering how can, he says, I want you to be involved with this. And right away, the first thing that you see is repair work. And the abilities there at ProMotor, we do a lot of repairs for other drag race teams. I'd say that most of our machine work that we do for outside work is for drag racing, whether it be pro stock or top fuel blocks. But as far as the engine part of it at the track, I thought, this is so foreign.
It is absolutely foreign.
It's not me. It's a flying bomb, and got to work around and hang out with Jimmo and the guys there, and you build a relationship, or you start to build a relationship. So I think that going forward in this year, we'll have a presence there and be available to do work if other teams need repair work. That's part of our business model. But to be more involved with what they're doing organizational wise with the engines, and just keeping track of maintenance and that sort of stuff.
And another set of eyes, and who knows what you come up with being there, and they're looking for an advantage, and maybe something strikes you.
Yeah, and to work with, they're all great, and just to work with Clay, he's like, I don't know if there's, I didn't know him before this year. I don't think you could knock the smile off that guy's face.
No, you can't. And one of the good guys out there, Clay Milliken, is, the guy's made of gold. Everybody loves him. He's a wonderful person, and I can assure you there will be repair work.
No,
I can assure you, like that.
Occupational hazard.
Part of drag racing. It's unfortunate, but when you're stepping on it and you got nitromethane in the tank, there will be repair work available.
Yeah, I think at Pomona, he said he got out of the tow vehicle, and he goes, it's gonna be the right side, right behind me in the front cylinder in there. So he goes, you want to know how I know? Because that's where the flames and sparks were coming out. It had blown the gasket in the head right out there.
Yeah.
So
it's a different style of racing.
But like you mentioned, though, that different perspective. Right? I've heard, being around the nitro stuff, we talked to Antron at PRI. Those guys are starting to think about the engine, not just, how can we tune it up, but maybe we need to think about building it differently, because they're looking at pro stock, they're looking at NASCAR and say, what can we apply from what those guys know to top fuel in order to get an advantage? Because, man, when they do get it hooked up, boy, they are all super close.
Yes.
When they get it hooked up. Now, there's always that issue.
Yep.
But when they get hooked up, if you're in the final round and they both have a good light and they both hook it up, you got to outrun the other person to the other end.
Yeah, they work hard.
Well, and they will get it hooked up. Over the course of a national event, you go through this process of qualifying, and the first run down, 2/3 or a third go up in smoke. And by the time we reach first round eliminations on Sunday morning, they're all going down. They have to. They're going down the racetrack, and in that moment, they have enough to get to the stripe first. But it's kind of interesting in that we got to make these things go fast, but you've also got to make them last. It's like one time in the past, it was disposable. Like all these things disposable. You want to get another one and throw it in there. Well, that is not cost effective in any way. We want to keep these things going. So maybe a little more insight from folks like yourself kind of overseeing these things, make these engines live a little while. I think about rings. I think about rings all the time. Like once upon a time, or even right now, it's like it's a disposable item.
Yep.
Well, maybe there's something there that in the future, these 11 or 12,000 horsepower nitro burning engines can live a little longer and the parts aren't quite as consumed. And if that's possible, that would be only beneficial to everybody who does that.
Absolutely. I think the efficiencies of applying the horsepower, it seems to be plenty of horsepower. You look at it, it's making it go down the track, like you said.
Yeah, and you think 12,000 horsepower, that's enough, right? And the answer is no. It is not enough. There is never enough.
That's true.
Well, I think about the durability aspect of it. Like you're touching on. Jeremy Wagler last year or this past summer, they do the compound turbo diesel stuff, crazy stuff, right? And he's holding this one piston up. This guy Black Death is killed, and he's like, "Yeah, this was last year. This is this year. This one looks brand new." He's like, exact same piston, exact same rings. All we changed was the surface finish on the cylinders.
Wow.
They added more RVK to hold more oil, to seal and to lubricate, and all of a sudden it goes from this thing that can't live very long to this thing that can live
that's right.
a long time. So that's why we're honing the cylinders out there. We'll show you some before you leave.
Okay, good deal. Good deal.
That is super exciting. So what would you like to work on? You seem to have been able to touch so many cool things, but when you look at the motorsports world and as an engine builder, what interests you? What else would you like to do that maybe you haven't?
We've done quite a bit. We've delved into the midgets. We have a couple engines down at the Chili Bowl today.
Okay.
But I like all of them. I mean, the win is being able to get to the finish line. Our work for us on the naturally aspirated is done, non-top fuel is done on the dyno. It has to, when it makes it off there, we've done pretty much what we can do. We might tune at the track a little bit, but our job is to make it get to the finish line, and from there we hope to win. So road racing, I like all forms of racing. The fuel racing, though, I think it's working with people. That's really it in life, is that you get to work with really good people, and you succeed together. So,
makes a difference. Exactly.
Well, Dennis, great job with Lake's engine. Just the nuts and bolts, of course, but the emotional side of it is the best part. Great job. Thank you for that.
Thanks.
And thanks for joining us on Hidden Horsepower.
All right, thanks. Appreciate it.
All right, so from Lake to more Lake, except we're going to add a little John Callie's in there. I'm going to talk some lifters, which is a very big part. And we are coming down the stretch here at the Engine Performance Expo.
In the quest for more horsepower, you have to talk to the valve train expert. So we know, John, that camshafts, that lift and that lobe design are really important for creating that area under the curve so that you can get more air into the engine so you can make more horsepower. But how does this lifter play into what this camshaft is trying to tell that valve to do?
Well, I think the lifters in the old days used to be one of the hardest parts to keep in the engine without problems.
Yeah, they tend to have failures, especially the flat tappet lifters. And with the flat tappet, you can only increase this ramp at a certain rate, because then otherwise you're running at the edge of the lifter. But going to a roller wheel solved that problem because it allows you to be more aggressive on your lift curve, correct?
Yeah, and the other thing with the flat tappet, the amount of break-in time that a team would have to do was critical, and if you didn't do it right, you had a failure. So with a roller cam,
I know a little bit about that, by the way.
and the roller cam, first of all, it's made of a different material. It's hardened. The lobes are around 60 to 62 RC, so it's real hard. So therefore, you have to have a matching roller component.
Got it.
And
the hardness of that wheel has to be close to the hardness of the cam.
and actually these are harder than that.
Okay, they're harder, okay.
Well, then these have needle bearings in them, and we'll show you the difference between, this is the new Black Mamba lifter, which uses no needles at all.
So it's a bushing style versus the needle bearings.
Well, when you say bushing, most people put a small piece in here and then a steel axle.
Okay.
Where our whole half-inch axle goes into the part. So the wheel actually rides on this axle.
Okay, which is nice because that's not steel, so being a bronze piece, this is actually kind of self-lubricating better than steel. And I also see some holes in here too, which is kind of crafty and genius.
Yeah. Well, what I'll do is I'll show you on the screen.
Yeah, go for it.
Well, first of all, we make two, both for Chevy and Ford.
Right.
And these two lifters are actually made different. On your project engine with your dad, we're using the Ford. And what the Ford is, we had to relocate the key so it wouldn't be right in the oil passageway.
Got it.
And then we had to offset where we're bringing the oil in.
I see that, yeah.
Okay. Now, we made bushings through CRE.
Okay, yep.
And they do a wonderful job, but when people think you can just use any bushing, you want to have all these different cutouts inside a groove all the way around where the oil hole is, so the lifters will work properly.
So you get the proper amount of oil.
Right.
Proper lubrication, if you don't know, is the 4 R's. Right oil, right place, right time, right amount. And what I'm seeing is this piece is all about those 4 R's, of getting that stuff where it's supposed to be, when it needs to be, and enough of it.
And so, like I say, the bushing for the Chevy lifter is different. So,
because where the actual key is in a different location, and then the oil holding is in a different location.
And if you noticed
I
here,
can see it.
The key here is in line with the roller. On
And
the
there it's
Chevy,
offset to the side.
It's in line with the axle.
Right.
Okay.
Now, part of this bushing is that you have to have that key, right? With a key, you have to have a bushing. You can't run a keyed lifter in a standard bore without having the bushing in there.
Well, and as an example, this is a small block, a big block Chevy tie bar.
Tie bar style,
and, and you see the curve because on a Chevy, they got two different angles.
Right.
And what we call is, this isn't done correctly, you get a washing machine action, which you don't want.
No.
Well, once you go to a key lifter, everything stays perfectly in line with the camshaft. And you want this to be in line properly with this cam, not like this or this. And so
the geometry has to be right for it to actually work.
And so when you...
And have longevity.
And that's why today with the new machinery, you can not only, when you bore the block, then move over, bore the lifter bore, and we want about a 2/1000 press on this part. You bore it, go down all through the block. You have another tool you just insert to press this in. And if you notice, there's little keyways
I see
here.
that, yep.
And that's to put it in your fixture in the mill so it goes in.
Locates it on the mill
properly.
correctly. Nice.
So the way this works is your oil pressure is coming from your oil hole. And it surrounds and goes into these slots on both sides of the lifter. So you have one on this side and another one on this side.
Right, and those are matched up to the oil holes in here. So you got oil going down the gallery, it's being distributed to these oil holes that then feed into the lifter.
And if you notice, look inside, you'll see a one groove all the way around where the oil hole is.
I see that, right.
And that's just to ensure getting oil everywhere. Now, it comes down through, here's the deal, it comes down
through the body
into the axle, and there's a V in the center here. So it goes from the down into the V and back up to 12 o'clock. This is 12 o'clock. One, because when it's sitting there, you got to get oil into this. If you had it the other way around, it's going to be difficult to get the oil.
And at that point, it's essentially functioning like a plain bearing, like you're cranking,
engine bearing.
Engine bearing, like a cranker or a rod journal bearing, is the same thing. It's riding on a wedge of oil as opposed to riding on the needle.
Yes, that's correct. Now I want to give you a comparison between a bushing and a needle bearing. Now, if you notice, you see arrows to 1, 2, 3 needles. That's carrying the entire load of the bearing.
Got it.
Now down here, these represent the points. So you, if this is your points, these are called Hertzian stress points.
Yep.
But you have a very thin part that it's riding on.
Right.
Okay, so now with the bushing axle, we have 40% of oil in here on a 1/2 inch diameter axle versus a 360. So you go about 100 times the load carrying capacity with this new part.
Yeah, so if you've got, say, 500 pounds of open pressure pointing down, all that 500 pounds of load is actually being concentrated on these three little bitty areas, which sends that pounds per square inch through the roof versus 500 pounds of pressure now being distributed over a 1/2 inch radius over a much broader area, so that
load carrying goes way
down.
up.
Yeah.
Now, the one thing is, people say, well, I have a bearing that has more, I made the needles smaller so I could get more needles in. Okay. You're still on 3 needles.
That's exactly, yeah.
Or we can make this, bore this bigger and go to a bigger roller or another roller. But the problem is impact. In other words, there's an impact that when you hit, either you float a valve and it comes down and hits, you don't want this wheel to crack.
Right.
Okay.
And we've seen that before. I have seen flat spotted needles because of that, because you get that valve float and it's hitting, and now you're flat spotting those needles, and once they flat spot, they stop rolling, they start skidding, and then you see all this failure. And sometimes people say, oh, it was the oil was too slick and it wouldn't allow it to roll. No, your needles got flat spotted, probably because you didn't have control of your valve train and it was bouncing all around.
And the one thing is, like on our product line, we make 3 different levels of axles, needles, and wheels. And you put those in what power level you're going to do. So the parts here, now if I take, this is one of our upper level 842s. So this has an excellent wheel, needles, axle.
Right.
But it can't do what this does. The other thing,
the load bearing capacity is just simply not there in a needle setup versus what a bushing setup is.
Plus, guys are taking their race engines and they're on the street. Well, what happens on the street? Well, you have to idle if you're at a stop sign.
Yes.
And that is the highest load on a roller bearing.
Oh, you're right.
At idle.
Right.
So now we fixed it with this.
Yeah.
And so, and all these parts are rebuildable. That's what we do.
Yep.
But anyway, this gives you a good comparison between
No, it's fantastic, yeah, because you can see visually, this is not a lot of load bearing area. There's quite a bit more load bearing area there. It makes total sense that, yeah, for street applications, when you're gonna run a lot of seat pressure because you're gonna run big valve springs because you've got this giant engine that's got all these heavy parts in it, it makes it better sense to have a bushing lifter like this that can hold that load.
Yeah.
And I guess too, that wheel diameter is also kind of nice too for the camshaft to be able to get that,
absolutely,
have more control and less dynamics.
Right, and the thing is, this is what we call an 850 wheel, but we also make a 910 wheel, but you can't fit a 910 wheel with a 936 diameter, which NASCAR requires. Plus, NASCAR would not approve
of the bushing.
This for a cup.
Right.
But anyway, that's where we...
Fortunately for my dad's engine, it doesn't have to go back through tech, so we can do what we kind of want to do, which is kind of nice.
And the one thing is when we started developing this, we actually ran this at Martinsville at an Infinity race.
Okay.
That was, I don't know, 4 years ago or something. And, you know, it was legal to do it, but we wanted to show that, yes, you can make it through these RPM ranges, blah, blah, blah. So the other thing is, this is a DLS coating on top.
Oh yeah, exactly. Having that coating on the body makes a massive difference in terms of the longevity, because DLC is essentially a dry film lubricant that imparts, boundary lubricity and extra anti-wear protection essentially for that component in the event there was a less oil available startup and things like that.
When we get a cup lifter back for rebuild, you can't tell that it was run.
Right.
It is unbelievable how these teams keep the oil clean. They preheat it before it's starting.
Right.
And that's the one thing I do hear. Well, what clearance do you recommend? Well, oddly enough, people always have a friend at Cup. So they know somebody.
Yeah.
And they'll take one sentence out of a big system and say, I'm going to do that. And you just have to be careful, folks, because that is such a controlled environment.
It's a complete recipe, and if you don't follow the whole recipe, you're not going to get the outcome.
That's correct. So anyway, we're real pleased. These have been out for about 2.5 years now, and we've had great success with them. And this is why I wanted to put these in your dad's engine.
Right, we appreciate that, because this is the good stuff. So we've gone to all the lengths, right? Keeping the same block, heads, and manifold, but inside we're trying to do all the upgrades we can, from the CP guys giving us new pistons. Obviously Total Seal's done some new rings. We've gone from a big thick ring to a really small thin ring, from iron to steel, made all those material improvements, which is kind of great because we're the same thing. We're going from the old style stuff to the new style, different materials, better coatings, that same process, and hopefully we're going to see some good results for it, and hopefully you guys can see the results when it's done.
Engine Performance Expo, a great collection of engine builders and fine minds, and we're coming down to the stretch here, folks. And it's getting a little punchy, right? It's getting a little loose here as we get another round table. Good news is we've got Dan Bagley from Mala to get us back straight. Welcome. This is our first live interaction that we've had.
This is. I saw myself on several videos. Hopefully everybody learned something from the videos that we did earlier, and it's good to be here with everybody.
No pressure. We're planning on you carrying this one.
Oh boy.
I'm tired now, Dan. This should have been apparent, like you're coming in the game, late in the game. New energy. Charles is back, of course. Talk about, obviously, this whole thing, like with your dad's engine and everything, the thickness of the rings. The advance of technology, right? That's what drives things forward. The advance of technology, and you've all been on the cutting edge. If you weren't, you wouldn't be industry leaders.
Well, me and Ben did a talk at SEMA with Billy. Yep. So we did a talk at me and you together at SEMA. Then me, you, and Billy did a talk at PRI about that exact topic. About it's the material, the coating technologies, the measurement technologies, all of these things we've been kind of dancing around the last 2 days. That's what enables a 300 horsepower gain. That's what enables the engine to pick up 50 or 90 horsepower from where it was before, because you shouldn't be afraid of the thin rings, because we have the right material, the right coatings, and then we can measure the cylinder bore finish correctly. We can do all these things by pulling those technologies together, but enables that next level of performance. And I forget who said it earlier, or maybe yesterday, I said, and you shouldn't be scared of it, because it's not new. It's actually been around for a long time, actually.
Well, and so often one new technology is dependent on some other technology coming to fruition. On a grander scale, I think about, for example, the evolution of turbocharging over the last, say, 15 years. But really, turbos have been around since World War II. They didn't really make it onto the performance scene until the electronic fuel injection technology made it easier to control the engine. And so suddenly the development of turbocharging and EFI were sort of parallel now. One technology depended on another one, no different than stuff inside the engine.
Correct, absolutely.
So what's next? That's I hate to ask that question, but we've covered so much ground. Is there more ground to cover? Are there new things coming? Where are we looking to find that next coating? Is it a material? Where is it? What is it? What do you think?
I can't help but think, after talking to Mike Copeland at Arrington Performance, what he's done with hydrogen combustion, that we can't, as racers, build a hydrogen combustion race engine. In fact,
I know AVL is doing it, aren't they, Mark?
I think they are, yes. I
Yeah.
don't know much about it, but I think I've seen documentation and stuff from them about it. And stuff.
Yeah, so I mean, he's unleashed
Yes.
people like AVL.
Yes, they're going to get something done. So, yeah, they're going to figure it out. So yes.
Yeah.
Well, I found it to be interesting. You referenced Mike talking about the some of the characteristics of the hydrogen and the
Mhm.
way it made its power. He's taking an engine that was pretty much designed for gasoline and converting it. But when people start to design for the characteristics of hydrogen, it could end up being different than what we have now.
Oh, exactly. I mean, Toyota has already done it in a partnership with Yamaha. In fact, recently the CEO of Toyota came out and said, we're going to pursue the hydrogen route because there's literally just not enough supply chain to build a complete full battery electric fleet. They just can't do it. We have to have alternative technology. So part of that's going to be hybrid, but part of it's going to be hydrogen combustion. So you're going to
Combustible hydrogen, not hydrogen fuel cell. People get confused about that all the time.
Right.
They think hydrogen fuels, which was discussed a long time. Combustible hydrogen, and it's in a tank, and we're turning an engine.
And again, that's another one of those technologies that's somewhat dependent on other technologies being able to
get there.
promote it. You know,
Mm-hmm.
that the energy density of the hydrogen is so much different than gasoline. It's going to require all kinds of different ways of thinking about how we build engines, right?
Exactly.
From the materials we use to the coatings that we use, reducing friction, all that stuff's going to matter. I hate to be cheesy, but like I feel like listening to Mark Malberg and coming over from what he does to our race industry, we haven't really even scratched the surface of what we know about how to apply, measurement and metrology and stuff to, the really, really high level race teams have been working on that stuff for a while, but as it trickles down to the machine shops and the performance engine builders and stuff, like, man, we have so much more to expand there that, again, like some of these technologies that feel like they're emerging, they're not really. They've been around a long time, but they're finally in a position where they can begin to have development and expansion based on the fact that we now have these other, technologies available.
Yeah, I think, Ben, to go with that, there's a lot of unknowns materials. So, we at Molly, we're doing a tremendous amount of testing on hydrogen engines. Unknown what it's doing. Hydrogen is a smaller atom, so when it burns quicker. It's more combustible, so to controlling it, 4% of room fill of hydrogen is combustible by static.
Oh, wow.
4%. So now we think about, okay, what's happening? We don't know what's happening with materials. We at Molly, we're testing some of that right now, but pistons becoming brittle, valves becoming brittle, controlling the combustion area, cooling pistons versus what we conventionally know today as creating a pistons and rings and so forth, but getting heat to keep it a cooler burn, to keep the components, whether you coat it or not, to be determined, but to keep the pistons, the valves from breaking. Then, sealing. What are we doing sealing? Because you have so much leakage. All engines have a certain amount of leakage that goes in there. Well, back to the 4%, you create 4% of hydrogen that goes into a crankcase. Now you create a large capsule. We all remember the Hindenburg, and
Wasn't good.
Wasn't good. So now we're working on positive displacement ventilation of forcing air in. Kind of, you can imagine, I know, Ben, you're a boat guy, but an inboard engine, what do? You have to ventilate that.
Sure.
Well, we have to come up with means to ventilate crankcase to create a suitcase of explosive gas as your family is driving down the road. Not a good day, right?
there's a gapless second ring for that, by the way.
So, and controlling the combustion, Molly makes a jet ignition system, and we have found that by doing the jet ignition on there, we have increased controlling the burn. We have made 50% increase in horsepower.
Wow.
And 30% increase in torque.
Wow.
By applying this system to the hydrogen into the engine. So there's a lot of development going into the hydrogen engines, and the efficiency, controlling it, safety, performance. we all love the performance.
Oh, yeah.
That's why
Yeah.
we're all sitting here. I heard 50% horsepower increase. I'm like,
That's a big number.
That's a big number, you know.
I was just about going to tell you I was going to retire before that happened, but now that 50%, I'm all in now. How many years do you think this is going to be?
One thing that Molly does that's incredible is the amount of research and development you guys do. I would say that you don't do a good job of telling everybody about it. Like Lake and I were over there at PRI, and you guys were showing us some of the absolutely mind-blowing level of R&D that you guys are doing. And so it's no surprise that you're looking at new and emerging trends and technologies as well. But my gosh, the level of investment that Molly has put into this stuff is pretty impressive.
Yeah, and coming from the race side and seeing it, and then going to Molly, and unfortunately there's some segmentation in Molly with business units that don't communicate as well. Everybody's fair game to me to talk to until they tell me to shut up.
Right.
Because I'm always on a quest of finding this information out to pass on to educate. That's why we're all here. But there's so much, and it's my drive to try to get some more of that information to get out here, and because there is so much testing that we've tested for engines that came into build, made their complete cycle through the consumer, and now they hit the aftermarket, and we were the original designers of how that came about. So I'm trying to close that loop, and every day I uncover something. It's like, wow, this is really cool. The new bearings I just launched, super cool. New technology, just applying it to older applications, small block, big block Chevy. Got a whole nother stuff coming in.
It's hard not to get excited when you see something. You're like, I could apply it to this, and I can take it over there. And,
that ignition. I read about I don't know if it was SAE white paper or something. I was reading about that ignition, and it was talking about how it could be combined with direct injection with gasoline for sizable gains, and to be able to run like double stoichiometric. I think that was the article I was reading that was referencing it to go way leaner.
Yes.
Yeah.
Yes, exactly. It was way leaner. I actually, sidebar, I got hit up on a nitro fuel team. You can't talk about this.
Top seat.
Nitro fuel team.
Turn it off for a second, then come right back.
Can we test this to get more horsepower out of a nitro fuel engine? I was like, probably not a good idea.
No, I say we should do it. We should do it. Now, on that, we do have a couple of questions. Everybody been watching all day. I think this is the time we sparked something. People love to talk about technology. And so, rapid fire, and there are no bad questions. But like Nate, who's been out there all day, by the way, thank you very much, Nate. Curious to know about ignition requirements of hydrogen. Do we know? We have any answer? Like, is it just as simple as one spark plug and you hit it at the same time we do with fuel, or?
Well, you're
the expert.
I'm not the expert.
Mike Copeland is the expert on this deal because he's not here right now.
Inside joke. I apologize.
Now, I do know the expert, okay, and know him very well. You guys know him as well.
We're all enamored by him.
Yes. So the jet ignition actually uses a spark plug to basically, it's an indirect injection of putting nitrogen in, igniting it, and it's actually atomized as it's coming out. So technically, kind of plus or minus, it's using a regular spark system. It's igniting it indirectly, and
the spark is there to make a blowtorch, basically.
To make a blowtorch, yes.
It's like a pre-chamber.
It's a pre-chamber. Thank you. That's the word I was looking for.
See, there you go. And one more that came in. What do you guys think about like electric compressors instead of exhaust-driven compressors? So I'm thinking, I think that's technology that gets used in a couple of places in F1 instead of an exhaust-driven turbocharger, say, using the electric motor instead of driving the wheels just to create boost. What do you think about that? Asks Dan.
Blake.
Well, obviously the Formula One engines today are the most efficient in terms of how much fuel energy is actually making it to the crankshaft. If in terms of that thermal efficiency, a good diesel engine used to be around 35%. Good race motors are going to be around that same number. They're over 50% thermal efficiency, which is rivaling like combined gas turbine stuff. It's crazy. But part of that is the fact they're utilizing that technology. So when they go full boost, qualifying lap, overtake mode, you have the turbocharged engine, but the exhaust is actually routed to divert from the turbo, and it's straight exhaust. But the turbo
compressor is still running off of battery power. So they're spinning it at full boost. They can make full boost at any engine RPM, which is crazy.
Yeah.
And so obviously, if you're looking at how do we make sustainable fuels, which they're working on, talked about yesterday a little bit, net carbon zero fuel, so that the full life cycle from production to combustion is net carbon zero, that fuel burned the most efficiently as possible leaves the least carbon footprint, that's the goal, right? Like the whole thing is, do we want to say pick the winner, or do you want to let technology sort out what's the most thing? So I think if you look at where Formula One's going, they're saying we're going to do sustainable fuel. We're going to use it most efficiently as possible. If you go to, say, a series hybrid, where there's still an electric motor that actually powers the vehicle. But where does that power come from? Well, batteries are big, they're heavy, the fire issues and all that. If you have a small, incredibly efficient internal combustion engine, just generating the power source for the car, and that's a sustainable fuel, how's that not a bad answer?
Interesting. No, I love it. And we all want the future to get here as soon as is possible, right?
I like the old stuff. Give me gas, give me oil, give me...
That's why you and Jason Lyon get along.
I won't argue with it.
But I would run an electric motor on the water pump, the oil pump, everything if I could.
Vacuum.
You know what I mean? Vacuum, everything.
Oh, yeah.
I mean, it's
just drag.
It's drag. It's horsepower. It's that, look at a top fuel car. What do you think how much power do you think it costs to turn that blower?
A lot.
Well,
I mean, I've been to Bill Miller's where he was testing
We're going to show up, right? If we spill the beans right now.
No, don't spill it.
We just say a lot.
But you say about Bill Miller, go ahead.
I said when Bill Miller Engineering was doing blowers for the NHRA cars. I mean, the motor that he took to turn it was big. He was testing blowers. He had a big motor just to turn the thing.
Yep.
It's like, how much is that? And he told me, and I was like, wow. That is a lot of horsepower just to drive that horsepower.
It's like
I've heard the numbers like 800.
It's like 1,000.
Yeah,
I mean, it was like his motor was 1,000 horsepower to drive that motor. I was like, wow, that's 1,000 horsepower dyno just to drive a motor.
That's not surprising at all based on like what we've
You're
seen,
right.
where you could look at combustion analysis and go, wow, I see how much power it's making, and I see how much is coming out on the dyno, and you're like, holy cow, man!
And you figure out all the other losses, right? If you know what all the other losses are from NA to boost, well, that delta is what took to drive it.
I actually had one. I'll tell a quick story. I had one on the dyno not too long ago, and I actually thought something was wrong with the engine. So what happened was they brought this engine they wanted to test. It was like some big block Chevy with like a Pro Charger on it, And so I was like, I'm going to tell you, it makes more power than my dyno can hold. And so they were like, well, can we just do like a break-in and do a basic tune-up or whatever? And I'm like, all right, well, maybe what we'll do is we'll just, they said, let's just take the tube off that connects the scroll of the compressor to the engine, and we'll just run it. Well, that didn't work, because as soon as I opened the throttle, there was so much air coming out of that thing. It literally, the hairdryer blower blew the entire engine dyno across the dyno cell.
Nice.
And so I was like, all right, well, that's not going to work. So we let's take the compressor cover off. That way it can't like shoot out, and then you get this murder wheel out there like turning 10 million RPM, right? So anyway, we're running this thing, and I'm like, this thing's busted. And they're like, what do you mean? I'm like, it doesn't make any power. Like, this thing should make way more power than this, right? And so, man, we like the better part of half a day, I'm like going, I'm just telling you, it sounds fine. It runs great. It goes all the way up. And I'm like, it just doesn't make any power. I'm looking at how much fuel flow the thing's using and how much power it's making. I'm like, this math doesn't add up, until it finally occurred to me. And it was like 800 or 900 horsepower worth of fuel going into the engine. It was making like 420. And I'm like, something's wrong with this thing. Till finally I realized what was going on was it was taking so much power to turn the blower.
Yeah.
And so to prove it, we turned the engine off. Now, you take a wrench and you put it on the front of the pulley of the engine. You go to crank it around with the spark plugs in. It's hard to turn, right? So I took a 3/8 Allen wrench, 90-degree Allen wrench, and I stuck it in the front of the compressor wheel. And with 2 fingers, I could turn the engine over, because I'm working backwards against all that gear ratio that from the crank. It was like 10-to-1 ratio. You can turn the whole engine over with a 3/8 Allen wrench. So that's going the other way. So you think about, well, if it takes 400 horsepower to turn, one of those kind, which is bigger than the one we had, but smaller than the one you were talking about, like, there's room for efficiency there too in our racing world, right? Like, so why don't we look at how could I reduce the losses in that system? Which, by the way, we got a plan for next year.
Yes, we do.
We'll talk about at some point, but there's a lot of areas to gain efficiency in the engine beyond just piston shape and coating and materials. Man, like reducing that friction has been your whole life study.
Whole
pretty
life,
much.
yeah.
But now we can start looking outside the engine. Lake, before you left Driven, we started testing like differential fluids and transmission fluids, and you start. What happens is you move away from the combustion chamber and you start looking at the entire vehicle. How do we gain efficiency from every step of the way? And so some of that's using electric motors and not dragging off the engine. Some of that's fluids and materials. But at the end of the day, it's a collaborative effort. From the time I think Billy Godbold said we keep talking about cylinder pressure because really it's the only thing that makes the car go. But if we could reduce how many taxes we have to pay along the way, we're going to have a net benefit.
Oh, you had to bring politics in.
Well, I was going to say, tribology for the win yet again.
Yes.
An oil nerd is always going to find a way to get that.
I know, every time.
I thought it would come out earlier in the expo, honestly.
I waited to the end to put the cherry on the top.
I get it. I get it. It makes perfect sense.
There's no bad questions, Joe, only bad answers.
That's right. That's right. NHRA start. Powertrain Performance Expo next year.
That's right.
Question mark. Well, exactly. Here's one for you that I'm just kind of curious, and I'm freestyling here a little bit at the end of the deal. Like, what would you guys like to see? Like, Mark, you and Jason yesterday talking. Annoyed and restricted by rules. These rules. Like, what would you like to see? Like a series or a combination or something. We talked Formula One. What would you like to see? A challenge for an engine builder to create, to build. I know you know where I'm going with this. What would you like to see to really be able to create what you want to create?
No rules.
No rules of anything.
No rules whatsoever.
An Indy 500 style race where they say, hey, listen, we're going to run 500 miles. Everyone's got to be safe because of these factors.
Yes.
But show
Nothing
up with
else.
whatever you want.
Whatever
cool
that'd be. But I'll tell you this roundtable stuff here is great. But we should really tape the roundtables that happen in the back room back there. Because that's...
Oh, we are.
If you want... Oh, I didn't know that.
All of our phones are being tracked.
No, it's the stuff that gets talked about out there is pretty darn cool of what people have done, other things have done, and talk. That's what I want to see is those conversations get posted because they're really good.
They're unscripted.
Yes,
and they're organic.
unscripted.
And,
I mean, this gets pretty unscripted like that, But I mean, being the guy that started NASCAR back in 1985, and the rule book was 13 pages long, and now it's 313 pages. I just don't like rules. I really don't.
What would you do if you could do something? You could show up to a race with no rules. What would you show up with?
RPM or engine size? What would you pick?
Right, there you go.
I would pick RPM.
My kind of guy.
I would pick RPM. But the question is, if you really got into it, would you drag race or would you race across the country? What would you do? Because there's a lot of drag racers here, and we talk about durability and we talk about these issues, and me and George were just back there talking, about his pro stock bike truck, his pro stock bike, and it's like, oh yeah, and somebody said something about durability, and he said, yeah, I could get like 4 passes out of this. I go, that's a mile.
Yeah, you got
we run
990
miles
more
or
to go.
1,000 miles or something. I go, you're talking about a mile and you said it's durable? Come on now, us NASCAR guys or the Baja stuff, we're going 500, 600, 700 miles. NASCAR now, our Xfinity motors, we're running between 1,000 and 1,200. So it's a big difference. So if you wanted to race, where are you talking and what are we doing? That's a big question of,
It's interesting.
It's almost like drag week or whatever, where these guys got to drive their cars there and then race the thing and then drive them home. Now that's
cool stuff.
I kind of think that's cool because it's kind of no rule. It's kind of like
there aren't that many rules. We got to take one of your off-road engines and
that's what I'm thinking.
Go drag and drive
we'll
that
put
thing.
JD1 in Kevin's wagon.
I would volunteer
Wagon of
for
Doom,
that.
Kevin.
There you go. That's something like that. I think probably drag race is the closest thing to being something cool, you know. Now
that is cool.
How about if we race between point to point? You know?
How about this? How about you road race, drag race, and circle track race all in the same week?
Well, I was thinking, that's your version of like Street Outlaws drag and drive, right? Like,
Right,
we got to
yes.
go, like, it's kind of
That's a
interesting
good point.
concept.
We could do a drag race, then an oval race,
That
then
would be
some
cool.
other type of race.
Yeah.
There you go.
Well, see, the car would, you just change the whole nature of the craft that you're in, right? All of a sudden, like drag racing, you're not going to have skinny tires up front. That's for certain.
No,
But you got to
you're
go around
exactly
a corner.
right. So if
like,
you had to
okay,
do all
pull
of
those
them,
off. Yeah,
Well, but there's no rules, so I can change my tires.
You think we get them shut down? You think we get them shut down 40 from Raleigh, North Carolina, all the way to Barstow, California?
We
can
try.
race 40 all the way.
That would be pretty cool.
I mean, I know they have that race, but it's not really legal. I don't know if I want to go that far with my race here, but
Well, they do something similar in the diesel world, where they have a pull, a drag race, and a chassis dyno.
Oh, they really do? That's cool. That's awesome.
The Ultimate Call-Out Challenges in Indy, and there's several events around there, but we actually part of that, and it's 3 functions, and it's really cool because I've been to several of them, and you see guys with 4-post lift out in the parking lot, and they're dropping both rear ends out of it, front and rear, if that's the correct way to say that, and and they're putting in different rear ends, weight box on front, they're putting an engine in for chassis dyno because you want to win the chassis dyno, and it's a point system of how you score, and they'll change the engines for torque engine to pull to sled, and it's all in one weekend.
Wow.
And they do that, and it's
cool.
a pretty cool event to see the long hours and the preparation to have different engine combinations for the different events.
That's really cool.
And swap it out, including rear ends and weight boxes as pullers put weight box in front, coolers. Stuff. So there actually is an event that does that, and
we need a gas class.
YouTube some of the chassis dyno failures on there, and it's pretty. You see why it's risky.
I want to go
Why
back.
does everybody like things blowing up?
I didn't say I like it. That's interesting. I didn't say I
Everybody
like
likes things blowing up.
I do want to take one step back, Joe, and talk about, like Mark, you were saying, talking to George. Of course, George, I don't even have to ask. I already know what his comeback would have been. Yeah, but look how much power we make compared to you per inch, right? But it goes back to that rules thing, right? So we do an exercise in one of our competition engine development classes where we compare, say, like a naturally aspirated F1 engine from the mid 2000s, right, to like a cup engine to a pro stock NHRA engine, right? Because those are arguably the 3 most highly developed combinations in gasoline world, right? But what's really interesting about those engines is if you only look at power per inch engine size, the Formula One wins hands down because they do like 19,000 RPM. That's why I asked the question, RPM or engine size, right? But if you look at it in terms of like torque, the pro stock engine crushes them. Not torque, I'm sorry, just engine size, right? Yeah. But what's interesting is when you look at the rules package for each of them, you go, well, why does a NASCAR engine only make X power? And you're like, well, give me a sheet metal manifold and 2 carburetors and all, I'll take all the handcuffs off. I bet you those things make way more power than everybody thinks.
I think they would too.
Yeah, I mean, it would be.
Well, the engines that ran in Pro Stock Truck was basically a NASCAR. The Pro Stock Truck engines from years ago was a NASCAR style 358 with
let's bring that back.
2 4s and a sheet metal intake.
I like that.
Guys, people out there, Cannonball Run. Everybody's in on this. Freestyle, everybody's in on it. But
I'm gonna
Dan
go
says,
back.
Mark, you got to run the one lap of America.
I'm going back to I think when the car shows up, you can't change it.
See, that's what I was thinking too. Like
I think that way we have wide tires for handling. Do you have to go down the drag strip? Okay.
Says the guy who doesn't want any rules.
Does it have to be a production car to begin with?
Hey, we can have rules, but they're just small rules.
Well, if it's got to be a production car to begin with, give me the GT3 RS.
Well, one of these gentlemen says, I've been on 140. It'll take the Baja vehicle to make it over the potholes.
I-40, yeah.
Oh, there you go. See, never thought about the potholes. Quick story. My Baja, the Raptor I take down to Baja to chase with, it's got all kinds of lights on it, right? I had to drive it back out here to inspect it. The lights fell off on the Texas on the I-40, so
goes across
he's right.
Baja, but not I-40.
Yes, it made Baja, but I-40 it didn't make it across. He's got a good point right there.
All right, good job, guys. Good job. That has been the technology roundtable, and now it is time. We've been building to this moment for a year. And change.
Yeah.
A lot of work has come up to this point.
Quite proud of this outcome.
Time to share. Get everybody. You've been like, they're doing this thing. Now's the time to share. Get ready, because we're about to reveal the final number.
How much power did it make? Okay, so last year, we dynoed it. It made just a tick over 1,000, like 1,042-ish.
46, something like that, yeah. So, But if you remember when we did that, we did not reach the limit of the engine. We reached the limit of the fuel system in the dyno.
Yeah.
So we
2 fuel pumps in.
Came back, added a second fuel pump, second regulator. You know, there was a whole bunch of errors in there that we had to fix along the way. We started with a fuel pump. We found out the regulator was a problem, so we put a second regulator. The guys at Holley sent us a bunch of great stuff. And that kind of fixed the fuel pressure problem. We haven't had any more fuel delivery issues since then.
But the next limit was RPM.
So then we thought, we are running out of RPM because the valves are floating. So we did all this work to fix the valve train, and we've done a great job at that. We can now go as high as you want to go. In fact, we can go higher than where the engine makes power naturally aspirated.
Right.
So what I was thinking was maybe we could put the supercharger on there, and that would fix some of that issue.
Right.
And it seems to have. It's moved us up several hundred RPM.
Yep.
But I think at some point you run into an issue where the engine's friction is coming up faster than you can overcome it with airflow.
Right. So with the combustion analysis, we can actually know what the indicated mean effective pressure is.
That's
we can back that out, and it's costing us over 300 horsepower to turn the blower.
Yep. So how we did that is we looked at the power and torque in the cylinder and compared that to the dyno when it was naturally aspirated.
Right.
And I think that was around 65 horsepower, somewhere in that nature. Then when we did the test with the blower, we could see the total power in the cylinder and the total power in the dyno and subtract that number.
Right.
And then subtract out the original 65 that we know is what the engine is, and the rest, it was a little over 300 horsepower just to turn the supercharger.
Yeah.
Like, that means you got to have
a lot of taxes.
Yeah, you got to have 15, 16, 1,700 horsepower worth of fuel system to feed the inside of your engine so that, on the outside, it's only making whatever, 1,200, 1,300 you're going to make. So.
Yeah, so one of the runs we made earlier, it was like about 1,600 something horsepower.
About 1,650 in the cylinder.
In the cylinder.
Yeah, that's crazy.
Yeah.
If only there was a way to get all that back.
I know. It makes the dyno look a lot better right now. So here's where we're at. Because of the in-cylinder pressure, we're seeing what it's telling us what it wants.
Yep.
And we're about to go into uncharted territory.
I'll be honest, the last 4 or 5 dyno pulls are uncharted territory. We are now doing things with the calibration that I personally have never done.
Yep.
Mainly because, I'll be honest, you're just too scared, right? Like, we can read spark plugs, we can make runs on a dyno, but you're always wondering how close to the edge am I?
Right.
Now that we have the combustion indication, we can see that we were still really soft. And so we've been like slowly inching up, chasing this tune-up going, are you sure? I mean, it says it needs it. And every time we did it, the engine got better.
Right.
It's amazing. And so here we
started
are.
off around 1,100 horsepower, and there's been a couple of runs right there at 1,300
Yeah,
now.
we're making a little bit over 1,300. But the crazy part is, like, when we were naturally aspirated, we're only 2 or 3 degrees less now at 20-something pounds of boost than we were NA. I would have never thought that was going to be the way. I mean, the old traditional rule of thumb is, well, 0.5 degree per pound of boost. So you figure, let's just say you got 31 degrees at NA and you got 22 pounds of boost. So 22 divided in half, you need to take 11 degrees away.
Yeah.
So, your 31 would become 20. Well, this thing was an absolute dog at 20 degrees.
Yeah.
And we've just been sneaking up, and we're all the way back up now to, I think, about 30 degrees or so we're going to try on this run.
Right.
And I don't know.
So anyway, that's why we're filming it now.
Just in case.
Just
this
in
might
case.
be the last run this engine ever makes.
Right,
But
so we'll see.
I think it'll be okay. The software, the spark plugs, and the dyno all indicate that it's a little bit soft. So I don't know. Maybe it will do nothing. Maybe it'll be worse. Maybe it'll be better. But there's only one way to find out.
It's fired up.
Okay, let's do it.
Okay, wow, what an amazing week. Mind blown every which way. I wish I could share everything with you guys that we learned and did this week, but it's...
I mean, so much of this Project Lake has been about trying to accomplish the goals, right? We need to test this, we need to do this, but what would happen is every time we would test something, it was like a rabbit hole, and we'd go down and start chasing something.
We learned so many things you didn't know that you didn't know before.
Yeah, I mean, we learned an incredible amount this week, and to get to share it with these guys, I think is just icing on the cake. You know what I mean? So Let's recap a little bit. Let's talk about the engine and the power and stuff. So we know from last year, we started out with the combination that was naturally aspirated, and we ran on the dyno. We ended up making about 657 horsepower. Now, that was good power. We weren't like blown away like this is the craziest, best engine in the world, but it's pretty good power. But we knew if we put some boost to it, it should get better.
Now, how much RPM did we turn in A last year?
Okay, so here's the thing. It was basically done at about 7,400 or so, 7,450, right in there. And after that, it was just going downhill. Now, that's just a function of the engine's volumetric efficiency starting to go away and the engine friction going up, right? So the same time you need more power, you're running out of it. Now, the cool thing about a blower, though, especially one that's crank driven like this ProCharger, is that as the engine's volumetric efficiency starts to go down, the blower is still trying to put air out. So the boost is going up, which is increasing the density of the air more than we're losing in volumetric efficiency. And so therefore the net power gain is pretty significant. So
it makes up for it.
Yeah, so right away, even with low boost, we made over 1,000, I think 1,046 horsepower last year. But unfortunately, my little dyno cell ran out of fuel pump, right? But
you gotta have air and fuel to make combustion.
You gotta have both, yeah. So we're like, cool, this is an opportunity to take a step 2 kind of thing. And we went and got an identical pump and we started to run that and it was like, it's a little better, but it's not way better. Then we realized what was restricting us was the regulator. So the boys over at Holley sent us some nice stuff and we got it all set up. That took care of the fuel flow problem. Pretty much we haven't had issue since then. We were able to then raise the boost. But before we talk about what happened then, I want to point out that if you look at the graph, we went from 657 at 7,400 to we didn't make peak power until about 7,900 or 7,950. Now here's the thing. I always suspected, and we talked about this, that it probably could make more if we kept going up.
You go more RPM, we could make more power.
Simply because we'd get a little more boost and, it's more power pulses. The problem was the valves were floating.
8,100 full valve float, which we saw in the Spintron video.
Yeah, so we took it apart, we put it on the Spintron, I was like, yep, it absolutely is. So then we fixed that, we addressed that problem by going to the Comp BSR rocker system. Which lowered that moment of inertia. We used that 3-piece really stiff push rod, and man, what a difference that made.
9,200 RPM and still like a sewing machine. It was crazy.
I don't know that it won't go higher than that. We just didn't need to because it was so far past the power.
It was way dead on power by that point.
So of course this week it was like, well, let's turn the boost up.
Let's go. Yeah.
And we did that. So I'll tell you what was really wild. We started with what I thought were moderately conservative numbers. Not like down in the ditch conservative, just this should be pretty close. And we weren't anywhere close. Like, if it wasn't for the fact that we had the in-cylinder combustion analysis and being able to indicate, mean effective pressure.
And know what's happening in the cylinder.
I honestly would have probably left a lot of meat on the bone. I would have left a lot on the table simply because, you tend to tune on the dyno to whatever your weakest cylinder is and you kind of compromise. But being able to go through and nitpick every cylinder individually and have the software tell us, you're still conservative, you're still conservative. And of course, we were looking at spark plugs going, well,
spark plug says it's okay.
You got the dyno saying it looks a little soft. You got your spark plug saying they look a little soft, and you got some super fancy software. And it was kind of like, well, if we're not going to listen to the data, then why bother? So as we started to chase it conservatively, man, it just kept going up and up. So we ended up making 1,327 horsepower. But here's the cool part: at 8,500 RPM. We picked up 1,000 RPM from the naturally aspirated, and nearly 1,000 RPM from the previous boost. We never even changed valve springs.
Exactly.
We didn't change the camshaft. We didn't change the valve springs. All we did was optimize the valve train stiffness, moment of inertia, and push rods, and we gained a ton of performance from this engine.
It was
pretty cool.
Well, it was stunning to see what it would do. I mean, we made 13 runs today over 1,000 horsepower.
And every one of those over 9,100 RPM. Now we made more than 13 runs today. We made more than 13 runs today, but 13 of them were over 1,000 horsepower and over 9,100 RPM. I don't even remember the last time we checked the valve latch. That was 2 or 3 days ago. That is impressive.
That was kind of what we wanted to build the engine for, was have something that wasn't just a one-run dyno hero.
it was something that we could make these kind of runs, you could do this kind of tuning, and it's crazy to think we actually accomplished that.
Yeah, it's
But
unbelievable.
there's so much more. I mean, there's so much more left here. It's not even close, which sounds ridiculous. To pick up 300 horsepower, and you're like, you're not even close yet? I'm
No,
like,
no.
we're
The
not
thing
even close
is,
yet.
like, the only thing we ran out of today was time. Like,
Right.
we've got 3 or 4 different kinds of fuels we want to test. We haven't tested dry sump stuff yet. We haven't tested humidity yet. We haven't tested, we want to go back and just keep going and pushing more and more and more. But man, we ran out of time. Luckily, within the time we had, we accomplished all of our goals and so much more. What about the frictional losses? You want to talk to these guys about friction?
Yeah. So with in-cylinder combustion, we can see how much power the actually engine's making.
Yeah.
Versus when the dyno will tell you how much made it out.
That's right.
So you can see the frictional loss.
The dyno is like after taxes. That's what you take home in your paycheck.
One's
right?
gross and one's net.
There you go. That's exactly what it is. So we found out that when we were running the engine naturally aspirated, there was about 65 horsepower or so that we were losing in there, somewhere in that neighborhood, right? But now that we're up here at 1,300 horsepower, it's something like 325 or 330 that we're losing. So that's still 65 of that is just the engine friction. All the rest is the power it's taking to turn the supercharger.
I think we netted it out. It was 313 net, I believe it was on one of the runs we looked at. Comparisons like 313 horsepower in taxes.
Yeah, so think about this. Like that last run that we just made, it made 1,680 horsepower in the cylinders.
1,680.
So wouldn't it be great to have all that available at the crankshaft?
Wait 1 second. That, by the way, is with a 1 millimeter, 1 millimeter, 2 millimeter ring set. Please tell me you don't need a 16th, 16th, 3/16th ring set anymore if you're going to make big power. That's 1,600 horsepower on a 112.
1,680. That's
1,680.
1,700. That's closer to 1,700.
Gapless, gas ported.
Yeah. That's pretty impressive. Like, everything about this engine, where we're at right now, is like, wow. And look, making 1,300 horsepower, 1,325, that's a great number. It's not like, set the world on fire or anything like that. But it was never meant to be, right? Like, no. We have so much more that we can explore and do on this
Everything
combination.
other than the connecting rods in this engine, because of the odd deck height, is a part numbered shelf.
You can just
product.
Swipe your credit card and get it.
Right. There's nothing custom or special other than the connecting rods, and that was just because of the deck height.
Yeah, that's pretty cool, man. So I'm so excited for next year and all the things that we can do and work on and try to optimize that. Now we have these tools, we just need to dig back in and get after it.
Yeah, exactly. Well, let's talk about it at the round table.
Can't wait. See you guys there.
And that is the payoff. Lake over 1,300. My goodness.
It's pretty awesome when you double it up. So that means we had 2 engines. We both picked up 300 horsepower on each engine. That's what I said earlier, man. Like 5-10 horsepower gains. Boring.
Yeah,
300, I get interested.
That's pretty amazing. All right, we got our final roundtable, guys, of Engine Performance Expo 2023. It is amazing. We're going to get into it. But before we do, this cannot happen without the people that make it possible. And I'm going to say their names, and you might not need anything at this moment, but the day that you do, please remember this is information exchange and what they have done and enabled us to do. Molly, of course, Driven Oil, that's one that you can get involved in right now. You might not need some of this stuff, but
everyone needs oil in their cars now.
Absolutely.
Everybody.
All the EFI, Morel Lifters, Straub Technologies, of course, amazing program he just announced at the expo here. That was amazing. Goodson, Silver Seal, Comp Cams, Edelbrock, thank you so much, guys. Get 'em Performance, I love learning a little bit about that. Rottler, Total Seal, CWT, Valvoline, everybody that has been involved with the Engine Performance Expo. It has been tremendous. And Billy, thank you so much, of course, and Scooter and everybody. This has been great, and I just it's the part of the social part of it, like what Mark just said, the stories that are happening, unfortunately for all of you guys, a little bit behind the scenes, and when they come in the studio, the profanity grows away, of course, right?
Most of it.
Most of it. But this has become, now this is our 3rd year, but our 4th expo.
Exactly.
This is becoming a thing, and I just love the fact, and this is your first, what was your takeaway?
It's like I said, it's the first one, and I'm actually impressed. I really like talking to people. I like talking to John Callies, and I'm I'm talking to John, and I'm thinking, holy crap, you did a lot of stuff. A lot of stuff I didn't even know about. What the heck? And, so I appreciate learning and picking up things from people. I wish I would have been able to talk to Scooter or Billy more.
Will be more times.
There's going to be more times.
There's
There's so many really smart people here, and every time I come into these kind of situations, what I basically learn is I'm not nearly as smart as I think I am. I need to step up my game.
There's always room to learn more.
Yeah, yeah. There's a lot of smart people here.
Even for Billy.
I mean, one of the things when you stop learning is when you're done. That's what you said about the best cam being the one you're going to make.
That's right.
I mean, the second you decide that the best cam's been made, and I've seen it happen, or the best whatever, when you're, then you're just done. It's time to start teaching and it's time to start, mentoring, but you're done doing. So, and this gets everybody excited. I was talking to Roy Johnson out there, hero of mine, and just seeing the excitement in him, talking to John Cosby. What you're saying about going on back there, we were talking about it, that a lot of what's going on, the conversations behind the camera that are off stage, they're amazing. It's so much fun. And yes, you're never, ever, once you think you're smart, you can just hang it up and, ride off in the sunset.
To butcher a quote from George Bryce, he said earlier, it's impossible to learn what you think you already know.
That's right.
Yeah. I think that should be the Expo tagline, right? Mm-hmm. This is what we're here for. Because there's always things to learn. And that's why we try to get the best minds together and continue to share. It's why we do the Expo. That's why we have the roundtables, so we can all learn.
Yeah, I think the culmination of all these people in one spot with a common goal of like sharing all this information out there is great, but the direct result of that is the natural sort of organic relationship building that was happening out there. I mean, we just met, Steve and I, we've met lots of times, but Scooter and Billy, but like you said, Billy, you're out here talking to heroes. I mean, Kazi's out there, and I was sitting earlier at lunch with Keith Dorton, and I said, half the reason I come is to sit by you guys, and he said, no, it's the same way. Like, we're learning just as much about what you do as you're learning about us, and so while we can't reproduce that for like the audience that's watching, it's the same like lessons to be learned, that relationships drive our industry more than almost any other thing we have. We talked about that a little bit earlier. It's like you got to be ready and you got to have a resume, but honestly, without relationships, you're not going to go very far in this industry.
My dad told me when I was a little bitty guy to don't ever mess up your relationships. Build all you can, because when you go in the ground, that's all you're taking. and it's so true. And we talk about what goes on behind the curtain here, which is incredible, and I wish all you people could be back there to see it, because it's just a brotherhood, if you will, of people that all love the same thing and do the same thing and have spent their lives doing the same thing, and they love sharing it with each other and helping float all the boats higher. And it's really, really cool, and that's what this thing's all about.
Well, the reality is we would not have gained 300 horsepower on either one of those engines without all the relationships.
And it's, I think, what you'd said, Joe, earlier, cross-pollination. Or better put, or another way is iron sharpens iron. We're
Absolutely.
here, we get better by being around other people. It makes us better.
It's funny, too. George said something earlier today about sometimes we hold back because we're afraid of letting our secrets out to other people, but letting those secrets out turn one secret into two secrets, into three secrets, and all of a sudden they're shared and everybody's that much better. And these things, somehow or another, over the years, these types of get-togethers have loosened those secrets and made people talk and made people care about each other to the point that it's selfless. You just keep throwing into this thing and it keeps growing, and that's really fun.
My buddy Roy Simmons told me one time, after they thought they were really good and they'd won a couple of Pro Stock championships, they got this fancy new shop and they had like card door locks, you had to swipe your card. Nobody was allowed in the building and everything's super top secret. And he said all we found was that after a while we just got slower because we weren't learning anything, and so it's sort of like, you guilt by association. You just learn by osmosis by hanging out with whoever you're hanging out with is what who you're gonna become like. You're not gonna
you're not going to change them nearly as much as they change you. So you got to be careful who you choose to hang around.
You know, I tell you a little story, and I guess I can say it now because the man's not with us anymore. But and I respected him a great deal, but I was never allowed to go in Edelbrock's place. He said, I don't want him to see what we're doing because, you know, he might learn something. And I told him, I said, you're always welcome in my place because I'm not smart enough to know what I don't know. So, you know, if you can pick up something I'm doing, then more power to you. But it's funny that the more we let people in on things and the more we share and the more we do, the better we all get.
Absolutely. Well, that was one of the videos we showed earlier today was me and Dr. Peter Lee down at Southwest Research. One of the reasons we started going down there to do work is because that's where so many people go. OEMs, NASA, everybody is going there. So they have these consortiums, like we talked about the hydrogen in the earlier panel. They've got a bunch of different OEMs that have all thrown in millions of dollars. Why? They're all competitors, but they know they can learn together.
Yep.
So we need to be there. If we want to learn more, we got to be where all that information exchange is taking place. So that's one of the reasons why we go down there. So I'm going down there next month to spend more time.
You know, we can be happy on the crumbs that fall off of their plate.
Yes, sir.
We'll feed this crowd really well.
Yes, sir.
You know, there's another element going back to like what George was saying. Sometimes, you know, you're afraid to let stuff out or whatever. And some of that just comes from that, you know, the idea is that we need relationships, but we can't have relationships without connection. And you can't have connection without a little bit of vulnerability, right? So if I'm so afraid to say what I know because I might find out I'm wrong or you might think less of me or whatever, and I'll have this sort of guarded fence up or whatever, we're never really going to connect. It's just going to be shake hands, how you doing, good to see you, you know, and go and do your thing. But if we're serious about building relationships, we've got to have that real human connections and share our failures and our successes, you know. And I think about how many times I've had bad days on the dyno, and you know, Billy, I called to cry on your shoulder, or Kazi would call me up and say, well, you know, do I need to come, you know, make you a cup of coffee and make you feel better or whatever. But those relationships happen because of the connection, which can only happen with some of that letting go of trying to be perfect. And you know, racing is an ego-driven sport, right? The whole goal for all this is we want to be at the top of the podium. I want to be the best, the smartest, most handsome, sexiest man alive, you know. But we have to let some of that go. I mean, think about all the guys that have been here this week that were fierce competitors, some of them very much against each other, who have now decided, you know, it's better if we do stuff together. So you got to have a little bit of that vulnerability and connection to be successful, I think, you know.
Well, this whole culture, whatever you want to call it, automotive, motorsports, like that, in the grand scheme of life on Earth, is really small. And we have this appreciation, but you know, in every high school, right? There's like 20 kids that go to the shop class. There's 1,500 in a high school. Who's playing football? Who's playing basketball? And it just becomes smaller and smaller and smaller. And this, you know, I'm a media guy, but in racing, like I get it and I like it. This is a very small thing, and we really have to work together to keep it relevant, keep it going, to keep it appreciated, to keep money in the sport, to keep sponsors on board. So whether it be like the guy who's selling the sponsorship for Hartford's Pro Stocker to keep him on the racetrack, whether it be the person who works in a media center at a race, like corralling those media around, whether it be your social media guy. You're telling me, Scooter was telling me a great story, like, I don't know about social media. What do? Went out and found some teenage guys, right? Like, they know about it. Let's bring them in. Like, we need you to help get this out there. Go out into the pits and showcase what interests you. Like, all of that, we're fighting against the tide of like normalcy in our world, which is definitely not normal. Like, we appreciate something that is different than the mainstream.
I like that Scooter called it a brotherhood. We, in our group, we call our fraternity the Brotherhood of BTUs, because we're all looking for the same thing, man. Like, so I really like that idea that it's truly a brotherhood, whether we just met or we've known each other for years and years.
You know, we still race each other every day. We're all racers. We either race on a racetrack, or we race on a dyno, or we race companies, or whatever we do. We still compete every day just as hard as ever, but then we throw together and share as well. So it's really, really a neat thing to be a part of.
part of the reason we race is so we can be measured and know where we stand. And so, what
right.
an honor to be racing against all the guys that.
I mean, we still want to kick their ass, every one of them.
Absolutely, yeah.
But when it's over with, we want everybody to be better. We want to make it all right.
Yeah, that's what makes this whole thing cool.
And in the end, you need people to race against. But you can't chase everybody out. Like you want them to taste some success, or they'll go home or go find something. Like, I don't know anybody that just keeps doing something over and over again without having success.
That's right. Joe,
eventually they're going to go.
No one wants to win on a solo pass in the finals.
That's it.
See, I learned some drag racing terminology. Look at that, right? You would do whatever it took, right?
Yeah.
Everybody would help out in the garage in the old days in NASCAR, right?
Yep.
You'd loan people parts and stuff. Why? Because it's a hollow victory if there's no one to race against.
That's right.
You want a full field, everybody running. It's like, who cares about the trophy if you only ran against yourself?
Yep.
And you want good competitors. I mean, you really do.
That's right,
Even regardless of thing, then you've got the whole thing of there's so many stories out there. You know, I was thinking about Michael Stapleton with the Ed Pink deal that he's telling. You know, we all know some of these stories, but they're not out there. You know, the sanctioning bodies are never really going to do a good job of telling what all's going behind the scenes to make these great engines that got through here and do these great things. So, I mean, to the point, some of it, we need to get together and recognize some of the achievements that people have done. We need to talk about what's going on behind the scenes. When you see what's going on behind the scenes, my wife hates things that are loud or fast. Racing, in fact, is loud and fast, you know. But then she starts hearing the stories of what people are doing behind the scenes, and she loves that. She loves how we're working on things. She loves how we compete with one another. She loves how we're striving to find better technology. And so if we can talk about these stories about what's going on behind the scenes, there's going to be a whole lot more interest in what we do.
Yeah. Well, that's why we're going to do the Hall of Fame, right?
Yeah,
we don't know how we're going to do it yet, but we're going to do it, right? Because we know it's important.
It reminds me of, like, I've got a mentor, my friend of mine, Russ, and he always likes to say, like, you can show me all your trophies, but I'm not really that impressed by them until you tell me who you had to beat to get them.
Yeah.
That's what really measures it, you know. So
we had an interesting story I want to share with you guys. I don't know if you know it, because I follow the bracket race scene. I'm a bracket racer, and a personal friend of mine, a guy named Troy Williams, who is an ace. He's won the $1 million race. Works at FTI Performance. Is a good guy, and just impressed the heck out of me with this move. Got to the final round of a big money bracket race, final round, and running a competitor who was also a friend who had a kind of a personal situation. Guy made it to the final round, like a little family tragedy. And for whatever reason, this is it, it's for 50 grand, right? Troy gets in, stages, the other guys trying to get in, for whatever reason, gets timed out, red light comes on, Troy's the winner, 50 grand. That's it, it's over. Troy backs it out, re-rack it. That's not how I want to win this thing. They reset the race, got in, ran the race, think he had a perfect light and final, won the race, won the 50 grand regardless. But to me, that was like sportsmanship, racer mentality moment of the year. Because there are a lot of people, 50 grand, that's more than you get for top fuel. And he said, you know, I'm sure there was a split, whatever, there's probably details that I don't know. But in that moment, it's what you just said. Like, this is about something bigger than that $50,000 check. There's a lot more going on here than just a couple of bucks or a trophy. You had heard about that one, obviously.
Yeah, but no, I mean, that type of thing. But the 50 grand is, you know, whether here or there, we'd all gone into investment banking if that was what drove us.
That's right.
You know,
Yep.
you know, we heard a car running. We smelt race gas. We saw somebody compete. And we got in there and we were just hooked. You know, every one of us here, we saw it, we felt it, we smelt it, and we're like, ooh, I can do this. Or I can try to be part of this. I mean, to think of, and you have to be, like you said, you have to be a little bit stupid too.
Well, you give up a lot of things. You give up your whole entire life. When you jump into this is what you're devoted to.
Yeah.
And as you said, your wife doesn't like anything loud and
I know,
all
she
that,
married
but
me.
it's just too bad, you know. You got to live with it. And all of us gave up a certain amount of our lifetime to be devoted to this, and that's why we do it. We do it because we win our race every day by being better every day. you win your race every day by making 10 more horsepower. So that's just the way it is. It's what we do, and sometimes we race cars, sometimes it's dynos, sometimes it's businesses, sometimes it's whatever, but we all race, and we race just as hard as anybody on any track.
Well, I think about, like you said in the interview earlier, the look in my dad's face, the emotion when he's sitting there talking to you when the engine was running. That's it, right?
Yep.
Oh, yeah.
Yep, it is. It's about people, you know. What we do every day is about people.
Relationships. It's
It is,
all.
absolutely. Yeah.
It's all the same.
Yeah. Because the parts of the people are going to change.
They are.
We're going to keep finding new things and keep evolving, but it's the relationships you have that enable you to get there and continue to climb. Because you can't do it on your own. There's no way. Like I said,
It wouldn't be fun to race by yourself. Like
Right.
you
No,
know, it's
So let's do let's go around the horn here with a final thought as we conclude 2 days of drinking from the fire hose. I think is what you called it, Lake. So much information coming at you. The good news for everybody out there is this is going to be available on YouTube. You're all going to be able to watch it again and again and share it and go back and check out those videos. And I think we're going to break them out as well, like we have in the past. Break out those videos so you'll be able to see the certain segments and share them with your friends. And everybody out there knows that there's somebody who couldn't watch on these given 2 days, but you can definitely send it and keep subscribing because we're going to be using this YouTube channel in the future. So this is always going to be here. But we'll start out with Ben. We'll come around the horn and we'll finish with Lake. And just a final thought. 2023, we're starting off. We're getting ready to go racing. Engine Performance Expo. Ben, give us your final take.
I mean, obviously, it was a great year of working on the engine project. Like, I don't know how I probably lost track of how many times you came to the shop and we did stuff. So, or you would give me homework and I would work on it and make videos and give them to you. But to me, that was the minor part of this, right? Like, you could say, man, that was a lot of work, and of course it was, and it was a lot of time. But the payoff really is more than just the trip here and getting to hang out with everybody. It's getting to show the whole world what's possible, what we're capable of, and what now they can do. Because I think, Scooter, you were saying earlier, the tide comes in and everybody's boat goes up. Well, that's pretty cool to think that work that we did throughout the year and then the effort that all of us put in, there's hundreds or maybe thousands of people out there that are get to be better because of this. That's why I came.
All right. Excellent. Dennis, next up.
Well, I came because this guy came by my shop last year and talked about a place locally he could come and do some work.
Yep.
And he's probably hooked everybody else the same way in a different way, right?
It's called being late.
I have my methods.
Yeah. So I didn't really know what I was, how that was going to be.
Right.
And because I just didn't want to be, hey, he's just going to come film something. It became a lot more than that. And there was a few folks in the industry that I didn't know from this and got to know. And really, even here, meeting you guys, but some others through this process, and the unintended consequences, what you set out to do, you learn other things. And I think that's the neat part for me. And even coming up here today, I was always busy with work, trying to get things done. On the dyno this morning, I come up here and it's like, well, I need to get up there. And over the top surprised.
Good.
Coming here.
Glad.
And which gives me a lot of energy, and I think all of us in what we do every day, that we look forward to tomorrow and this year. Race season starts and it's new again. For me, it was always when Daytona 500, when you get there and it's there, it's like, wow, it happened again.
Yep.
We're here, and whatever that spot is for everybody here in their life, in racing, as racing goes, it's really a neat feeling. Like you said, the fuel, the smell, the noise, it's the passion in what we do.
Yeah.
So
Excellent. No, I agree. I think the note I take from that is, take the time to, like everybody's got a load of work, but maybe take the time to do something a little different and break out of your normal routine to experience something like this. Like, of course, the work is waiting for you when you get back home.
That's right.
But you walk away with this. Steve?
I came here and I was thinking we do these videos, and one of the things that I've really been working on is I really share a lot of stuff, and I try to teach people stuff that I know, and I think that I'm really trying to focus on that there's a, this upcoming generation, thinking of my son that's sitting over here watching, who's going to take over my shop, and then I can go play with stuff someday is my goal, and he can take over. And I want to see that happen more and more, and so that's what I wanted to come here for, and that's what I really see is there's a whole bunch of other people that are really thinking the same way. Want to keep our industry going, want to bring the boats up with the tide, like Scooter just said, and that's absolutely true. And that sharing and talking to people and learning from no offense, the fathers, the fathers of our industry here, is a fascinating deal, and I'm proud to be here. I think it's a great thing, and I hope that it continues to grow, and I think it will, and I hope that our industry continues to grow, gets bigger. People do exactly what everybody was talking about right here, which honestly I haven't heard all that much, really. About hey, let's we love racing and competing against each other, but so how did you do that? Mm-hmm. And you can actually tell somebody, maybe you need to do this and start doing these other things, and you kind of change your methods or whatever it is, and that's a great thing that I'm looking forward to being more a part of.
Excellent. And plug your YouTube channel. Might as well, right? Where we watch your videos.
Yeah, Steve Morris Engines.
Excellent.
Yeah, so pretty simple.
You do some videos with it?
Yeah, I know. I was thinking about it, and one of the brand new things that I think I'm actually going to be doing is we're going to put the tagline, or the intro will be, warning, you may learn something by watching this.
I like that. That's good.
Learn.
That's what we want to do. It's just I don't mind teaching people or just showing people. Sometimes that's usually the biggest comment that I get on any of our videos is, "Wow, I really appreciate that you're showing us all this stuff. I've never thought about this, and you explain it on our level."
Compliment.
More than happy to.
Yeah, that's a compliment.
Yeah.
Scooter.
Well, I'm now that I'm the father of this, or
Yes.
one of the fathers, which I'm proud to be. I was sitting here thinking about education and sharing and so forth, and in about 1980, I made a video, one that I could even show my mother. I'm very proud of, on how to build a small block Chevy. The first one was how to degree a cam. Mm-hmm. And we probably gave away hundreds of thousands of those videos. And then we did a how to build a Chevrolet engine or something. I don't know. It was horribly done because we didn't have these tools that are available to us today. But that started, and you, to this day, if I'm at a show, I'll have some high school teacher or something come up and say, I use your video all the time. And I think, holy mackerel, I'm almost embarrassed by that. But it shows me the power of sharing. Mm-hmm. And we talk about relationships, and even though they weren't personal, through those videos, I made relationships with those shop teachers and some of those students, and on and on and on. And there's no question that the power of giving back is the most powerful thing. That you can't measure it on a dyno. No. Can't measure the cylinder pressure. We don't know. But it's got plenty of power, and we feel it here at this event, these types of events. And again, I wish that everybody out there could see what goes on back in the backside of the wall with all the people, because I'm at the downside of my career, and I love just sharing things with the people that I grew up with. There's a lot of people back there that are really special people, and here, but we're all very, very beneficial in the development of our industry. I love making sure that I've given back to them whatever I can. As little as there is here, at least I like sharing it. And that's why I want to see these things continue. That's why when you have this thing next year, I hope I'm able to come. I love them. I'll be back as long as I'm able to be back, and that y'all will have me. And hopefully we can continue to share our experiences with everybody out there and grow it, raise it.
Excellent. No, he's welcome back, right? I feel like.
Well, I'll say this way.
I feel
back
like
to the brotherhood.
Right?
Everybody that's in the brotherhood is in the brotherhood. Once you're here, you're always here.
Next time, I'm not going to agree to be on the last panel. That's the last person to get out of here. I don't know that I agree to that, but
probably a
this
smart
time,
strategy.
Yeah.
When it turns out you're the father of social media, though, I mean,
Yeah,
it's
that's
got
true.
certain obligations.
I don't think we got to worry about that either.
Billy, final thought.
You know, one is just, you know, I don't get a chance to thank Scooter enough. You know, 27 years. He's trusted my head a little, my heart a lot. You know, y'all were talking about people that are willing to give up anything to help you along. You know, he used to sit me down to Harvey Crane, and I'd spend time with Harvey. And Harvey taught me everything he knew how to do. And I knew that Harvey was working with the pro stock team. And I knew Harvey was working with the cup team. And I was working with a bunch of pro stock teams and a bunch of cup teams. And I was convinced that Harvey wasn't telling me everything that Harvey knew. And Scooter's telling me, Harvey's telling you everything he knows. You know, trust him. And I couldn't get that Harvey would just totally be like that. Well, you know, we don't have Harvey anymore. But later on, we wound up with crane cams. And I got to look over all of Harvey's notes. He was showing me everything.
Right.
There was absolutely nothing that he held back. And we were racing against each other on Sunday. And this guy, who's a legend, was taking this 28-year-old kid, 25-year-old kid, and telling him everything he could do to beat him. And I think a few of them I probably won. And I think probably my biggest fan probably was Harvey and Scooter. And so, you know, it's a big deal.
It is. That's why we love you, Billy. That's why we love each other. Because we're brothers, right? We have just met each other for the first time today, but we all had that same shared passion, experience. It may have been going straight line. It may have been going left, turn right, going in circles. But we all have that shared passion, a shared experience. And if you're in it, you're in it. And you know it. And that connection. I remember the first time I met Ben at SEMA. Within 5 seconds, it's like, dude, this is my best friend. he's been late almost as much as anybody else because of that, right? I mean, but that's why this is important, you know. And I got to thank Chris Douglas, because Chris Douglas is the guy that actually first started that little bit of snowball rolling that turned into something. You know, you think back to things you don't even think about that could turn into something bigger. You know, we started going out there to Ronnie Shaver's to test oil because, we got to make a hot rod oil. And my God, you couldn't put a normal size cam in an NASCAR engine. So it didn't matter that at Gibbs, we had all these dynos. We couldn't freaking cam in them because it wouldn't fit because they're the wrong size. Yeah. So we're like, Ron's got a Spintron. He's not using it. Just go put it out there. Of course, we're buddies, so we use it. Well, that one little thing turned into going out there and doing dyno work. Then one day,
just what you're saying is exactly what we're saying about relationships. Is that relationship existed with Shaver?
Yeah.
So you put those together, and then you put these together, and you go up here and put one together, and all of a sudden we're sitting around a table here.
Yeah, because Chris had the idea. Here.
And Brian was willing to do it.
Yeah,
you know, Shaver
they were willing to do it. Dino Don was willing to say, play along with me. Yeah, we'll go it. We start doing Facebook Lives. We didn't even do a video. We just did a Facebook Live. And we're like, oh, okay, well, we should start like recording them and like editing them. And next thing you know, then there's ATC goes away. And then COVID happens. And we're like, it's all these series, but
Back to relationships. We would have never had the first one of these if we didn't have people we could call and say, hey, can we make it happen?
And all those people that know how to make us look good, right?
Yeah,
Exactly.
there's a whole lot behind these cameras. They're doing an awesome job.
That's
And we sit up here and we do all the talking. You see us all day and you get tired of hearing us. But like you said, there's an army of people here in this room and in the back room that make all this possible. And hopefully everybody enjoys watching it because it's a pleasure to do it.
Yes.
It's a pleasure to do this, and hopefully everyone enjoys watching it and you get something from it because that's why we do it.
A lot of information was shared. Gentlemen, great job. Thank you very much. The final roundtable is concluded. Thank you so much. Engine Performance Expo 2023 in the books. Remember, there will be more, though. You can tell that. And I think most of these people can be seen at a racetrack near you. So don't forget to support your local tracks and get out there. I'd love for you to come out to an NHRA national event at some point in the 2023 season. I'll see you there. And that'll do it. We'll see you next time from the Engine Performance Expo.